and welcome to Simplilearn's Generative AI Full Course. Whether you are a beginner or want to boost up your skills, you are in the right place. We'll start with the basics and guide you through key concepts like large language models, deep learning, and agentic AI, all explained very simple. You learn how to use tools like OpenAI Codex, Hugging Face, and LangChain, plus gets hands-on demo with machine learning, reinforcement learning, and easy AI workflows. We'll also cover no-code AI options, transformers, GANs, and advanced topics like quantum AI. And on the top of it, I will prepare you for the AI job interviews and special tools to help you stand out. So let's get started. Before we commence, if you are interested to master the future of technology, then the professional certificate course in generative AI and machine learning is the perfect opportunity for you. Offered in collaboration with the ICT Academy IT Kanpur, this 11-month live and interactive program provides hands-on expertise in cutting-edge areas like generative AI, machine learning, and tools like ChatGPT, DALL-E 2, and even Hugging Face. You'll also gain practical experience through 15 plus projects, integrated labs, and live master classes delivered by esteemed IT Kanpur faculty. So hurry up and enroll now and find the course link in the description box below and in the pinned comments.
Now, the agenda for today's session. Firstly, let's get started with the agenda for today's session. Now, we will have a brief introduction to this session. Followed by that, we will have a briefing of what exactly is AI, then how does it work. Next, we will understand the key technologies and frameworks involved, and we will also go through some everyday use cases where we can take help of AI, and also some of the responsibilities that we need to keep in mind for the ethical use of AI. And lastly, we will explore some prompts. Now that I have made myself clear with the agenda, let's get started with the first part, introduction. How can AI simplify daily tasks? As we discussed in the use case, a human might have a lot of routine and mundane tasks. For example, automation. AI can simplify your daily tasks like checking up emails and drafting email responses, enhancing productivity by getting AI assistance for research in marketing trends or any other researches based on your job profile. And you can have a personalized AI assistance for recommendations for learning and much more. And after that, it will save you a lot of time, reducing effort. Now, the next part. Get set up with generative AI models like Microsoft Copilot and try some of the examples. So if you get access to one of the generative AI models like GitHub, then you can access GitHub Copilot easily, use it in Microsoft 365 apps like Word, Excel, and Teams. Then you can also explore prompting basics to start up with simple commands like drafting emails or summarizing documents. And proceeding ahead, we have another opportunity to experiment with different use cases like trying Copilot for brainstorming, planning, and organization. And fourth one, customize and iterate. Improvise AI generated results by refining prompts based on your needs and requirements. Now, let's proceed ahead and understand what exactly is AI and how it works, which will involve some of the key topics like understanding the basics and technologies involved, etc. So, generative AI is an advanced type of artificial intelligence that can sync up with human activities and gather requirements to assist humans in their daily tasks, improving efficiency and effectiveness. Not just these professional tasks, AI can create new content like text, images, music, and videos. It uses natural language processing and neural networks to learn patterns from existing data and then generate new content. Now, let's see how we can use AI to simplify our daily tasks and make life easier. Firstly, AI can create unique content, not just analyze data and make predictions. It can assist you in real-time generation of original text, images, music, and more. Next is AI as a creative partner. Generative AI can produce original text, images, music, and much more. It goes beyond traditional AI. Unlike predictive AI, generative AI creates new content rather than just analyzing data. Proceeding ahead, we have the next functionality where it can enhance human creativity by assisting with brainstorming ideas, storytelling, design, and content generation. Lastly, it is widely used in multiple fields, found in marketing, education, entertainment, and software development. Now, let's proceed ahead and understand the key technologies behind generative AI. Large language models is the first one, trained on vast amounts of text to generate human-like responses. For example, ChatGPT, Palm, Llama, and Microsoft Copilot. It is used for writing summarization of code and emails and much more. Now, the next part is natural language processing. It enables AI to understand, interpret, and generate human-type languages. It powers chatbots, voice assistants, and translation tools. Next, it helps improve communication between humans and AI. Now, let's proceed ahead and understand the everyday use cases of AI assistants, starting with creative writing and content creation. You can create and generate blog posts, articles, social media captions, and scripts. AI assistant in brainstorming ideas, editing text, and improving clarity. And lastly, you can also create poetry, stories, or some song lyrics using AI. The second one is organizing and planning. You can make use of AI to plan a trip itinerary based on preferences and budget. You can generate meal plans and grocery lists as well. You can schedule events and set reminders and manage to-do lists. The next use case is personal assistance. You can use AI to draft and refine emails or messages. It also helps you by providing phone books and recommending movies and music. And lastly, summarize documents, articles, or even meeting notes. Lastly, we have some other practical uses which include the following. Learning new skills with AI generated study plans, translating languages to provide real time interpretations, offering health and fitness suggestions based on personal goals. Now, proceeding ahead, we will understand AI agents. AI agents are advanced virtual assistants designed to perform tasks autonomously. They interact with users, process information, and execute commands. Some of the examples are ChatGPT, Microsoft Copilot, Gemini, and others. Now, what do AI agents actually do? So, AI agents conduct the following tasks. First, automate some repetitive tasks. Repetitive tasks like scheduling meetings, setting up reminders, and managing emails is done by AI assistants. It can enhance decision making by providing data driven insights and recommendations. Third is it can act as a personalized digital assistant which can help you with learning, travel planning, productivity, and much more. Lastly, integrating with tools and apps which can help you work across Microsoft 365, CRM platforms, and much more. And now, let's proceed with the major part of today's session where we have to focus on how to use AI responsibly and effectively. So, here we have a detailed Microsoft Copilot AI overview and also AI agents and their role in productivity. Let's go through that first. So here we have a quick briefing of Microsoft 365 Copilot, and we have also some links to the Copilot Success Kit, Copilot Chat, Agent Starter Kit, and the community links over here, and resources, Copilot mobile version, what's new, and all and everything you need to know about Copilot, about the technical readiness, etc. Now back to the presentation where we were discussing about the responsible use of AI. So the importance of ethical use of AI. AI should be used in a way that it is fair, transparent, and accountable. Understanding AI limitations will help you prevent misinformation and misuses. Ethical AI usage ensures trust and reliability in everyday applications. Proceeding ahead, we will discuss about ensuring transparency and accountability. First one, clearly communicate when AI is used in content creation. Provide with the specific prompts that you're expecting in your output so that it cannot miss on the target. Secondly, we need to verify AI generated information before sharing or acting on it because there might be instances where we might go wrong explaining our inputs or there might be some discrepancy in the data provided to analyze and generate a report. And lastly, understand how AI makes decisions to avoid over reliance. You need to understand the thought process of an AI and expect what kind of results it might generate so that you don't have to rely on one single prompt every single time. Now, let's move ahead and address some potential biases in AI. AI can sometimes reflect biases present in its training data. Common biases include general bias, racial bias, cultural bias, confirmation bias, and socio-economic biases. Let's discuss each one of them. Firstly, gender bias. AI-generated job descriptions may reinforce stereotypes, example, associating engineers' roles with men. Second one is racial bias. Facial recognition systems may misidentify individuals from certain ethnic backgrounds. Third one, cultural bias. AI might prioritize Western perspectives in content generation. Fourth one, confirmation bias. It may reinforce existing beliefs by favoring information similar to past searches. Lastly, socioeconomic bias. For example, AI generated loan approvals may favor individuals from higher income backgrounds. Now, you also need to focus on responsible prompting. Use clear and neutral language to avoid influencing biased results. Ask AI to provide diverse perspectives and sources when generating responses. Be mindful of data privacy and avoid sharing sensitive personal information. Now, let's go ahead and check some of the prompt examples. So now we are on the Microsoft Copilot prompt gallery, which will show you some of the sample prompts that you can make use of. For example, get a to-do list, add an image, quiz yourself, create a technology, write more confidently. For example, you might have a description. You can just add it to improvise or add more impact onto it. Find a specific information, draft an email, create a shopping list, and so on. So here you can also go through some other prompts as well by clicking on View All Prompts, and a whole new world of prompt gallery will open up for you. Try it out and let us know your experience in the comment section below.
If you ever wondered how machine learning can now understand and generate human-like text, you are in the right place. From chatbots like ChatGPT to AI assistant that power search engines, LLMs are transforming how we interact with technology. One of the most exciting advancements in this space is Google's Gemini or OpenAI ChatGPT, a cutting-edge large language model designed to push the boundaries of what AI can achieve. In this video, we will explore what LLMs are, how they work, and why models like Gemini are critical for the future of AI. Google Gemini is part of a new wave of AI models that are smarter, faster, and more efficient. It is designed to understand context better, offer more accurate responses, and integrate deeply into services like Google Search and Google Assistant, providing more human-like interactions. So we will break down the science behind LLMs, including their massive training datasets, transformer architecture, and how models like Gemini use deep learning innovation to change industries. Plus, we will compare Google Gemini to other popular LLMs such as OpenAI ChatGPT models, showing how each of these technologies is used to power chatbots, virtual assistants, and other AI-driven applications. By end of this video, you will have a clear understanding of how large language models like Gemini work, their key features, and what they mean for their future AI. Don't forget to like, subscribe, and hit the bell icon to never miss any update from Simplilearn. So what are the large language models? Large language models like ChatGPT 4, Generative Pre-trained Transformer 4, O, and Google Gemini are sophisticated AI systems designed to comprehend and generate human-like text. These models are built using deep learning techniques and are trained on vast datasets collected from the internet. They leverage self-attention mechanism to analyze relationship between words or tokens, allowing them to capture context and produce coherent, relevant responses. LLMs have significant application, including powering virtual assistant, chatbots, content creation, language translation, and supporting research and decision making. Their ability to generate fluent and contextually appropriate text has advanced natural language processing and improved human-computer interaction. So now let's see what our large language model used for. Large language models are utilized in scenarios with limited or no domain-specific data available for training. These scenarios include both few-shot and zero-shot training approaches, which rely on the model's strong inductive bias and its capability to derive meaningful representation from a small amount of data or even no data at all. So now let's see how our large language model trained. Large language models typically undergo pre-training on a boat, all-encompassing dataset that shares statistical similarities with the dataset specific to the target task. The objective of pre-training is to enable the model to acquire high-level features that can later be applied during the fine-tuning phase for specific tasks. So there are some training processes of LLM which involve several steps. The first one is text pre-processing. The textual data is transformed into a numerical representation that the LLM model can effectively process. This conversion may involve techniques like tokenization, encoding, and creating input sequences. The second one is random parameter initialization. The model's parameters are initialized randomly before the training process begins. The third one is input numerical data. The numerical representation of the text data is fed into the model of processing. The model's architecture, typically based on transformers, allows it to capture the contextual relationship between the words or tokens in the next. The fourth one is loss function calculation. A loss function calculation measures the discrepancy between the model's prediction and the actual next word or token in a syntax. The LLM model aims to minimize this loss during training. The fifth one is parameter optimization. The model's parameters are adjusted through optimization technique This involves calculating gradient and updating the parameters accordingly, gradually improving the model's performance. The last one is iterative training. The training process is repeated over multiple iteration or epochs until the model's output achieve a satisfactory level of accuracy on that given task or dataset. By following this training process, large language models learn to capture linguistic patterns, understand context, and generate coherent responses, enabling them to excel at various language-related tasks. The next topic is how do large language models work? So large language models leverage deep neural network to generate output based on patterns learned from the training data. Typically, a large language model adopts a transformer architecture which enables the model to identify relationship between words in a sentence irrespective of their position in the sequence. In contrast to RNNs that rely on recurrence to capture token relationship, transformer neural network employs self-attention as their primary mechanism. Self-attention calculates attention scores that determine the importance of each token with respect to the other token in the text sequence, facilitating the modeling of intricate relationships within the data. Next, let's see application of large language models. Large language models have a wide range of application across various domains. So here are some notable applications. The first one is natural language processing, NLP. Large language models are used to improve natural language understanding tasks such as sentiment analysis, named entity recognition, text classification, and language modeling. The second one is chatbot and virtual assistant. Large language models power conversational agents, chatbots, and virtual assistant, providing more interactive and human-like user interaction. The third one is machine translation. Large language models have been used for automatic language translation, enabling text translation between different languages with improved accuracy. The fourth one is sentiment analysis. LLMs can analyze and classify the sentiment or emotion expressed in a piece of text, which is valuable for market research, brand monitoring, and social media analysis. The fifth one is content recommendation. These models can be employed to provide personalized content recommendations, enhancing user experience and engagement on platforms such as news website or streaming services. So these applications highlight the potential impact of large language models in various domains, improving language understanding, automation, and interaction between humans and computers.
In this tutorial, we will learn about OpenAI's Gen AI agents. So generative AI agents are advanced AI-driven systems designed to autonomously perform tasks, generate content, and assist in decision-making by leveraging large language models, or also known as LLMs, and machine learning algorithms. Imagine an AI agent automating repetitive processes, enhancing productivity, and providing personalized recommendations across various domains, including customer support, marketing, and software development. By understanding context and generating human-like responses, they improve user engagement and streamline workflows. Businesses benefit from cost savings, faster problem solution, and improved efficiency. Such are a few out of many use cases of AI agents. Today, we will cover the OpenAI Gen AI agents and their facts, their challenges, and future implications. That's it. If these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Also, just that you know, if you want to upskill yourself, master generative AI and artificial intelligence skills and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various generative AI courses and certifications. Simplilearn offers various certification programs in collaboration with some of the world's leading universities like Purdue, IIT Guwahati, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, machine learning, generative AI, and over a dozen others. That's not all, you also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also academics from top universities. After completing these courses, thousands of learners have transitioned into an AI and machine learning role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a generative AI program that fits your experience and areas of interest. Now, without further delay, let's get started. OpenAI Gen AI agents. So, first, let's get started with the agenda for today's session. We will have a brief introduction to generative AI agents. Followed by that, we will understand the core components of Gen AI agents, then how generative AI agents work, architectures and deployment, enhancing AI agents with external tools, challenges and limitations of Gen AI agents, future trends and advancements in AI agents will be the last one. So I hope I made myself clear with the agenda. Now let's get started with the first part, which is Introduction to Generative AI Agents. So basically, what exactly do you mean by the term Generative AI Agents? So an AI agent is just an LLM that can take actions, and it can do so autonomously without any human supervision, and now also reason about the tasks. An AI agent is software entity that autonomously interact with environments, make decisions, and execute tasks. Generative AI agents extend by leveraging large language models like OpenAI GPT to generate intelligent responses and perform tasks beyond rule based automation. Now, we will also look into the evolution of AI agents. Traditional rule based AI agents had limited to predefined rules. Like if you define a process and give the steps, it will just perform them and complete it. It will not take a step beyond it. And machine learning based AI agents can learn from data but need structured inputs. And then comes the generative AI agents, which are capable of understanding, reasoning, and generating human like responses autonomously. Like they understand the environment and learn through it and take their steps based on the principle they have been trained for. And also, they will provide the reason for which they have taken a certain step. Now, moving ahead, why generative AI agents matter a lot. So there are three key points to consider. Firstly, efficiency. They automate repetitive tasks with minimal human intervention. Next is high scalability. They handle large volumes of work, example customer support, content generation, and many more. And finally, intelligence. They can adapt to different use cases dynamically. Nobody has to write rules for them. Now let's focus on OpenAI and its latest release of agents. So OpenAI just released two new groundbreaking agents, the Operator Agent and Deep Research Agent. These two releases are absolutely massive for all AI agent developers. So Operator is the first AI agent released by OpenAI, and what it does is it mimics human actions on your browser. So it means it can scroll, type, click, and navigate Google web pages for you just like any other human would. But more importantly, and what many people have missed out is this agent is actually based on a completely new model called CUA, which stands for Computer Using Agent. So, this agent, unlike standard GPT models, wasn't trained to just output text. You like write a prompt and expect an output in the text format. Instead of that, it can go beyond it. This agent was actually trained to output mouse and keyboard clicks, which is exactly what makes this agent so powerful in your browser. But not only that, it can also reason about every single action. This is also something that we haven't seen before. This agent doesn't just perform actions in your browser, it actually reasons about every single step and what it should do next. Just like we discussed before about the generic overview of generative AI agents, same as the OpenAI operator here. It takes the step based on the environment, and also it will give you a particular reason for which or based on which it took a certain action, and it also asks you what to do next. Let's say if you want to book a ticket, it'll navigate to all the websites. It can go through some better flight options for you. Let's say the low cost ones, the low hours of flight ones, and best timings, and then finally selects the best one for you based on your recommendations and asks you if it should proceed with booking or not. So that's how it works. Now, of course, there are some limitations as well. The first limitation is it has still a lower bit of accuracy. It's really high compared to other projects that we have seen in the past where people just prompt GPT models to perform actions in the browser that can browse web using GPT-4o vision capabilities, but it often struggles with other models. So whenever there was a model on a web page, like some other random model available working readily on a web page, it would just accidentally pop up and it would not be able to do anything because it would just get confused. It would not be able to close it, and then basically you would have to get involved yourself and close this model manually. And the second limitation is high cost. Right now, this particular operator agent is only available on $200 plus plan. So we can probably guess it's going to be pretty expensive in the API Also, I do think that if you are focusing on the right thing, then costs are not going to be an issue. Now, let's talk about the second agent that OpenAI deployed. Now, the second agent which was deployed by OpenAI is called as Deep Research. So, this second agent released by OpenAI was trained to perform comprehensive research. It can search the web, it can pull up the necessary resources, and then it can compile all that information into a really comprehensive document or maybe a report as well. The groundbreaking thing about this agent is it's powered by the new O3 model. So again, similar to the operator agent, but it doesn't just search the web and provide you with the results. It actually reasons about every single source and then it thinks about what other information it needs to find out next, and it's really incredibly powerful. Deep research doesn't just output the most average thing on the internet just like some other standard GPT models. It would compile novel insights. Now, let's move on to the real world applications. There are a wide variety of real world applications. First one is customer support AI agents, which helps you in automating help desk responses. Next, powerful AI assistants like copilots for professionals. Third one is research and analysis agents for data summarization, literature reviews, and many more. Fourth one is creative writing and content generation, automating social media posts, emails, etc. And lastly, AI-driven code assistants like GitHub Copilot, OpenAI Codex, and many more. Now, let's go through the next part, which is core components of these generative AI agents. Let's begin with the foundation models. So the foundation models are GPT-4, Dolly, and Whisper. GPT-4 for natural language processing, Dolly for image generation, and Whisper for speech to text conversion. The next one would be prompt engineering and context handling. So here, designing effective prompts for AI agents to generate relevant responses, using few shot and zero shot learning for adaptability, and lastly, implementing context-aware AI agents that remember past interactions from the user. Now, next would be the memory and long-term context storage. AI agents typically process short-term prompts, but memory-based approaches, for example, LangChain's memory module, enable long-term reasoning as well. Now, storing and retrieving user-specific data for personal responses is also one of the priority. Next will be the tool use and API integrations. Using external API to fetch real-time data, for example, weather, stock prices, news, etc., and integrating databases for structured information retrieval. And proceeding further, we have autonomous decision making. AI agents evaluate multiple options before making a decision. Planning and reasoning techniques to enhance responses is a priority for them. Proceeding ahead, we will discuss how generative AI agents work. Starting with the first step, input processing and context awareness. AI agents analyze user input, detect intent, and extract entities. For example, in a travel booking AI agent, it identifies destination, date, and budget from user queries. Just like the example we discussed before, right? You provide the point A and point B, the best time for you to fly, and the best number of hours that you focus on flying, and lastly, the destination, right? All these things will be evaluated in real time. The cost, the number of hours, the flight, the options provided, the amenities provided on the flight, and all those things, and also budget as well. And based on that, they take a decision. Now proceeding ahead, generating intelligent responses. So here, RAG, or also known as Retrieval Augmented Generation. AI searches external databases for responding. Next, we have chain of thoughts reasoning, or also known as COT reasoning, and AI breaks down problems into fine steps. And last step is fine-tuning the models, custom trained AI for specific industries. For example, if you're preparing an AI agent for a dedicated sector like healthcare, legal, customer support, based on that, you will fine-tune your AI agent or model. Now, next is decision trees and multi-step reasoning. AI can simulate a thought process, breaking down complex questions into manageable steps. For example, whenever you open DeepSeek or whenever you open OpenAI ChatGPT for the most premium version, you will write a prompt and there will be an option called Think, right? If you just click on that, it will explain you the thought process it is going through and how is it planning on giving a reason for you, right? And followed by that, we have handling uncertainty and error correction. AI self-corrects through confidence scoring and human feedback loops. Last step in this particular stage is fine-tuning and reinforcement learning, or also known as RLHF. Human in the loop training to improve responses, and AI learns from real world interactions and adapts over time. So it's basically called overtime learning, where it adapts to the real world environment and learns things and provides the best feasible solution. Now, the next stage is architecture and deployment of AI agents. So, in the first one, we have standalone versus multi agent systems. So, firstly, the standalone AI agents. They perform tasks independently. For example, ChatGPT. Multi-agent systems, on the other hand, work together to achieve complex tasks. For example, one agent for summarization, another for execution. Now, next in this particular stage is agent orchestrator model. A central AI agent coordinates multiple AI sub-agents. For example, in an AI-powered research assistant, one agent gathers all the data that is required, the second agent summarizes all the information collected, and the third agent formats the output. Followed by that, we have cloud-based AI agents and edge-based AI agents. Cloud-based AI agents compute, for example, OpenAI API, Azure AI, and edge-based AI agents run on local devices for faster processing. For example, Tesla's AI in self-driving cars. Followed by that, we have using APIs to build AI agents. OpenAI's API for GPT-4 powered by AI agents, LangChain framework for AI agent orchestration, and Llama Index for document-based AI agents. The next stage, we will discuss about enhancing AI agents with external tools. In that, the first step is integrating with databases. AI agents can query SQL and non-SQL query databases for structured data retrieval. Proceeding ahead, we have connecting with web scrapers and APIs. AI agents can fetch real-time data using tools like Beautiful Soup, Scrappy, and OpenAI plugins. Next ahead, using vector databases for context recall. FAISS ChromaDB store long-term memory for AI agents. For example, legal AI agents retrieve case law from vector embeddings. Lastly, we have autonomous agents and workflows. AutoGPT and Baby AGI are best examples. These AI agents that self-improve by learning from previous tasks, and True AI, which is a set of multiple AI agents collaborating to solve a complex problem. Now, the main part, challenges and limitations of generative AI agents. In that, the first one will be the ethical considerations. AI bias and fairness concerns are the primary ones. Addressing AI hallucinations, which is false information generation, and then we have computational cost and efficiency, which is a major concern amongst all the industries. Large AI models require significant computational power. Strategies to optimize AI agent efficiency will also considered to be expensive to hire many training models or also human programmers. Followed by that, we have security risks and data privacy. Risk of data leaks or data breaches and AI jailbreaking is one of the highest security threat. Implementing secure AI architecture is one of the primary solutions that you need to focus on. And lastly, we have legal and compliance issues. This would majorly be concerned from the enterprise level. GDPR, HIPAA, and AI regulations compliance is mandatory, and AI liability in decision making is also important. And now, the last stage of today's discussion, which is future trends and advancements in AI agents. Starting with the first one, AI agents with emotional intelligence are also known as affective AI. AI is capable of detecting emotions and adapting responses accordingly. For example, if you have designed a therapeutic AI chatbot for mental health. Now, the next one, self-improving AI systems. So meta learning and auto ML are a few examples. AI agents that learn from new data autonomously, for example, AI adjusting marketing campaigns based on customer responses. And now the next one, AGI and roadmap to superintelligence. Well, this always ends up with question. Will AI agents evolve into AGI, or also known as artificial general intelligence? And are the implications of self-learning AI real? This is the major question. And lastly, the role of AI agents in the future of work. Now we can see there are a lot of AI agents like Copilot which will assist humans in their day-to-day tasks, whether it is business, healthcare, or education. And also, you have a lot of automation and transformation happening in the IT industry, which will reduce the work hours and stress on the employees by automating all those mundane tasks by the help of Copilots, also the generative AI agents.
Are you feeling like every other video, article, or tweet you see these days is about generative AI? You're not wrong. It's the tech world's current obsession. But instead of just nodding along, wondering what it all means, what if we could actually master it? In this video, we are cutting through the hype, giving you a practical step you need to truly understand. I will be breaking down the entire journey into manageable phases from fundamental knowledge to building your own Gen AI projects. Before we begin, let me tell you what generative AI or Gen AI means. As the name suggests, it is generating data. It's a technology where it uses existing data for creating new ones. It might be in the form of text, images, audio, video, code, or even 3D models. For better understanding, I will be dividing the entire roadmap into 4 phases plus one additional phase as a bonus phase for you to excel in this field. Phase 1 is all about laying the foundation, which includes the basics of AI and machine learning. Think of artificial intelligence as making computers smart enough to do things which people can do. Machine learning is just one of the way to do it, allowing computers to learn from example instead of being told exactly what to do. It's a learning by seeing and doing it, not just by a rule book. There are 3 main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is where the computers learn with correct answers, whereas unsupervised learning involves finding patterns on its own, and reinforcement learning is about learning through rewards. You will need Python too. Key tools include NumPy for numerical operations, Pandas for organizing data, and Matplotlib and Seaborn for data visualization. These help you to work with and understand data. You need to understand data preparation, which involves cleaning and organizing data. Also, learn about the feature engineering, which is the process of selecting important parts of the data of the model. Gen AI uses deep learning. You can think of deep learning as a computer network with many layers. Understand the basic idea of how these networks learn from data. This is the key for understanding more complex Gen AI models. Moving on to phase 2, where you can start exploring the Gen AI models. Some of Gen AI models include GANs, which are 2 networks competing, one making fake data and other tries to spot it. This model works well for creating realistic outputs. The second model is VAEs. This model learns a hidden representation of data to create new or similar data. The next model is transformers, which are excellent at understanding context in sequence like text, audio, and even images using attention. The last model is diffusion model, which can create high quality data by reversing a noising process. This model is very popular for images. Apart from Gen AI models, you need to cover text generation model, which falls under natural language processing, which is NLP. These models power text creation from writing articles to translating languages. And lastly, you will cover image generation using GANs and diffusion models. In phase 3, we will focus on developing our practical skills. You can start with small projects such as generating basic images or text with small datasets. Do experiment and learn the workflow. Join platforms like Hugging Face, Reddit, Stack Overflow, and Kaggle forums to ask questions and learn from others. To showcase your work, you can use GitHub to share your projects and code. Phase 4 is truly about staying ahead. Gen AI is always changing, so you need to be aware of it. New architectures are constantly being built, so briefly be aware that more advanced models are continuously being developed beyond the basics that we have covered. I would also recommend learning about deploying models on cloud platforms like AWS, Google Cloud, or Azure, which will be useful for larger projects. Additionally, you can read research papers, follow tech experts online, whether on Twitter or LinkedIn, and stay curious about this field. Continuous learning is the key in this field. Now that you have built a strong foundation in generative AI, Phase 5 is all about mastering the future of technology. A certification course provides formal validation of specialized knowledge and skills, making individuals stand out to employees and demonstrating a commitment to professional development. This recognition often leads to enhanced credibility that improves career opportunities with specific field.
Now we will begin with the agenda for MCP tutorial for beginners. So firstly, we will have a quick briefing of what exactly is an MCP, or as it is called, Multi-Agent Collaboration Protocol. Followed by that, we will understand some basic protocols and standards in communication. Next, we will try to relate MCP to the understanding of protocols and standards. Followed by that, we will get started with our demonstration on developing a web scraper agent using MCP. And for that, we will be needing Node.js, Cursor AI, and Firecrawl API. So I will be walking you through those demonstration steps one after the other, and this will be a very beginner-friendly tutorial and practical demonstration on MCP. Now that I've made myself clear with the agenda, let's get started with MCP. So what exactly is MCP? As MCP on their webpage says, MCP is a Model Context Protocol, or Multi-Agent Collaboration Protocol is an open source protocol that standardizes how applications supply context to large language models. Similar to how USB-C unifies hardware connections, MCP offers a consistent way to integrate AI models with various data sources and tools. Now let's go to the official documentation of MCP to have a broader overview. So, as they say, MCP is one such tool, if you remember N8N and all the AI tools and data sources that you used. For example, if you wanted an AI travel agent, as we have an already existing tutorial on our channel, you can go through it for a brief overview. So you might be needing an email writing agent, and you might be needing an airport code searching AI agent, hotel searching AI agent, flight booking AI agent, and a lot of agents connected to one another through a complex network using an N8N platform, right? Now, in this particular MCP, that will be minimized. So you will have a standardized approach where you just eliminate all those boilerplate coding, agents, manual searching for databases, manual search for knowledge bases, manual search for agents which are specifically designed for the purpose. You just explain your initiative, attach the API keys, and MCP takes over and gives you a fully furnished and finished product within no time. That's the main approach of MCP. So here you can see an overview image where we have the parts: MCP hosts, clients, servers, local data sources, remote services, and local data sources. If you wanted to go ahead with local data sources or local knowledge base, you can go ahead with that. But in case if you wanted some open source, then you can also go ahead with that. So here we have all the quick starts and guides and example and tutorials to how to begin with that one, and all the explore pages that you want to go ahead with if you wanted to have a deep dive into core architecture, the resources available, prompts, tools, transport samplings, and a lot more. And in case if you wanted to contribute your dedicated resources for the community, you can also go ahead with that, and you can also have some support and feedback for MCP. Now that we have a brief understanding of MCP and still clueless about what exactly is MCP, then let's go ahead with some standards and protocols so that you can get a template and you can relate MCP to that template and understand what's the role or importance of MCP in AI agent development. Now, understanding the standards and protocols. Now, let us imagine that you get a team of people to work on a project, and you are the manager that leads and directs this particular team for a purpose, right? Now, the complex problem. No one is friend of anyone. Everyone is new to everyone on the team. And each and every person in this team belongs to a different country and doesn't have a common language in between. For example, person A speaks Mandarin, person B speaks Hindi, person C speaks French, so on. There is no common language between any one of those. Now imagine each and every one of these team members as an AI agent or a tool working for the purpose. In this scenario, you might have to hard code the ports of communication, instructions on how to do, And you need to go on to each and every single AI agent and explain the stuff in a very dedicated and a specific way. This could take a very long time. In the same way, if you relate this to a person, then you might have to reach to every single person and speak to them in their own tongue and explain them the procedures and the steps to be taken to finish the task. Now, how would you do that? It would be a lot complex. Mandarin, you might not even know French or a different language. And in that particular scenario, you might be stuck. What if there was one single language that everyone knew? For example, English. Now you can get all of them together and explain the stuff in one single call and close it. And what might be so wonderful is that you'll not even waste a lot of time and there is no hard coding, there is no manual effort there, right? In the same way, if you relate this to a web server, then you are the client, you have the server, and you just, let's say you're working on Facebook or Instagram, you try to post something, you try to write a comment, you try to like something, right? That is the activity. And these particular activities will go through 4 different types of requests. One is the get request, put request, post request, and last is the delete request, right? Now, if you are connected to a single server, this might not be as tough as possible. But if you are getting connected to multiple servers, then you might be requiring different protocols every single time. Now, this can be a combination of 2 parts, HTTP and the URL that you're trying to get connected to, right? Now, to eliminate the efforts between multiple servers and multiple requests at one go, you have one single tool called as API. And the most popular API is the REST API, which has a standard way of communicating. So here, the REST API works as the language English that we discussed before. In the same way, it has maintained a standard where each and every web client can have his communication to his dedicated server or multiple servers in one go using one single language or medium or standard, that is REST API. Without REST API and the standards and protocols, it might be very confusing and you might end up in a complex situation which might not yield in the type of result you're expecting. Now, if you can relate the development of multiple AI agents for a single purpose to the web communication and a meeting, you also expect if there were a template for development of AI agents which could make the process less complex, just like REST API did in a web service and just like English did in a team meeting, then MCP comes into the picture. MCP is your template for it, right? So just like your REST API and the meetings, you have a MCP. Earlier, without MCP, we used to have one tool called NA10, where you had all the tools connected to it and all the LLMs programmed to it, and you had to do this hard coding for each and every tool that you have included in the network and each and every agent that you have related to it. You had to specifically instruct, write down steps, develop a persona to your AI agent, right? There was a lot of stuff. But if you eliminate this particular complexity with one tool, then that would be your MCP. You just had to include MCP and tell your purpose, and your job would be done. Now that you have a brief understanding or a general overview of what exactly is MCP, now let's go ahead and build one. Now, the steps would include the following. For the project that we are building, which is a web crawler or web scraper, we might need the help of Node.js. So firstly, we will install and set the environment for Node.js. Followed by that, we will be needing an editor. So for that, we will be choosing the Cursor AI editor. And next, we will use an API. So for that, we will be using the Firecrawl API. And lastly, we can get started with building one once we have all the required resources. So let's get started. So as we discussed before, we will get started by installing Node.js into our operating system. So we're working on Windows operating system. So we might have to go ahead with Windows. So I'll choose Windows and the architecture will be the one which I'm working with. So that would be x64. But in case if you are working with a different operating system, say Mac OS, then you might have to select ARM or any suitable architecture that you can be compatible with. For Linux, you'll have to choose with the same and so on. So since we're working with Windows, so Windows it is and x64 architecture. and click on that Windows installer MSI file. So it will be getting started to install, and you'll have to click on that Windows installer.msi file and it'll get downloaded. While it is getting downloaded, let's go to the next web page and download and install the Cursor AI that we will be needing for this demonstration today. You'll have to log in, create an account and log in, and automatically it will give you the version that suits our operating system. Since we are in Windows, it gave me a Windows operating system. Just sign up or log in. So since you've already an account, just log into your account and confirm it's that you, and followed by that you'll have installed your Cursor AI. Choose your theme. I'll go with the Cursor Dark theme. And here you make sure that you have Cursor tab, Control K agent, and you can also choose the data sharing option. I'll go with the privacy mode in case if you want the other one, go ahead with that. And here you have a few review settings, and there you go. Now you're on the new window for Cursor AI. And meanwhile, let's check on the Node.js installation. I think the wizard has already started installing the Node.js setup. So this is the window. Let's quickly go through each and every instance that we have gone through so far in this particular window from the beginning. So it started off with some packages that we would be needing. So yeah, chocolatey and KB299. Yeah, further we have, and the last one is Python 13, right? Version 3.13.3 is approved. So far so good. I think we can now get started with the next step. So here we are on the Cursor AI. So we might have to get started going through the Cursor AI settings to create our new MCP. So there are quite a few methods that you can try out to reach to settings. One is you can go to the file, and there you may have to choose the preferences, and then you have the Cursor settings. You just can use that particular step, or you can go ahead with the search options as well. So you can use that step, or you can also use the other step where you can just go to the search window and search for the settings. Here you can see MCP on the left window. So let me also walk you through a few other steps. So go to the search window and type down Cursor AI or Cursor settings. I think there has been a discrepancy, but not to worry. We'll go with the regular approach where we go to the file, preferences, and Cursor settings. And there you have the options on the left hand side. Go to MCP, and so far you don't have any MCP servers because this is the first time you've logged into Cursor AI. So you just have to add new global MCP server, which is available on the blue color button. Just click on that. And now you'll have a mcp.json file which is completely empty. You'll have to write down a few hard-coded codes here, which are not too complex related to the earlier ones that you have worked on in A10. So you might need a few more tools here. So go to the Firecrawl website. Before that, let's go through some awesome MCP servers GitHub link. So here we have almost all information related to the MCP. So let's open a new window and open all these links. What is MCP, clients, tutorials, community, legend, server implementations, framework, tips and tricks, right? For further information, you can go through all these web pages individually. So back to the home page, here you have everything you needed. The basic information of what exactly is MCP, and further you have some server implementations. Like if you scroll down, so you have awesome MCP services. This is where the beginning is. And next you have server implementations, aggregators, art and culture, coding execution, right? Customer data platforms. So here you have aggregators, art and culture, dedicated web spaces. So, and you have also cloud platforms that you can work along with. And moving further, you have code executions, coding agents, command lines as well, and communication related stuff. So you can go along and perform your operations, customer data or platforms, data platforms, and much more. Let's close all these windows and get started with the next stage where we need an API, right? So for that, the project that we're working on, which is web crawler, we will be needing an API from one of the providers, which is Firecrawl API. Okay, that's the one, Firecrawl MCP. So that's the one. Click on that particular link. Here, to generate an API, first you might have to sign up with Firecrawl. So before we sign up, let's go through the website of Firecrawl from the beginning. So that's the template code that you'll be working on. And also here we have a wide variety of crawl options, media parsing options, smart weight actions, right? Reliability first and all those things. And also we have the pricing details. For now, we'll go ahead with the free plan. And yeah, let me add down my details, my email address, and you might also have to add a password. So let me type down something. Yeah, so the password is not too strong enough. That's a good thing. They have a really strong website. So that's a sign you need to have strong passwords, and also make sure that you don't share your passwords and the API keys that you generate using Firecrawl. Now that my password is a little too longer, I think it should be access. Yeah, it's accessible and it is a successful account generation. Now you need to check your email and confirm that login credentials are right and everything. So once you are signed up, let's go through another website for generating our API keys. So Firecrawl API, scroll a little bit. So API documentation. So here you'll find some documentation related to Firecrawl and all the details that you need to go through for API key generation. So Firecrawl MCP server. Yeah, that's the website that we're looking for. Firecrawl MCP server. That's the one. And here you have overview, content, tools, and other resources that you're looking for. Now, this is the template server configuration that you'll be needing. So make sure that you have an eye on it. And now you will also have the details that you might have to go through. Like basically, it'll have the steps that you need to follow in the content page. Click on content. There you go. So it has all the features and details that you need to go ahead with. And tools, you have the crawling, extraction, scraping tools that you can work along with Firecrawl, and a few comments here. Now, yeah, the email has not been confirmed yet. Let's try to resend and reconfirm the email so that we just sign up or log in and create our API keys as soon as possible. So there you go. I have verified my email in my phone. So I'll just enter the credentials and sign in. Successful, you are signed in. On the left hand side, you can see the overview, playground, extract, activity logs, usage, API keys, and all the settings. So here you can see my API key has been by default hidden, so I'll not visualize it now. So you have two options, either view or copy. So we will be copying it for the first time to be on the safe side. So since we are new to this particular website, so we don't have any activities registered on this particular web page. So now we have the API keys. Now let's go to the content page to verify the steps that we need to follow. So we need to install npm and we need to go to the cursor AI settings and add a new MCP server, which we already did. So we just need to copy the template code and we just need to place it there. And also, don't worry about where exactly to place your API keys in the template. We have that place. So we are back on the cursor AI. Now we will replace this template code with the code that we just copied. And remember, if you're using Windows, try cmd/c. Okay. If you're not on Windows, you can eliminate that cmd/c. But if you are working in Windows, then you definitely need that cmd/c. Okay, let's erase this and replace that. So I'll name my tool as Firecrawl. And I'll go to the new line where I'll write down my command, and the command will be the code that I just copied from the Firecrawl window. So let me type down the command in double quotes in the new line, and I'll paste the command here, which is the code that we copied from the Firecrawl window. Control V. There you go. So the white stuff, which is in cmd/c, so that's the one you need to focus on. If you are working on Windows, that you definitely need it. If you're not working on Windows, then you can just omit it. Now, there might be some concerns with the codes, don't worry. Now, to cross-verify, you can just go back to the Firecrawl homepage and cross-verify it with the template for configuration that they have made us available. Let's go back to the Firecrawl window, and at the same time, you can see your API key here. So that's where you need to place your API key. So here we are on the Firecrawl window. You need to copy the API key and place it in the place where they have mentioned your API key. So if you have cross-verified with the configuration code, that's fine. And now you can just check the double quotes. So that's the one you need to focus on. Let me if there is a way to zoom it in, let me try to zoom in. Yeah, that's the one, CMD/C. If you're on Windows, you definitely need this. If you're not on Windows, you can just choose to omit it. Now let me just do one last final check. I think I missed a double quote somewhere. Yeah, I need to remove it from this place and add it to the end. Just a second. Okay, remove the double quote at that place. Now it should be after MCP. And once everything is done, you can just quickly choose to save and close this particular window. Check the distance between the API key and the double ampersand places. That's fine. And saving is really simple. Choose those three dots, close, save. And once that is clicked, it's all done. You get to choose to close this particular mcp.json file and get back to your agent. So once you have closed it, you will have your new server that you've just created in the cursor settings. But in a few times you get no tool connected, no server connected, or there might be some errors. So in that case, you just need to cross verify the npm installation, node.js installation, and check all the files that are there or not. But even if everything is installed and you can see the versions available, and if you're still seeing this or watching that particular error, then don't worry, just close the cursor AI and restart it, or you can also choose the refresh option, which is right available there. So I've closed and restarted it, and the same procedure, go to File, Preferences, Cursor Settings, and there you'll see the MCP models, and there you'll find it right there, correct? Now close it and go to the window where you'll find the server. Yeah, that's the one. And here you choose the agent. Make sure that you choose the agent instead of anything else. Not manual, not ask. I choose the agent. And now I'll write down a simple prompt. Search for Simplilearn on Google. Now it should give me results which it finds on Google. Maybe it's a home page, maybe it's a social media handle like LinkedIn or YouTube or Instagram, anything that it finds related to Simplilearn. Only the term Simplilearn. So here you can see it has given me 3 different results. First one is Simplilearn website. Second one is Simplilearn YouTube channel, and the third one is LinkedIn page. So let's get started with the official web page. So click on the simplilearn.com. Now, it's asking me permission, open. Now we are on Simplilearn homepage. Similarly, let's go back and select for the YouTube page. So that's the one. Open again, get permissions. So you're on the Simplilearn YouTube page. Now I think it might ask for a login for LinkedIn. But anyways, let's try to check if it can open without logging in to LinkedIn or not. So yeah, you can see I've logged into the YouTube. Yeah, it is asking me to log in. So let's quickly log in. It might take a couple of seconds. So there you go. I've logged into LinkedIn. Now open. So I can see Simplilearn's homepage getting loaded in a second. Yeah, there you go. On LinkedIn, we have opened the Simplilearn's homepage successfully.
OpenAI just dropped something huge. It's called Codex. If you're writing code or just love tech, this is about to blow your mind. This AI is not just smart, it rewrites how we write code like for real. But here's the thing, is all this hype actually worth it? That's what we are diving into today. We'll break down what Codex is, how it works, the cool features that make it special, how safe and reliable it really is, and how it stacks up against other AI coding tools out there. So if you're curious whether Codex is a game changer or just a fancy buzz, stick with me and let's get into it. Alright, so what exactly is Codex? Imagine having a supercharged AI developer in the cloud. It's like a team of experts who can juggle writing new features, fixing bugs, answering questions about your code, all at the same time. Codex runs in these safe, isolated sandboxes loaded with your exact code base. So it's working with your code just like a real teammate would. But what powers Codex? A special AI model called Codex 1, trained on tons of real coding projects to produce code that looks just like a human wrote it. It follows instructions carefully, keeps testing until everything works perfectly, and even adapts to your coding style. Oh, and there's a cool fact. In OpenAI's own coding benchmark test called SWE Bench, Codex nailed up to 85% accuracy solving real-world coding problems. That's a massive jump over other AI models. So it's not just a good-looking code, it's a trustworthy code. Now you might be wondering, how do I actually use Codex? Now if you have got ChatGPT Pro, Team or Enterprise, Codex is right there in the sidebar. You just type what you want, maybe write me a login feature or fix this bug in the payment system and hit the code button easy. Want to ask questions about your code? Hit ask and get answers right away. Each task Codex handles run in its own secure cloud workspace. It reads your file, edits them, runs tests, linters, and checks type, basically everything a human dev does. Tasks take anywhere from a minute to half an hour depending on how tricky they are, and you can watch the whole process live. When it's done, Codex commits the changes and gives you all the receipt, terminal logs, and the results, citations, and so you can easily see what it did. You can review the work, ask for changes, create GitHub pull requests, or merge directly. You can even set up a Codex environment to match your real development setup for smoother results. Want Codex to work even better? Just add agents.md file to your repository, like kind of a guidebook telling Codex how your project works, what commands to run for testing, and your coding standards. Think of it like onboarding a new developer, giving clear instructions, and Codex becomes smarter and more helpful. But even without that, Codex is already rocking in OpenAI's internal test. Talking about is Codex safe or not? Look, handing over code to AI can feel scary, right? But OpenAI built Codex with safety first. It runs in locked down cloud containers with zero internet access, so it can't browse random sites or grab sketchy stuff. And Codex shows you everything it does. Log, test results, even when things go wrong, you can always stay in control. No surprise, just transparency. Now, who's already using Codex? This isn't just theory. OpenAI engineers live with Codex. They offload boring stuff like renaming, refactoring, writing tests, and fixing bugs, so they can focus on the cool, creative part. Cisco uses it to speed up features and untangle huge code bases. Superhuman speeds up testing and test product managers do small code tweaks without bugging engineers. Codex helps team work smarter and faster, cutting down distractions and keeping projects moving. Let's talk about the updates to Codex CLI and development experience. If you love working with the terminal, OpenAI launched Codex CLI, a lightweight open source assistant that brings Codex powers to your local workflow. They also made a smaller, faster version called Codex Mini for quick QA and editing. Perfect when you want instant help. Signing is in a breeze now. Just use your ChatGPT account, pick up your API organization, and boom, you're all set. Plus and Pro users even get free credits to start. Right now, Codex is rolling out globally to ChatGPT Pro, Team, and Enterprise users. Plus and education users, you are next in line. For API users, Codex Mini costs around 1.50 per million input tokens and $6 per million output tokens, with discounts if you reuse prompts a lot. Heads up, Codex is still in early days. It can't yet process images or change course mid-task, and remote task delegation takes longer than quick edits, but it's evolving fast and will soon handle more complex work. What's next? The future. OpenAI vision. Developers own the work they love and delegate the rest to AI agents, boosting productivity like never before. Soon you'll chat with Codex mid-task, guide it, get progress updates, and assign jobs from your IDE, GitHub, or issue tracker. Imagine a smooth, unified workflow where AI is your teammate across all your tools. Now, how does Codex stacks up against other AI coding assistants? GitHub Copilot is amazing for real-time code suggestions while you type, like a buddy sitting next to you. Codex works more like a remote teammate that handles entire coding tasks asynchronously. Writing features, fixing bugs, running tests, and submitting pull requests, freeing you up for bigger picture stuff. And GPT-4, it's great at code snippets and explanation, but Codex is trained specifically for software engineering, producing cleaner, more reliable code tailored to real projects. Together, these tools form an unstoppable AI coding dream team. But Codex's ability to multitask safely and transparently is pushing the limits of what AI coding can do. So whether you're a solo developer or a part at a team, Codex is here to change the way you build software. It's available now for ChatGPT Pro, Team and Enterprise with Plus and Education coming soon. Try it out, play with different tasks and see how it speeds up with your workflow, cuts headaches and makes coding way more fun. Now if you like this deep dive, smash that like button, subscribe for more tech news and drop your thoughts or questions about Codex below.
Welcome to the short course on Generative AI Models for Beginners by Simplilearn. So in this course, we will learn about the basic understanding of Generative AI. Then we will move on to the C applications of the many GenAI tools. And thirdly, we will understand the GenAI models and then we will create our first GenAI model. And then we will move on and see the real world impact of the generative AI models. And then we will create a chatbot using the GenAI model. And then we will conclude the course with the limitations of the GenAI models. And finally, we will see the future of GenAI models. Now, let us begin with the first chapter, that is basic understanding of generative AI. So, let us begin with what is generative AI. So generative AI is a type of artificial intelligence that creates new content such as text, images, music, or even code from scratch based on what it has learned. So unlike the traditional AI, which just analyzes or classifies data, like recognizing faces or recommending products, generative AI creates. It's like the difference between a judge and an artist. One evaluates and the other one imagines and produces. So let's break it down with a simple real-world examples. The first one is ChatGPT, that is a text generation. So what it does? So ChatGPT, like the one you are talking to right now, generates human-like conversations and answers. So you can ask it to write stories, emails, explain difficult topics, or even debug a code. For example, you say, write me a bedtime story about a robot and a unicorn. The ChatGPT creates an entire story for you on that particular spot. So let's move on and see DALL-E, that is for the image generation. So DALL-E creates pictures from words, that is the text prompts. Then artists and marketers use it to generate logos, illustrations, or more without hiring a designer. For example, you type a cat wearing a spacesuit on Mars and DALL-E draws it instantly. Now moving on to GPT-3, that is text plus logic task. So what it does? So GPT-3 is a powerful language model that can create and write essays, summary books, translate languages, and even write computer code. So developers use it in apps to create smart features like the AI writing assistant. So then you give GPT-3 a blog title and it writes the full article with an intro, subheadings, and conclusion. So after knowing all this, let's move on and see why are generative models. So generative models are changing the way we create content across multiple fields. So under the text field, we are writing books, articles, reports, or even poetry. And then we are assisting in the customer support with the chatbots. And then under the images section, we are helping the artists generate concepts and visuals. And then we are even handling the speeding up design and marketing content creation. And then under the music part, we are composing the background scores for videos or games. And then we are helping musicians brainstorm the melodies or the lyrics. And then finally, we write the boilerplate code under this coding section, debugging, or even creating full web apps. So now moving on, we'll see traditional AI versus generative AI. So let's compare both side by side with the simple explanations. So the main goal of traditional AI is to analyze and make decisions. And the main goal of generative AI is create new content. For example, under traditional AI, predicting stock prices or recommending books. on movies. And the generative AI, we are writing stories, generating images, and so on. So traditional AI handles data. It uses data to classify or forecast, and generative AI learns from data to generate something new. The traditional AI, it labels, scores, and categories as output, and generative AI, the text, images, music videos, and so on. For example, traditional AI is face recognition, fraud detection, spam filters, and generative AI is ChatGPT, DALL-E, Music LM, and so on. So down the line in the next chapter, we will see the applications of some generative AI tools like the ChatGPT, DALL-E, and GPT-3. So imagine this. You are working on a college project. It's late at night and the deadlines is tomorrow. You need a well-written report and a poster design and a clear presentation. So total chaos, right? But what if I tell you that there's an AI assistant that can help you with all of this in just minutes? So welcome to the world of generative AI. Today we'll explore how tools like ChatGPT, DALL-E, and GPT-3 are being used by the students, content creators, and professionals to do amazing things faster, easier, and smarter. So let's break down each tool and see how you can actually use them in real life. So this is ChatGPT 4.0. If you're not aware of what ChatGPT is, so ChatGPT is an AI chatbot that can create, write essays, summaries, articles, explain topics, solve coding problems, and even conduct mock interviews all through one single chat. So let's look at real ways you can use it. So ChatGPT model, it uses this GPT-4, the latest in the generative AI pre-trained transformer that is a GPT family. So GPT-4 is designed for more nuanced and human-like conversation. So have a look at the real ways we can use it. So the first prompt we are going to try is explain the greenhouse effect like I am in class 12. So basically this prompt is asking for the greenhouse effect explanation, and it is asking the ChatGPT to behave that it is explaining to a class 12 person. So we will give this. So you can basically see a human-like generation. Just like, sure, the greenhouse effect is a natural process that warms the Earth's surface. It happens when certain gases in the Earth's atmosphere trap the heat. Here's how it works. It will have a detailed explanation on the solar energy, Earth's surface absorption, greenhouse gases, heat trapping, and all. So after all this 4 points, it has also given without the greenhouse effect, the Earth would be too cold to sustain life. However, human activities like as burning fossil fuels, deforestation, and industrial processes. So you can basically think it has given one nutshell, and if you just understand this, you have a clear vision of what a greenhouse effect is. So the first point we can see over here is that it is like a own tutor. So the first point, we have just been to ChatGPT, that is founded by chat.openai.com. We have typed a question and we have got a simple and easy to understand answer. And even you can have a follow-up question. Like if I ask, is solar energy related to greenhouse effect? You can even have a follow-up question. Yes, solar energy is related to the greenhouse effect. So it's almost like its own tutor. So great for the late night cramming or the quick concept clarity. So this is it. And now moving on to the second thing that it can help with, that writing assignments or essays in just minutes. So we will ask ChatGPT, write a 350-word essay on climate change for college purpose. And you can see I have provided conditions. You can even customize it by saying make it simple and yet engaging and awesome. So it will basically create, it has even created a own title, a growing concern for our future. Climate change, it has created paragraphs, and basically you can even customize this word count and topic, then review the generated draft. You can even personalize it. Do you like this personality? And done and dusted. You can just have this. Now writing feels less stressful and it would be more fun. It can even give you an interview experience. For example, just imagine you are having your interview on the next Monday and you are preparing and you're very confused about what to prepare and what not. Then you can basically ask ChatGPT to behave like an interviewer for a particular job. I can even paste your job description from that particular company and you can ask that what are the probable questions I can have. So let's have a demo. Ask me 3 HR questions for a software development internship and suggest improvements. And you can even post this. And in no time, it has started generating. Here are the 3 HR questions for a software development internship. The first one, can you walk me through a recent coding project you have worked on and explain how you approach solving the problem? And you know what? This is a very, very common question. And it has given one tip also, suggestion. This question evaluates your problem solving skills, your technical ability, and how you approach development tasks. It gives the interviewer insight into your practical experience and thought process. So how do you manage the deadlines when working on the multiple projects or the tasks simultaneously? So this question assesses your time management skills and ability to prioritize the task. So the software development often involves juggling multiple assignments. So this gives the interviewer an idea of your organization skills. So this is very important. It has also written, how do you keep yourself updated with the latest programming languages and technologies? So basically this question looks after your own learning ability. So the self-improvement part. So it has even created one answer over it. And it has also suggestions for the improvement, provide specific examples, highlight the soft skills, prepare for the problem-solving questions, and so on. And for example, if I write, customize it with a data analyst fresher role, having no experience, what all the interviewer can ask me in the technical round, and it will give you answer in no time. HR questions for a data analyst fresher. Why are you interested in pursuing a career as a data analyst, and what are the steps you have taken to prepare yourself for this role? Can you describe a situation where you had to analyze data or solve a problem using numbers or data in your studies or personal projects? How do you approach learning new tools or technologies, especially when it comes to data analysis software? And then we have this technical question. What is the difference between the structured and unstructured data? What is data normalization? How comfortable are you with the data visualization tools? Can you describe a visualization you would use to represent sales data over time? Can you explain what a pivot table is when it is used in data analysis? And there are suggestions that you showcase your learning journey, focus on the problem solving skills, prepare for the basic technical questions. Since you are a fresher, the technical questions may focus on the fundamentals like the Excel, Python, that is the libraries, pandas, and so on. So in no time, it can even have a mock interview over here. So you can even create ideas over here. It can brainstorm you with the ideas available. For example, you have a group project and you want an idea. I'll type over here, give 5 creative ideas for a group project on sustainability. And if you post this, in no time it has created this 5 ideas. Sustainable packaging design challenge. Objectives: design a sustainable. It has created one objective, it has given one approach for you and one outcome. Then it has created community based urban garden, and for each topic, if you see, for each idea, if you see, it has created the objective, the approach and the outcome. So these projects can not only be educational but also impactful. So you never run out of inspiration from ChatGPT. So ChatGPT is a lot, and here if you can actually see, it has various search, deep search and create image, and you can basically do everything you want from ChatGPT. Let's now move on to DALL-E. The next we would be seeing is DALL-E. So DALL-E is an AI that creates images from text. You tell it what to draw and it generates the artwork, logos and visuals. So you would be getting DALL-E from this ChatGPT only, and in the Explore GPTs in the sidebar, you have to just mention DALL-E 2. So there are various versions of DALL-E, and we'll start chatting. And now if you close this sidebar, you can basically see DALL-E 2. So DALL-E is an AI that creates the images, and DALL-E, this model uses a version of the CLIP model, that is a contrastive language image pre-training, combined with the VQ-VA2 or other generative image models. So DALL-E creates images from the text descriptions, generating highly creative visuals based on the natural language input. So let's see how you can use it. So for example, you're going to design the college poster design. So instantly it would be done. So we would write create a poster for a college fest with DJs, neon lights and a crazy crowd, okay? And you can basically give the prompt. And in no time, it will create one great image for you. You can write and you can see it has created a great image. You can basically download this image and do anything. Here's the poster for your college fest featuring a vibrant DJ scene with the neon lights and the energetic crowd. So forget Photoshop, let AI do the heavy lifting. So then you can create presentations over here, adding better visuals. So I'll write, draw a cartoon showing water pollution in a river. And you can basically see this. Now you can insert it into the PowerPoint or Canva and design it on your own. It acts as a vector, it acts as an icon, and anything you want to act. Then you can instantly create club logos and branding. So you can even generate a logo for over here through DALL-E 2. Logo for a coffee club with books and steaming mugs. And you can see it has created a drastic logo and it feels like real. So you had just given one prompt and get 4 to 5 variations of logo. You can even ask it for a different version. So great for the student clubs or college events. Then you can even have it for the costume design or any ideas again. So we'll write futuristic costume design for a sci-fi play with glowing elements. And even you can see here, it has created a futuristic costume design for a scientific fiction play with the glowing elements. And it is very amazing. The qualities of the images are of high quality. And use vivid descriptions, use more detailed prompts, and you will get a great output from DALL-E 2. So, art students and theater class, this is your new secret weapon. So, let's move on to GPT-3. Our next genai tool is GPT-3. So, GPT-3 is the powerhouse engine behind the tools like ChatGPT. So it doesn't just chat, it can write full code, research summary papers, business emails, and more. So GPT-3 is a predecessor of GPT-4 based on the same GPT architecture but with a 175 billion parameters. It was one of the most advanced language models when it was released. So let's explore how it helps in the real world task. So initially, we can use ChatGPT because it is a ChatGPT 4 version. There is a GPT-3 is basically a predecessor of GPT-4. So I'm using ChatGPT over here. You can also use ChatGPT 4 to understand the GPT-3. So the first one is building websites without coding. So you can even write a HTML for personal portfolio with my name, bio, and contact form. And in no time, it has generated this. You can just copy it, paste it in VS Code or any of the code editors you like, and you can definitely get a proper output of this. Perfect for the beginners or the design students. Then you can even summarize a lengthy research paper. You can have to just upload the paper, and if you see this plus section, you can just click on this. You can just upload from your computer and summarize it in 2 seconds. It can even brainstorm you with the project and the startup ideas, like suggest 5 unique app ideas for college students. Now you can see the first one is Study Buddy Finder. Helps students find partners based on their courses, schedules, and many preferences. And you can even see Campus Event Hub, Course Material Exchange, Mental Wellness Check-in, Foodie Finder, and so on. It has even created bullet points for better understanding. So it is a noise-free study timer. Use it to kickstart your next hackathon or competition or anything. So I'm not dragging it more because as I have already showed you the use of ChatGPT. So that's it. Moving on to the next lesson of understanding the generative AI models. Imagine you are teaching a computer to be creative, like painting a picture, writing a poetry, or designing a dress. That's exactly what generative AI models aim to do. So learn from the data and generate new content that looks, sound, or feels real. But how do this pull off? Let's break it down into the 3 major families of models. The first one is GANs, that is the Generative Adversarial Networks. Then the second one we have is VAEs, that is the Variational Autoencoders. And the third one, the final one, is transformers like the GPT. So let's understand this in a detailed one. The first one is Generative Adversarial Networks, GANs, the artist versus the critic game. So how it works? Think of GANs like a competition between the 2 neural networks. The generator is like a rookie artist trying to create a fake art. The discriminator is the tough critic trying to tell the real art from the fake. So the artist creates random images. The critic says fake or real, and the artist learns to get better. So over the time, the fake images become indistinguishable from the real ones. So there's a real world analogy. It's like a student, that is a generator, forging a signature and a teacher, discriminator, spotting it. As both improve, the forgeries become nearly perfect. So there are certain applications. The first application is creating realistic human faces. Then style, the transfer in the art. And then we have fashion design prototypes. And then finally we have deep fakes, that is controversial but technically fascinating. And then let's move on to the challenges. So, training instability. The second one is it requires a lot of data and computing. So, moving on, we'll understand variational autoencoders, that is the VAEs, the data compressor with creativity. So, VAEs are like the compress and the rebuild systems. They take input data like an image, compress it into a low dimensional space that is called a latent space, and then reconstruct it. But here's the twist. The VAs don't just remember, they imagine. So by sampling different points in the latent space, they can generate new similar looking content. So let's move on and see the applications. First application is anomaly detection. So what doesn't fit in the normal data? Then the second one is generating handwritten digits and faces. And then we have data compression. And then finally we can see drug discovery, that is generating molecular structures. So now let's move on to the strengths. So more stable than the GANs, and it gives a well-structured latent space for the interpolation. So now moving on to the third model, we have transformer models, that is a master of the sequences. So unlike the GANs or the VAEs, which focus more on images, transformers shine in handling sequences, especially the text. The core data idea is attention mechanism, a way to let the model focus on the different words when generating a sentence. So for example, when GPT generates a sentence, I like ice cream because it's sweet. It pays attention to the context, understanding how because relates to the ice cream and sweet. So let's now move on to the applications. The first one is chatbots, like the ChatGPT. And then we have code generation, that is the GitHub Copilot. And then thirdly, we have language translation. And finally, we have summarization and content creation. And then let's move on and see why transformers stand out. So the first one is they scale data well. The second one is they can be fine-tuned on specific tasks like the medical summarization or legal drafting. Then finally we have they handle the long-range dependencies better than the older models like the Are Gans or the Lstms. Then we have a comparison and the use cases. So the first one is GANs, and it is best at image generation. And then we have an example use, that is the face synthesis. And the associated strength is high realism, and the weakness is it is hard to train. Then we are seeing the VAEs, and it is best at data compression, plus it is also good in anomaly detection. So it is used as a latent space exploration. And then coming to the strength, it is very stable training, and then coming to weakness, it has a less sharp outputs. So then coming to the model type, that is the transformers, and it is best at text and language. And then we have an example use, that is a ChatGPT and summarization. And then we have strength, that is powerful with the large data. And then we have certain weakness, that is expensive to train. Now moving on, let's clear something, which to use and when. So if you don't know which generative model to use for what, it can mess things up fast. So let's say you are building an app that needs to write emails, make pictures, answer questions, and turn speech into text. If you use the wrong model for the wrong job, your results will be poor, things will be slow, and you will waste time. So let's understand which models performs what. So for a sharp, realistic images, we are using GANs. And then coming to the next, for variation and latent space analysis, we are using VAEs. And then finally, for the language or the text-based task, we are using transformers. So finally, how do these models actually work? So the GAN training process is, the first process is generator makes the fake data. Then the step 2 is the discriminator tries to classify the real versus fake. Then the third step is both get better at their jobs with each round. So the final goal is to fool the discriminator with the realistic outputs. So the transformers under the hood pays attention mechanism. So it helps model understand which words matter more. Then we have self-attention, that is allows the model to look at all the words in a sentence at once. And then we have positioner, that is encoding, and it helps track the orders of the words as transformers don't read left to right like humans. So this is why models like GPT-4 can summarize, translate, and generate in text so well. So understanding the differences between these generative models is like knowing which tool to use for which creative job. So GANs are your digital painters, VAs are the smart compressors with imagination, and transformers are your text wizards. So down the line we'll see how to create our first generative AI model. In this chapter, we will be creating our first generative AI model. So the objective of this lesson is breaking down the steps of building a generative AI model using a pre-trained model. So we are here not training a model from the scratch. So instead, we will fine-tune or directly use a pre-trained model. So this makes it fast and beginner-friendly. So if I tell the steps in nutshell, we will be first choosing a pre-trained model. For example, GPT-2 because it is lightweight and good for beginners. The source from which we will getting the model is Hugging Face's Model Hub, and then we will be setting up the environment in Google Colab as you can see. Then we will be installing the libraries, the transformers, torch, and then loading the pre-trained model and the tokenizer. Then we will be writing a prompt and generating a text. So here we will be using the pipeline API for simplicity and parameters like max length and temperature. So let's begin. So here I am inside this Google Colab and I have chosen a new notebook to begin with, and then I'll just insert exclamation pip install transformers and shift enter. And it may take some time, and you can see it has actually installing all the required transformers. So pip install means install this package in Colab, and transformers is a library by the Hugging Face. So it gives us access to the powerful AI models like GPT-2, BERT and more. And then we will install from transformers import pipeline, and then we will be using the loading generator GPT-2 text generator. So generator equal to, and you can see pipeline text generation and tab. So we'll execute this, and basically this pipeline is a shortcut tool. It hides all the complex code needed to run the AI models. So here the text generation tells like, hey, I want a model that can write text for me, and GPT-2 is the actual model name. It was trained by the OpenAI to predict what word comes next in a sentence. And then basically you can see that it has model 7 tensors, 100%, has loaded everything, and the storage is also enabled for this repository. And then we'll begin with the prompt. Okay, so let's give the prompt and let's keep it very simple. Prompt equal to once upon a time in a world full of AI, comma. And then in the next line I will be writing result is equal to generator, and we'll be passing the prompt inside it, and then we'll be giving the max length, one parameter, and I will be specifying it as 100, and I will be giving the number return sequence, number return sentence is equal to 1, and I don't require this, so I will be directly printing the result. The first one, the first doc will print, and then we will be passing the generated text, and I will run this. And so the prompt I have given, this is a starting sentence you give to the AI, like saying, hey, start a story with this and this and this. So max length is equal to 100. So this particularly means generate up to 100 words or characters after the prompt. And then you can even see I have given this num return sequence is equal to 1. This is asking for just one version of the result. So you can basically ask for 2-3 versions. I have just asked for only one. And then the result you can see. And in the third bracket, I have given a 0 and the generated text. It extracts the generated text from the result. So you will see the AI write a continuation of your prompt basically. So that's your first generative AI output. You can basically see, once upon a time in the world of AI, your only limit was when you could kill monsters, but now you can for the first time ever. The new monsters are in the battle in the blood of elves now, not the usual black and white battles that you have experienced with the past couple of years, and it has created a great one. So you can even see the power of generative AI. It has that power of completing your text, your prompt. So then let's write result equal to generator and if I want to write prompt comma enter, then max length I will again mention equal to 100, then enter. I want the num return sequence equal to 1, and have to put a comma over here. Okay, so don't forget this, guys. And then temperature is equal to 0.7 comma top. Okay, don't worry, I'll explain one by one as I write. Equal to 50, then top p equal to 0.95 comma, then I'll write do samples equal to true, basically a boolean value. So then after this I'll print the result, print result, and in third brackets will be the first one, and then again third brackets will give in generated text, and then we're basically gonna shift enter. So here basically we have parameters like temperature. So temperature, what it does, it controls the creativity. This is lower is equal to safe and higher is the wild, and creative is 0.7 medium. So this top underscore k is equal to 50. So pick from the top 50 likely next words instead of just the top one. Then we have this top underscore p is equal to 0. It is the nuclear sampling, that is a more natural randomness. Then we have do sample is equal to true, that is enables the randomness. So without this the output is too predictable. So once you run this code, you will see something like, once upon a time in a world full of AI, and with every advancement in AI machines, there has been a change in the way we think about the world, and we need to make sure that we can make sure, and it has repeated it so many times. So every time you run it, you might get a slightly different result. So over here, you have used the Hugging Faces Transformers library to load the GPT-2. Then you wrote a prompt, and then the AI continued it using its training. So you did it without any complex machine learning setup inside the Google Colab. So this is your very first generative AI model. In the next chapter, we will be seeing the real world of impact of generative AI models. So generative AI is not just about another buzzword. It's fundamentally changing how businesses operate, solve problems, and serve customers. From generating product descriptions to designing aircraft parts, generating AI is stepping into roles that once required human creativity and intelligence. So in this session, we will explore how industries across the board are using generative AI in meaningful and practical ways. The first one is healthcare. That is a faster diagnosis and drug discovery. So in healthcare, generative AI is helping doctors and scientists make faster decisions. The first one is medical imaging. So AI can analyze medical images like the X-rays or MRIs and create reports to help doctors quickly identify the problems. For example, a hospital uses AI to write reports for doctors, cutting down the time spent on each patient. Then we have drug discovery. So AI helps scientists discover new medicines faster by predicting how proteins fold, which is important for the creating drugs. For example, a company used AI to discover a new drug in just 18 months, which usually takes much longer time. Then moving on to the next one, we have finance, that is a smarter risk management and report generation. So in finance, AI is making it easier to analyze data and detect the problems. The first one is automated financial reports. So AI can create financial reports based on data, saving time for analysts. For example, a hedge fund uses AI to write the market reports in minutes. Then we have fraud detection. So AI helps banks detect fraud by generating the fake transaction data to test their security systems, making them more reliable. So for instance, MasterCard uses AI to create realistic transaction data to improve their fraud detection system. So now moving on to the third, we have retail, and that is the personalized shopping experience. So retailers use AI to create personalized shopping experiences for customers. The first one we have is product descriptions. So AI writes product descriptions that are customized for different customer groups, such as casual descriptions for young buyers and formal ones for the professionals. For example, a clothing brand uses AI to automatically write descriptions for thousands of products. And then we have virtual try-ons. So AI lets customers try on clothes or makeup virtually to see how it would look on them before buying. So for instance, Sephora's app uses AI to suggest makeup and lets users see how it looks on their face using their phone camera. So now moving on to the fourth one, we have manufacturing. There is a faster design and maintenance. So AI is also making manufacturing more efficient. The first one is AI generated designs. AI helps create lighter, stronger parts for products, reducing waste and material costs. For example, an airplane company used AI to design parts that were 50% lighter but just as strong as the traditional designs. Then moving on, we have predictive maintenance. So AI helps factories predict when machines will need maintenance, reducing downtime and improving efficiency. For example, a factory uses AI to automatically create maintenance schedules for machines based on their performance data. So now moving on to the fifth one, we have education. That is a personalized learning for students. So AI is making education more personalized and accessible. The first one is AI tutors. So AI-powered tutors can help students with the homework by guiding them step by step through problems. For example, a student stuck on a math problem can get hints and explanations from an AI tutor available at any time. Then we have automated feedback. So teachers use AI to create quizzes and provide feedback on assignments, saving them hours each week. For instance, a teacher uses AI to review essays and provide comments in just minutes instead of hours. So now moving on, we have sixth one is entertainment, that is creating content at a scale. So in entertainment, AI is being used to create content faster and cheaper. First one is script writing. AI can help writers come up with ideas, generate dialogues, and even create storyboards before filming. For example, a filmmaker uses AI to plan scenes and create visuals before they start shooting, save time in the pre-production. So then we have virtual characters. So AI can create virtual characters that speak and act, which is useful for movies, games, and social media content. For instance, AI is used to create virtual influencers who interact with their followers on social media. So now moving on down the line, we will see how to create a chatbot in Google Colab. So before we dive into the code, let's first understand what the Hugging Face Transformers library is. So the Hugging Face Transformers library is one of the most popular libraries for the natural language processing, and it provides the pre-trained models that can perform a variety of tasks like the text generation, text classification, named entity recognition, and more. So here in the code, we will be using a model called DialogGPT Small, which is a variant of GPT-2 designed for conversation generation. So the DialogGPT was trained on the large conversational datasets, making it a perfect fit for building the chatbots. So let's now build the setting up the environment. So for this, we will install pip install transformers. So this line basically installs the Transformers library. You need this to work with the pre-trained models provided by the Hugging Face. So this will allow you to load the models like the DialogGPT we will be using here, a conversational AI model, and use it to generate the chat responses. And here we will begin with importing the necessary libraries. From Transformers, import the auto model. For the casual Llm auto tokenizer, import torch, and then we will run this. So here we are importing the necessary components like the auto model ID for the casual Llm. So this class basically loads a pre-trained model for the casual language modeling, which is used for the text generation task. So we will use it to load the DialogGPT model. And the auto tokenizer, the tokenizer converts the text into tokens which are known as numbers, that the model can process and then converts the model's output back into the human readable text. So the torch is then, PyTorch is the deep learning framework used by the model. It's used for the tensor manipulations as models rely on these tensors for the input and output. So let's begin. Then we will begin with the loading the model and the tokenizer. So here this converts the raw text, that is the user input, into tokens. Into that model understands. So each word or phrase is mapped into the unique ID, making it easier for the model to process and generate a response. So then model is that pre-trained DialogGPT small model is loaded over here. So this model has been trained on a large corpus of dialogues, which enables it to generate the relevant responses in a conversational manner. So then we will begin with the chat initialization. And before beginning with the chat initialization, we will see that the tokenizer config JSON is 100% complete, and the best part of Collab is it will give you all the status of how it is complete and for which particular merges.text.vocab.json which is completing and what problem is there. So let's just run this and let me explain. So chat history IDs. So this is a variable where we store the history of the conversation. So this helps the model maintain the context across multiple user inputs. Then we have having a print statement that start chatting with your AI, type quit to exit. So this provides a welcoming message to the user to start chatting and gives the exit command. So then we will begin with the chat loop, that is the main logic of the chatbot. So then we'll begin with this chat loop logic. So we have written for step in range 5, user input is equal to input and then u and then semicolon and then a space. And then we have written if user input dot lower is equal to quit, then I have to break it. Break the loop. Break. So then I'll run this. And this section of the code basically uses input to get the user's message and exit condition. If the user types quit, the loop will break and the chat ends. So let's see. And here basically you can see I have written hey and still it doesn't break. So let's write quit over here and let's see what happens. So you can see that it has stopped generating, means it has got out of the logic. So here we have this encoding user input. So encoding the user input is converted into token IDs using the tokenizer dot encode. So the EOS token, that is the end of sequence token, is added at the end of the user input. This tells the model that the input has ended and it prepares for generating a response. Then tensors. So this is the return underscore tensors equal to PT. That part ensures that the encoded input is returned as a PyTorch tensor. This is the format that the model expects. So we will run this. And then we will be moving on to managing the conversation in history. So here we are having this managing conversation history and it is up to maintaining the context. So we want to keep the track of the conversation history so that the model can respond in context. So if there's previous chat history, that is the chat history IDs, it is concatenated with the new input, allowing the model to consider the entire conversation so far. So if there is no previous history, that is the first user input, the new input IDs are used directly. So then we will be moving on to generating a response. So here we are concentrating on generating a response. Chat history IDs is equal to model generated bot input IDs, max length equal to 1000 and pat token ID is equal to tokenizer dot EOS token ID. So model response, so this part sends the concatenated input to the model, that is model.generate, and generates a response. The maximum length specifies the maximum length of the generated text. So in this case, it is set to 1000 tokens. Then we have pad token ID, that is ensures the padding tokens are handed correctly. That is the model needs to know which tokens are just padding. Then we will be moving on to the decoding the response. And here we are seeing response is equal to tokenizer dot decode chat history, IDs, there is a bot input IDs dot shape and everything. So basically decoding this generated token IDs are converted back into the human readable text using the tokenizer dot decode. Then we have skip the special tokens. The skipped special tokens is equal to true. It ensures that any special tokens like the EOS are not included in the final output. So we will run this. And then finally, we are actually printing the response, that is displaying the response. So the print, this generating the response is displayed to the user. So we'll run this and you can see bot, I'm so sorry. So what happens when you run this code? You initiate the chat and the bot welcomes you to start chatting. So every time you input something, the bot takes your message, encodes it and sends it to the model along with the conversation history. The model generates a response considering the entire conversation so far, and the bot outputs that response. So this loop continues until you type quit, ending the conversation. So, building a chatbot is essential because it enhances the user engagement by providing the real-time, personalized interactions, making it more dynamic and the user-friendly compared to the static content. So, chatbots are available 24/7, ensuring the users can get immediate responses at any time. So, by automating the repetitive tasks like answering common questions, processing orders, or providing basic customer support, chatbots free up valuable resources, allowing human employees to focus on more complex tasks. So then, additionally, chatbots can improve customer satisfaction by quickly resolving the inquiries, reducing the wait times, and enhancing the overall user experience. So implementing the context management allows the bot to remember the previous interactions, ensuring a continuous and more personalized experience for the user. So finally, enabling the multi-turn conversation handling means the chatbot can engage in back and forth dialogues rather than only answering the isolated questions, so making it feel more conversational and human-like. So these features collectively help create an intelligent, efficient, and engaging chatbot that can significantly improve user interactions and streamline the business operations. So you can even fine-tune your own model. So this could be your own dataset to make it more specific to a particular domain or a use case. You can even make it worth handling the longer conversations so that it remembers the chat history for a long time. So guys, you have made your first chatbot and down the line, let's get improved. So in this lesson, we will understand about the limitations of generative AI models. So the first one is lack of understanding. So AI models generate content by predicting what comes next based on the patterns in data, but they don't truly understand the content. For example, when an AI creates an article or a code, it doesn't know what it's writing. It's just mixing patterns based on the past data. Then moving on to the dependence on the data quality. So the AI's performance is only as good as the data it's trained on. So if it has biased or incomplete data, it can generate biased or inaccurate results. Think about biased hiring algorithms or flawed healthcare recommendations, real issues caused by the bad training data. So now moving on to the third one, we have creativity limitations. So AI can produce impressive creative outputs like artwork or music. So however, it struggles to innovate or produce truly original ideas like a human artist would. It's more about remixing the existing content rather than inventing something groundbreaking. Now moving on to the next, we have ethical concerns. So AI models can sometimes generate harmful content, from offensive language to deep fakes that are hard to distinguish from the real footage. So this poses risk for misinformation and ethical dilemmas especially in media and entertainment. So now moving on to the next, we have context and nuance. So generative AI can miss the subtle nuance in conservations or emotions. For instance, if you asked a model to help with the sensitive topics like mental health, it might offer advice that's generic and more tailored to the individual's emotional needs. Next, we have cost and resource intensive. So training a generative AI model requires huge amounts of computing power, time, and energy. So these models often run on the powerful servers, consuming a lot of resources, which raises concerns about the sustainability and the environmental impact. So now moving on to the next one, we have limited problem solving capabilities. While generative AI is great at tasks like writing essays or summarizing text, it's not well suited for the task requiring the deeper reasoning or the complex problem solving. It can simulate problem solving, but it doesn't truly understand the solution in the way humans do. Now, moving on to the next one, we have risk of over-reliance. So with AI generating more and more content, there's a risk of becoming too dependent on the technology. So people might rely on AI for the tasks that require human expertise or critical thinking, which could hinder the personal creativity or decision making. So now moving on, we have data privacy issues. So AI models can sometimes generate content based on the personal data, raising concerns about privacy. So this is especially problematic in the areas like healthcare, where sensitive data can be inadvertently shared or misused. So now moving on to the next one, we have generalization challenges. So generative models are great at specific tasks, but struggle with the broader generalization. For instance, a model trained to generate images of the cats may struggle to create the convincing images of a completely different animal, showing that AI is limited in its flexibility. Now moving on down the line, we will understand the future of Gen AI models. The first one is improved understanding and comprehension. So that the future of generative AI will likely see models that can understand the context more deeply, providing more relevant and meaningful outputs. So we might see AI models that can truly comprehend the meaning behind the responses, rather than just spitting out the data. So next, we'll move on to the enhanced creativity. So as AI models evolve, we can expect them to push boundaries and become more innovative. So with advancements in the techniques like the reinforcement learning and neural architecture search, we could see AI producing truly original content, potentially revolutionizing fields like the art, music, and literature. So now moving on, we have more ethical AI. So in the future, we will likely see more regulations around AI usage to prevent the harmful outcomes. So AI companies are already working on improving the transparency, reducing bias, and making their models more ethical and responsible. So now moving on, we have better personalization. So the future holds AI that can offer more tailored, personalized experience. So imagine an AI that truly understands your needs and preferences. So providing you with the content, products or services that feel personalized and relevant. Now moving on to the next one, we have energy efficiency. So as the demand for the generative AI grows, researchers are focusing on creating more energy efficient models. We may see smaller, more powerful models that can run on less computational power, reducing the environmental impact. So next we have human AI collaboration. So rather than replacing humans, the future of generative AI models is likely to be centered on collaboration. So we will see AI helping people be more productive, augmenting creativity and providing insights that humans can use to make better decisions. So now moving on to the next, we have integration with the new technologies. So generative AI will continue to integrate with the new technologies like augmented reality, that is the AR, then the virtual reality, that is the VR, the blockchain, and opening up new possibilities for the immersive experiences and the decentralized applications. So now moving on, we have solving complex real world problems. So in the near future, we could see AI models working alongside scientists to tackle the big challenges like climate change, pandemics, and global food security. So AI could help analyze data, predict trends, and offer innovative solutions to these pressing problems. So now we'll see the next one. We have more accessible AI. So as technology advances, AI will become more accessible. Tools will be easier to use, and people from all the walks of life, not just the technical experts, will be able to harness the power of AI to create and innovate. So while generative AI models are still evolving, their potential to transform the industries, enhance creativity, and solve the complex problems is undeniable. But it's important to address their limitations and work towards creating more ethical, efficient, and responsible AI systems. So the future is exciting and we are just getting started. So guys, congratulations on completing the Gen AI Models for Beginners course by Simplilearn. You have now built a strong foundation on the generative AI models by learning what generative AI was, how it impacted the real world, then creating chatbots, creating your first Gen AI model, and then finally closing it with the future of Gen AI models. So as you move forward, continue experimenting with your own data sets and refining your own pipeline to unlock the full potential of Gen AI in creating smarter, context-aware Gen AI systems and models.
In this video, we will walk you through how to set up and use OpenAI's powerful language model using Python. Whether you are a beginner or just looking to refresh your skills, you'll learn how to get your API key, configure your environment, write your first script, and interact with models like GPT-4o Mini, GPT-4o. So guys, if you want to learn more about it, watch this video till the end. So guys, let us start with first understanding what exactly is LLM. LLM stands for Large Language Model, which is a type of artificial intelligence trained on vast amount of text data to understand and generate human-like language. These models, such as OpenAI's GPT or Meta's Llama, use deep learning techniques to analyze context, predict the next word in a sentence, and also provide intelligent responses to text inputs. Unlike traditional rule-based systems, LLM learns patterns, grammar, facts, and even reasoning skills from the data they trained on. In simple terms, LLM can read and write text almost like humans, making them incredibly powerful tools for building intelligent applications. Now, let us move ahead and try to understand some of the real-world applications of LLM. So, the first one are chatbots and virtual assistants. Apps use LLMs to power smart conversation with users, whether it's customer support, booking assistance, or mental health guidance. LLM help deliver human-like, helpful interactions. The next one we have all over here is content generation. From blog intros to product descriptions, LLM can generate content at scale, making them valuable for marketing apps and writing tools. Next, we have summarizations and insights. Apps like news aggregator or legal tools use LLMs to summarize long documents into digestible insights. Next one, we have code generation. Developers focus to use LLMs to auto-generate code snippets, help debug errors, or explain programming concepts. And finally, we have language translation and correction. Language apps leverage LLMs to provide real-time translation, grammar correction, and learning suggestions. Overall, LLMs enable apps to understand and respond to user inputs with remarkable fluency, making them central to next-gen user experiences. Now, let us discuss about some of tools and framework from where LLMs can be made. So guys, depending on your preferred programming language and project type, here are some of the key things. If I talk about Python guys, it is widely used for quick prototyping with LLMs. Libraries like LangChain, Transformers and OpenAI make it easy to connect with LLM APIs. If we talk about Node.js guys, it is ideal for web-based apps and backend services. We can use packages like OpenAI, Axios or LangChain. Now let us discuss something about LangChain. So LangChain is actually a popular framework which simplifies working with LLMs. It handles prompt templates, chaining multiple steps, memory management, and even data retrieval. And you could easily integrate with the front-end frameworks like React, Vue, or Flutter for building the user interface that interacts with LLM via APIs. So guys, now let us set up our environment. But before that, you need to make sure that you have Python installed on the system. So I'm basically using Windows operating system and I'm at command prompt. So I will just type Python V, check the version of Python. So guys, as you can see, I have already installed Python in my system. But if you don't have Python on your system, then you need to install it. You can watch our Simplilearn's video where we have installed Python on Windows operating system. Now, after that, what you need to do is guys, you need to run this bash script. Now guys, let us create our virtual environment. So for creating our virtual environment, you can type python /m vnv llm env. This is the name of our virtual machine. Just right click on this. Okay. Now let us activate our virtual machine. Now after that, what you need to type is llm env, the name of your virtual environment, /script /activate. Now this will enable your virtual machine, which is llm env. Now after this, what we have to do is we have to download one of the important libraries. So let us download it. So guys, I'll tell you one of the most secure way. So you'll be using API keys of ChatGPT all over here. So I'm not using .env, but still I would suggest for security reason to always create a .env file. So for the same purpose, what we are going to do, I'm going to install OpenAI python.env. So this package will help you manage your API's key very smoothly. Just right click on this and it is going to install the .env package. Now after that, let us set our API key. So guys, go all over here. So create a new secret key. Let us give it as name as LLM test. So you have to go on platform.openai/API/keys. So this is the link where you will create your secret key. Now you create your secret key all over here. Copy this, okay, and just add in your .env file in your project structure. So guys, after copying that, what you need to do is you need to set your API key. So there are two ways to do it. One is very simple way, which I would not suggest it. Like just create a variable and paste your secret key. The next is using .env. So by creating a .env file and setting your variables and then pasting your given API key. That is one of the good things. Now let us go all over here. Just copy this. Now guys, after creating this variable, just paste your given API key. Right click on this and our API key is set. Now guys, what you need to do is open a notepad and this is just for simple demonstration. You just type this code. Now let us discuss about this code for a minute to understand what is going on all over here. So guys, as you can see all over here, I have imported OpenAI and I have also imported operating system. Okay, so this OS module OpenAI repeat. So guys, this OpenAI Python library, you can use it with the OpenAI's API. Then we are also importing OS module to interact with the environment variables on our system. Now finally, what we are doing is OpenAPI.API key equals to os.getEnv and OpenAPI key. So this line gets your OpenAPI key from an environment variable called OpenAPI key. Okay, and And it also sets it to the library who knows how to authenticate your request. You need to have this key set up in your system environment variables before running the code. Now next, we have response equals to openai.chat.completions.create, and here I have added my model. So if you are not having paid account, then it will be bit troublesome for you, because there are different kind of models, and like 4.0 basically comes at a charged prices. So get your plan upgraded and your billing plans, so because based on that the number of tokens are there. In that way your API call is going to happen. Now here you could see I have written the messages as role, system, content, your helpful assistant, role, user, content, hello, can you assist me using GPT-4o mini model. So basically what we are doing all over here is I'm calling the OpenAI chat completion API to create a method. First of all, I specified my model, which is basically optimized for faster responses for mini, and then there is a message parameter which simulates a chat conversation. The system message sets the assistant's behavior, like you are a helpful assistant, and there is a user message which is asking the model, hello, can you assist me using the GPT-4o mini model. So basically this prints out the content of the first response message generated by model, and the API returns a list of choices, usually just one, and you can access the message text from the first choice. Now this script basically sends a chat message to the OpenAI GPT-4o mini model and prints the model's reply. It uses your API key stored in the environment to authenticate and perform the request. So this is how basically this is happening. I hope so guys you would have got a brief idea regarding this code. Okay. Now after this you need to go to your designated folder. Okay. So I have saved my given file in C users SLP13089. Now going to documents. Okay. So inside this I have this folder called app.py. Now I'm going to run the given file. Now just right click on this and let's see what happens. You can see we are getting some error. Okay, you can see the message here is code is 429 and my quota is exceeded. Okay, I need to upgrade my plan, and this is generally going to happen if you have not upgraded your plan, because the number of API calls are already set. But this is something very much feasible. Now let me tell you what will be the output of this program. So you could see all over here that in the user it's asking the content as hello, can you assist me using GPT-4o mini model. Now the answer would be yes, I can definitely assist you using the GPT-4o mini model. How can I help you today? So that is a kind of a simulated reply that we are going to see in our given output, and this is a very simple way of integrating LLM model. So in this way you are going to get the output. Okay, I hope so you would have got a brief idea how you could integrate LLM models into your given project. So that is one of the way. Now let us move ahead and discuss about some of the more key concepts all over here. Now let us discuss about designing effective prompts. Crafting a strong prompt is key to unlocking accurate, relevant, and context-aware responses from large language models. And here are some essential guidelines to help you write better prompts. First of all, be clear and specific. Vague instructions often lead to generic or confusing answers. So instead of asking explain AI, a clearer version would be explain artificial intelligence in simpler terms for a high school student. This not only narrows down the scope but also defines the complexity level and target audience, helping the model tailor its response accordingly. Next one we have define the role or tone. LLMs can adopt different styles or personas based on your prompt. For instance, saying you are a career coach, give advice to a fresher looking to enter data science will lead to more structured and empathetic guidance. You can also adjust tone, formal, casual, humorous, or technical tone based on your app's use case. Next one we have is called providing context. If your prompt depends on previous information or has multiple parts, provide that background clearly. For example, given this resume summary and job description, write a tailored cover letter in 100 words. This example helps the model understand relationship between inputs and generate more relevant output. So guys, keep this in mind while you are designing an effective prompt. Now, let us discuss some of the effective prompting techniques. First one we have is zero-shot prompting. Now, here you give only one instruction with no examples. Like, for example, here you will say, translate the sentence to French. How are you? Okay, this is great for simple or well-known tasks. So that is called zero-shot prompting. Now, let me tell you one more prompting technique which is called as few-shot prompting. Now, here you have to provide 1 to 3 examples to set the format or tone. Like for example, English hello to Spanish hola, then good night to buenas noches, or basically you say hello and then in Spanish you add hola. So this helps guide the model and also it improves the consistency. Now, the final one that we are going to discuss, that is called chain of thoughts. Now, prompt the model to think step by step. So this is all about chain of thought. For example, if you say like if a train leaves at 3 p.m. and travels for 2 hours, what time will it arrive? So let's think step by step. This is ideal for reasoning, heavy tasks like math, logic puzzles, or multi-step questions. So guys, mastering these techniques will make your LLM-based app more intelligent, reliable, and it will be tailored to user needs. Now let us discuss about future scope and advanced topics. So as you grow more confident with building LLMs, there are several advanced techniques and future-ready capabilities you can explore to build smarter, more specialized applications. These methods help overcome limitations of generic LLMs, making them more accurate, efficient, and customized for your specific needs. Now, let us discuss about these parameters because these are the future scope which could help you improve your LLM. The first one we'll talk about fine-tuning versus prompt tuning. So fine-tuning basically involves retraining base model on your own dataset. This is useful when you want the model to understand industry-specific language or behave in a certain way consistently. However, it's resource intensive and usually requires large datasets and GPU support. If I talk about prompt tuning, guys, on the other hand, it's kind of lightweight. It focuses on crafting or learning optimal prompts, often called soft prompts, without changing the underlying model. It's faster, cheaper, and works well for specific tasks like classification, summarization, or form filling. Use fine-tuning when you need deep domain adaptation. Use prompt tuning for faster task-specific improvements. Now, next thing what you could include is RAG. So, if I talk about RAG, so RAG stands for Retrieval Augmented Generation. This basically combines the power of LLM with a knowledge retriever. So instead just relying solely on the model's internal knowledge, RAG, what it does, it pulls the real-time external data like PDF, websites, or databases, okay, to provide grounded and up-to-date answer. For example, let's say if you are saying to ChatGPT, like summarize the latest policy from this PDF. Okay, so if you give a government-generated PDF and you want to know what is the latest policy with certain regards, so the retriever fetches the relevant text and the LLM is going to summarize that. So this is how RAG actually is very useful, and this is one of the future scopes of LLM. The third thing, how to improve it, is by connecting to the external data. One of the most exciting advancements in LLM app development is the ability to connect the model to external data sources. So by most default, LLMs like GPT-4 generate responses based on static pre-trained knowledge. But real-world applications often need to access up-to-date, domain-specific or user-generated data, which is where this integration becomes essential. So instead of relying only on what the LLM knows, you can dynamically feed it information from various data systems, making your app smarter, more relevant, and context-aware. Examples of external data sources can be you could connect to databases like SQL or MongoDB, retrieve customer records, inventory data, transaction histories, etc. and let the LLM analyze or summarize them. The next one is cloud storage. So you could use Google Drive, Dropbox, AWS S3. Rate documents, PDF, or spreadsheet and answer questions about their contents. Third one, if we talk about, is knowledge bases. Notion, Confluence, SharePoint are those things. Pull the internal wiki pages or team documentation into the LLM for better organizational support. Third one will be APIs and web scraping. Bring in live weather data, stock prices, policy updates, or even product listings from e-commerce sites. Then you have search indexes like RAG. It uses tools like Llama Index, LangChain, or Haystack to retrieve and inject relevant information into the prompt before LLM generates a response. Now guys, why does this matter? Because these are the future scope or where our LLM advancement is heading up to. And these capability will turn your app into live knowledge connected assistant, capable of answering user queries with real-time accuracy and deep customization. And this becomes very much useful in scenarios like customer support bots, enterprise dashboards, research tools, or intelligent CRMs. So guys, by building LLM-powered application, it's just not a trend. It's a transformative shift in how we design intelligent, user-centric software. From setting up a basic prompt response interface to mastering prompt engineering and exploring advanced techniques like RAG, external data integration, you now can understand how LLMs can unlock powerful capabilities in your application. So guys, whether you are creating a chatbot, research tool, or an internal assistant, you are no longer just encoding. You are designing intelligent conversation, keep exploring, and keep fine-tuning. And let the power of language model elevate your ideas into smart and dynamic experience.
Imagine you are managing a global supply chain company, and where you have to handle orders, shipments, and demand forecasting. But unexpected issues arises where sudden shortages like transport delays and the changes in demand. So instead of relying on manual adjustments, what if an AI agent could handle everything automatically? This AI wouldn't just suggest actions, it would decide, execute, and continuously improve its strategies. That's the power of Agentic AI. With that said guys, I welcome you all on our today's tutorial on what is Agentic AI. Now, let us start with understanding first the first wave of artificial intelligence, which was predictive analytics, or we could say data analytics and forecasting. What exactly happened? Predictive AI focused more on analyzing the historical data, identifying the patterns, and making forecasts about the future events. And these models do not generate any new content, but instead it was predicting outcomes based on the statistical models and machine learning. Now, technically how it used to work? So basically what we had, we used to take, suppose this is the ML model, okay? So this is taking a structured data, which could be suppose any past user activity, or it could be a transaction record, or any sensor reading. For example, you can consider, say, Netflix users' watch history, okay? It could be any movie genre, watch time, and the user rating. So now, after this, what we were basically doing is, we were doing the feature engineering or pre-processing, okay? Now, in the feature engineering process, we were extracting key features like user watch time trends, preferred genres, and watch frequency. And we could also apply scaling, normalization, and encoding techniques to basically make data more usable for the ML model. Then we were using the ML models. Suppose it could be a time series forecasting models like ARIMA, Lstm, and all those given algorithms, which was basically predicting the future movie preferences based on the historical data. And in the output, guys, Netflix AI recommends new shows or movie based on the similar user patterns. So this is how exactly the Netflix model was working, incorporating the machine learning model. So this was exactly the first wave of AI. Now, let us discuss about the second wave of AI. Now, if I discuss about the second wave, which was basically content creation and use of conversational AI. So, LLM models like ChatGPT became very much popular during the second wave of artificial intelligence. So what exactly was happening? Generative AI was taking input data and it was producing new content such as text, images, videos, or even code. And these models learn from patterns in large data sets, and it was generating human-like outputs. Now, let us understand how exactly this technology was working. So basically, first there was a data input. Okay, so basically any prompt from the user. So suppose in the GPT, okay, so I'll just open GPT all over here and say we are, suppose we are giving any new prompt, say such as write an article on AI. Okay, so this was our given prompt, and after this, what exactly was happening was tokenization and pre-processing. So the input text, suppose which I have written all over here, write an article on AI. So this text was basically split into smaller parts. For example, like you could consider certain thing like this. So here you have write as one, and as next. And similarly, you could carry on, for the other words. Then what exactly used to happen that these words were, converted into word embeddings, means the numerical vectors representing words like in a higher dimensional space. And then we used to perform neural network processing. So here the LLM processes input such as attention mechanisms, okay, or using these models like GPT-4, BERT, and Llama. And with the help of self-attention layers, they were understanding the context and they were predicting the next word. Okay. Now, as a result, you are getting output certain thing like this. So, which was basically a generative AI phase. So this was, guys, our second evolution of AI. Now, if I talk about our third wave, so it is basically agentic AI or autonomous AI agent. Now, what is this, guys? So the agentic AI actually goes beyond text generation. So it integrates decision making, action execution, and autonomous learning. These AI systems don't just respond to prompts, but they also independently plan, execute, and optimize the processes. So you could understand something like this. So here the first step was the user input or receiving any goal. So user provides any high-level instruction. For example, it could be like, say, optimize warehouse shipments for maximum efficiency. It could something be like that. And unlike generative AI, which would generate text, agentic AI executes real-world actions. After this, suppose the prompt that we have given, like optimize warehouse shipments for maximum efficiency, then the next step would have been querying the databases. The AI would pull the real-time data from multiple sources. So it could be traditional database like SQL or NoSQL, where we are fetching inventory levels or shipment history. Then it could be a vector database from where it is receiving some unstructured data like past customer complaints and all those things. Then with the help of external APIs, it is connecting to like forecasting services or fuel price APIs or supplier ERP systems. And these things are like present with this respect. Then the third step was the LLM decision making. Now, after querying the database, the AI agent processes data through the LLM based reasoning engine. Example like decision rules applied, like suppose if inventory is low, then it could automate supplier restocking orders. Like if shipment cost is increasing, then it is rerouting shipments through cheaper vendors. And suppose also if weather condition impacts the route, then it is adjusting the delivery schedules. Now you can understand how agentic AI is behaving all over here in the decision-making process. Now, next step would be action execution via APIs. So AI is executing tasks without human intervention. It is triggering an API call to reorder a stock from a supplier or update the warehouse robot workflows to prioritize fast-moving products, or even send emails and notifications to logistic partners and about the changes, what is going to be happening. And after this, finally, it is continuously learning, which is a data flywheel all over here. Okay, the AI is monitoring the effectiveness of its action, like it was restocking efficient or did routing shipments, reduce the cost and all. So it is monitoring the effectiveness of the action it has taken. And the data flywheel is continuously improving the future decisions. So basically it is using reinforcement learning and fine-tuning to optimize its logic. Okay. Now let's have a just quick recap about the comparison of all these three waves of AI. So basically, predictive AI's main focus was on forecasting the trends. Okay, while generative AI was creating the content, and agentic AI on the other hand, which is at the final step right now, is making decision and taking action. So you could see how the evolution happened of AI in all these stages. And if you understand about the learning approach, then predictive AI was basically analyzing the historical data, while generative AI was learning from the patterns like using text, image generation. Okay, and but agentic AI is basically using the reinforcement learning or the self-learning to improve its learning approach. Now, if we just look at the user involvement in predictive AI, so human is asking for the forecast and all. Here, human is giving the prompts, but in the agentic AI, the prompts or the intervention of human input has become very much minimal. If you could understand the technology, like basically predictive AI was using machine learning, time series analytics, so these kind of algorithms they were using. Generative AI was using transformers like GPT, Llama, BERT, and all those things. Now, agentic AI is doing what, guys? It is using LLM plus APIs plus autonomous execution. So we have discussed how this workflow is, in a short way, how it is working. And moving ahead, we are also going to discuss through an example how exactly all these steps like agentic AI is working. So based on the example, you could understand like predictive AI, Netflix recommendation model which they have on their system. And similarly, if we talk about generative AI, then you could understand about ChatGPT, writing articles and all those things. And agentic AI, we could imagine like how AI, if incorporated in supply chains, how things are working out. So guys, I hope so you would have got a brief idea regarding the three waves of AI. Now let us move ahead and bit understand about what is the exact difference between generative AI and agentic AI. Now guys, let us understand the difference between generative AI and agentic AI. So let us first deep dive into what exactly is a generative AI. Okay. So as you can see all over here that generative AI models generally are taking input query, okay, and they are processing it using LLM or large language model and basically returning a static response without taking any further action. So in this case, for example, a chatbot like ChatGPT, it is taking the input from the user. So as I've shown you earlier that suppose I've given an input like write a blog post on AI in healthcare. So when I have written this given user input or given the query, so when it goes to the large language model, this model is actually tokenizing all these input query, and it is retrieving the relevant knowledge from its training data, and it generates text based on the patterns. Now we give the prompt, then LLM processes it, okay, and then we are getting the given output. So now this is basically how generative AI is working. So you could see all over here we have GPT model, we have DALI, we have Codex. So these are some of the amazing generative AI models. Okay. Now let us discuss a bit about DALI, which is actually a realistic image generation Gen AI. So like DALI is described as the realistic image generation model by the OpenAI, and this actually is a part of generative AI category alongside with GPT, which is basically for human-like language creation purposes. This model was created. And you could have also Codex for like, it could be used for advanced code generation purposes. So let us discuss a bit about DALI. So DALI is like a deep learning model, basically, which is designed to generate realistic images from the text prompt. And it can create highly detailed and creative visuals based on descriptions provided by the users. So some of the aspects of DALI, like you could have all over here, like text to image generation, where users can input text prompts and DALI can generate unique images based on those description. The images generated by DALI are highly realistic and creative. Okay, and it can generate photorealistic images, artistic illustration, and even surreal or imaginative visuals. We will also have customization and variability, where it is allowing variation of an image edits based on text instruction and multiple style. So this is also part of a generative AI model, and this tool is actually playing a very amazing role. So I will show you one example like how generative AI is actually working in the image generation purposes. So guys, as you can see all over here, I have opened this generative AI tool called DALI. Let us give a prompt to DALI and let us see how the image is generated. So let's say we want a futuristic city at sunset filled with neon skyscraper. Say have flying cars and holographic billboards. The streets are bustling with humanoid robots, and we can have people wearing let's just say high-tech, let's include some technology. Okay, now let us see how DALL-E is trying to create an image. So this is how actually generative AI is working. So let us wait for a few seconds as the output comes up. Now you can see all over here that this image which is generated, basically this is generated by AI, and you could see based on our prompt, it has given like the kind of the input we gave, and we got the output based on this. Now, so this is one of the amazing Gen AI tool. We could explore this, guys. Okay. Now, guys, let us discuss about agentic AI, or autonomous decision making and action execution. So you can see this diagram all over here. So agentic AI, like unlike the generative AI, it is not generating responses, but it is also executing a task autonomously based on the given query. For example, like if we take AI in managing a warehouse inventory. Okay. Suppose we want to optimize the warehouse shipment for the next quarter. So here what is going to happen? So first the agent is going to receive its goal all over here. Okay. And this AI agent is going to query the external data sources. So it could for example, it could be your inventory databases or logistics API, and then it retrieves real-time inventory levels and it demands the given forecast. Okay, now at here it is going to make the autonomous discussions, and the kind of output we are going to get will be kept in observation by this agent. Okay, so basically it is going to analyze the current warehouse stock, predict demand for the next quarter, check the supplier's availability, and automate the restocking if inventory is below the given threshold. So for example, you could imagine suppose based on the output what we are going to get all over here. So based on this output we could get certain thing like this, like say current inventory level, like say 75% capacity. Okay, then it could have also other thing like say demand forecasts, say 30% increase in expected in quarter 2, and also it is going to go say reordering initiated. So this is the output what we are going to get based on the supply chain management example what we are trying to get. So as we have seen in generative AI, user is giving the input, okay, prompt, then it is using a LLM model to generate the given output. But agentic AI is doing what, guys? It is going to take action beyond just generating a text. So in this scenario, it is querying the inventory databases, it is automating the purchase order, it is going to select the optimal shipping providers, which could be suitable for the given company. It is going to continuously refine the strategies based on the real-time feedback. So guys, let's recap once more. So if we talk about the function base, then Gen AI is more concerned with producing a written content or a visual content, okay? And even it can code from the pre-existing input. But if we talk about agentic AI, guys, it is actually, it's all about decision making, taking actions towards a specific goal, and it is focused on achieving the objectives by interacting with the environment and making the autonomous decision. Gen AI is exactly relying on the existing data to predict and generate content based on, say, patterns it has learned during its training phase. but it does not adapt or evolve from its experiences. Whereas if I talk about agentic AI, it is adaptive. So it is learning from its actions and experiences. It is improving over time by analyzing the feedback, adjusting its behavior to meet objectives more effectively. With the help of Gen AI, human input is essential to the prompt, so that basically with the help of that, it could go into the LLM model and it could generate the given output based on your prompt. Once you set up the agentic AI, it requires like minimum human involvement. It operates autonomously, making decisions and adapting to changes like without continuous human guidance. And it can even learn in real time. So that's what the beauty of agentic AI is. So we have given one example of Gen AI, like basically giving prompt to the ChatGPT or DALI. Okay. And agentic AI, one example could be your supply chain management system. Now, let us deep dive into understanding the technical aspects of how agentic AI is exactly working. Now, guys, let us try to understand how agentic AI is exactly working. So there is actually a 4-step process of how agentic AI exactly works. So the first step is perceiving, where basically what we are doing is we are gathering and processing information from databases, sensors, and digital environments. And also the next step is reasoning. So with the help of large language model as a decision-making engine, it is generating the solutions. If we talk about the third step, which is acting, so it is integrating with external tools and softwares to autonomously execute the given task. And finally, it is learning continuously to improve through the feedback loop, which is also known as the data flywheel. Okay. Now, let us explore each of the steps one by one and let us try to understand. So if we talk about perceiving, okay, so this is actually the first step where agentic AI is actually stepping up. So it is doing the perception, where what exactly is happening, guys, that AI is collecting data from multiple sources. So this data could be from database, okay, like your traditional and vector databases, okay. So it could be GraphQL, like vector database means the same. And if we talk about other from data, it could be from APIs, like it is fetching real-time information from external systems. It is basically taking data from the IoT sensors, like for real-world applications like robotics and logistics. And also it could take data from the user inputs also, like it could be text command, voice commands, or a chatbot interaction. Now, how it is exactly working, guys? So basically, let us recollect everything technically and let us see how this is happening. So the first step which is going in perceiving is the data extraction, where exactly the AI agent queries the structured databases like SQL or NoSQL for relevant records. It is also using vector databases to retrieve any semantic data for context-aware responses, like it could be any complaint certain it is trying to find out. Okay, so next, after it has got the data extraction, it goes for feature extraction and pre-processing, where AI is filtering the relevant features from the raw data. For example, like a fraud detection AI is scanning the transaction log for anomalies. The third thing, it is entity recognition and object detection. So AI uses basically computer vision to detect objects and images, and then it is applying the named entity recognition. This is a technique, okay, to extract the critical terms from the given text also. So we have 3 step-by-step process which is happening in perceiving. The first one is data extraction. Second one is feature extraction and pre-processing. The third one is like entity recognition and object detection. So let us take a very simple example, like AI-based customer support system. So if we consider an agentic AI assistant like for a customer service, so say a customer is asking, where is my order? So the AI queries multiple databases all over here. Suppose it is going to query the e-commerce order database to retrieve the order status, or it could go to the logistics API to track the real-time shipment location. Also, it could go for customer interaction history to provide personalized response. The result what we get all over here is that the AI is fetching the tracking details, identifying any delays if it is happening, and suggesting the best course of action. Now, the next step is reasoning. Okay. Now, AI's understanding and decision making and problem solving is making agentic AI way greater. So here what is exactly happening, like once the AI has perceived the data, now it should start reasoning it. Okay, so the LLM model acts as a reasoning engine, orchestrating AI processes and integrating with specialized models for various functions. So if we talk about the key components like here used in the reasoning, it could be LLM based decision making. So AI agents could use models like LLMs like GPT-4, Claude, Llama to interpret a user intent and generate a response. It is basically coordinating with smaller AI models for domain specific tasks, like it could be like financial prediction or medical diagnostics. So these could be, the given example. Then it is using retrieval augmented generation or RAG model, okay, to with the help of which AI is enhancing the accuracy, by retrieving any proprietary data from the company's databases. For example, like instead of relying on GPT-4's knowledge, the AI can fetch company-specific policies to generate the accurate answers. So this could be the one. And in the reasoning, the final step is AI workflow and planning. So it is a multi-step reasoning where AI is breaking down complex tasks into logical steps. For example, like if asked to automate a financial report, AI is retrieving the transaction data, analyzing the trend, and it is formatting the results. Also, for example, you could use this in supply chain management. So suppose, consider there is a logistics company which is using the agentic AI to optimize what could be the shipping routes. So a supply chain manager requesting the AI agent to find the best shipping route to reduce the delivery cost. So the AI processes real-time fuel prices, traffic conditions, and weather report. So using LLM plus data retrieval, it finds out the optimized routes and selects the cheapest carrier. Result you get is that AI chooses the best delivery option. So here the cost is reduced and improving efficiency. So this is one of the use cases, guys. So after perceiving, you get his reasoning. Okay. Now let us move ahead and discuss about the third step, which is act. So in this step, basically what is happening, like AI is taking autonomous actions. So unlike generative AI, which stops at generating content, so agentic AI takes the real world action. Okay. How AI is executing tasks autonomously, guys? So basically first step is like here the integration with APIs and software could be happen, where AI can send automated API calls to the business systems. For example, like reordering the stock from the supplier's API. So suppose any inventory level is going down, so it could, reorder that particular stock from the supplier's API. So it is interacting with the given API. Now, it could also automate the workflows, like AI executes multi-step workflows without human supervision. So here, like AI can handle like insurance claims by verifying the documents, checking policies, and approving the payouts. And finally, AI could operate within predefined business rules, okay, to prevent any unauthorized actions also. So ethical AI is basically being worked in this direction. For example, like AI can automatically process claims up to say 10,000 US dollars, but it is requiring the human approval for the higher amounts. So based on, insurance and policy making stuff, so agentic AI could be, really helpful in this scenario. One example, like let's consider, so let's say we have this agentic AI managing an IT support system. So suppose a user says my email server is down. So the AI can diagnose the issue, restart the server, and confirms the given resolution. Now, if it is unresolved, then AI escalates to a human technician. Then it results into AI is fixing the issues autonomously, reducing the downtime. Okay. So this is where your action or act is coming up into the picture. Now, if we go on to the next and the final step, which is learning. So learning basically with the help of data flywheel, it is continuously learning. Okay. So this is the feedback loop all over here, which is the data flywheel. So how AI learns over the time? If we ask this question, so what is exactly happening that it is interacting with the data collection. Suppose AI logs successful and failed actions. For example, like if users correct AI generated responses, the AI is learning from those corrections. Second thing, what you could do is you could you could fine tune the model and do reinforcement learning. So AI adjusts its decision making models, basically to improve future accuracy. It uses reinforcement learning basically to optimize workflows based on past performance. Okay. Now, third step could be automated data labeling and self-correction. So here, what is happening that AI is labeling and categorizing past interactions to refine its knowledge base. Example like AI autonomously is updating frequently asked answers based on the recurring user queries. So in this way, AI is learning over the time. Example one you could consider. So say we have this AI is optimizing any financial fraud detection. So say this is consider that this is a bank which is AI powered, which has this AI powered fraud detection system. So AI is analyzing these financial transaction and it is detecting any suspicious activity. And if flagged, the transactions are false, and AI is learning to reduce these false alerts. So over the time, AI is improving the fraud detection accuracy, like minimizing disruptions for the customer. So in this way, AI is getting smarter over the time, like reducing the false alerts and also the financial fraud. So let's have a just quick recap of what we studied right now. So Agentic AI works in 4 steps. The first step is perceiving, where AI is gathering data from databases, sensors, and APIs. The next step is reasoning. So it is using LLM to interpret task, applies logic, and generating the solution. The third step is acting. So here AI is integrating with external systems and automating the task. And finally, it is learning. So AI is improving over the time, via feedback loop, or which is basically called as data flywheel. So guys, now let us see this diagram and try to understand what this diagram is trying to say. So the first thing, you could see an AI agent all over here. So this is an AI agent, which is basically an autonomous system. So which has the capability of perceiving its environment, making decisions, and executing actions without any human intervention. Now, AI agent is acting as the central intelligence, okay, in this given diagram, and it interacts with the user, okay, and various other data sources. It processes input, queries databases, makes decision using a large language model, and it is executing action, and it is learning from the given feedback. Now, the next step, you could see the LLM model. So if we talk about LLMs, these are the large language model, which is kind of an advanced AI model trained on massive amount of text data to understand, generate, and reason over natural language. Now, if I talk about this LLM, so this is actually acting as the reasoning engine all over here. And it is interpreting the user inputs and making informed decision. It is also retrieving relevant data from the databases, generating responses. It can also coordinate with multiple AI models for different tasks, like it could be content generation, okay, predictions, or decision making. Now, when the user is asking a chatbot, like for example, let's say, what is my account balance? So the LLM processes the query, retrieves the relevant data, and responds the given bank balance accordingly. But now if you look at the kind of database the LLM is interacting, so we have the traditional database and the vector database. So here, if I say the database, like AI agent basically is querying the structured database. So suppose structured database, like it could be a customer records or inventory data, or it could be any transactional log also. So traditional databases basically store well-defined, structured information. Okay. So for example, like when a bank AI assistant is processing a query like show my last 5 transactions, so it is basically fetching the information from a traditional SQL-based database. Next, we have this vector database also, guys. So vector database is a specialized kind of a database for storing unstructured data, which could be like text embeddings, images, or audio representations. So guys, like unlike traditional databases that store exact values, vector databases store in a high-dimensional mathematical space. It allows AI models to search semantically similar data instead of like exact matches. Now, AI is retrieving the contextual information from the vector databases, which is actually enhancing the decision making. It is improving the AI memory by allowing the system also to search for conceptually similar past interaction. Let's take an example to understand this. For example, we have discussed about a customer support chatbot. So suppose if it queries a vector database to find out similar past tickets, like when responding to a customer query. So a recommendation engine could use a vector database to find out similar products on a user's past preferences. So this could be done in that scenario. Also, some of the popular vector databases could be like Facebook's AI similarity search, Pinecone, or VV8. These are the certain amazing vector databases. Then you could see the next step is, after it has worked on these given data, it is performing the action. So the action component is referring where AI's agent has this ability to now execute tasks autonomously after the reasoning is done. So AI is integrating with external tools, APIs, or automation software to complete the given task. It does not provide only information, but it is actually, performing the given action. So for example, like in a customer support, the AI can automatically reset a user's password after verifying their identity. If we talk about in finance, then AI can approve a loan also, like based on the predefined eligibility criteria. Now, finally, we have the data flywheel. So data flywheel is a continuous feedback loop where AI is learning from the past interactions, refining its models, and it is always improving over the time. Now, every time like the AI is interacting with the data or taking an action or receiving a feedback, that information is fed into this model. So this is creating a self-improving AI system that is becoming smarter over the time. So the data flywheel is allowing AI to learn from every interaction, and AI is becoming more efficient by continuously optimizing responses and refining strategies. Best thing could be used in fraud detection. So in this, the AI is going to learn from the past fraud cases and it is going to detect new fraudulent patterns and more effectively. Chatbots also can learn from user feedback and improve the responses. And finally, you have the model customization, which is basically you are trying to fine-tune the AI models on specific business need or any industry requirement. So AI models are not static, like they can be adapted and optimized for a specific task. So custom fine-tuning is actually improving the accuracy and domain-specific application, like it could be finance, healthcare, or cybersecurity. So a financial institution, say, fine-tuning an LLM to generate an investment advice, on the historical market trends. That could be one use case. Or in healthcare, if we discuss the healthcare provider is fine-tuning then AI model to interpret the medical reports and recommend the treatments. So guys, based on the given diagram, you would have got a brief idea like how, agentic AI is working. Now, if we discuss about the future of agentic AI, then guys, I would say it looks very much promising because it is keep improving itself and it is finding new ways to be useful. Like with better machine learning algorithms and smarter decision making, these AI systems will be more independent, handling complex tasks on their own. And believe me, in industries like healthcare, finance, customer service, they have already started to see how AI agents can make more impact and it could be more efficient from a personalization perspective, managing resources and many more other things. So as this system continue to learn and adapt, I think so they will be opening up even more possibilities, helping businesses grow, improving how we live and work. Now, I would say that in conclusion that agentic AI is actually paving the way for new opportunities, like unlike the older versions of AI, which was assisting with generating content or predicting the data, or responding to any queries. But agentic AI can perform techniques independently with minimal human effort. And agentic AI has become self-reliant in decision-making way, and it is making very big differences in industry like healthcare, logistics, customer services, which is enabling companies to be more efficient. As a result, it is providing better services to their clients.
So what is deep learning? Deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. Unlike traditional machine learning models, which require manual feature extraction, deep learning models automatically discovers representation from raw data. So this is made possible through neural networks, particularly deep neural networks, which consist of multiple layers of interconnected nodes. So these neural networks are inspired by the structure and the function of human brain. Each layer in the network transforms the input data into more abstract and composite representation. For instance, in image recognition, the initial layer might detect simple features like edges and textures, while the deeper layer recognizes more complex structure like shapes and objects. So one of the key advantages of deep learning is its ability to handle large amount of unstructured data, such as images, audios, and text, making it extremely powerful for various applications. So stay tuned as we delve deeper into how these neural networks are trained, the types of deep learning models, and some exciting applications that are shaping our future. Types of deep learning. Deep learning AI can be applied supervised, unsupervised, and reinforcement machine learning using various methods for each. The first one, supervised machine learning. In supervised learning, the neural network learns to make prediction or classify that data using labeled datasets. Both input features and target variables are provided, and the network learns by minimizing the error between its prediction and the actual targets. A process called backpropagation. CNN and RNN are the common deep learning algorithms used for tasks like image classification, sentiment analysis, and language translation. The second one, unsupervised machine learning. In unsupervised machine learning, the neural network discovers patterns or clusters in unlabeled datasets without target variables. It identifies hidden pattern or relationship within the data. Algorithms like autoencoders and generative models are used for tasks such as clustering, dimensionality reduction, and anomaly detection. The third one, reinforcement machine learning. In this, an agent learns to make decisions in an environment to maximize a reward signal. The agent takes action, observes the records, and learns policies to maximize cumulative rewards over time. Deep reinforcement learning algorithms like deep Q networks and deep deterministic polygradient are used for tasks such as robotics and gameplay. Moving forward, let's see what are the artificial neural networks. Artificial neural networks, ANNs, inspired by the structure and the function of human neurons, consist of interconnected layers of artificial neurals or units. The input layer receives data from the external resources and it passes to one or more hidden layers. Each neuron in these layers computes a weighted sum of inputs and transfers the result to the next layer. During training, the weight of these connections are adjusted to optimize the network's performance. A fully connected artificial neural network includes an input layer or more hidden layers and an output layer. Each neuron in a hidden layer receives input from the previous layer and sends its output to the next layer. So this process continues until the final output layer produces the network response. So moving forward, let's see types of neural networks. So deep learning models can automatically learn features from data, making them ideal to tasks like image recognition, speech recognition, and natural language processing. So the most common architecture in deep learnings are the first one, feed-forward neural network, FNNs. So these are the simplest type of neural network where information flows linearly from the input to the output. They are widely used for tasks such as image classification, speech recognition, and natural language processing, NLP. The second one, convolutional neural network, designed specifically for image and video recognition. CNNs automatically learn features from images, making them ideal for image classification, object detection, and image segmentation. The third one, recurrent neural networks, RNNs, are specialized for processing sequential data time series and natural language. They maintain an internal state to capture information from previous input, making them suitable for tasks such as speech recognition, NLP, and language translation. So now let's move forward and see some deep learning application. The first one is autonomous vehicle. Deep learning is changing the development of self-driving car. Algorithms like CNNs process data from sensors and cameras to detect objects, recognize traffic signs, and make driving decisions in real time, enhancing safety and efficiency on the road. The second one is healthcare diagnostic. Deep learning models are being used to analyze medical images such as X-rays, MRIs, and CT scans with high accuracy. They help in early detection and diagnosis of diseases like cancer, improving treatment outcomes and saving lives. The third one is NLP. Recent advancement in NLP powered by deep learning models like Transformer, ChatGPT have led to more sophisticated and human-like text generation, translation, and sentiment analysis. So applications include virtual assistant, chatbots, and automated customer service. The fourth one, deepfake technology. So deep learning techniques are used to create highly realistic synthetic media known as deepfakes. While this technology has entertainment and creative application, it also raises ethical concern regarding misinformation and digital manipulation. The fifth one, predictive maintenance. In industries like manufacturing and aviation, deep learning models predict equipment failures before they occur by analyzing sensor data. Their proactive approach reduces downtime, lowers maintenance cost, and improves operational efficiency. So now let's move forward and see some advantages and disadvantages of deep learning. So first one is high computational requirements. So deep learning requires significant data and computational resources for training. whereas advantage is high accuracy, achieves state-of-the-art performance in tasks like image recognition and natural language processing. Whereas deep learning needs large label datasets, often require extensive label dataset for training, which can be costly and time-consuming together. So second advantage of deep learning is automated feature engineering. Automatically discovers and learn relevant features from data without manual intervention. The third disadvantage is overfitting. So deep learning can overfit to training data, leading to poor performance on new unseen data. Whereas the third deep learning advantage is scalability. So deep learning can handle large complex dataset and learn from massive amount of data. So in conclusion, deep learning is a transformative leap in AI, mimicking human neural networks. It has changed healthcare, finance, autonomous vehicles, and NLP.
In this video, we will learn about an important popular deep learning neural network called Generative Adversarial Networks. Yann LeCun, one of the pioneers in the field of machine learning and deep learning, described it as the most interesting idea in the last 10 years in machine learning. In this video, you will learn about what are generative adversarial networks and look in brief at generator and discriminator. Then, we'll understand how GANs work and the different types of GANs. Finally, we'll look at some of the applications of GANs. So let's begin. So what are generative adversarial networks? Generative Adversarial Networks, or GANs, introduced in 2014 by Ian J. Goodfellow and co-authors, became very popular in the field of machine learning. GAN is an unsupervised learning task in machine learning. It consists of two models that automatically discover and learn the patterns in input data. The two models, called generator and discriminator, compete with each other to analyze, capture and copy the variations within a dataset. GANs can be used to generate new examples that possibly could have been drawn from the original dataset. In the image below, you can see that there is a database that has real 100 rupee notes. The generator, which is basically a neural network, generates fake 100 rupees notes. The discriminator network will identify if the notes are real or fake. Let us now understand in brief about what is a generator. A generator in GANs is a neural network that creates fake data to be trained on the discriminator. It learns to generate plausible data. The generated instances become negative training examples for the discriminator. It takes a fixed length random vector carrying noise as input and generates a sample. Now the main aim of the generator is to make the discriminator classify its output as real. The portion of the GAN that trains the generator includes a noisy input vector, the generator network, which transforms the random input into a data instance, a discriminator network which classifies the generated data, and a generator loss, which penalizes the generator for failing to dolt the discriminator. The backpropagation method is used to adjust each weight in the right direction by calculating the weight's impact on the output. The backpropagation method is used to obtain gradients, and these gradients can help change the generator weights. Now, let us understand in brief what a discriminator is. A discriminator is a neural network model that identifies real data from the fake data generated by the generator. The discriminator's training data comes from two sources. The real data instances, such as real pictures of birds, humans, currency notes, etc., are used by the discriminator as positive samples during the training. The fake data instances created by the generator are used as negative examples during the training process. While training the discriminator, it connects with two loss functions. During discriminator training, the discriminator ignores the generator loss and just uses the discriminator loss. In the process of training the discriminator classifies both real data and fake data from the generator. The discriminator loss penalizes the discriminator for misclassifying a real data instance as fake or a fake data instance as real. Now moving ahead, let's understand how GANs work. Now GANs consists of two networks, a generator which is represented as G of X and a discriminator which is represented as D of X. They both play an adversarial game where the generator tries to fool the discriminator by generating data similar to those in the training set. The discriminator tries not to be fooled by identifying fake data from the real data. They both work simultaneously to learn and train complex data like audio, video or image files. Now you are aware that GANs consists of two networks, a generator G of X and discriminator D of X. Now the generator network takes a sample and generates a fake sample of data. The generator is trained to increase the probability of the discriminator network to make mistakes. On the other hand, the discriminator network decides whether the data is generated or taken from the real sample using a binary classification problem with the help of a sigmoid function that gives the output in the range 0 and 1. Here is an example of a generative adversarial network trying to identify if the 100 rupee notes are real or fake. So first, a noise vector or the input vector is fed to the generator network. The generator creates fake 100 rupee notes. The real images of 100 rupee notes stored in a database are passed to the discriminator along with the fake notes. The discriminator then identifies the notes and classifies them as real or fake. We train the model, calculate the loss function at the end of the discriminator network, and backpropagate the loss into both discriminator and generator. Now the mathematical equation of training a GAN can be represented as, you can see here. Now this is the equation and these are the parameters. Here G represents generator, D represents the discriminator. Now P data of X is the probability distribution of real data. P of Z is the distribution of generator. X is the sample of probability data of X. Z is the sample size from P of Z. D of X is the discriminator network and G of Z is the generator network. Now the discriminator focuses to maximize the objective function such that D of X is close to 1 and Z of Z is close to 0. It simply means that the discriminator should identify all the images from the training set as real, that is 1, and all the generated images as fake, that is 0. The generator wants to minimize the objective function such that D of Z of Z is 1. This means that the generator tries to generate images that are classified as real, that is 1, by the discriminator network. Next, let's see the steps for training a neural network. So we have to first define the problem and collect the data. Then we'll choose the architecture of GAN. Now depending on your problem, choose how your GAN should look like. Then we need to train the discriminator on real data. That will help us predict them as real for n number of times. Next, you need to generate fake inputs for the generator. After that, you need to train the discriminator on fake data to predict the generator data as fake. Finally, train the generator on the output of discriminator. With the discriminator predictions available, train the generator to fool the discriminator. Let us now look at the different types of GANs. So first we have vanilla GANs. Now vanilla GANs have min-max optimization formula that we saw earlier, where the discriminator is a binary classifier and is using sigmoid cross entropy loss during optimization. In vanilla GANs, the generator and the discriminator are simple multi-layer perceptrons. The algorithm tries to optimize the mathematical equation using stochastic gradient descent. Up next, we have deep convolutional GANs or DC GANs. Now DC GANs support convolutional neural networks instead of vanilla neural networks at both discriminator and generator. They are more stable and generate higher quality images. The generator is a set of convolutional layers with fractional strided convolutions or transpose convolutions, so it unsamples the input image at every convolutional layer. The discriminator is a set of convolutional layers with strided convolutions, so it downsamples the input image at every convolutional layer. Moving ahead, the third type you have is conditional GANs or CGANs. Vanilla GANs can be extended into conditional models by using an extra label information to generate better results. In CGAN, an additional parameter called Y is added to the generator for generating the corresponding data. Labels are fed as input to the discriminator to help distinguish the real data from fake data generated. Finally, we have super resolution GANs. Now SR GANs use deep neural networks along with adversarial neural network to produce higher resolution images. Super resolution GANs generate a photorealistic high resolution image when given a low resolution image. Let's look at some of the important applications of GANs. So with the help of DC GANs, you can train images of cartoon characters for generating faces of anime characters and Pokemon characters as well. Next, GANs can be used on the images of humans to generate realistic faces. The faces that you see on your screens have been generated using GANs and do not exist in reality. Third application we have is GANs can be used to build realistic images from textual descriptions of objects like birds, humans, and other animals. We input a sentence and generate multiple images fitting the description. Here is an example of a text-to-image translation using GANs for a bird with a black head, yellow body, and a short beak. The final application we have is creating 3D objects. So GANs can generate 3D models using 2D pictures of objects from multiple perspectives. GANs are very popular in the gaming industry. GANs can help automate the task of creating 3D characters and backgrounds to give them a realistic feel.
We've looked at a lot of examples of machine learning, so let's see if we can give a little bit more of a concrete definition. What is machine learning? Machine learning is the science of making computers learn and act like humans by feeding data and information without being explicitly programmed. And we see here we have a nice little diagram where we have our ordinary system. Your computer, nowadays you can even run a lot of this stuff on a cell phone because cell phones have advanced so much. And then with artificial intelligence and machine learning, it now takes the data and it learns from what happened before. And then it predicts what's going to come next. And then really the biggest part right now in machine learning that's going on is it improves on that. How do we find a new solution? So we go from descriptive, where it's learning about stuff and understanding how it fits together, to predicting what it's going to do, to post-scripting, coming up with a new solution. And when we're working on machine learning, there's a number of different diagrams that people have posted for what steps to go through. A lot of it might be very domain specific. So if you're working on photo identification versus language versus medical or physics, some of these are switched around a little bit or new things are put in. They're very specific to the domain. This is kind of a very general diagram. First, you want to define your objective. Very important to know what it is you're wanting to predict. Then you're going to be collecting the data. So once you've defined an objective, you need to collect the data that matches. You spend a lot of time in data science collecting data, and the next step, preparing the data. You got to make sure that your data is clean going in. There's the old saying, bad data in, bad answer out, or bad data out. And then once you've gone through and we've cleaned all this stuff coming in, then you're going to select the algorithm. Which algorithm are you going to use? You're going to train that algorithm. In this case, I think we're going to be working with SVM, the support vector machine. Then you have to test the model. Does this model work? Is this a valid model for what we're doing? And then once you've tested it, you want to run your prediction. You want to run your prediction or your choice or whatever output it's going to come up with. And then once everything is set and you've done lots of testing, then you want to go ahead and deploy the model. And remember I said domain specific. This is very general as far as the scope of doing something. A lot of models, you get halfway through and you realize that your data is missing something and you have to go collect new data because you've run a test in here someplace along the line. You're saying, hey, I'm not really getting the answers I need. So there's a lot of things that are domain specific that become part of this model. This is a very general model, but it's a very good model to start with. And we do have some basic divisions of what machine learning does that's important to know. For instance, do you want to predict a category? Well, if you're categorizing things, that's classification. For instance, whether the stock price will increase or decrease. So in other words, I'm looking for a yes-no answer. Is it going up or is it going down? And in that case, we'd actually say, is it going up? True. If it's not going up, it's false, meaning it's going down. This way, it's a yes-no, 0, 1. Do you want to predict a quantity? That's regression. So remember, we just did classification. Now we're looking at regression. These are the two major divisions in what data is doing. For instance, predicting the age of a person based on the height, weight, health, and other factors. So based on these different factors, you might guess how old a person is. And then there are a lot of domain-specific things, like do you want to detect an anomaly? That's anomaly detection. And this is actually very popular right now. For instance, you want to detect money withdrawal anomalies. You want to know when someone's making a withdrawal that might not be their own account. We've actually brought this up because this is really big right now. If you're predicting the stock, whether to buy stock or not, you want to be able to know if what's going on in the stock market is an anomaly. Use a different prediction model because something else is going on. You got to pull out new information in there. Or is this just the norm? I'm going to get my normal return on my money invested. So being able to detect anomalies is very big in data science these days. Another question that comes up, which is on what we call untrained data, is do you want to discover structure in unexplored data? And that's called clustering. For instance, finding groups of customers with similar behavior given a large database of customer data containing their demographics and past buying records. And in this case, we might notice that anybody who's wearing a certain set of shoes goes shopping at certain stores, or whatever it is, they're going to make certain purchases. By having that information, it helps us to market or group people together so that we can now explore that group and find out what it is we want to market to them if you're in the marketing world. And that might also work in just about any arena. You might want to group people together, whether they're based on their different areas and investments and financial background, whether you're going to give them a loan or not. Before you even start looking at whether they're a valid customer for the bank, you might want to look at all these different areas and group them together based on unknown data. So you don't know what the data is going to tell you, but you want to cluster people together that come together. Let's take a quick detour for quiz time. Oh, my favorite. So we're going to have a couple questions here under our quiz time. And we'll be posting the answers in the part 2 of this tutorial. So let's go ahead and take a look at these quiz times questions, and hopefully you'll get them all right, and it'll get you thinking about how to process data and what's going on. Can you tell what's happening in the following cases? Of course, you're sitting there with your cup of coffee and you have your checkbox and your pen trying to figure out what's your next step in your data science analysis. So the first one is grouping documents into different categories based on the topic and content of each document. Very big these days. You have legal documents, you have maybe it's a sports group documents, maybe you're analyzing newspaper postings, but certainly having that automated is a huge thing in today's world. B, identifying handwritten digits in images correctly. So we want to know whether they're writing an A or capital A, B, C. What are they writing out in their handwriting? C, behavior of a website indicating that the site is not working as designed. D, predicting salary of an individual based on his or her years of experience. Boy, HR hiring setup there. So stay tuned for part 2. We'll go ahead and answer these questions when we get to the part 2 of this tutorial. Or you can just simply write at the bottom and send a note to Simplilearn, and they'll follow up with you on it. Back to our regular content. And these last few bring us into the next topic, which is another way of dividing our types of machine learning, and that is with supervised, unsupervised, and reinforcement learning. Supervised learning is a method used to enable machines to classify, predict objects, problems, or situations based on labeled data fed to the machine. And in here you see we have a jumble of data with circles, triangles, and squares, and we label them. We have what's a circle, what's a triangle, what's a square, and we have our model training, and it trains it so we know the answer. Very important, when you're doing supervised learning, you already know the answer to a lot of your information coming in. So you have a huge group of data coming in, and then you have new data coming in. So we've trained our model. The model now knows the difference between a circle, a square, a triangle. And now that we've trained it, we can send in this case, a square and a circle goes in, and it predicts that the top one's a square and the next one's a circle. And you can see that this is being able to predict whether someone's going to default on a loan, because I was talking about banks earlier. Supervised learning on stock market, whether you're going to make money or not. That's always important. And if you are looking to make a fortune in the stock market, keep in mind it is very difficult to get all the data correct on the stock market. It is it fluctuates in ways really hard to predict. So it's quite a roller coaster ride. If you're running machine learning on the stock market, you start realizing you really have to dig for new data. So we have supervised learning, and if you have supervised, we should need unsupervised learning. In unsupervised learning, machine learning model finds the hidden pattern in an unlabeled data. So in this case, instead of telling it what the circle is and what a triangle is and what a square is, it goes in there, looks at them and says, for whatever reason, it groups them together. Maybe it'll group it by the number of corners. And it notices that a number of them all have 3 corners, a number of them all have 4 corners, and a number of them all have no corners. And it's able to filter those through and group them together. We talked about that earlier with looking at a group of people who are out shopping. We want to group them together to find out what they have in common. And of course, once you understand what people have in common, maybe you have one of them who's a customer at your store, or you have 5 of them are customer at your store, and they have a lot in common with 5 others who are not customers at your store. How do you market to those 5 who aren't customers at your store yet? They fit the demographics of who's going to shop there, and you'd like them to shop at your store, not the one next door. Of course, this is a simplified version. You can see very easily the difference between a triangle and a circle, which might not be so easy in marketing. Reinforcement learning. Reinforcement learning is an important type of machine learning where an agent learns how to behave in an environment by performing actions and seeing the result. And we have here where in this case, a baby. It's actually great that they used an infant for this slide because the reinforcement learning is very much in its infant stages. But it's also probably the biggest machine learning demand out there right now, or or in the future, it's going to be coming up over the next few years, is reinforcement learning and how to make that work for us. And you can see here where we have our action. In the action in this one, it goes into the fire. Hopefully the baby didn't, it was just a little candle, not a giant fire pit like it looks like here. When the baby comes out, and the new state is the baby is sad and crying because they got burned on the fire. And then maybe they take another action. The baby's called the agent because it's the one taking the actions. And in this case, they didn't go into the fire. They went a different direction, and now the baby's happy and laughing and playing. Reinforcement learning is very easy to understand because that's how, as humans, that's one of the ways we learn. We learn whether it is, you burn yourself on the stove, don't do that anymore. Don't touch the stove. In the big picture, being able to have a machine learning program or an AI be able to do this is huge because now we're starting to learn how to learn. That's a big jump in the world of computer and machine learning. And we're going to go back and just kind of go back over supervised versus unsupervised learning. Understanding this is huge because this is going to come up in any project you're working on. We have in supervised learning, we have labeled data, we have direct feedback. So someone's already gone in there and said, yes, that's a triangle. No, that's not a triangle. And then you predict an outcome. So you have a nice prediction. This new set of data is coming in and we know what it's going to be. And then with unsupervised training, it's not labeled. So we really don't know what it is. There's no feedback. So we're not telling it whether it's right or wrong. We're not telling it whether it's a triangle or a square. We're not telling it to go left or right. All we do is we're finding hidden structure in the data, grouping the data together to find out what connects to each other. And then you can use these together. So imagine you have an image and you're not sure what you're looking for. So you go in and you have the unstructured data, find all these things that are connected together. And then somebody looks at those and labels them. Now you can take that labeled data and program something to predict what's in the picture. So you can see how they go back and forth and you can start connecting all these different tools together to make a bigger picture. There are many interesting machine learning algorithms. Let's have a look at a few of them. Hopefully this gives you a little flavor of what's out there. And these are some of the most important ones that are currently being used. We'll take a look at linear regression, decision tree, and the support vector machine. Let's start with a closer look at linear regression. Linear regression is perhaps one of the most well-known and well-understood algorithms in statistics and machine learning. Linear regression is a linear model. For example, a model that assumes a linear relationship between the input variables x and the single output variable y. And you'll see this if you remember from your algebra classes, y equals mx plus c. Imagine we are predicting distance traveled y from speed x. Our linear regression model representation for this problem would be y equals m times x plus c, or distance equals m times speed plus c, where m is the coefficient and c is the y-intercept. And we're going to look at two different variations of this. First, we're going to start with time is constant. And you can see we have a bicyclist. He's got his safety gear on, thank goodness. Speed equals 10 meters per second. And so over a certain amount of time, his distance equals 36 kilometers. We have a second bicyclist who's going twice the speed, or 20 meters per second. And you can guess if he's going twice the speed and time is a constant, then he's going to go twice the distance. And that's easily to compute. 36 times 2, you get 72 kilometers. And so if you had the question of how fast would somebody who's going 3 times that speed, or 30 meters per second is, you can easily compute the distance in our head. We can do that without needing a computer. But we want to do this for more complicated data. So it's kind of nice to compare the two. But let's just take a look at that and what that looks like in a graph. So in a linear regression model, we have our distance to the speed, and we have our m equals the VE slope of the line. And we'll notice that the line has a plus slope. And as the speed increases, distance also increases, hence the variables have a positive relationship. And so your speed of the person, which equals y equals mx plus c, distance traveled in a fixed interval of time, and we could very easily compute, either following the line or just knowing it's 3 times 10 meters per second, that this is roughly 102 kilometers distance that this third bicyclist has traveled. One of the key definitions on here is positive relationship. So the slope of the line is positive. As distance increase, so does speed increase. Let's take a look at our second example where we put distance is a constant. So we have speed equals 10 meters per second. They have a certain distance to go, and it takes them 100 seconds to travel that distance. And we have our second bicyclist who's still doing 20 meters per second. Since he's going twice the speed, we can guess that he'll cover the distance in about half the time. 50 seconds. And of course you could probably guess on the third one, 100 divided by 30, since he's going 3 times the speed, you could easily guess that this is 33.333 seconds time. When we put that into a linear regression model or a graph, if the distance is assumed to be constant, let's see the relationship between speed and time. And as time goes up, the amount of speed to go that same distance goes down. So now your m equals a minus VE slope of the line. As the speed increases, time decreases, hence the variable has a negative relationship. Again, there's our definition, positive relationship and negative relationship dependent on the slope of the line. And with a simple formula like this, and even a significant amount of data, let's see with the mathematical implementation of linear regression. And we'll take this data. So suppose we have this data set where we have x, y, x equals 1, 2, 3, 4, 5, standard series, and the y value is 3, 2, 2, 4, 3. When we take that and we go ahead and plot these points on a graph, you can see there's kind of a nice scattering, and you could probably eyeball a line through the middle of it. But we're going to calculate that exact line for linear regression. And the first thing we do is we come up here and we have the mean of xi. And remember, mean is basically the average. So we added 5 plus 4 plus 3 plus 2 plus 1 and divide by 5. And that simply comes out as 3. And then we'll do the same for y. We'll go ahead and add up all those numbers and divide by 5. And we end up with the mean value of y of I equals 2.8. Where the xi references it's an average or means value, and the yi also equals a means value of y. And when we plot that, you'll see that we can put in the y equals 2.8 and the x equals 3 in there on our graph. We kind of gave it a little different color so you could sort it out with the dashed lines on it. And it's important to note that when we do the linear regression model should go through that dot. Now let's find our regression equation to find the best fit line. Remember, we go ahead and take our y equals mx plus c, so we're looking for m and c. So to find this equation for our data, we need to find our slope of m and our coefficient of c. And we have y equals mx plus c, where m equals the sum of x minus x average times y minus y average, or y means and x means, over the sum of x minus x means squared. That's how we get the slope of the value of the line. And we can easily do that by creating some columns here where we have x, y. Computers are really good about iterating through data, and so we can easily compute this and fill in a graph of data. And in our graph, you can easily see that if we have our x value of 1, and if you remember the xi, or the means value, is 3, 1 minus 3 equals a negative 2, and 2 minus 3 equals a negative 1, so on and so forth. And we can easily fill in the column of x minus xi, y minus yi, and then from those we can compute x minus xi squared and x minus xi times y minus yi. And you can guess it that the next step is to go ahead and sum the different columns for the answers we need. So we get a total of 10 for our x minus xi squared, and a total of 2 for x minus xi times y minus yi. And we plug those in, we get 2/10, which equals 0.2. So now we know the slope of our line equals 0.2. So we can calculate the value of c. That'd be the next step, is we need to know where it crosses the y-axis. And if you remember, I mentioned earlier that the linear regression line has to pass through the means value, the one that we showed earlier. We can just flip back up there to that graph, and you can see right here there's our means value, which is 3, x equals 3 and y equals 2.8. And since we know that value, we can simply plug that into our formula, y equals 0.2x plus c. So we plug that in, and we get 2.8 equals 0.2 times 3 plus c, and you can just solve for c. So now we know that our coefficient equals 2.2. And once we have all that, we can go ahead and plot our regression line. Y equals 0.2 times x plus 2.2. And then from this equation, we can compute new values. So let's predict the values of y using x equals 1, 2, 3, 4, 5 and plot the points. Remember, the 1, 2, 3, 4, 5 was our original x values. So now we're going to see what y thinks they are, not what they actually are. And when we plug those in, we get y of designated with y of p. You can see that x equals 1 equals 2.4, x equals 2 equals 2.6, and so on and so on. So we have our y predicted values of what we think it's going to be when we plug those numbers in. And when we plot the predicted values along with the actual values, we can see the difference. And this is one of the things that's very important with linear regression in any of these models, is to understand the error. And so we can calculate the error on all of our different values. And you can see over here we plotted x and y predict. And we draw in a little line so you can sort of see what the error looks like there between the different points. So our goal is to reduce this error. We want to minimize that error value on our linear regression model. Minimizing the distance. There are lots of ways to minimize the distance between the line and the data points, like sum of squared errors, sum of absolute errors, root mean square error, etc. We keep moving this line through the data points to make sure the best fit line has the least square distance between the data points and the regression line. So to recap with a very simple linear regression model, we first figure out the formula of our line through the middle, and then we slowly adjust the line to minimize the error. Keep in mind this is a very simple formula. The math gets, even though the math is very much the same, it gets much more complex as we add in different dimensions. So this is only 2 dimensions, y equals mx plus c, but you can take that out to x, z, ijq, all the different features in there, and they can plot a linear regression model on all of those using the different formulas to minimize the error. Let's go ahead and take a look at decision trees, a very different way to solve problems in the linear regression model. Decision tree is a tree-shaped algorithm used to determine a course of action. Each branch of a tree represents a possible decision, occurrence, or reaction. We have data which tells us if it is a good day to play golf. And if we were to open this data up in a general spreadsheet, you can see we have the outlook, whether it's rainy, overcast, sunny, temperature, hot, mild, cool, humidity, windy, and did I like to play golf that day, yes or no? So we're taking a census. And certainly I wouldn't want a computer telling me when I should go play golf or not. But you can imagine if you got up in the night before, you're trying to plan your day, and it comes up and says tomorrow would be a good day for golf for you in the morning, and not a good day in the afternoon, or something like that. This becomes very beneficial, and we see this in a lot of applications coming out now where it gives you suggestions and lets you know what would fit the match for you for the next day or the next purchase or the next whatever, next meal out. In this case, is tomorrow a good day for playing golf based on the weather coming in? And so we come up and let's determine if you should play golf when the day is sunny and windy. So we found out the forecast tomorrow is going to be sunny and windy. And suppose we draw our tree like this. We're going to have our humidity, and then we have our normal, which is if you have a normal humidity, you're going to go play golf. And if the humidity is really high, then we look at the outlook. And if the outlook is sunny, overcast, or rainy, it's going to change what you choose to do. So if you know that it's a very high humidity and it's sunny, you're probably not going to play golf because you're going to be out there miserable, fighting off the mosquitoes that are out joining you to play golf with you. Maybe if it's rainy, you probably don't want to play in the rain. But if it's slightly overcast and you get just the right shadow, that's a good day to play golf and be outside, out on the green. Now in this example, you can probably make your own tree pretty easily because it's a very simple set of data going in. But the question is, how do you know what to split? Where do you split your data? What if this is much more complicated data where it's not something that you would particularly understand? Like studying cancer, they take about 36 measurements of the cancerous cells, and then each one of those measurements represents how bulbous it is, how extended it is, how sharp the edges are. Something that as a human we would have no understanding of. So how do we decide how to split that data up? And is that the right decision tree? So that's a question that's going to come up. Is this the right decision tree? For that, we should calculate entropy and information gain. 2 important vocabulary words there are the entropy and the information gain. Entropy. Entropy is a measure of randomness or impurity in the data set. Entropy should be low. So we want the chaos to be as low as possible. We don't want to look at it and be confused by the images or what's going on there with mixed data. And the information gain. It is a measure of decrease in entropy after the data set is split, also known as entropy reduction. Information gain should be high, so we want our information that we get out of the split to be as high as possible. Let's take a look at entropy from the mathematical side. In this case, we're going to denote entropy as I of P of and N, where P is the probability that you're going to play a game of golf, and N is the probability where you're not going to play the game of golf. Now, you don't really have to memorize these formulas. There's a few of them out there depending on what you're working with. But it's important to note that this is where this formula is coming from, so when you see it, you're not lost when you're running your programming, unless you're building your own decision tree code in the back. And we simply have a log squared of p over p plus n minus n over p plus n times the log squared of n of p plus n. But let's break that down and see what it actually looks like when we're computing that from the computer script side. Entropy of a target class of the data set is the whole entropy. So we have entropy play golf. And when we look at this, if we go back to the data, you can simply count how many yeses and no in our complete data set for playing golf days. In our complete set, we find we have 5 days we did play golf and 9 days we did not play golf. And so our I equals, if you add those together, 9 plus 5 is 14. And so our I equals 5 over 14 and 9 over 14. That's our P and N values that we plug into that formula. And you can go 5 over 14 equals 0.36, 9 over 14 equals 0.64. And when you do the whole equation, you get the minus 0.36 log root squared of 0.36 minus 0.64 log squared root of 0.64. And we get a set value. We get 0.94. So we now have a full entropy value for the whole set of data that we're working with. And we want to make that entropy go down. And just like we calculated the entropy out for the whole set, we can also calculate entropy for playing golf and the outlook. Is it going to be overcast or rainy or sunny? And so when we look at the entropy, we have P of sunny times E of 3 of 2. And that just comes out how many sunny days yes and how many sunny days no over the total, which is 5. Don't forget to put we'll divide that 5 out later on. Equals P overcast equals 4 comma 0 plus rainy equals 2 comma 3. And then when you do the whole setup, we have 5 over 14. Remember I said there was a total of 5? 5 over 14 times the I of 3 of 2 plus 4 over 14 times the 4 comma 0 and 514 over I of 2, 3. And so we can now compute the entropy of just the part that has to do with the forecast. And we get 0.693. Similarly, we can calculate the entropy of other predictors like temperature, humidity, and wind. And so we look at the gain outlook. How much are we going to gain from this? Entropy play golf minus entropy play golf outlook. And we can take the original 0.94 for the whole set minus the entropy of just the rainy day and temperature, and we end up with a gain of 0.247. So this is our information gain. Remember, we define entropy and we define information gain. The higher the information gain, the lower the entropy, the better. The information gain of the other 3 attributes can be calculated in the same way. So we have our gain for temperature equals 0.029. We have our gain for humidity equals 0.152, and our gain for a windy day equals 0.048. And if you do a quick comparison, you'll see the 0.247 is the greatest gain of information, so that's the split we want. Now let's build the decision tree. So we have the outlook. Is it going to be sunny, overcast, or rainy? That's our first split because that gives us the most information gain. And we can continue to go down the tree using the different information gains with the largest information. We can continue down the nodes of the tree where we choose the attribute with the largest information gain as the root node and then continue to split each subnode with the largest information gain that we can compute. And although it's a little bit of a tongue twister to say all that, you can see that it's a very easy to view visual model. We have our outlook, we split it 3 different directions. If the outlook is overcast, we're going to play. And then we can split those further down if we want. So if the outlook is sunny, but then it's also windy, if it's windy, we're not going to play. If it's not windy, we'll play. So we can easily build a nice decision tree to guess what we would like to do tomorrow and give us a nice recommendation for the day. So we want to know if it's a good day to play golf when it's sunny and windy. Remember the original question that came out? Tomorrow's weather report is sunny and windy. You can see by going down the tree, we go outlook sunny, outlook windy. We're not going to play golf tomorrow. So our little smartwatch pops up and says, I'm sorry, tomorrow's not a good day for golf. It's going to be sunny and windy. And if you're a huge golf fan, you might go, uh-oh, it's not a good day to play golf. We can go in and watch a golf game at home. So we'll sit in front of the TV instead of being out playing golf in the wind. Now that we looked at our decision tree, let's look at the third one of our algorithms we're investigating. Support vector machine. Support vector machine is a widely used classification algorithm. The idea of support vector machine is simple. The algorithm creates a separation line which divides the classes in the best possible manner. For example, dog or cat, disease or no disease. Suppose we have a labeled sample data which tells height and weight of males and females. A new data point arrives and we want to know whether it's going to be a male or a female. So we start by drawing a line. We draw decision lines, but if we consider decision line 1, then we will classify the individual as a male. And if we consider decision line 2, then it will be a female. So you can see this person kind of lies in the middle of the two groups, so it's a little confusing trying to figure out which line they should be under. We need to know which line divides the classes correctly, but how? The goal is to choose a hyperplane, and that is one of the key words they use when we talk about support vector machines. Choose a hyperplane with the greatest possible margin between the decision line and the nearest point within the training set. So you can see here we have our support vector, we have the two nearest points to it, and we draw a line between those 2 points. And the distance margin is the distance between the hyperplane and the nearest data point from either set. So we actually have a value, and it should be equally distant between the two points that we're comparing it to. When we draw the hyperplanes, we observe that line 1 has a maximum distance. So we observe that line 1 has a maximum distance margin, so we'll classify the new data point correctly. And our result on this one is going to be that the new data point is male. One of the reasons we call it a hyperplane versus a line is that a lot of times we're not looking at just weight and height. We might be looking at 36 different features or dimensions. And so when we cut it with a hyperplane, it's more of a three-dimensional cut in the data, or multi-dimensional. It cuts the data a certain way. And each plane continues to cut it down until we get the best fit or match. Let's understand this with the help of an example. Problem statement. I always start with a problem statement when you're going to put some code together. We're going to do some coding now. Classifying muffin and cupcake recipes using support vector machines. So the cupcake versus the muffin. Let's have a look at our data set. And we have the different recipes here. We have a muffin recipe that has so much flour. I'm not sure what measurement 55 is in, but it has 55, maybe it's ounces? But it has a certain amount of flour, a certain amount of milk, sugar, butter, egg, baking powder, vanilla, and salt. And so based on these measurements, we want to guess whether we're making a muffin or a cupcake. And you can see in this one, we don't have just two features. We don't just have height and weight as we did before between the male and female. In here, we have a number of features. In fact, in this, we're looking at 8 different features to guess whether it's a muffin or a cupcake. What's the difference between a muffin and a cupcake? Turns out muffins have more flour, while cupcakes have more butter and sugar. So basically the cupcake's a little bit more of a dessert, where the muffin's a little bit more of a fancy bread. But how do we do that in Python? How do we code that to go through recipes and figure out what the recipe is? And I really just want to say cupcakes versus muffins, like some big professional wrestling thing. Before we start in our cupcakes versus muffins, we are going to be working in Python. There's many versions of Python, many different editors. That is one of the strengths and weaknesses of Python, is it just has so much stuff attached to it, and it's one of the more popular data science programming packages you can use. In this case, we're going to go ahead and use Anaconda and Jupyter Notebook. The Anaconda Navigator has all kinds of fun tools. Once you're into the Anaconda Navigator, you can change environments. I actually have a number of environments on here. We'll be using Python 3.6 environment. So this is in Python version 3.6. Although it doesn't matter too much which version you use. I usually try to stay with the 3x because they're current, unless you have a project that's very specifically in version 2x. 2.7 I think is usually what most people use in the version 2. And then once we're in our Jupyter Notebook editor, I can go up and create a new file. And we'll just jump in here. In this case, we're doing SVM muffin versus cupcake. And then let's start with our packages for data analysis. And we almost always use there's a few very standard packages we use. We use import numpy. That's for number Python. And they usually denote it as NP. That's very common. And then we're going to import pandas as PD. And numpy deals with number arrays. There's a lot of cool things you can do with the numpy setup as far as multiplying all the values in an array, in a numpy array, data array. Pandas, I can't remember if we're using it actually in this data set. I think we do as an import. It makes a nice data frame. And the difference between a data frame and a numpy array is that a data frame is more like your Excel spreadsheet. You have columns, you have indexes, so you have different ways of referencing it, easily viewing it. And there's additional features you can run on a data frame. And Pandas kind of sits on NumPy, so you need them both in there. And then finally, we're working with the support vector machine. So from sklearn, we're going to use the sklearn model, import svm, support vector machine. And then as a data scientist, you should always try to visualize your data. Some data obviously is too complicated or doesn't make any sense to the human. But if it's possible, it's good to take a second look at it so that you can actually see what you're doing. Now for that, we're going to use two packages. We're going to import matplotlibary.pyplot as PLT, again very common. And we're going to import Seaborn as SNS. And we'll go ahead and set the font scale in the SNS right in our import line. That's what this semicolon followed by a line of data. We're going to set the SNS. And these are great because the Seaborn sits on top of matplotlibary, just like Pandas sits on NumPy. So it adds a lot more features and uses and control. We're obviously not going to get into matplotlibary and Seaborn. That'd be its own tutorial. We're really just focusing on the SVM, the support vector machine from sklearn. And since we're in Jupyter Notebook, we have to add a special line in here for our matplotlibary. And that's your %sign or ampersand matplotlibary in line. Now, if you're doing this in just a straight code project, a lot of times I use like Notepad++, and I'll run it from there. You don't have to have that line in there because it'll just pop up as its own window on your computer, depending on how your computer's set up. Because we're running this in the Jupyter Notebook as a browser setup, this tells it to display all of our graphics right below on the page. So that's what that line is for. I remember the first time I ran this, I didn't know that, and I had to go look that up years ago. It was quite a headache. So matplotlibary inline is just because we're running this on the web setup. And we can go ahead and run this, make sure all our modules are in. They're all imported, which is great. If you don't have them import, you'll need to go ahead and pip, use the PIP or however you do it. There's a lot of other install packages out there, although pip is the most common. And you have to make sure these are all installed on your Python setup. The next step, of course, is we got to look at the data. You can't run a model for predicting data if you don't have actual data. So to do that, let me go ahead and open this up and take a look. And we have our cupcakes versus muffins. And it's a CSV file, or .csv, meaning that it's comma-separated variable. And it's going to open it up in a nice spreadsheet for me. And you can see up here we have the type. We have muffin, 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 cupcake, cupcake, cupcake. And then it's broken up into flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. So what we can do is we can go ahead and look at this data also in our Python. Let us create a variable recipes equals, we're going to use our pandas module, .read CSV. Remember, it's a comma-separated variable. And the file name happened to be cupcakes versus muffins. Oops, I got double brackets there. Do it this way. There we go. Cupcakes versus muffins. Because the program I loaded, or the place I saved this particular Python program is in the same folder, we can get by with just the file name. But remember, if you're storing it in a different location, you have to also put down the full path on there. And then because we're in pandas, we're going to go ahead and you can actually, inline you can do this, but let me do the full print. You can just type in recipes.head in the Jupyter Notebook. But if you're running in code in a different script, you need to go ahead and type out the whole print recipes.head. And Pandas knows that that's going to do the first 5 lines of data. And if we flip back on over to the spreadsheet where we opened up our CSV file, you can see where it starts on line 2. This one calls it 0, and then 2, 3, 4, 5, 6 is going to match. Go and close that out because we don't need that anymore. And it always starts at 0. And it automatically indexes it since we didn't tell it to use an index in here. So that's the index number for the left-hand side. And it automatically took the top row as labels. So Pandas using it to read a CSV is just really slick and fast. One of the reasons we love our pandas. Not just because they're cute and cuddly teddy bears. And let's go ahead and plot our data And I'm not going to plot all of it. I'm just going to plot the sugar and flour. Now, obviously, you can see where they get really complicated if we have tons of different features. And so you'll break them up and maybe look at just 2 of them at a time to see how they connect. And to plot them, we're going to go ahead and use Seaborn. So that's our SNS. And the command for that is sns.lmplot. And then the 2 different variables I'm going to plot is flour and sugar. Data equals recipes. The hue equals type. And this is a lot of fun because it knows that this is pandas coming in. So this is one of the powerful things about pandas mixed with Seaborn and doing graphing. And then we're going to use a palette set 1. There's a lot of different sets in there. You can go look them up for Seaborn. We'll do a fit regular equals false, so we're not really trying to fit anything. And it's a scatter, KWS. A lot of these settings you can look up in Seaborn. Half of these you could probably leave off when you run them. Somebody played with this and found out that these were the best settings for doing a Seaborn plot. And let's go ahead and run that. And because it does it inline, it just puts it right on the page. And you can see right here that just based on sugar and flour alone, there's a definite split. And we use these models because you can actually look at it and say, hey, if I drew a line right between the middle of the blue dots and the red dots, we'd be able to do an SVM and a hyperplane right there in the middle. Then the next step is to format or pre-process our data. And we're going to break that up into 2 parts. We need a type label, and remember, we're going to decide whether it's a muffin or a cupcake. Well, a computer doesn't know muffin or cupcake, it knows 0 and 1. So, what we're going to do is we're going to create a type label, and from this we'll create a numpy array, np, where, and this is where we can do some logic. We take our recipes from our panda, and wherever type equals muffin, it's going to be 0. And then if it doesn't equal muffin, which is cupcakes, it's going to be 1. So we create our type label. This is the answer. So when we're doing our training model, remember we have to have a training data. This is what we're going to train it with, is that it's 0 or 1. It's a muffin or it's not. And then we're going to create our recipe features. And if you remember correctly from right up here, the first column is type. So we really don't need the type column because that's our muffin or cupcake. And in pandas, we can easily sort that out. We take our value recipes dot columns. That's a pandas function built into pandas. Dot values, converting them to values. So it's just the column titles going across the top. And we don't want the first one. So what we do is, since it always starts at 0, we want 1 colon till the end. And then we want to go ahead and make this a list, and this converts it to a list of strings. And then we can go ahead and just take a look and see what we're looking at for the features, make sure it looks right. Let me go ahead and run that. And I forgot the S on recipes, so we'll go ahead and add the S in there and then run that. And we can see we have flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. And that matches what we have up here, right where we printed out everything but the type. So we have our features and we have our label. Now, the recipe features is just the titles of the columns, and we actually need the ingredients. And at this point, we have a couple options. One, we could run it over all the ingredients. And when you're doing this, usually you do, but for our example, we want to limit it so you can easily see what's going on. Because if we did all the ingredients, we have, that's what, 7, 8 different hyperplanes that would be built into it. We only want to look at one so you can see what the SVM is doing. And so we'll take our recipes and we'll do just flour and sugar. Again, you can replace that with your recipe features and do all of them, but we're going to do just flour and sugar, and we're going to convert that to values. We don't need to make a list out of it because it's not string values. These are actual values on there. And we can go ahead and just print ingredients, and you can see what that looks like. And so we have just the amount of flour and sugar, just the two sets of plots. And just for fun, let's go ahead and take this over here and take our recipe features. And so if we decided to use all the recipe features, you'll see that it makes a nice column of different data. So it just strips out all the labels and everything. We just have just the values. But because we want to be able to view this easily in a plot later on, we'll go ahead and take that and just do flour and sugar. And we'll run that and you'll see it's just the two columns. So the next step is to go ahead and fit our model. We'll go ahead and just call it model. And it's a SVM. We're using a package called SVC. In this case, we're going to go ahead and set the kernel equals linear. So it's using a specific setup on there. And if we go to the reference on their website for the SVM, you'll see that there's 8 of them here. 3 of them are for regression. 3 are for classification. The SVC, support vector classification, is probably one of the most commonly used. And then there's also one for detecting outliers, and another one that has to do with something a little bit more specific on the model. But SVC and SVR are the 2 most commonly used, standing for support vector classifier and support vector regression. Remember, regression is an actual value, a float value or whatever you're trying to work on, and SVC is a classifier, so it's a yes, no, true, false. But for this, we want to know 0, 1, muffin, cupcake. We go ahead and create our model. And once we have our model created, we're going to do model.fit. And this is very common, especially in the sklearn. All their models are followed with the fit command. And what we put into the fit, what we're training with it, is we're putting in the ingredients, which in this case we limited to just flour and sugar, and the type label. Is it a muffin or a cupcake? Now, in more complicated data science series, you'd want to split into, we won't get into that today, we split it into training data and test data, and they even do something where they split it into thirds, where a third is used for, where you switch between which one's training and test. There's all kinds of things that go into that, and it gets very complicated when you get to the higher end. Not overly complicated, just an extra step, which we're not going to do today, because this is a very simple set of data. And let's go ahead and run this, and now we have our model fit. And I got an error here, so let me fix that real quick. It's capital SVC, it turns out. I did it lowercase. Support vector classifier. There we go. Let's go ahead and run that. And you'll see it comes up with all this information that it prints out automatically. These are the defaults of the model. You notice that we changed the kernel to linear. And there's our kernel linear on the printout. And there's other different settings you can mess with. We're going to just leave that alone for right now. For this, we don't really need to mess with any of those. So next, we're going to dig a little bit into our newly trained model. And we're going to do this so we can show you on a graph. And let's go ahead and get the separating. And we're going to say, we're going to use a W for our variable on here. And we're going to do model.coefficient _0. So what the heck is that? Again, we're digging into the model. So we've already got a prediction and a train. This is the math behind it that we're looking at right now. And so the W is going to represent 2 different coefficients. And if you remember, we had y equals mx plus c. So these coefficients are connected to that, but in 2-dimensional. It's a plane. We don't want to spend too much time on this because you can get lost in the confusion of the math. So if you're a math whiz, this is great. You can go through here and you'll see that we have a equals minus w of 0 over w of 1. Remember, there's 2 different values there. And that's basically the slope that we're generating. And then we're going to build an XX. What is XX? We're going to set it up to a numpy array. There's our np dot line space. So we're creating a line of values between 30 and 60. So it just creates a set of numbers for x. And then if you remember correctly, we have our formula, y equals the slope times x plus the intercept. Well, to make this work, we can do this as yy equals the slope times each value in that array. That's the neat thing about NumPy. So when I do a times xx, which is a whole NumPy array of values, it multiplies a across all of them. And then it takes those same values and we subtract the model intercept. That's your, remember we had mx plus c, so that'd be the c from the formula, y equals mx plus c. And that's where all these numbers come from. A little bit confusing because it's digging out of these different arrays. And then what we want to do is we're going to take this and we're going to go ahead and plot it. So plot the parallels to separating hyperplane that pass through the support vectors. And so we're going to create B equals a model support vectors, pulling our support vectors out there. Here's our YY, which we now know is a set of data. And we have we're going to create YY down equals A times XX plus B1 minus A times B0. And then model support vector B is going to be set that to a new value, the -1 setup, and YY up equals A times XX plus B1 minus A times B0. And we can go ahead and just run this to load these variables up. If you wanted to understand a little bit more of what's going on, you can see if we print YY, we just run that, you can see it's an array. This is a line. It's going to have, in this case, between 30 and 60, so it's going to be 30 variables in here. And the same thing with YY up, YY down. And we'll plot those in just a minute on a graph so you can see what those look like. You just go ahead and delete that out of here and run that so it loads up the variables. Nice clean slate. I'm just going to copy this from before. Remember this, our SNS, our seaborn plot, LM plot, flour, sugar. And I'll just go ahead and run that real quick so you can see remember what that looks like. It's just a straight graph on there. And then one of the neat things is because seaborn sits on top of PyPlot, we can do the PyPlot for the line going through. And that is simply plt.plot. And that's our XX and YY, our two corresponding values, XY. And then somebody played with this to figure out that the line width equals 2 and the color black would look nice. So let's go ahead and run this whole thing with the PyPlot on there. And you can see when we do this, it's just doing flour and sugar on here. Corresponding line between the sugar and the flour and the muffin versus cupcake. And then we generated the support vectors, the YY down and YY up. So let's take a look and see what that looks like. So we'll do our PL plot. And again, this is all against XX, our X value. But this time we have YY down. And let's do something a little fun with this. We can put in a K dash dash. That just tells it to make it a dotted line. And if we're going to do the down one, we also want to do the up one. So here's our YY up. And when we run that, it adds both sets of line. And so here's our support, and this is what you expect. You expect these two lines to go through the nearest data point. So the dashed lines go through the nearest muffin and the nearest cupcake when it's plotting it. And then your SVM goes right down the middle. So it gives it a nice split in our data. And you can see how easy it is to see, based just on sugar and flour, which one's a muffin or a cupcake. Let's go ahead and create a function to predict muffin or cupcake. I've got my recipes I pulled off the internet, and I want to see the difference between a muffin or a cupcake. And so we need a function to push that through. And we'll create a function with def. And let's call it muffin or cupcake. And remember, we're just doing flour and sugar today. We're not doing all the ingredients. And that actually is a pretty good split. You really don't need all the ingredients to know it's flour and sugar. And let's go ahead and do an if-else statement. So if model predict is of flour and sugar equals 0. So we take our model and we run a predict. It's very common in sklearn where you have a dot predict. You put the data in and it's going to return a value. In this case, if it equals 0, then print you're looking at a muffin recipe. Else, if it's not 0, that means it's 1, then you're looking at a cupcake recipe. That's pretty straightforward for a function, or def for definition. DEF is how you do that in Python. And of course, if you're going to create a function, you should run something in it. And so let's run a cupcake, and we're going to send it values 50 and 20, a muffin or a cupcake. I don't know what it is. And let's run this and just see what it gives us. And it says, oh, it's a muffin. You're looking at a muffin recipe. So it very easily predicts whether we're looking at a muffin or a cupcake recipe. Let's plot this. Oops, there we go. Plot this on the graph so we can see what that actually looks like. And I'm just going to copy it and paste it from below, where we're plotting all the points in there. So this is nothing different than what we did before. If I run it, you'll see it has all the points and the lines on there. And what we want to do is we want to add another point. And we'll do plt plot. And if you remember correctly, we did, for our test, we did 50 and 20. And then somebody went in here and decided we'll do YO for yellow, or it's kind of an orangish yellow color is going to come out. Marker size 9. Those are settings you can play with. Somebody else played with them to come up with the right setup so it looks good. And you can see there it is graphed, clearly a muffin. In this case, in cupcakes versus muffins, the muffin has won. And if you'd like to do your own muffin cupcake contender series, you certainly can send a note down below, and the team at Simplilearn will send you over the data they use for the muffin and cupcake. And that's true of any of the data. We didn't actually run a plot on it earlier. We had men versus women. You can also request that information to run it on your data setup so you can test that out. So to go back over our setup, we went ahead for our support vector machine code. We did a predict 40 parts flour, 20 parts sugar. I think it was different than the one we did, whether it's a muffin or a cupcake. Hence, we have built a classifier using SVM, which is able to classify if a recipe is of a cupcake or a muffin, which wraps up our cupcake versus muffin. What's in it for you? We're going to cover clustering. What is clustering? K-means clustering, which is one of the most common used clustering tools out there, including a flowchart to understand K-means clustering and how it functions. And then we'll do an actual Python live demo on clustering of cars based on brands. Then we're going to cover logistic regression. What is logistic regression? Logistic regression curve and sigmoid function. And then we'll do another Python code demo to classify a tumor as malignant or benign based on features. And let's start with clustering. Suppose we have a pile of books of different genres. Now we divide them into different groups like fiction, horror, education, and as we can see from this young lady, she definitely is into heavy horror. You can just tell by those eyes and the maple Canadian leaf on her shirt. But we have fiction, horror, and education, and we want to go ahead and divide our books up. Well, organizing objects into groups based on similarity is clustering. And in this case, as we're looking at the books, we're talking about clustering things with known categories. But you can also use it to explore data. So you might not know the categories, you just know that you need to divide it up in some way to conquer the data and to organize it better. But in this case, we're going to be looking at clustering in specific categories. And let's just take a deeper look at that. We're going to use K-means clustering. K-means clustering is probably the most commonly used clustering tool in the machine learning library. K-means clustering is an example of unsupervised learning. If you remember from our previous thing, it is used when you have unlabeled data. So we don't know the answer yet. We have a bunch of data that we want to cluster into different groups. Define clusters in the data based on feature similarity. So we've introduced a couple terms here. We've already talked about unsupervised learning and unlabeled data. So we don't know the answer yet. We're just going to group stuff together and see if we can find an answer of how things connect. We've also introduced feature similarity. Features being different features of the data. Now with books, we can easily see fiction and horror and history books. But a lot of times with data, some of that information isn't so easy to see right when we first look at it. And so K-means is one of those tools where we can start finding things that connect, that match with each other. Suppose we have these data points and want to assign them into a cluster. Now when I look at these data points, I would probably group them into two clusters just by looking at them. I'd say two of these group of data kind of come together. But in K-means, we pick K clusters and assign random centroids to clusters, where the K clusters represents two different clusters. We pick k clusters and assign random centroids to the clusters, then we compute distance from objects to the centroids. Now we form new clusters based on minimum distances and calculate the centroids. So we figure out what the best distance is for the centroid, then we move the centroid and recalculate those distances. Repeat previous two steps iteratively till the cluster centroids stop changing their positions and become static. Repeat previous two steps iteratively till the cluster centroids stop changing and the positions become static. Once the clusters become static, then k-means clustering algorithm is said to be converged. And there's another term we see throughout machine learning is converged. That means whatever math we're using to figure out the answer has come to a solution, or it's converged on an answer. Shall we see the flow chart to understand? Make a little bit more sense by putting it into a nice easy step-by-step. So we start, we choose k, we'll look at the elbow method in just a moment. We assign random centroids to clusters, and sometimes you pick the centroids, because you might look at the data in a graph and say, oh, these are probably the central points. Then we compute the distance from the objects to the centroids. We take that and we form new clusters based on minimum distance and calculate their centroids. Then we compute the distance from objects to the new centroids. And then we go back and repeat those last two steps. We calculate the distances. So as we're doing it, it brings into the new centroid, and then we move the centroid around and we figure out which objects are closest to each centroid. So the objects can switch from one centroid to the other as the centroids are moved around. And we continue that until it is converged. Let's see an example of this. Suppose we have this data set of 7 individuals and their score on 2 topics, A and B. So here's our subject, in this case referring to the person taking the test. And then we have subject A, where we see what they've scored on their first subject, and we have subject B, and we can see what they score on the second subject. Now let's take 2 farthest apart points as initial cluster centroids. Now remember, we talked about selecting them randomly, or we can also just put them in different points and pick the furthest one apart so they move together. Either one works okay, depending on what kind of data you're working on and what you know about it. So we took the 2 furthest points, 1 and 1, and 5 and 7. And now let's take the 2 farthest apart points as initial cluster centroids. Each point is then assigned to the closest cluster with respect to the distance from the centroids. So we take each one of these points in there, we measure that distance, and you can see that if we measured each of those distances, and you use the Pythagorean theorem for a triangle in this case, because you know the x and the y, and you can figure out the diagonal line from that. Or you can just take a ruler and put it on your monitor. That'd be kind of silly, but it would work if you're just eyeballing it. You can see how they naturally come together in certain areas. Now we again calculate the centroids of each cluster. So cluster 1 and then cluster 2, and we look at each individual dot. There's 1, 2, 3, we're in one cluster. The centroid then moves over. It becomes 1.8, 2.3. So remember, it was at 1 and 1? Well, the very center of the data we're looking at would put it at the roughly 2, 2, but 1.8 and 2.3. And the second one, if we wanted to make the overall mean vector, the average vector of all the different distances to that centroid, we come up with 4, 1 and 5, 4. So we've now moved the centroids. We compare each individual's distance to its own cluster, mean, and to that of the opposite cluster, and we find, we can build a nice chart on here, that as we move that centroid around, we now have a new different kind of clustering of groups, and using Euclidean distance between the points and the mean, we get the same formula. You see new formulas coming up. So we have our individual dots, distance to the mean, centroid of the cluster, and distance to the mean, centroid of the cluster. Only individual 3 is nearer to the mean of the opposite cluster, cluster 2, than its own cluster 1. And you can see here in the diagram where we've kind of circled that 1 in the middle. So when we've moved the centroids of the clusters over, one of the points shifted to the other cluster because it's closer to that group of individuals. Thus, individual 3 is relocated to cluster 2, resulting in a new partition. And we regenerate all those numbers of how close they are to the different clusters. For the new clusters, we will find the actual cluster centroids. So now we move the centroids over. And you can see that we've now formed 2 very distinct clusters on here. On comparing the distance of each individual's distance to its own cluster mean and to that of the opposite cluster, we find that the data points are stable. Hence, we have our final clusters. Now, if you remember, I brought up a concept earlier, k-mean on the k-means algorithm. Choosing the right value of k will help in less number of iterations. And to find the appropriate number of clusters in a data set, we use the elbow method. And within sum of squares, WSS, is defined as the sum of the squared distance between each member of the cluster and its centroid. And so you see what we've done here is we have the number of clusters. And as you do the same k-means algorithm over the different clusters, and you calculate what that centroid looks like, and you find the optimal, you can actually find the optimal number of clusters using the elbow of the graph, is called as the elbow method. And on this, we guessed at 2 just by looking at the data. But as you can see, the slope, you actually just look for right there where the elbow is in the slope, and you have a clear answer that we want 2 different, to start with k-means equals 2. A lot of times people end up computing k-means equals 2, 3, 4, 5 until they find the value which fits on the elbow joint. Sometimes you can just look at the data, and if you're really good with that specific domain, remember domain, I mentioned that last time, you'll know that where to pick those numbers or where to start guessing at what that k value is. So let's take this, and we're going to use a use case using k-means clustering to cluster cars into brands using parameters such as horsepower, cubic inches, make, year, etc. So we're going to use the dataset cars data, having information about 3 brands of cars, Toyota, Honda, and Nissan. We'll go back to my favorite tool, the Anaconda Navigator with the Jupyter Notebook. And let's go ahead and flip over to our Jupyter Notebook. And in our Jupyter Notebook, I'm going to go ahead and just paste the basic code that we usually start a lot of these off with. We're not going to go too much into this code because we've already discussed NumPy, we've already discussed matplotlib and pandas. NumPy being the number array, pandas being the pandas data frame, and matplot for the graphing. And don't forget, since if you're using the Jupyter Notebook, you do need the matplot library inline so that it plots everything on the screen. If you're using a different Python editor, then you probably don't need that because it'll have a pop-up window on your computer. And we'll go ahead and run this just to load our libraries and our setup into here. The next step is, of course, to look at our data, which I've already opened up in a spreadsheet. And you can see here we have the miles per gallon, cylinders, cubic inches, horsepower, weight pounds, how heavy it is, time it takes to get to 60. My card is probably on this one at about 80 or 90. What year it is. So this is, you can actually see this is kind of older cars, and then the brand, Toyota, Honda, Nissan. So the different cars are coming from all the way from 1971 if we scroll down to the 80s. We have between the 70s and 80s a number of cars that they've put out. And let's when we come back here, we're going to do importing the data. So we'll go ahead and do dataset equals, and we'll use pandas to read this in, and it's from a CSV file. Remember, you can always post this in the comments and request the data files for these, either in the comments here on the YouTube video or go to Simplilearn.com and request that. The cars CSV, I put it in the same folder as the code that I've stored. So my Python code is stored in the same folder, so I don't have to put the full path. If you store them in different folders, you do have to change this and double check your name variables. And we'll go ahead and run this, and we've chosen dataset arbitrarily because it's a dataset we're importing. And we've now imported our cars CSV into the dataset. As you know, you have to prep the data. So we're going to create the X data. This is the one that we're going to try to figure out what's going on with. And then there's a number of ways to do this, but we'll do it in a simple loop so you can actually see what's going on. So we'll do for I in x.columns. So we're going to go through each of the columns, and a lot of times it's important. I'll make lists of the columns and do this because I might remove certain columns, or there might be columns that I want to be processed differently. But for this, we can go ahead and take x of I, and we want to go fill NA, and that's a pandas command. But the question is, what are we going to fill the missing data with? We definitely don't want to just put in a number that doesn't actually mean something. And so one of the tricks you can do with this is we can take x of I, and then in addition to that, we want to go ahead and turn this into an integer, because a lot of these are integers. So we'll go ahead and keep it integers. And we add the bracket here. And a lot of editors will do this. They'll think that you're closing one bracket. Make sure you get that second bracket in there if it's a double bracket. That's always something that happens regularly. So once we have our integer of x of I, this is going to fill in any missing data with the average. And I was so busy closing one set of brackets, I forgot that the mean also has brackets in there for the pandas. So we can see here we're going to fill in all the data with the average value for that column. So if there's missing data, it's in the average of the data it does have. And then once we've done that, we'll go ahead and loop through it again and just check and see. to make sure everything is filled in correctly. And we'll print, and then we take x is null, and this returns a set of the null value, or the how many lines are null, and we'll just sum that up to see what that looks like. And so when I run this, and so with the x, what we want to do is we want to remove the last column because that had the models. That's what we're trying to see, if we can cluster these things and figure out the models. There is so many different ways to sort the x out. For one, we could take the x and we could go data set, our variable we're using, and use the iLocation, one of the features that's in pandas. And we could take that and then take all the rows and all but the last column of the data set. And at this time we could do values. We just convert it to values. So that's one way to do this. And if let me just put this down here and print x, it's a capital X we chose, and I run this, you can see it's just the values. We could also take out the values and it's not going to return anything because there's no values connected to it. What I like to do with this is, instead of doing the iLocation, which does integers, more common is to come in here and we have our data set, and we're going to do dataset dot columns. And remember, that lists all the columns. So if I come in here, let me just mark that as red, and I print dataset dot columns. You can see that I have my index here. I have my MPG, cylinders, everything, including the brand, which we don't want. So the way to get rid of the brand would be to do data columns of everything but the last one, -1. So now if I print this, you'll see the brand disappears. And so I can actually just take dataset columns -1, and I'll put it right in here for the columns we're going to look at. And let's unmark this and unmark this. And now if I do an x.head, I now have a new data frame, and you can see right here we have all the different columns except for the brand at the end of the year. And it turns out when you start playing with the data set, you're going to get an error later on, and it'll say cannot convert string to float value. And that's because for some reason these things, the way they recorded them, must have been recorded as strings. So we have a neat feature in here on pandas to convert. And it is simply convert objects. And for this we're going to do convert underscore numeric equals true. And yes, I did have to go look that up. I don't have it memorized, the convert numeric in there. If I'm working with a lot of these things, I remember them, but depending on where I'm at, what I'm doing, I usually have to look it up. And we run that. Oops, I must have missed something in here. Let me double check my spelling. And when I double check my spelling, you'll see I missed the first underscore in the convert objects. And when I run this, it now has everything converted into a numeric value, because that's what we're going to be working with, is numeric values down here. And the next part is that we need to go through the data and eliminate null values. Most people, when they're doing small amounts, working with small data pools, discover afterwards that they have a null value and they have to go back and do this. So, be aware, whenever we're formatting this data, things are going to pop up, and sometimes you go backwards to fix it. And that's fine. That's just part of exploring the data and understanding what you have. And I should have done this earlier, but let me go ahead and increase the size of my window one notch. There we go. Easier to see. So we'll do for I in working with x dot columns. We'll page through all the columns. And we want to take x of I, and we're going to change that, and we're going to alter it. And so with this, we want to go ahead and fill in x of I. Pandas has the fill in a, and that just fills in any non-existent missing data. And we'll put my brackets up, and there's a lot of different ways to fill this data. If you have a really large data set, some people just void out that data and then look at it later in a separate exploration of data. One of the tricks we can do is we can take our column and we can find the means. And the means is in our quotation marks. So when we take the columns, we're going to fill in the non-existing one with the means. The problem is that returns a decimal float. So some of these aren't decimals. Certainly Let me be a little careful of doing this, but for this example, we're just going to fill it in with the integer version of this. It keeps it on par with the other data that isn't a decimal point. And then what we also want to do is we want to double check. A lot of times you do this first part first to double check, then you do the fill, and then you do it again just to make sure you did it right. So we're going to go through and test for missing data. And one of the ways you can do that is simply go in here and take our x of I column. So it's going to go through the x of I column. It says is null. So it's going to return any place there's a null value. It actually goes through all the rows of each column is null, and then we want to go ahead and sum that. So we take that and we add the sum value, and these are all pandas. So is null is a panda command, and so is sum. And if we go through that and we go ahead and run it, and we go ahead and take and run that, you'll see that all the columns have 0 null values. So we've now tested and double checked, and our data is nice and clean. We have no null values. Everything is now a number value. We turned it into numeric. And we've removed the last column in our data. And at this point, we're actually going to start using the elbow method to find the optimal number of clusters. So we're now actually getting into the sklearn part, the k-means clustering on here. I guess we'll go ahead and zoom it up one more notch so you can see what I'm typing in here. And then from sklearn, sklearn cluster, we're going to import k-means. I always forget to capitalize the k and the m when I do this. So it's capital K, capital M, k-means. And we'll go ahead and create a array, WCSS equals, we'll make it an empty array. If you remember from the elbow method from our slide, within the sum of squares, WSS is defined as the sum of square distance between each member of the cluster and its centroid. So we're looking at that change in differences as far as a square distance. And we're going to run this over a number of k-mean values. In fact, let's go for I in range, we'll do 11 of them. Range 0 of 11. And the first thing we're going to do is we're going to create the actual, we'll do it all lowercase. And so we're going to create this object from the k-means that we just imported. And the variable that we want to put into this is in clusters. And we're going to set that equals to I. That's the most important one because we're looking at how increasing the number of clusters changes our answer. There are a lot of settings to the k-means. Our guys in the back did a great job just kind of playing with some of them. The most common ones that you see in a lot of stuff is how you init your k-means. So we have k-means plus plus. This is just a tool to let the model itself be smart how it picks its centroids to start with, its initial centroids. We only want to iterate no more than 300 times. We have a max iteration we put in there. We have the nth init, the random state equals 0. You really don't need to worry too much about these when you're first learning this. As you start digging in deeper, you start finding that these are shortcuts that will speed up the process as far as the setup. But the big one that we're working with is the in clusters equals I. So we're going to literally train our k-means 11 times. We're going to do this process 11 times. And if you're working with big data, you know the first thing you do is you run a small sample of the data so you can test all your stuff on it. And you can already see the problem that if I'm going to iterate through a terabyte of data 11 times, and then the k-means itself is iterating through the data multiple times, that's a heck of a process. So you got to be a little careful with this. A lot of times, though, you can find your elbow, using the elbow method, find your optimal number on a sample of data, especially if you're working with larger data sources. So we want to go ahead and take our k-means, and we're just going to fit it. If you're looking at any of the sklearn, very common, you fit your model. And if you remember correctly, our variable we're using is the capital X. And once we fit this value, we go back to the array we made, and we want to go ahead and just append that value on the end. And it's not the actual fit we're pinning in there, it's when it generates the value you're looking for is inertia. So k-means.inertia will pull that specific value out that we need. And let's get a visual on this. We'll do our PLT plot, and what we're plotting here is first the x-axis, which is range 0, 11, so that will generate a nice little plot there, and the WCSS for our y-axis. It's always nice to give our plot a title, and let's see, we'll just give it the elbow method for the title, and let's get some labels. So let's go ahead and do PLT X label, and what we'll do number of clusters for that, and PLT Y label, and for that we can do, oops, there we go, WCSS, since that's what we're doing on the plot on there. And finally we want to go ahead and display our graph, which is simply PLT dot show. There we go. And because we have it set to inline, it'll appear inline. Hopefully I didn't make a type error on there. And you can see we get a very nice graph. You can see a very nice elbow joint there at 2, and again right around 3 and 4, and then after that there's not very much. Now, as a data scientist, if I was looking at this, I would do either 3 or 4, and I'd actually try both of them to see what the output looked like. And they've already tried this in the back, so we're just going to use 3 as a setup on here. And let's go ahead and see what that looks like when we actually use this to show the different kinds of cars. And so let's go ahead and apply the k-means to the cars data set. And basically we're going to copy the code that we looped through up above, where k-means equals k-means number of clusters, and we're just going to set the number of clusters to 3, since that's what we're going to look for. And you could do 3 and 4 on this and graph them just to see how they come up differently. It'd be kind of curious to look at that. But for this we're just going to set it to 3. Go ahead and create our own variable y k-means for our answers. And we're going to set that equal to, whoops, a double equal there, to k-means, but we're not going to do a fit. We're going to do a fit predict is the setup you want to use. And when you're using untrained models, you'll see a slightly different, because usually you see fit and then you see just the predict. But we want to both fit and predict the k-means on this. And that's fit underscore predict, and then our capital X is the data we're working with. And before we plot this data, we're going to do a little pandas trick. We're going to take our x value and we're going to set x as matrix. So we're converting this into a nice rows and columns kind of setup, but we're going to have columns equals none, so it's just going to be a matrix of data in here. And let's go ahead and run that. A little warning. You'll see these warnings pop up because things are always being updated. So there's like minor changes in the versions and future versions. Instead of matrix, now it's more common to set it dot values instead of doing as matrix. But as matrix works just fine for right now, and you'll want to update that later on. But let's go ahead and dive in and plot this and see what that looks like. And before we dive into plotting this data, I always like to take a look and see what I am plotting. So let's take a look at y k-means, and I'm just going to print that out down here. And we see we have an array of answers. We have 2, 1, 0, 2, 1, 2. So it's clustering these different rows of data based on the 3 different spaces it thinks it's going to be. And then let's go ahead and print x and see what we have for x. And we'll see that x is an array, it's a matrix, so we have our different values in the array. And what we're going to do, it's very hard to plot all the different values in the array. So we're only going to be looking at the first 2, or positions 0 and 1. And if you were doing a full presentation in front of the board meeting, you might actually do a little different and dig a little deeper into the different aspects, because this is all the different columns we looked at. But we'll only look at columns 1 and 2 for this to make it easy. So let's go ahead and clear this data out of here, and let's bring up our plot. And we're going to do a scatter plot here. So PLT scatter, and this looks a little complicated, so let's explain what's going on with this. We're going to take the x values, and we're only interested in y of k-means equals 0, the first cluster. Okay? And then we're going to take value 0 for the x-axis, and then we're going to do the same thing here. We're only interested in k-means equals 0, but we're going to take the second column. So we're only looking at the first 2 columns in our answer, or in the data. And then the guys in the back played with this a little bit to make it pretty. And they discovered that it looks good if it has a size equals 100. That's the size of the dots. We're going to use red for this one. And when they were looking at the data and what came out, it was definitely the Toyota on this. We're just going to go ahead and label it Toyota. Again, that's something you really have to explore in here as far as playing with those numbers and see what looks good. We'll go ahead and hit enter in there. And I'm just going to paste in the next 2 lines, which is the next 2 cars. And this is our Nissan and Honda. And you'll see with our scatter plot, we're now looking at where y_k means equals 1. And we want the 0 column and yk means equals 2. Again, we're looking at just the first 2 columns, 0 and 1. And each of these rows then corresponds to Nissan and Honda. And I'll go ahead and hit enter on there. And finally, let's take a look and put the centroids on there. Again, we're going to do a scatter plot. And on the centroids, you can just pull that from our k-means, the model we created, dot cluster centers, and we're going to just do all of them in the first number and all of them in the second number, which is 0, 1, because you always start with 0 and 1. And then they were playing with the size and everything to make it look good. We'll do a size of 300. We're going to make the color yellow, and we'll label them. It's always good to have some good labels, centroids. And then we do want to do a title, PLT title, and pop up there. PLT title, because you always want to make your graphs look pretty, and we'll call it clusters of car make. And one of the features of the plot library is you can add a legend. It'll automatically bring in it since we've already labeled the different aspects of the legend with Toyota, Nissan, and Honda. And finally, we want to go ahead and show, so we can actually see it. And remember, it's inline, so if you're using a different editor that's not the Jupyter Notebook, you'll get a pop-up of this. And you should have a nice set of clusters here. So we can look at this, and we have clusters of Honda in green, Toyota in red, Nissan in purple. And you can see where they put the centroids to separate them. Now, when we're looking at this, we can also plot a lot of other different data on here because we only looked at the first 2 columns. This is just column 1 and 2, or 0, 1 as you label them in computer scripting. But you can see here we have nice clusters of car make, and we were able to pull out the data, and you can see how just these 2 columns form very distinct clusters of data. So if you were exploring new data, you might take a look and say, well, what makes these different? Almost going in reverse, you start looking at the data and pulling apart the columns to find out why is the first group set up the way it is. Maybe you're doing loans and you want to go, well, why is this group not defaulting on their loans? And why is the last group defaulting on their loans? And why is the middle group 50% defaulting on their bank loans? And you start finding ways to manipulate the data and pull out the answers you want. So now that you've seen how to use k-mean for clustering, let's move on to the next topic. Now let's look into logistic regression. The logistic regression algorithm is the simplest classification algorithm used for binary or multi-classification problems. And we can see we have our little girl from Canada who's into horror books is back. That's actually really scary when you think about that with those big eyes. In the previous tutorial, we learned about linear regression, dependent and independent variables. So, to brush up, y equals mx plus c, a very basic algebraic function of y and x. The dependent variable is the target class variable we are going to predict. The independent variables, x1 all the way up to xn, are the features or attributes we're going to use to predict the target class. We know what a linear regression looks like, but using the graph, we cannot divide the outcome into categories. It's really hard to categorize 1.5, 3.6, 9.8. For example, a linear regression graph can tell us that with increase in number of hours studied, the marks of a student will increase, but it will not tell us whether the student will pass or not. In such cases where we need the output as categorical value, we will use logistic regression. And for that, we're going to use the sigmoid function. So you can see here we have our marks, 0 to 100, number of hours studied. That's going to be what they're comparing it to in this example. And we usually form a line that says y equals mx plus c, And when we use the sigmoid function, we have p equals 1 over 1 plus e to the minus y. It generates a sigmoid curve. And so you can see right here, when you take the ln, which is the natural logarithm, I always thought it should be nl, not ln. That's just the inverse of e, or e to the minus y. And so when we do this, we get ln of p over 1 minus p equals m times x plus c. That's the sigmoid curve function we're looking for. And we can zoom in on the function, and you'll see that the function, as it derives, goes to 1 or to 0, depending on what your x value is. And the probability, if it's greater than 0.5, the value is automatically rounded off to 1, indicating that the student will pass. So if they're doing a certain amount of studying, they will probably pass. Then you have a threshold value at the 0.5. It automatically puts that right in the middle usually. And your probability, if it's less than 0.5, the value rounded off to 0, indicating the student will fail. So if they're not studying very hard, they're probably going to fail. This, of course, is ignoring the outliers of that one student who's just a natural genius and doesn't need any studying to memorize everything. That's not me, unfortunately. I have to study hard to learn new stuff. Problem statement: to classify whether a tumor is malignant or benign. And this is actually one of my favorite data sets to play with because it has so many features, and when you look at them, you really are hard to understand. You can't just look at them and know the answer. So it gives you a chance to kind of dive into what data looks like when you aren't able to understand the specific domain of the data. But I also want you to remind you that in the domain of medicine, if I told you that my probability was really good at classified things at, say, 90% or 95%, and I'm classifying whether you're going to have a malignant or a benign tumor, I'm guessing that you're going to go get it tested anyways. So you got to remember the domain we're working with. So why would you want to do that if you know you're just going to go get a biopsy because, you know, it's that serious? This is like an all or nothing. Just referencing the domain, it's important. It might help the doctor know where to look just by understanding what kind of tumor it is. So it might help them or aid them in something they missed from before. So let's go ahead and dive into the code, and I'll come back to the domain part of it in just a minute. So use case, and we're going to do our normal imports here, where we're importing NumPy, Pandas, Seaborn, the Matplot library, and we're going to do Matplot library inline since I'm going to switch over to Anaconda. So let's go ahead and flip over there and get this started. So I've opened up a new window in my Anaconda Jupyter Notebook. And by the way, Jupyter Notebook, you don't have to use Anaconda for the Jupyter Notebook. I just love the interface and all the tools that Anaconda brings. So we got our import NumPy as in P for our NumPy number array. We have our Pandas PD. We're going to bring in Seaborn to help us with our graphs as SNS. So many really nice tools in both Seaborn and Matplot library. Then we'll do our Matplot library.pyplot as PLT, and then of course we want to let it know to do it in line. And let's go ahead and just run that so it's all set up. And we're just going to call our data, not creative today, equals PD, and this happens to be in a CSV file. So we'll use the pd.read_CSV, and I happen to name the file, I renamed it, data for p2.csv. You can, of course, write in the comments below the YouTube and request for the data set itself, or go to the Simplilearn website, and we'll be happy to supply that for you. And let's just open up the data before we go any further, and let's just see what it looks like in a spreadsheet. So when I pop it open in a local spreadsheet, and this is just a CSV file, comma-separated variables, we have an ID, so I guess they categorize this for reference or what ID, which test was done. The diagnosis, M for malignant, B for benign, so there's two different options on there. And that's what we're going to try to predict is the M and B and test it. And then we have like the radius mean or average, the texture average, perimeter mean, area mean, smoothness. I don't know about you, but unless you're a doctor in the field, most of the stuff, I mean, you can guess what concave means just by the term concave, but I really wouldn't know what that means in the measurements they're taking. So they have all kinds of stuff like how smooth it is, the symmetry, and these are all float values. We can just page through them real quick, and you'll see there's, I believe, 36 if I remember correctly in this one. So there's a lot of different values they take and all these measurements they take when they go in there and they take a look at the different growth, the tumorous growth. So back in our data, and I put this in the same folder as the code. So I saved this code in that folder. Obviously, if you have it in a different location, you want to put the full path in there. And we'll just do pandas first 5 lines of data with the data.head. When we run that, we can see that we have pretty much what we just looked at. We have an ID, we have a diagnosis. If we go all the way across, you'll see all the different columns coming across displayed nicely for our data. And while we're exploring the data, our Seaborn, which we referenced as SNS, makes it very easy to go in here and do a joint plot. You'll notice very similar to, because it is sitting on top of the plot library, so the joint plot does a lot of work for us. And we're just going to look at the first 2 columns that we're interested in, the radius mean and the texture mean. We'll just look at those 2 columns. And data equals data. So that tells it which 2 columns we're plotting and that we're going to use the data that we pulled in. And let's just run that. And it generates a really nice graph on here. And there's all kinds of cool things on this graph to look at. I mean, we have the texture mean and the radius mean, obviously the axes. You can also see, one of the cool things on here is you can also see the histogram. They show that for the radius mean. Where is the most common radius mean come up and where the most common texture is. So we're looking at on each growth its average texture, and on each radius its average radius on there. It gets a little confusing because we're talking about the individual object's average, and then we can also look over here and see the histogram showing us the median, or how common each measurement is. And that's only 2 columns, so let's dig a little deeper into Seaborn. They also have a heat map. And if you're not familiar with heat maps, a heat map just means it's in color. That's all that means. Heat map. I guess the original ones were plotting heat density on something, and so ever since then it's just called a heat map. And we're going to take our data and get our corresponding numbers to put that into the heat map. And that's simply data.corr for that. That's a pandas expression. So remember, we're working in a pandas data frame, so that's one of the cool tools in pandas for our data. And let's just pull that information into a heat map and see what that looks like. And you'll see that we're now looking at all the different features. We have our ID, we have our texture, we have our area, our compactness, concave points. And if you look down the middle of this chart, diagonal, going from the upper left to bottom right, it's all white. That's because when you compare texture to texture, they're identical. So they're 100%, or in this case, a perfect 1 in their correspondence. And you'll see that when you look at, say, area, or right below it, it has almost a black on there when you compare it to texture. So these have almost no corresponding data. They don't really form a linear graph or something that you can look at and say how connected they are. They're very scattered data. This is really just a really nice graph to get a quick look at your data. It doesn't so much change what you do, but it changes verifying. So when you get an answer or something like that, or you start looking at some of these individual pieces, you might go, hey, that doesn't match. According to showing our heat map, this should not correlate with each other. And if it is, you're going to have to start asking, well, why? What's going on? What else is coming in there? But it does show some really cool information on here. I mean, we can see from the ID, there's no real one feature that just says, if you go across the top line, that lights up. There's no one feature that says, hey, if the area is a certain size, then it's going to be benign or malignant. It says there's some that sort of add up. And that's a big hint in the data that we're trying to ID this, whether it's malignant or benign. That's a big hint to us as data scientists to go, okay, we can't solve this with any one feature. It's going to be something that includes all the features, or many of the different features, to come up with a solution for it. And while we're exploring the data, let's explore one more area, and let's look at data.isNull. We want to check for null values in our data. And if you remember from earlier in this tutorial, we did it a little differently where we added stuff up and summed them up. You can actually, with pandas, do it really quickly, data.isNull and sum it, and it's going to go across all the columns. So when I run this, you're going to see all the columns come up with no null data. So we've just to rehash these last few steps, we've done a lot of exploration. We have looked at the first 2 columns and seen how they plot with the Seaborn, with a joint plot, which shows both the histogram and the data plotted on the XY coordinates. And obviously, you can do that more in detail with different columns and see how they plot together. And then we took and did the seaborne heat map, the SNS heat map of the data. And you can see right here where it did a nice job showing us some bright spots where stuff correlates with each other and forms a very nice combination or points of scattering points. And you can also see areas that don't. And then finally we went ahead and checked the data. Is the data null value? Do we have any missing data in there? Very important step because it'll crash later on. If you forget to do this step, it will remind you when you get that nice error code that says null values. Okay, so not a big deal if you miss it, but it's no fun having to go back when you're in a huge process and you've missed this step, and now you're 10 steps later and you got to go remember where you were pulling the data in. So we need to go ahead and pull out our x and our y. So we just put that down here, and we'll set the x equal to, and there's a lot of different options here. Certainly we could do x equals all the columns except for the first two, because if you remember the first two is the ID and the diagnosis. So that certainly would be an option. But what we're going to do is we're actually going to focus on the worst radius, the worst texture, parameter, area, smoothness, compactness, and so on. One of the reasons to start dividing your data up when you're looking at this information is sometimes the data will be the same data coming in. So if I have two measurements coming into my model, it might overweigh them. It might overpower the other measurements because it's basically taking that information in twice. That's a little bit past the scope of this tutorial. What I want you to take away from this, though, is that we are dividing the data up into pieces, and our team in the back went ahead and said, hey, let's just look at the worst. So I'm going to create an array, and you'll see this array, radius worst, texture worst, perimeter worst. We've just taken the worst of the worst, and I'm just going to put that in my X. So this X is still a pandas data frame, but it's just those columns. And our Y, if you remember correctly, is going to be, oops, hold on one second. It's not X, it's data. There we go. So X equals data, and then it's a list of the different columns, the worst of the worst. And if we're going to take that, then we have to have our answer for our Y, for the stuff we know. And if you remember correctly, we're just going to be looking at the diagnosis. That's all we care about is what is it diagnosed? Is it benign or malignant? And since it's a single column, we can just do diagnosis. Oh, I forgot to put the brackets. There we go. Okay. So it's just diagnosis on there. And we can also real quickly do like x dot head if you want to see what that looks like. And y dot head. And run this. And you'll see it only does the last one. I forgot about that if you don't do print. You can see that the y dot head is just MMM because the first ones are all malignant. And if I run this, the x dot head is just the first 5 values of radius worst, texture worst, parameter worst, area worst, and so on. I'll go ahead and take that out. So moving down to the next step, we've built our two data sets, our answer and then the features we want to look at. In data science, it's very important to test your model. So we do that by splitting the data. And from sklearn model selection, we're going to import train test split. So we're going to split it into 2 groups. There are so many ways to do this. I noticed in one of the more modern ways, they actually split it into 3 groups, and then you model each group and test it against the other groups. So you have all kinds of, and there's reasons for that, which is past the scope of this, and for this particular example isn't necessary. For this, we're just going to split it into 2 groups, one to train our data and one to test our data. And the sklearn model selection, we have train test split. You could write your own quick code to do this where you just randomly divide the data up into 2 groups, but they do it for us nicely. And we can actually do it in one statement with this, where we're going to generate 4 variables, capital X train, capital X test. So we have our training data we're going to use to fit the model, and then we need something to test it. And then we have our Y train, so we're going to train the answer, and then we have our test. So this is the stuff we want to see how good it did on our model. And we'll go ahead and take our train test split that we just imported, and we're going to do X and our Y, our 2 different data that's going in for our split. And then the guys in the back came up and wanted us to go ahead and use a test size equals 0.3. That's test underscore size. Random state. It's always nice to kind of switch your random state around, but not that important. What this means is that the test size is we're going to take 30% of the data and we're going to put that into our test variables, our Y test and our X test. And we're going to do 70% into the X train and the Y train. So we're going to use 70% of the data to train our model and 30% to test it. Let's go ahead and run that and load those up. So now we have all our stuff split up and all our data ready to go. And now we get to the actual logistics part. We're actually going to create our model. So let's go ahead and bring that in from sklearn. We're going to bring in our linear model and we're going to import logistic regression. That's the actual model we're using. And this, we'll call it log model. Oops, there we go, model. And let's just set this equal to our logistic regression that we just imported. So now we have a variable log model set to that class for us to use. And with most of the models in the sklearn, we just need to go ahead and do a fit on there. And we use our X train that we separated out with our Y train. Now let's go ahead and run this. So once we've run this, we'll have a model that fits this data, that 70% of our training data. And of course it prints this out that tells us all the different variables that you can set on there. There's a lot of different choices you can make. But for what we're doing, we're just going to let all the defaults sit. We don't really need to mess with those on this particular example. And there's nothing in here that really stands out as super important until you start fine-tuning it. But for what we're doing, the basics will work just fine. And then we need to go ahead and test out our model. Is it working? So let's create a variable yPredict. And this is going to be equal to our log model. And we want to do a predict. Again, very standard format for the sklearn library is taking your model and doing a predict on it. And we're going to test yPredict against the Y test. So we want to know what the model thinks it's going to be. That's what our yPredict is. And with that, we want the capital X test. So we have our train set and our test set. And now we're going to do our yPredict. And let's go ahead and run that. And if we print yPredict, let me go ahead and run that. You'll see it comes up and it prints a nice array of B and M for benign and malignant for all the different test data we put in there. So it does pretty good. We're not sure exactly how good it does, but we can see that it actually works and is functional. It was very easy to create. You'll always discover with our data science that as you explore this, you spend a significant amount of time prepping your data and making sure your data coming in is good. There's a saying, good data in, good answers out. Bad data in, bad answers out. That's only half the thing. That's only half of it. Selecting your models becomes the next part as far as how good your models are. And then, of course, fine-tuning it depending on what model you're using. So we come in here, we want to know how good this came out. So we have our yPredict here, logModel.predict X test. So for deciding how good our model is, we're going to go from the sklearn.metrics, we're going to import classification report. And that just reports how good our model is doing. And then we're going to feed it the model data. And let's just print this out. And we'll take our classification report. And we're going to put into there our test, our actual data. So this is what we actually know is true. And our prediction, what our model predicted for that data on the test side. And let's run that and see what that does. So we pull that up, you'll see that we have a precision for benign and malignant, B and M. And we have a precision of 93 and 91, a total of 92. So it's kind of the average between these two of 92. There's all kinds of different information on here. Your F1 score, your recall, your support coming through on this. And for this, I'll go ahead and just flip back to our slides that they put together for describing it. And so here we're going to look at the precision using the classification report. And you see this is the same printout I had up above. Some of the numbers might be different because it does randomly pick out which data we're using. So this model is able to predict the type of tumor with 91% accuracy. So we look back here, you'll see where we have benign and malignant. It actually is 92 coming up here. But we're looking at about a 92, 91% precision. And remember, I reminded you about domains. So when we're talking about the domain of a medical domain, with a very catastrophic outcome, at 91 or 92% precision, you're still going to go in there and have somebody do a biopsy on it. Very different than if you're investing money and there's a 92% chance you're going to earn 10% and 8% chance you're going to lose 8%, you're probably going to bet the money, because at that odds it's pretty good that you'll make some money, and in the long run, you do that enough, you definitely will make money. And also with this domain, I've actually seen them use this to identify different forms of cancer. That's one of the things that they're starting to use these models for, because then it helps the doctor know what to investigate. So that wraps up this section. We're going to go in there and let's discuss the answer to the quiz asked in Machine Learning Tutorial Part 1. Can you tell what's happening in the following cases? Grouping documents into different categories based on the topic and content of each document. This is an example of clustering where k-means clustering can be used to group the documents by topics using bag of words approach. So if you've gotten in there that you're looking for clustering, and hopefully you had at least one or two examples like k-means that are used for clustering different things, then give yourself a 2 thumbs up. B. Identifying handwritten digits in images correctly. This is an example of classification. The traditional approach to solving this would be to extract digit-dependent features like curvature of different digits, etc., and then use a classifier like SVM to distinguish between images. Again, if you got the fact that it's a classification example, give yourself a thumb up, and if you're able to go, hey, let's use SVM or another model for this, give yourself those 2 thumbs up on it. C. Behavior of a website indicating that the site is not working as designed. This is an example of anomaly detection. In this case, the algorithm learns what is normal and what is not normal, usually by observing the logs of the website. Give yourself a thumbs up if you got that one. And just for a bonus, can you think of another example of anomaly detection? One of the ones I use it for in my own business is detecting anomalies in stock markets. Stock markets are very fickle and they behave very erratic. So finding those erratic areas and then finding ways to track down why they're erratic. Was something released in social media? Was something released? You can see where knowing where that anomaly is can help you to figure out what the answer is to it in another area. D. Predicting salary of an individual based on his or her years of experience. This is an example of regression. This problem can be mathematically defined as a function between independent, years of experience, and dependent variables, salary of an individual. And if you guessed that this was a regression model, give yourself a thumbs up. And if you're able to remember that it is between independent and dependent variables and that terms, give yourself 2 thumbs up. Summary. So to wrap it up, we went over what is k-means. And we went through also the chart of choosing your elbow method and assigning a random centroid to the clusters, computing the distance, and then going in there and figuring out what the minimum centroids is and computing the distance and going through that loop until it gets the perfect centroid. And we looked into the elbow method to choose k based on running our clusters across a number of variables and finding the best location for that. We did a nice example of clustering cars with k-means, even though we only looked at the first 2 columns to make it simple and easy to graph. You can easily extrapolate that and look at all the different columns and see how they all fit together. And we looked at what is logistic regression. We discussed the sigmoid function, what is logistic regression, and then we went into an example of classifying tumors with logistics. I hope you enjoyed part 2 of machine learning.
In this video, we are going to learn how to automate Google Sheets using n8n. It is a very powerful workflow automation tool. We will start by setting up a webhook trigger to receive data from external sources, then connect it to Google Sheets to automatically store and update data in real time. By the end of this tutorial, guys, you will be able to capture form submissions, automate data entry without manual work, or set up live workflow that runs seamlessly. So whether you are a beginner or an automation pro, this tutorial is must-see for you. First, understanding what exactly is n8n. So I'm at the official website of n8n, and n8n is an open source workflow automation tool that allows you to connect various applications like APIs and databases without writing extensive code. It provides a visual editor where you can create workflows by linking different nodes. Think of it an alternative to Zapier and Apache Airflow. But this tool has more control and flexibility, and also it has self-hosting capabilities. Now if you see, the key features of n8n are as follows. It has this amazing visual editor where you can drag and drop nodes to create workflows. No complex coding is required. It has over 350 plus integrations, and it supports APIs, databases, messaging apps, AI tools, and cloud services. For example, you can think of like Google Sheets, Slack, Telegram, OpenAI, AWS, GitHub, MySQL. So it has integration to these tools. And apart from that, it has self-hosting and cloud options. You can run it on your own server for data privacy, also available as cloud service. It has also conditional logic and data transformation. It supports if condition, loops, branching. You could also modify API responses, filter data, and perform calculations. And guys, this feature is very amazing. For real-time automation, it has webhooks. So n8n can receive data from webhooks to trigger instant actions. For example, when a form is submitted in Typeform and send an email via Gmail. So it can automate in real time. Now you'd be wondering, how does n8n works? Now let us try to understand how n8n works exactly. So you can think of n8n as a digital assistant that automates your task without requiring you to write complex codes. It basically works by connecting different applications, services, and database into a sequence of steps called workflow. So if you go and log in to the creators.n8n.io.dashboard, if you register for this n8n, you're going to get a workflow template. Okay, you can go all over here. And you can share your template with the template name and give a description about it. And this could be your template code, whether it is free or paid. You can just click on this. And after that, I have reviewed my submission guidelines of n8n terms and services. And then you can click this workflow. Now, let us try to understand what exactly is a workflow. But before that, let us try to understand nodes. Okay, so nodes are tiny workers that do specific tasks. You can consider this something like that. And workflows are a sequence of nodes working together to complete a job. Like for example, let us say we are sending an email when you get a new form submission. Imagine you have a Google form where people can contact you. So every time someone builds the form, you want to automatically send them an email. So in n8n, you can create a workflow like this. So a Google Forms node collects the new response, and Gmail node sends an automatic email to the person who submits the form. So this is something like this. We'll be doing a one hands-on tutorial also to elaborate more about it. So this is one of the way how it works. Next, there is a concept of triggers. So there are trigger-based execution mode also, how to start your workflow. So you have to also understand, guys, that n8n workflows don't run all the time. They only start when something happens. So there are three ways to trigger a workflow. So the first one is trigger-based execution, okay, which is basically called as an event-driven. The workflow automatically starts when a specific event occurs. For example, let's say a new row is added to the Google Sheets. Now the workflow starts to run. Or you can think about it something like that. When a customer fills out a type form survey, the workflow runs. Think of it like a doorbell. When someone rings a bell, like for example, submits a form or updates a database, the workflow wakes up and does its jobs. Next one, we have the schedule execution, or we call it as cron jobs. Now here the workflow run on schedule, like daily, weekly, monthly. For example, every Monday at 9 a.m., a report is generated and sent via email. Or every hour, n8n checks for new tweets and saves them. Think of this like an alarm clock. You set it once and it automatically rings at the right time. Now let us discuss about the workflow components, which are like the brains of the system. So every n8n workflow is made up of different types of nodes. And each node has a special role, just like team members working on a project. So whenever we trigger the node or start the workflow, so what happens exactly? First, there is a webhook node, which starts someone when, like for example, someone is sending a data to your API. Then there is a scheduler node, which starts at a specific time, like every morning at around 8 a.m. And then there is a type form trigger node, which starts when someone fills out a type form survey. So we'll try to cover all these things in this today's tutorial. Now, there are some also nodes, like we call them as action nodes, which basically perform tasks. So these nodes do not actually work in your workflow. For example, let's say send an email node or send an email via Gmail or Outlook, or there is a HTTP request node which fetches the data from an API like a weather update or something. Then there is a Google Sheet node which like adds a new data to a spreadsheet. So these are called as action nodes, which basically performs task. Then you could also understand a bit about, let's say, logic nodes, which adds intelligence. So these nodes allow you to add conditions and decision in your workflow. For example, let's say if node checks a condition is met, like for example is an email from a VIP customer, you can imagine something like this. Then there is a switch node which routes the workflow based on different cases. Like for example, the payment example is the best one. Like if the payment is failed, send a reminder. Otherwise, if it's successful, send a confirmation. And then you could also find out the loop node, which repeats an action multiple times, like sending a follow-up email every 3 days. So guys, these were some of the logics nodes which basically adds intelligence. And finally, we have the data nodes, which store and retrieves the information. These nodes basically help you save and manage data. For example, like Google Sheet node, which helps you to read and write data from my spreadsheet, or MySQL node, which stores customer data in a database, or Airtable node, which basically updates information in a table. Think of it like filing cabinet. It organizes and stores important documents or data for future use. So putting up all together, let's say you run an online store and you want to notify your team on Slack when a new order is placed in Shopify. So here is how your init and workflow would look like. There is a trigger node, like Shopify will trigger, like it is going to detect a new order. Then the action node is going to come up, which is going to fetch order details from Shopify. Then there is a logic node. If the order is above $1,000, it marks it as a high priority. An action node which basically sends a Slack message to your sales team. So this is like the entire process which runs automatically, saving your time and effort. Now guys, you would be wondering, why should you use n8n? See guys, there is no need for coding skills. You can just drag and drop nodes. It saves a lot of time by automating repetitive tasks. And it works with hundreds of apps and APIs like Google, Slack, Shopify, ChatGPT, etc. It also has self-hosting option which ensures privacy and full control. And finally, it is free and open source, unlike some other tools which have some strict limits. Now we are going to move forward and do a small hands-on to make you more understand about this platform. So guys, now let us create an automation using n8n. So first click on the first step. And let's say we want to use a trigger, let's say on a webhook call. So basically when we will be sending any HTTP request like get, post, put or delete, it is going to trigger our webhook on n8n. So just click on this and you could see our method is, let's say, post, and we want to post a data on using this post request. And after selecting this, guys, just click for listen for test event. Let's test our webhook API. Copy this and then you can go to this online tool which is called as Recuben. Okay. And it is just a very simple tool where you could just do one thing. You could paste the same URL which you have copied it from here. Okay. Now, after going all from here, what are you going to do? Just click on the send request. Now, you could see we have got a successful message that the workflow has started. But how to be sure of that this thing is working? Because in the output section, you will be seeing these kind of output. Okay. So our webhook API is working very much fine. Now, what next thing you could do? So the next thing, let's say, let us add a node all over here. So for example, let's add a Google Sheet. Okay. And let us trigger an API. Okay. Let us say append a row in a sheet, or we want to update a row. So now you could see all over here, we have this option called append or update a row from this list. And let's say we have this document called monthly expense. And you could also choose it, let's say from expense, and we want to add these properties, what values to send. Suppose name, we could say the name as Neil, and all over here, that's one thing. Okay. Then what we could do, we could add another option, like what would be the cell format, and we could add the next property, let's say as email, let's say .com. Okay, now we could test these steps. Okay, now you could also say let's add a column, okay, to name. Okay, and let's say we could add just one value. Then we could add another column, let's say email. Okay, let's okay, we could write the name of another column. Okay, so we had only two columns that I have actually created all over here, name and email. So that's why our workflow is showing the same. And also, guys, there is one point to note. You have to also connect to your given applications. Okay, so I'll just show you how you could do it. But first, let us try to test this step. Okay, so okay, fine. We can choose it, match each column manually. And let's test the given step. Let's wait for the output. And if I open my Google Sheet, you could see, we can see, the name, email, and it's already mentioned here. So this is like how you are basically creating your workflow. So if you go back to your canvas, you could see our workflow has been created using the webhook call. Similarly, you can trigger a lot of, in a very different ways. Suppose you could add a next node, like you could add AI and all those things, and you can create this automation using n8n. Guys, this is a very amazing tool, and this automation tool is definitely going to save a lot of time for you.
In this video, we will learn about an important popular deep learning neural network called Generative Adversarial Networks. Jan LeCun, one of the pioneers in the field of machine learning and deep learning, described it as the most interesting idea in the last 10 years in machine learning. In this video, you will learn about what are generative adversarial networks and look in brief at generator and discriminator. Then, we'll understand how GANs work and the different types of GANs. Finally, we'll look at some of the applications of GANs. So let's begin. So what are generative adversarial networks? Generative Adversarial Networks, or GANs, introduced in 2014 by Ian J. Goodfellow and co-authors, became very popular in the field of machine learning. GAN is an unsupervised learning task in machine learning. It consists of two models that automatically discover and learn the patterns in input data. The two models, called generator and discriminator, compete with each other to analyze, capture, and copy the variations within a dataset. GANs can be used to generate new examples that possibly could have been drawn from the original dataset. In the image below, you can see that there is a database that has real 100 rupee notes. The generator, which is basically a neural network, generates fake 100 rupees notes. The discriminator network will identify if the notes are real or fake. Let us now understand in brief about what is a generator. A generator in GANs is a neural network that creates fake data to be trained on the discriminator. It learns to generate plausible data. The generated instances become negative training examples for the discriminator. It takes a fixed length random vector carrying noise as input and generates a sample. Now the main aim of the generator is to make the discriminator classify its output as real. The portion of the GAN that trains the generator includes a noisy input vector, the generator network, which transforms the random input into a data instance, a discriminator network which classifies the generated data, and a generator loss, which penalizes the generator for failing to dolt the discriminator. The backpropagation method is used to adjust each weight in the right direction by calculating the weight's impact on the output. The backpropagation method is used to obtain gradients, and these gradients can help change the generator weights. Now, let us understand in brief what a discriminator is. A discriminator is a neural network model that identifies real data from the fake data generated by the generator. The discriminator's training data comes from two sources. The real data instances, such as real pictures of birds, humans, currency notes, etc., are used by the discriminator as positive samples during the training. The fake data instances created by the generator are used as negative examples during the training process. While training the discriminator, it connects with two loss functions. During discriminator training, the discriminator ignores the generator loss and just uses the discriminator loss. In the process of training the discriminator classifies both real data and fake data from the generator. The discriminator loss penalizes the discriminator for misclassifying a real data instance as fake or a fake data instance as real. Now moving ahead, let's understand how GANs work. Now GANs consists of two networks, a generator which is represented as G of X and a discriminator which is represented as D of X. They both play an adversarial game where the generator tries to fool the discriminator by generating data similar to those in the training set. The discriminator tries not to be fooled by identifying fake data from the real data. They both work simultaneously to learn and train complex data like audio, video or image files. Now you are aware that GANs consists of two networks, a generator G of X and discriminator D of X. Now the generator network takes a sample and generates a fake sample of data. The generator is trained to increase the probability of the discriminator network to make mistakes. On the other hand, the discriminator network decides whether the data is generated or taken from the real sample using a binary classification problem with the help of a sigmoid function that gives the output in the range 0 and 1. Here is an example of a generative adversarial network trying to identify if the 100 rupee notes are real or fake. So first, a noise vector or the input vector is fed to the generator network. The generator creates fake 100 rupee notes. The real images of 100 rupee notes stored in a database are passed to the discriminator along with the fake notes. The discriminator then identifies the notes and classifies them as real or fake. We train the model, calculate the loss function at the end of the discriminator network, and backpropagate the loss into both discriminator and generator. Now the mathematical equation of training a GAN can be represented as, you can see here. Now this is the equation and these are the parameters. Here G represents generator, D represents the discriminator. Now P data of X is the probability distribution of real data, P of Z is the distribution of generator, X is the sample of probability data of X, Z is the sample size from P of Z, D of X is the discriminator network, and G of Z is the generator network. Now the discriminator focuses to maximize the objective function such that D of X is close to 1 and Z of Z is close to 0. It simply means that the discriminator should identify all the images from the training set as real, that is 1, and all the generated images as fake, that is 0. The generator wants to minimize the objective function such that D of Z of Z is 1. This means that the generator tries to generate images that are classified as real, that is 1, by the discriminator network. Next, let's see the steps for training a neural network. So we have to first define the problem and collect the data. Then we'll choose the architecture of GAN. Now depending on your problem, choose how your GAN should look like. Then we need to train the discriminator on real data. Now that will help us predict them as real for n number of times. Next, you need to generate fake inputs for the generator. After that, you need to train the discriminator on fake data to predict the generated data as fake. Finally, train the generator on the output of discriminator. With the discriminator predictions available, train the generator to fool the discriminator. Let us now look at the different types of GANs. So first we have vanilla GANs. Now vanilla GANs have min-max optimization formula that we saw earlier, where the discriminator is a binary classifier and is using sigmoid cross-entropy loss during optimization. In vanilla GANs, the generator and the discriminator are simple multi-layer perceptrons. The algorithm tries to optimize the mathematical equation using stochastic gradient descent. Up next, we have deep convolutional GANs or DC GANs. Now DC GANs support convolutional neural networks instead of vanilla neural networks at both discriminator and generator. They are more stable and generate higher quality images. The generator is a set of convolutional layers with fractional strided convolutions or transpose convolutions, so it unsamples the input image at every convolutional layer. The discriminator is a set of convolutional layers with strided convolutions, so it downsamples the input image at every convolutional layer. Moving ahead, the third type you have is conditional GANs or CGANs. Vanilla GANs can be extended into conditional models by using an extra label information to generate better results. In CGAN, an additional parameter called y is added to the generator for generating the corresponding data. Labels are fed as input to the discriminator to help distinguish the real data from fake data generated. Finally, we have super resolution GANs. Now, SR GANs use deep neural networks along with adversarial neural network to produce higher resolution images. Super resolution GANs generate a photorealistic high resolution image when given a low resolution image. Let's look at some of the important applications of GANs. So with the help of DC GANs, you can train images of cartoon characters for generating faces of anime characters and Pokemon characters as well. Next, GANs can be used on the images of humans to generate realistic faces. The faces that you see on your screens have been generated using GANs and do not exist in reality. Third application we have is GANs can be used to build realistic images from textual descriptions of objects like birds, humans, and other animals. We input a sentence and generate multiple images fitting the description. Here is an example of a text-to-image translation using GANs for a bird with a black head, yellow body, and a short beak. The final application we have is creating 3D objects. So GANs can generate 3D models using 2D pictures of objects from multiple perspectives. GANs are very popular in the gaming industry. GANs can help automate the task of creating 3D characters and backgrounds to give them a realistic feel.
Welcome to our video about transformers in AI. And no, we don't mean the robot toys from the movies. We are diving into something even cooler in the world of computers and AI. Have you ever wondered how your phone knows what word you might type next, or how Google Translate works so well? That's where transformers come in. They are like super smart computer brains that can understand and create human-like text. Here's a fun example. I asked a transformer to tell me a joke and it said, "Why did the computer go to the art school?" Because it wanted to improve its draw speed. Okay, that's a bit cheesy, but it shows how these computer programs can come up with new ideas on their own. Transformers are changing how we use technology every day. They help us with things like translating languages, summarizing long articles, writing emails and stories, and even playing games like chess. In this video, we will explore how transformers work, why they are so special, and what cool things they might do in the future. So let's talk about what exactly are transformers. Transformers are an artificial intelligence model used to process and generate natural languages. They can read and understand huge amount of text and then use that knowledge to answer questions, translate languages, summarize information, and even create stories or write code. The magic behind transformers is their ability to focus on different text paths with attention mechanisms. This means that they can understand context better than older models, making their outputs more accurate and natural sounding. The basic structure of a transformer includes two main parts, the encoder and the decoder. Think of the encoder as a translator that understands and processes the input, and the decoder as the one that takes the processed information and turns it into the output. For example, if we are translating a sentence from English to French, the encoder reads the English sentence and converts it into a form that AI can understand. The decoder then takes this form and generates the French sentence. A great example of a transformer in action is ChatGPT. ChatGPT uses transformers to understand and generate human-like text. When you ask a question, it processes your input with its encoder and generates a response with its decoder. This lets it have conversations, write essays, and even tell jokes. For instance, if you ask ChatGPT, "What's the weather like today?" it uses its transformer model to understand your question and respond it with "It's sunny, with a chance of rain in the afternoon." This ability to understand and generate text makes transformers incredibly powerful. So let's talk about how transformers work. Transformers are especially good at sequence-to-sequence learning tasks, like translating a sentence from one language to another. Here's how they work. First, there's the attention mechanism. This allows the transformer to focus on different parts of input data. For example, if it's translating the sentence, "The cat sat on the mat," it can pay attention to each word's context to understand the meaning better. So it knows cat is related to sat and mat, helping it produce an accurate translation in another language. Transformers also use something called positional encoding. Since they process all words at once, they need a way to understand the order of the words. Positional encoding adds information about the position of each word to the input, helping the transformers understand the sequence. Another key feature is like parallel processing. Unlike older models like recurrent neural network, which is RNNs, the process text words by word. Transformers can process the entire sentence at once. This makes them much faster and more efficient. Let's compare transformers with recurrent neural networks. But first, let's understand what are RNNs. So RNNs is a type of neural network designed to handle sequential data. They process data one step at a time, maintaining a memory of previous steps. This makes them good for tasks where order matters, like speech recognition or time series prediction. However, RNNs have a problem called the vanishing gradient, which means that they can forget information from earlier in the sequence. Imagine trying to understand the sentence, Alice went to the park and then to the store. And RNN might struggle to remember Alice by the time it gets to the store, but a transformer can easily keep track of Alice throughout the sentence. So why are transformers better? Unlike RNNs, transformers process the entire sentence at once, keeping the context intact. This solves the vanishing gradient problem and makes transformers faster and more accurate to tasks like language translation and text generation. So let's talk about the applications of transformers. At first, we have language translation. They are used by services like Google Translate to convert text from one language to another. For example, translating hello, how are you to Spanish as hola. Then we have document summarization. They can take long articles and summarize them into shorter, more concise versions. For instance, summarizing a 10-page report into a few key points, making it easier to understand the main ideas without reading the whole document. Then we have content generation. Transformers can write articles, stories, and even code. They can create new content based on what they have learned. For example, you could ask a transformer to write a short story about a space adventure, and then it would come up with a unique narrative. Then we have game playing. Transformers can learn and play complex games like chess, making strategic decisions just like a human player. They analyze the entire board and make moves considering all possible outcomes. Let's talk about image processing. They are used in tasks like image classification and object detection, helping computers understand visual data. For example, identifying objects in a photo, like recognizing a cat, tree, or a car. Now let's understand the training process. The training transformers involves two main steps. Semi-supervised learning. They can learn from both labeled data where the answer is known and unlabeled data where the answer is not provided. This makes them very versatile. For example, a transformer could be trained on a mix of articles with and without summaries to learn how to summarize text effectively. Pre-training and fine-tuning. Transformers are pre-trained on a large data set to learn general patterns. Then they are fine-tuned with specific tasks, making them highly versatile. For instance, a transformer might be pre-trained on a large collection of books to understand language and then fine-tuned to generate marketing copy for a specific brand. The future potential of transformers is huge. Researchers are continuously improving them, making them even more powerful. We can expect more advanced applications in areas like healthcare, finance, and more sophisticated AI systems that interact with humans in more natural ways. Imagine having an AI that can provide personalized medical advice or one that can help you write a novel. In conclusion, we can say that transformers are a revolutionary architecture in AI. They offer speed, efficiency, and versatility, changing how we interact with the technology. The future looks bright for transformers, and we can't wait to see what they'll do next.
Why reinforcement learning? Training a machine learning model requires a lot of data, which might not always be available to us. Further, the data provided might not be reliable. Learning from a small subset of actions will not help expand the vast realm of solutions that may work for a particular problem. You can see here we have the robot learning to walk. Very complicated setup when you're learning how to walk, and you'll start asking questions like, if I'm taking one step forward and left, well, what happens if I pick up a 50-pound object? How does that change how a robot would walk? These things are very difficult to program because there's no actual information on it until it's actually tried out. Learning from a small subset of actions will not help expand the vast realm of solutions that may work for a particular problem. And we'll see here it learned how to walk. This is going to slow the growth that technology is capable of. Machines need to learn to perform actions by themselves and not just learn off humans. And you see the objective climb a mountain. A real interesting point here is that as human beings, we can go into a very unknown environment and we can adjust for it and kind of explore and play with it. Most of the models, the non-reinforcement models in computer machine learning, aren't able to do that very well. There's a couple of them that can be used or integrated. To see how it goes is what we're talking about with reinforcement learning. So what is reinforcement learning? Reinforcement learning is a sub-branch of machine learning that trains a model to return an optimum solution for a problem by taking a sequence of decisions by itself. Consider a robot learning to go from one place to another. The robot is given a scenario and must arrive at a solution by itself. The robot can take different paths to reach the destination. It will know the best path by the time taken on each path. It might even come up with a unique solution all by itself. And that's really important, as we're looking for unique solutions. We want the best solution, but you can't find it unless you try it. So when we're looking at our different systems, our different model, we have supervised versus unsupervised versus reinforcement learning. And with the supervised learning, that is probably the most controlled environment. We have a lot of different supervised learning models, whether it's linear regression, neural networks, there's all kinds of things in between, decision trees. The data provided is labeled data with output values specified. And this is important because when we talk about supervised learning, you already know the answer for all this information. You already know the picture has a motorcycle in it, so you're supervised learning. You already know that the outcome for tomorrow, for going back a week, you're looking at stock, you can already have like the graph of what the next day looks like, so you have an answer for it. And you have labeled data which is used, you have an external supervision, and solves problems by mapping labeled input to known output. So very controlled. Unsupervised learning, and unsupervised learning is really interesting because it's now taking part in many other models. They start with you can actually insert an unsupervised learning model in almost either supervised or reinforcement learning as part of the system, which is really cool. Data provided is unlabeled data. The outputs are not specified. Machine makes its own predictions. Used to solve association with clustering problems. Unlabeled data is used. No supervision. Solves problems by understanding patterns and discovering output. So you can look at this and you can think some of these things go with each other. They belong together. So it's looking for what connects in different ways. And there's a lot of different algorithms that look at this. When you start getting into those, there's some really cool images that come up of what unsupervised learning is. How it can pick out, say, the area of a donut. One model will see the area of the donut, and the other one will divide it into 3 sections based on its location versus what's next to it. So there's a lot of stuff that goes in with unsupervised learning. And then we're looking at reinforcement learning. Probably the biggest industry in today's market in machine learning, or growing market. It's very infant stage as far as how it works and what it's going to be capable of. The machine learns from its environment using rewards and errors. Used to solve reward-based problems. No predefined data is used. No supervision. Follows trial and error problem solving approach. So again, we have a random, at first you start with a random, I try this, it works and this is my reward, doesn't work very well maybe, or maybe doesn't even get you where you're trying to get it to do, and you get your reward back, and then it looks at that and says, well, let's try something else, and it starts to play with these different things, finding the best route. So let's take a look at important terms in today's reinforcement model. And this has become pretty standardized over the last few years, so these are really good to know. We have the agent. Agent is the model that is being trained via reinforcement learning. So this is your actual entity that has, however you're doing it, whether you're using a neural network or a Q table or whatever, combination thereof. This is the actual agent that you're using. This is the model. And you have your environment. The training situation that the model must optimize to is called its environment. And you can see here, I guess we have a robot who's trying to get a chest full of gems or whatever, and that's the output. And then you have your action. This is all possible steps that can be taken by the model, and it picks one action. And you can see here that it's picked 3 different routes to get to the chest of diamonds and gems. We have a state, the current position condition returned by the model. And you could look at this if you're playing like a video game. This is the screen you're looking at. So when you go back here, the environment is a whole game board. So if you're playing one of those Mobius games, you might have the whole game board going on, but then you have your current position. Where are you on that game board? What's around that? What's around you? If you were talking about a robot, the environment might be moving around the yard, where it is in the yard and what it can see, what input it has in that location. That would be the current position condition returned by the model. And then the reward. To help the model move in the right direction, it is rewarded. Points are given to it to appraise some kind of action. So, yeah, you did good, or if didn't do as good, trying to maximize the reward and have the best reward possible. And then policy. Policy determines how an agent will behave at any time. It acts as a mapping between action and present state. This is part of the model. What is your action that you're going to take? What's the policy you're using to have an output from your agent? One of the reasons they separate policy as its own entity is that you usually have a prediction of different options, and then the policy, well, how am I going to pick the best? Based on those predictions, I'm going to guess at different options, and we'll actually weigh those options in and find the best option we think will work. So it's a little tricky, but the policy thing is actually pretty cool how it works. Let's go ahead and take a look at a reinforcement learning example. And just in looking at this, we're going to take a look, consider what a dog that we want to train. So the dog would be like the agent. So you have your puppy or whatever. And then your environment is going to be the whole house or whatever it is where you're training them. And then you have an action. We want to teach the dog to fetch. So action equals fetching. And then we have a little biscuit, so we can get the dog to perform various actions by offering incentives such as a dog biscuit as a reward. The dog will follow a policy to maximize this reward, and hence will follow every command and might even learn new actions like begging by itself. So you have, so we start off with fetching. It goes, oh, I get a biscuit for that. It tries something else, and you get a handshake or begging or something like that, and it goes, oh, this is also reward based, and so it kind of explores things to find out what will bring it as biscuit. And that's very much like how a reinforced model goes. Is it looks for different rewards. How do I find? Can I try different things and find a reward that works? The dog also will want to run around and play and explore its environment. This quality of model is called exploration. So there's a little randomness going on in exploration. And it explores new parts of the house. Climbing on the sofa doesn't get a reward. In fact, it usually gets kicked off the sofa. So let's talk a little bit about Markov's decision process. Markov's decision process is a reinforcement learning policy used to map a current state to an action where the agent continuously interacts with the environment to produce new solutions and receive rewards. And you'll see here's all of our different vocabulary we just went over. We have a reward, our state, our agent, our environment, and our action. And so even though the environment kind of contains everything, that you really, when you're actually writing the program, your environment's going to put out a reward and state that goes into the agent. The agent then looks at this state, or it looks at the reward usually first, and it says, okay, I got rewarded for whatever I just did, or I didn't get rewarded. And then it looks at the state, and then it comes back, and if you remember from policy, the policy comes in, and then we have a reward. The policy is that part that's connected at the bottom. And so it looks at that policy and it says, hey, what's a good action that will probably be similar to what I did, or sometimes they're completely random, but what's a good action that's going to bring me a different reward? So taking the time to just understand these different pieces as they go is pretty important in most of the models today. And so a lot of them actually have templates based on this you can pull in and start using. Pretty straightforward as far as once you start seeing how it works, you can see your environment says, hey, this is the agent did this. If you're a character in a game, this happened, and it shoots out a reward in a state. The agent looks at the reward, looks at the new state, and then takes a little guess and says, I'm going to try this action. And then that action goes back into the environment. It affects the environment then changes depending on what the action was, and then it has a new state and a new reward that goes back to the agent. So in the diagram shown, we need to find the shortest path between node A and D. Each path has a reward associated with it, and the path with a maximum reward is what we want to choose. The nodes A, B, C, D denote the nodes to travel from node A to B is an action. Reward is the cost of each path, and policy is each path taken. And you can see here A can go to B, or A can go to C right off the bat, or it can go right to D. And if you explored all three of these, you would find that A going to D was a 0 reward, A going to C and D would generate a different reward, or you could go A, C, B, D. There's a lot of options here. And so when we start looking at this diagram, you start to realize that even though today's reinforced learning models do really good at finding an answer, they end up trying almost all the different directions you see. And so they take up a lot of work or a lot of processing time for reinforcement learning. They're right now in their infant stage, and they're really good at solving simple problems. And we'll take a look at one of those in just a minute in a tic-tac-toe game. But you can see here, once it's gone through these and it's explored, it's going to find the ACD is the best reward. It gets a full 30 points for it. So let's go ahead and take a look at a reinforcement learning demo. In this demo, we're going to use reinforcement learning to make a tic-tac-toe game. You will be playing this game against the machine learning model. And we'll go ahead, and we're doing it in Python. So let's go ahead and go through not always, I actually have a lot of Python tools. Let's go through Anaconda, which will open up a Jupyter notebook. Seems like a lot of steps, but it's worth it to keep all my stuff separate, and it also has a nice display when you're in the Jupyter notebook for doing Python. So here's our Anaconda navigator. I open up the notebook, which is going to take me to a web page, and I've gone in here and created a new Python folder. In this case, I've already done it and enabled it to change the name to tic-tac-toe. And then for this example, we're going to go ahead and import a couple things. We're going to import numpy as np. We'll go ahead and import pickle. Numpy, of course, is our number array, and then pickle is just a nice way sometimes for storing different information, different states that we're going to go through on here. And so we're going to create a class called state. We're going to start with that. And there's a lot of lines of code to this class that we're going to put in here. Don't let that scare you too much. There's not as much here. It looks like there's going to be a lot here, but there really is just a lot of setup going on in our class state. And so we have up here, we're going to initialize it. We have our board. It's a tic-tac-toe board, so we're only dealing with 9 spots on the board. We have player 1, player 2 is end. We're going to create a board hash. We'll look at that in just a minute. We're just going to store some information in there. Symbol of player equals 1. So there's a few things going on as far as the initialization. Then something simple, we're just going to get the hash of the board. We're going to get the information from the board on there, which is columns and rows. We want to know when a winner occurs. So if you get 3 in a row, that's what this whole section here is for. Let me go ahead and scroll up a little bit. And you can get a copy of this code if you send a note over to Simplilearn. We'll send you over this particular file, and you can play with it yourself and see how it's put together. I don't want to spend a huge amount of time on this because this is just some real general Python coding. But you can see here we're just going through all the rows, and you add them together, and if it equals 3 in a row. Same thing with columns. Diagonal, so you got to check the diagonal. That's what all this stuff does here, is it just goes through the different areas. Actually, let me go ahead and put, there we go. And then it comes down here and we do our sum, and it says true, -3 just says did somebody win, or is it a tie? So you got to add up all the numbers on there anyway, just in case they're all filled up. And next we also need to know available positions. These are ones that no one's ever used before. This way when you try something, or the computer tries something, it's not going to give it an illegal move. That's what the available positions is doing. Then we want to update our state. And so you have your position going in. We're just sending in the position that you just chose. And you'll see there's a little user interface we put in there. You can pick the row and column in there. And again, I mean, this is a lot of code. So really it's kind of a thing you'd want to go through and play with a little bit and just read through it, get a copy of it. A great way to understand how this works. And here is a given reward. So we're going to give a reward, result equals self winner. This is one of the hearts of what's going on here, is we have a result self.winner. So if there's a winner, then we have a result. If the result equals 1, here's our feedback. If it doesn't equal 1, then it gets a 0. So it only gets a reward in this particular case if it wins. And that's important to know because different systems of reinforced learning do rewarding a lot differently depending on what you're trying to do. This is a very simple example with a 3x3 board. Imagine if you're playing a video game, certainly you only have so many actions, but your environment is huge. You have a lot going on in the environment. And suddenly a reward system like this is going to be just, it's going to have to change a little bit. It's going to have different rewards and different setup. And there's all kinds of advanced ways to do that as far as weighing, you add weights to it. And so they can add the weights up depending on where the reward comes in. So it might be that you actually get a reward. In this case, you get the reward at the end of the game. And I'm spending just a little bit of time on this because this is an important thing to note. But there's different ways to add up those rewards. It might have, like if you take a certain path, the first reward is going to be weighed a little bit less than the last reward because the last reward is actually winning the game or scoring or whatever it is. So this reward system gets really complicated in some of the more advanced setups. In this case, though, you can see right here that they give a 0.1 and a 0.5 reward just for picking the right value and something that's actually valid instead of picking an invalid value. So rewards, again, that's like key. It's huge. How do you feed the rewards back in? Then we have a board reset. That's pretty straightforward. It just goes back and resets the board to the beginning because it's going to try out all these different things while it's learning. It's going to do it by trial and error, so you have to keep resetting it. And then, of course, there's the play. We want to go ahead and play rounds equals 100. Depends on what you want to do on here. You can set this different. You can obviously set that to higher level. But this is just going to go through, and you'll see in here that we have player 1 and player 2. This is the computer playing itself. One of the more powerful ways to learn to play a game or even learn something that isn't a game is to have two of these models that are basically trying to beat each other. And so they keep explore new things. This one works for this one, so this one tries new things. It beats this. We've seen this in chess, I think was a big one, where they had the two players in chess with reinforcement learning. It was one of the ways they trained one of the top computer chess playing algorithms. So this is just what this is. It's going to choose an action, it's going to try something, and the more it tries stuff, the more we're going to record the hash. We actually have a board hash where they get the hash set up on here where it stores all the information. And then once you get to a win, one of them wins, it gets the reward. Then we go back and reset and try again. And then kind of the fun part we actually get down here is we're going to play with a human. So we'll get a chance to come in here and see what that looks like when you put your own information in. And then it just comes in here and does the same thing it did above. It gives it a reward for its things, or sees if it wins or ties, looks at available positions, all that kind of fun stuff. And then finally we want to show the board. So it's going to print the board out each time. Really, as an integration, is not that exciting. What's exciting in here is, one, looking at this reward system. Whoops, play one more up. The reward system is really the heart of this. How do you reward the different setup? And the other one is when it's playing, it's got to take an action. And so what it chooses for an action is also the heart of reinforcement learning. How do we choose that action? And those are really key to right now where reinforcement learning is in today's technology, is figuring this out. How do we reward it, and how do we guess the next best action? So we have our environment, and you can see the environment is or the state, which is kind of like what's going on. We're going to return the state depending on what happens. And we want to go ahead and create our agent, in this case our player. So each one is, let me go and grab that. And so we look at a class player. This is where a lot of the magic is really going on, is how is this player figuring out how to maneuver around the board, and then the board of course returns a state that it can look at and a reward. So we want to take a look at this. We have name, self-state, this is class player, and when we say class player, we're not talking about a human player, we're talking about just the computer players. And this is kind of interesting. So remember I told you, depending on what you're doing, there's going to be a decay gamma, explore rate. These are what I'm talking about, is how do we train it. As you try different moves, it gets to the end, the first move is important, but it's not as important as the last one. And so you could say that the last one has the heaviest weight, and then as you get there, the first one, let's see, the first move gives you a 5 reward, the second gives you a 2 reward, and the third one gives you a 10 reward, because that's the final ending. You got it. The 10's going to count more than the first step. And here's our, we're going to get the board information coming in, and then choose an action. This was the second part that I was talking about that was so important. So once you have your training going on, we have to do a little randomness, and you can see right here is our NP random uniform. So it's picking out a random number. Take a random action. This is going to just pick which row and which column it is. And so choosing the action, this one you can see we're just doing random states, choice, length of positions, action position, and then it skips in there and takes a look at the board for P in positions. And it's actually storing the different boards each time you go through, so it has a record of what it did, so it can properly weigh the values. And this simply just appends a hash state. What's the last state? Append it to the to our states on here. Here's our feedback reward. So the reward comes in, and it's going to take a look at this and say, is it none? What is the reward? And here is that formula. Remember I was telling you about up here that was important because it has decay gamma times the reward. This is where, as it goes through each step, and this is really important. This is kind of the heart of this, of what I was talking about earlier. You have step 1, and this might have a reward of 2. You have step 2. I probably should have done ABC. This has a step 3, step 4, and so on until you get to step N. And this might have a reward of 10. So reward of 10. We're going to add that, but we're not adding, let's say this one right here, let's say this reward here right before 10 was, let's say it's also 10. That just makes the math easy. So we had 10 and 10. We had 10, this is 10 and 10n, whatever it is, but it's 0.9. So instead of putting a full 10 here, we only do 9. That's 0.9 times 10. And so this formula, as far as the decay times the reward minus the cell state value, it basically adds in, it says here's 1, or here's 2, I'm sorry, I should have done this ABC, it would have been easier. So the first move goes in here and it puts 2 in here. Then we have our self set up on here. You can see how this gets pretty complicated in the math, but this is really the key, is how do we train our states? And we want the final state, the win, to get the most points. If you win, you get most points. And the first step gets the least amount of points. So you're really training this almost in reverse. You're training it from the last place where you have, like it says, okay, this is now where I need to sum up my rewards, and I want to sum them up going in reverse, and I want to find the answer in reverse. Kind of an interesting play on the mind when you're trying to figure this stuff out. And of course we want to go ahead and reset the board down here and save the policy load policy. These are the different things that are going in between the agent and the state to figure out what's going on. Let's go ahead and load that up. And then finally, we want to go ahead and create a human player. And the human player is going to be a little different in that you choose an action, row and column. Here's your action. If action in positions, meaning positions that are available, you return the action. If not, it just keeps asking you until you get the action that actually works. And then we're going to go ahead and append to the hash state, which we don't need to worry about because it returns the action up here, and feed forward. Again, this is because it's a human. At the end of the game, backpropagate and update state values. This part isn't being done because it's not programming the model. The model is getting its own rewards. So we've gone ahead and loaded this in here. So here's all our pieces. And the first thing we want to do is set up P1 player 1, P2 player 2, and then we're going to send our players to our state. So now it has P1, P2, and it's going to play, 50,000 rounds. Now we can probably do a lot less than this, and it's not going to get the full results. In fact, you know what? Let's go ahead and just do 5, just to play with it, because I want to show you something here. Oops. Somewhere in there I forgot to load something. There we go. I must have forgot to run this. Run. Oops, forgot a reference there for the board, rows and columns, 3 by 3. There is actually in the state, it references that. We can just tack it on the end. It was supposed to be at the beginning. So now I've only set this up with, let's see, where are we going here? I've only set this up to train 5 times. And the reason I did that is we're going to come in and actually play it, and then I'm going to change that, and we can see how it differs on there. There we go. And it didn't even make it through a run, and we're going to go ahead and save the policy. So now we have our player 1 and our player 2 policy. The way we set it up, it has 2 separate policies loaded up in there. And then we're going to come in here and we're going to do player 1 is going to be the computer, experience rate 0, load policy 1, human player human, and we're going to go ahead and play this. Now remember, I only went through it just 1 round of training, in fact minimal training. And so it puts an X there, and I'm going to go ahead and do row 0, column 1. And you can see this is very basic on here. And so I put in my 0, and then I'm going to go 0, block it, 0, 0. And you can see right here, it let me win. Just like that, I was able to win. 0, 2, and woo, human wins. So I only trained it 5 times. We're going to run this again, and this time, instead of 5, let's do 5,000 or 50,000. I think that's what the guys in the back had. And this takes a while to train it. This is where reinforcement learning really falls apart. Look how simple this game is. We're talking about a 3 by 3 set of columns. And so for me to train it on this, I could do a Q table which would go much quicker. You could build a quick Q table with almost all the different options on there, and you would probably get the same result much quicker. We're just using this as an example. So when we look at reinforcement learning, you need to be very careful what you apply it to. It sounds like a good deal until you do like a large neural network where you're doing, you set the neural network to a learning increment of 1. So every time it goes through, it learns. And then you do your actions. So you pick from the learning setup, and you actually try actions on the learning setup until you get what you think is going to be the best action. So you actually feed what you think is right back through the neural network. There's a whole layer there, which is really fun to play with. And then it has an output. Well, think of all those processes. I mean, that is just a huge amount of work it's going to do. Let's go ahead and skip ahead here. Give it a moment. It's going to take a minute or two to go ahead and run. Now, to train it, we went ahead and let it run, and it took a while. This took, I got a pretty powerful processor, and it took about 5 minutes plus to run it. And we'll go ahead and run our player setup on here. Oops, it brought in the last, whoops, it brought in the last round. So give me just a moment to redo the policy save. There we go. I forgot to save the policy back in there. And then go ahead and run our player again. So we've saved the policy, and then we want to go ahead and load the policy for P1 as a computer. And we can see the computer's gone in the bottom right corner. I'm going to go ahead and go 1, 1, which is the center. And it's gone right up the top, and if you have ever played tic-tac-toe, you know the computer has me. But we'll go ahead and play it out. Row 0, column 2. There it is, and then it's gone here, and so I'm going to go ahead and go row 0, 1, 2, no, 0, 1, there we go, and column 0. That's where I wanted. Oh, and it says, okay, your action, there we go, boom. So you can see here, we've got a, didn't catch the win on this, it said tie. Kind of funny that it didn't catch the win on there. But if we play this a bunch of times, you'll find that it's going to win more and more. The more we train it, the more the reinforcement happens. This lengthy training process is really the stopper on reinforcement learning. As this changes, reinforcement learning will be one of the more powerful packages evolving over the next decade or two. In fact, I would even go as far as to say it is the most important machine learning tool and artificial intelligence tool out there, as it learns not only a simple tic-tac-toe board, but we start learning environments. And the environment would be like in language. If you're translating a language or something from one language to the other, so much of it is lost if you don't know the context it's in, what's the environments it's in. And so being able to attach environment and context and all those things together is going to require reinforcement learning to do. So again, if you want to get a copy of the tic-tac-toe board, it's kind of fun to play with. Run it, you can test it out, you can do test it for different values. You can switch from P1 computer where we loaded the policy 1 to load the policy 2 and just see how it varies. There's all kinds of things you can do on there. So what is Q-learning? Q-learning is reinforcement learning policy which will fill the next best action given a current state. It chooses this action at random and aims to maximize the reward. And so you can see here's our standard reinforcement learning graph. By now, if you're doing any reinforcement learning, you should be familiar with this, where you have your agent takes an action, the action affects the environment, and then the environment sends back the reward or the feedback, and the state, it's the new state the agent's in. Where is it at on the chessboard? Where is it at in the video game? If your robot's out there picking trash up off the side of the road, where is it at on the road? Consider an ad recommendation system. Usually when you look up a product online, you get ads which will suggest the same product over and over again. Using Q-learning, we can make an ad recommendation system which will suggest related products to our previous purchase. The reward will be if user clicks on the suggested product. And again, you can see you might have a lot of products on your web advertisement or your pages, but it's still not a float number. It's still a set number, and that's something to be aware of when you're using Q-learning. And you can see here that if you have 100 people clicking on ads and you click on one of the ads, it might go in there and say, okay, this person clicked on this ad. What is the best set of ads based on clicking on this ad or these two ads afterwards based on where they are browsing? So let's go ahead and take a look at some important terms when we talk about Q-learning. We have state. The state S represents the current position of an agent in an environment. The action A is the step taken by the agent when it is a particular state. Rewards. For every action, the agent will get a positive or negative reward. And again, when we talk about states, we're usually not, when you're using a Q table, you're not usually talking about float variables. You're talking about true, false. And we'll take a closer look at that in a second. And episodes, when an agent ends up in a terminating state and can't take a new action. This might be if you're playing a video game, your character stepped in and is now dead or whatever. Q values used to determine how good an action A taken at a particular state S is Q A of S. And temporal difference, a formula used to find the Q value by using the value of the current state and action and previous state and action. And there's Bellman's equation, which basically is the equation that kind of covers what we just looked at in all those different terms. The Bellman equation is used to determine the values of a particular state and deduce how good it is to be in take that state. The optimal state will give us the highest optimal value. Factor influencing Q values, the current state and action, that's your SA, so your current state and your action. Then you have your previous state and action, which is your S, I guess prime, I'm not sure how they reference that, S prime, A prime. So this is what happened before. Then you have a reward for action. So you have your R reward. And you have your maximum expected future reward. And you can see there's also a learning rate put in there and a discount rate. So when we're looking at these, just like any other model, we don't want to have an absolute final value on here. We don't want it to, if you do absolute values instead of taking smaller steps, you don't really have that approach to the solution. You just have a jump, and then pretty soon if you jump one solution out, that's what's going to be the new solution, whichever one jumps up really high first. Kind of ruining the whole idea of doing a random selection. I'll go into the random selection in just a second. Steps in Q learning. Step 1. Create an initial Q table with all values initialized to 0. Again, we're looking at 0, 1. So are you know, here's our action. We start, we're an idle, we took a wrong action, we took a correct action, and end. And then we have our actions, fetching, sitting, and running. And of course, we're just using the dog example. And choose an action and perform it. Update values in the table. And of course, when we're choosing an action, we're going to kind of do something random and just randomly pick one. So you start out and you sit, and you have then depending on that action you took, you can now update the value for sitting after you start, from start to sitting. Get the value of the reward and calculate the value Q value using the Bellman equation. And so now we attach a reward to sitting. And when we attach all those rewards, we continue the same until the table is filled with or an episode ends. And I mentioned I was going to come back to the random side of this. And there's a few different formulas I use for the random setup to pick it. I usually let whatever Q model I'm using do their standard one, because someone's usually gone in and done the math for the optimal spread. But you can look at this. If I have running has a reward of 10, sitting has a reward of 7, fetching has a reward of 5, just kind of without doing like a means, using the bell curve for the means value, and like I said, there's some math you can put in there to pick so that you're more like, so that running has even a higher chance. But even if you were just going to do an average on this, you could do a random number by adding them all together. So you get 10 plus 7 plus 5 is 22. You could do 0 to 22, or 0 to 21, but 1 to 22. 1 to 5 would be fetching, and so forth, the last 10. So you can just look at this as what percentage are you going to go for that particular option. And then that gets your random setup in there, and then as you slowly increment these up, you see that if you're idle, where's one? Here we go. Sitting at the end. If you're at the end of wherever you're at, sitting gets a reward of 1. Where's a good one on here? Oh, wrong action. Running for a wrong action gets almost no reward. So that becomes very, very less likely to happen, but it still might happen. It still might have a percentage of coming up. And that's where the random programming and Q learning comes in. The below table gives us an idea of how many times an action has been taken and how positively correct action or negatively wrong action it is going to affect the next state. So let's go ahead and dive in and pull up a little piece of code and see what this looks like in Python. In this demo, we'll use Q learning to find the shortest path between two given points.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
If you've seen my videos before, I like to do it in the Anaconda Jupyter Notebook setup, just because it's really easy to see and it's a nice demo. And so here's my Anaconda. This one I'm actually using Python 3.6 environment that I set up in here. And we'll go ahead and launch the Jupyter Notebook on this. And once we're in our Jupyter Notebook, which has the kernel loaded with Python 3, we'll go ahead and create a new Python 3 folder in here. And we'll call this Q Learning. And to start this demo, let's go ahead and import our NumPy array. We'll just run that so it's imported. And like a lot of these model programs, when you're building them, you spend a lot of time putting it all together, and then you end up with this really short answer at the end. And we'll take a look at that as we come into it. So we go ahead and start with our location to state. So we have L1, L2. These are our 9 locations, 1 to 9. And then of course the state is going to be 0, 1, 2, 3, 4. It's just a mapping of our location to a integer on there. And then we have our actions. Our actions are simply moving from one location to another. So I can go to location 0, I can go to location 1, 2, 3, 4, 5, 6, 7, 8. So these are my actions I can choose. These are the locations of our state. And if you remember earlier, I'd mentioned that the limitation is that you don't want to put in a continually growing table, because you can actually create a dynamic queue table where you continually add in new values as they arise. Because if you have float values, it just becomes infinite, and then your memory in your computer is gone, or it's not going to work. At the same time, you might think, well, that kind of really limits the queue learning setup. But there are ways to use it in conjunction with other systems. And so you might look at, well, I've been doing some work in stock. And one of the questions that comes out is to buy or sell the stock. And the state coming in might be, you might take it and create what we call buckets, where anything that you predict is going to return more than a certain amount of money, the error for that stock that you've had in the past, you put those in buckets, and suddenly you start creating these buckets, you realize you do have a limited amount of information coming in. You no longer have a float number. You now have bucket 1, 2, 3, and 4. And then you can take those buckets, put them through a queue learning table, and come up with the best action. Which stock should I buy? It's like gambling. Stock is pretty much gambling if you're doing day trading. You're not doing long-term investments. And so you can start looking at it like that. A lot of the current feeds say that the best algorithms used for day traders, where you're doing it on your own, is really to ask the question, do I want to trade the stock? Yes or no? And now you have it in a queue learning table, and now you can take it to that next level, and you can see where that can be a really powerful tool at the end of doing a basic linear regression model or something. What is the best investment? And you start getting the best reward on there. So if we're going to have rewards, these rewards we just create. It says if you're this should match our queue table, because it's going to be you have your state and you have your action across the top, if you remember from the dog. And so we have whatever state we're in going down, and then the next action and what the reward is for it. And of course, if you were actually doing something more connected, your reward would be based on the actual environment it's in. And then we want to go ahead and create a state to location so we can map the indexes. So just like we defined our rewards, we're going to go ahead and do state to location. And you can see here it's a dictionary setup for location state and location to state with items. And we also need to define what we want for learning rates. You remember we had our 2 different rates as far as like learning from the past and learning from the current. So we'll go ahead and set those to 0.75 and the alpha set to 0.9. And we'll see that when we do the formula. And of course, any of this code, send a note to our Simplilearn team. They'll get you a copy of this code on here. And let's go ahead and pull. There we go. Well, the next two sections. Since we're going to keep it short and sweet. Here we go. So let's go ahead and create our agent. So our agent is going to have our initialization where we send it all the information. We'll define our self gamma equals gamma. We could have just set the gamma rate down here instead of submitting it. It's kind of nice to keep them separate because you can play with these numbers on our self alpha. Then we have our location state. We'll set that in here. We have our choice of actions. We're going to go ahead and just embed the rewards right into the agent. So obviously this would be coming from somewhere else instead of from self-generated. And then a self state to location equals our state to location dictionary. And we go ahead and create a Q learning table. And I went ahead and just set the Q learning table up to 0 to 0, what the setup is, location to state, how many of them are there. And this just creates an array of 0 to 0 setup on there. And then the big part is the training. We have our rewards new equals a copy of self.rewards. Ending state equals the self location state in location. So this is whatever we end up at. Rewards new equals ending state plus ending state equals 999. Just kind of goes to a dead end. And we start going through iterations. And we'll go ahead, let's do this. So this, we're going to come back and we're going to call it on here. Let me just erase that. Switch it to an arrow. There we go. So what we're doing is we're going to send in here to train it. We're going to say, hey, I want to iterate through this 1,000 times and see what happens. Now this part would actually be, instead of iterating, you might have your external environment and they're going back and forth and you iterate through outside of here. But just for ease of use, our agent's going to come in here and iterate through this. Sometimes I'll put this iteration in here and I'll have it call the environment and say, hey, this is what I did, what's the next state? And the environment does its thing right in here as I iterate through it. And then we want to go ahead and pick a random state to start with. That's what's going on here. You have to start somewhere. And then you have your playable actions. We're going to start with just an empty thing for playable actions and we'll fill that up. So that's what choices I have. And so we're going to iterate through the rewards matrix to get the states, directly reachable from the randomly chosen current state. Assign those states to a list named playable actions. And so you can see here we have range 9. I usually use length of whatever I'm looking at, which is our locations or states as they are. We have a reward. So we want to look at the rewards. The new reward is our is in our chart here of rewards underscore new current state plus J. J being what is the next state we want to try. And so we go ahead and do our playable actions and we append J. And so what we're doing is we're randomly trying different things in here to see what's going to generate a better reward. And then of course we go ahead and choose our next state. So we have our random choice playable actions. And if you remember, I mentioned on this, let me just go ahead and, whoops, let's do a free form. When we were talking about the next state, this right here just does a random selection. Instead of a random selection, you might do something where whatever the best selection is, which might be option 3 here, and then so you can see that it might use a bell curve, and then option 2 over here might have a bell curve like this. Oops. And we start looking at these averages and these spreads, or we can just add them all together and pick the one that kind of goes in all of those. So those are some of the options we have in here. We just go with a random choice. That's usually where you start, play with it. And then we have our reward section down here. And so we want to go ahead and find, well in this case, the temporal difference. So you have your rewards new plus the self gamma, and this is the formula we were looking at. This is Bellman's equation here. So we have our current value, our learning rate, our discount rate involved in there, the reward system coming in for that, and we can add it all together. This is, of course, our maximum expected future setup in here. So this is all of our Bellman's equation that we're looking at here. And then we come up in here and we update our Q table. That's all this is on this one. And that's right here. We have self Q, current state, next state, and we add in our alpha because we don't want to train all of it at once in case there's slight differentials coming in there. We want to slowly approach the answer. And then we have our route equals the start location, and next location equals start location. So we're just incrementing. We took a step forward. And then finally, remember I was telling you how we're going to do all this and just have some simple thing at the end where it just generates a simple path. We're going to go ahead and get the optimal route. We want to find the best route in here. And so we've created a definition for the optimal route down here. Just scroll down for that. And we get the optimal route. We go ahead and put the information in, including the Q table, self, start location, end location, next location, route, Q. And it says while next location is not equal to end location, so while we can still go, our start location equals self location to state start location. So we already have our best value for the start location. The next state looks at the Q table and says, hey, what's the next one with the best value? And then the next location, we go ahead and pull that in and we just append it. That's what's going on down here. And then our start location equals the next location. And we just go through all the steps. And we'll go ahead and run this. And now that we have our Q table, our Q agent loaded, we're going to go ahead and take our Q agent, load them up with our alpha, gamma that we set up above, along with the location step, action, reward, state to location. And our goal is to plot a course between L9 and L1. And we're going to go through 1,000 iterations on here. And so when I run that, it runs pretty quick. Why is this so fast? If you've been running neural networks and you've been doing all these other models, you sit here and wait a long time. Well, we're a very small amount of data. These are all integers. These aren't float values. The math is not heavy on the processing end, and this is where Q tables are so powerful. If you have a small amount of information coming in, you very quickly get an answer off of this, even though we went through it 1,000 times to train it. And you'll see here we have L9, 8, 5, 2, and 1, and that's based on our reward table we had set up on there. And this is the shortest path going between these different setups in here. And if you remember on our reward table, you can see that if you start here, you can go to here. There's places you can't go. That's how this reward table was set up. So I can only go to certain places. So kind of a little maze set up in there. And you can play with it. This is really fun setup to play with. And you can see how you can take this whole code and you can, like I was saying earlier, you can embed it into another setup and model and predictions where you put things into buckets and you're trying to guess the best investment, the best course of action. As long as you can take that course of action and reduce it down to a yes, no. Or if you're using text, you can use a one-hot encoder, which word is next. There's all kinds of things you can do with a Q table, depending on just how much information you're putting in there. So that wraps up our demo. In this demo, we've found the shortest distance between two paths based on whatever rules or state rewards we have to get from point A to point B and what available actions there are.
Hello and welcome to this tutorial on deep learning. My name is Mohan, and in the next about 1.5 hours I will take you through what is deep learning and into TensorFlow environment to show you an example of deep learning. Now, there are several applications of deep learning, really very interesting and innovative applications, and one of them is identifying the geographic location based on a picture. And how does this work? The way it works is pretty much we train an artificial neural network with millions of images which are tagged, their geolocation is tagged, and then when we feed a new picture, it will be able to identify the geolocation of this new image. For example, you have all these images, especially with maybe some significant monuments or significant locations, and you train with millions of such images, and then when you feed another image, it need not be exactly one of those that you have trained. It can be completely different. That is the whole idea of training. It will be able to recognize, for example, that this is a picture from Paris because it is able to recognize the Eiffel Tower. So the way it works internally, if we have to look a little bit under the hood, is these images are nothing but this is digital information in the form of pixels. So each image could be a certain size. It can be 256 by 256 pixel kind of a resolution, and then each pixel is either having a certain grade of color, and all that is fed into the neural network, and it then gets trained in, and it's able to, based on these pixel information, it is able to get trained and able to recognize the features and extract the features, and thereby it is able to identify these images and the location of these images. And then when you feed a new image, it kind of, based on the training, it will be able to figure out where this image is from. So that's the way, a little bit under the hood, how it works. So what are we going to do in this tutorial? We will see what is deep learning and what do we need for deep learning. And one of the main components of deep learning is neural networks. So we will see what is neural network, what is a perceptron, and how to implement logic gates like AND, OR, NOR, and so on using perceptrons. The different types of neural networks, and then applications of deep learning, and we will also see how neural networks works. So how do we do the training of neural networks? And at the end, we will end up with a small demo code which will take you through in TensorFlow. Now, in order to implement deep learning code, there are multiple libraries or development environments that are available, and TensorFlow is one of them. So the focus at the end of this would be on how to use TensorFlow to write a piece of code using Python as a programming language. And we will take up an example which is a very common one, which is like the hello world of deep learning, the handwriting number recognition, which is a MNIST, commonly known as MNIST database. So we will take a look at MNIST database and how we can train a neural network to recognize handwritten numbers. So that's what you will see in this particular video. So let's get started. What is deep learning? Deep learning is like a subset of what is known as a high-level concept called artificial intelligence. You must be already familiar, must have heard about this term, artificial intelligence. So artificial intelligence is like the high-level concept, if you will. And in order to implement artificial intelligence applications, we use what is known as machine learning. And within machine learning, a subset of machine learning is deep learning. Machine learning is a little bit more generic concept, and deep learning is one type of machine learning, if you will. And we will see a little later in maybe the following slides a little bit more in detail how deep learning is different from traditional machine learning. But to start with, we can mention here that deep learning uses one of the differentiators between deep learning and traditional machine learning is that deep learning uses neural networks. And we will talk about what are neural networks and how we can implement neural networks and so on and so forth as a part of this tutorial. So a little deeper into deep learning. Deep learning primarily involves working with complicated unstructured data compared to traditional machine learning, where we normally use structured data. In deep learning, the data would be primarily images or voice or maybe text file. And it is a large amount of data as well. And deep learning can handle complex operations. It involves complex operations. And the other difference between traditional machine learning and deep learning is that the feature extraction happens pretty much automatically. In traditional machine learning, feature engineering is done manually. The we data scientists have to do feature engineering, feature extraction. But in deep learning, that happens automatically. And of course, deep learning, for large amounts of data, complicated unstructured data, deep learning gives very good performance. Now, as I mentioned, one of the secret sources of deep learning is neural networks. Let's see what neural networks is. Neural networks is based on our biological neurons. The whole concept of deep learning and artificial intelligence is based on human brain, and human brain consists of billions of tiny stuff called neurons, and this is how a biological neuron looks, and this is how an artificial neuron looks. So neural networks is like a simulation of our human brain. Human brain has billions of biological neurons, and we are trying to simulate the human brain using artificial neurons. This is how a biological neuron looks. It has dendrites, and the corresponding component with an artificial neural network is, or an artificial neuron, are the inputs. They receive the inputs through dendrites. And then there is the cell nucleus, which is basically the processing unit in a way. So in artificial neuron also there is a piece which is an equivalent of this cell nucleus, and based on the weights and biases, we will see what exactly weights and biases are as we move. The input gets processed, and that results in an output. In a biological neuron, the output is sent through a synapse, and in an artificial neuron there is an equivalent of that in the form of an output. And biological neurons are also interconnected. So there are billions of neurons which are interconnected. In the same way, artificial neurons are also interconnected. So this output of this neuron will be fed as an input to another neuron, and so on. Now, in neural network, one of the very basic units is a perceptron. So what is a perceptron? A perceptron can be considered as one of the fundamental units of neural networks. It can consist at least of one neuron, but sometimes it can be more than one neuron. But you can create a perceptron with a single neuron, and it can be used to perform certain functions. It can be used as a basic binary classifier. It can be trained to do some basic binary classification, and this is how a basic perceptron looks like. And this is nothing but a neuron. You have inputs x1, x2, to xn, and there is a summation function, and then there is what is known as an activation function. And based on this input, what is known as the weighted sum, the activation function either gives an output like a 0 or a 1. So we say the neuron is either activated or not. So that's the way it works. So you get the inputs. These inputs are, each of the inputs are multiplied by a weight, and there is a bias that gets added, and that whole thing is fed to an activation function, and then that results in an output. And if the output is correct, it is accepted. If it is wrong, if there is an error, then that error is fed back, and the neuron then adjusts the weights and biases to give a new output, and so on and so forth. So that's what is known as the training process of a neuron or a neural network. There's a concept called perceptron learning. So perceptron learning is again one of the very basic learning processes. The way it works is somewhat like this. So you have all these inputs like x1 to xn, and each of these inputs is multiplied by a weight, and then that sum, this is the formula or the equation. So that sum, wi xi sigma of that, which is the sum of all these product of x and w, is added up, and then a bias is added to that. The bias is not dependent on the input or the input values, but the bias is common for one neuron. However, the bias value keeps changing during the training process. Once the training is completed, the values of these weights, W1, W2, and so on, and the value of the bias gets fixed. So that is basically the whole training process, and that is what is known as the perceptron training. So the weights and biases keep changing till you get the accurate output. And the summation is of course passed through the activation function. As you see here, this WIXI summation plus B is passed through activation function, and then the neuron gets either fired or not, and based on that there will be an output. That output is compared with the actual or expected value, which is also known as labeled information. So this is the process of supervised learning. So the output is already known, and that is compared, and thereby we know if there is an error or not. And if there is an error, the error is fed back and the weights and biases are updated accordingly till the error is reduced to the minimum. So this iterative process is known as perceptron learning or perceptron learning rule, and this error needs to be minimized. So till the error is minimized, this iteratively the weights and biases keep changing, and that is what is the training process. So the whole idea is to update the weights and the bias of the perceptron till the error is minimized. The error need not be zero. The error may not ever reach zero, but the idea is to keep changing these weights and bias so that the error is minimum, the minimum possible that it can have. So this whole process is an iterative process, and the iteration continues till either the error is zero, which is unlikely situation, or it is the minimum possible within these given conditions. Now in 1943, two scientists, Warren McCulloch and Walter Pitts, came up with an experiment where they were able to implement the logical functions like AND, OR, and NOR using neurons. And that was a significant breakthrough in a sense. So they were able to come up with the most common logical gates. They were able to implement some of the most common logical gates, which could take two inputs like A and B and then give a corresponding result. So for example, in case of an AND gate, A and B, and then the output is AB. In case of an OR gate, it is A plus B, and so on and so forth. And they were able to do this using a single layer perceptron. Now, most of these gates, it was possible to use single layer perceptron except for XOR, and we will see why that is in a little bit. So this is how an AND gate works. The inputs A and B, the output should be fired, or the neuron should be fired only when both the inputs are 1. So if you have 0, 0, the output should be 0. For 0, 1, it is again 0, 1, 0, again 0, and 1, 1, the output should be 1. So how do we implement this with a neuron? So it was found that by changing the values of weights, it is possible to achieve this logic. So for example, if we have equal weights like 0.7, 0.7, and then if we take the sum of the weighted product, so for example 0.7 into 0, and then 0.7 into 0 will give you 0, and so on and so forth. And in the last case, when both the inputs are 1, you get a value which is greater than 1, which is the threshold. So only in this case the neuron gets activated and the output is, there is an output. In all the other cases, there is no output because the threshold value is 1. So this is implementation of an AND gate using a single perceptron or a single neuron. Similarly, an OR gate. In order to implement an OR gate, in case of an OR gate, the output will be 1 if either of these inputs is 1. So for example, 0, 1 will result in 1, or rather, in all the cases it is 1 except for 0, 0. So how do we implement this using a perceptron? Once again, if you have a perceptron with weights, for example 1.2, now if you see here, if in the first case when both are 0, the output is 0. In the second case, when it is 0 and 1, 1.2 into 0 is 0, and then 1.2 into 1 is 1. And in the second case, similarly, the output is 1.2. In the last case, when both the inputs are 1, the output is 2.4. So during the training process, these weights will keep changing, and then at one point where the weights are equal to W1 is equal to 1.2 and W2 is equal to 1.2, the system learns that it gives the correct output. So that is implementation of OR gate using a single neuron or a single layer perceptron. Now XOR gate. This was one of the challenging ones. They tried to implement an XOR gate with a single level perceptron but it was not possible. And therefore, in order to implement an XOR, so this was like a roadblock in the progress of neural network. However, subsequently they realized that this can be implemented, an XOR gate can be implemented using a multi-level perceptron or MLP. So in this case, there are 2 layers instead of a single layer, and this is how you can implement an XOR gate. So you will see that X1 and X2 are the inputs, and there is a hidden layer, and that's why it is denoted as H3 and H4, and then you take the output of that and feed it to the output at O5 and provide a threshold here. So we will see here that this is the numerical calculation. So the weights are, in this case for X1 it is 20 and minus 20, and once again 20 and minus 20. So these inputs are fed into H3 and H4. So you will see here for H3 the input is 0 1 1 1, and for H4 it is 1 0 1 1. And if you now look at the output, final output, where the threshold is taken as 1, if we use a sigmoid with the threshold 1, you will see that in these 2 cases it is 0, and in the last 2 cases it is 1. So this is the implementation of XOR. In case of XOR, only when one of the inputs is 1, you will get an output. So that is what we are seeing here. If we have either both the inputs are 1 or both the inputs are 0, then the output should be 0. So that is what is an exclusive OR gate. So it is exclusive because only one of the inputs should be 1, and then only you will get an output of 1, which is satisfied by this condition. So this is a special implementation. XOR gate is a special implementation of perceptron. Now that we got a good idea about perceptron, let's take a look at what is a neural network. So we have seen what is a perceptron, we have seen what is a neuron, so we will see what exactly is a neural network. So neural network is nothing but a network of these neurons, and they are different types of neural networks. There are about 5 of them. These are artificial neural network, convolutional neural network, then recursive neural network or recurrent neural network, deep neural network, and deep belief network. So, and each of these types of neural networks have a special, they can solve a special kind of problems. For example, convolutional neural networks are very good at performing image processing and image recognition and so on, whereas RNN are very good for speech recognition and also text analysis and so on. So each type has some special characteristics, and they're good at performing certain special kind of tasks. What are some of the applications of deep learning? Deep learning is today used extensively in gaming. You must have heard about AlphaGo, which is a game created by a startup called DeepMind, which got acquired by Google. And AlphaGo is an AI which defeated the human world champion Lee Sedol in this game of Go. So gaming is an area where deep learning is being extensively used, and a lot of research happens in the area of gaming as well. In addition to that, nowadays there are neural networks or special type called Generative Adversarial Networks, which can be used for synthesizing either images or music or text and so on, and they can be used to compose music. So the neural network can be trained to compose a certain kind of music. And autonomous cars, you must be familiar with Google's self-driving car, and today a lot of automotive companies are investing in this space, and deep learning is a core component of this autonomous cars. The cars are trained to recognize, for example, the road, the lane markings on the road, signals, any objects that are in front, any obstruction, and so on and so forth. So all this involves deep learning. So that's another major application. And robots, we have seen several robots, including Sophia. You may be familiar with Sophia, who was given a citizenship by Saudi Arabia. And there are several such robots which are very human-like, and the underlying technology in many of these robots is deep learning. Medical diagnostics and healthcare is another major area where deep learning is being used. And within healthcare diagnostics, again, there are multiple areas where deep learning and image recognition, image processing can be used. For example, for cancer detection, as you may be aware, if cancer is detected early on, it can be cured. And one of the challenges is in the availability of specialists who can diagnose cancer using these diagnostic images and various scans and so on and so forth. So the idea is to train neural network to perform some of these activities so that the load on the cancer specialist doctors or oncologists comes down, and there is a lot of research happening here, and there are already quite a few applications that are claimed to be performing better than human beings in this space. It can be lung cancer, it can be breast cancer, and so on and so forth. So healthcare is a major area where deep learning is being applied. Let's take a look at the inner working of a neural network. So how does an artificial neural network, let's say, can we train a neural network to identify the shapes like squares and circles and triangles when these images are fed? So this is how it works. Any image is nothing but it is a digital information of the pixels. So in this particular case, let's say this is an image of 28 by 28 pixel and this is an image of a square. There is a certain way in which the pixels are lit up, and so these pixels have a certain value, maybe from 0 to 256, and 0 indicates that it is black or it is dark, and 256 indicates it is white or lit up. So that is like an indication or a measure of how the pixels are lit up. And so this is an image is, let's say, consisting of information of 784 pixels. So all the information what is inside this image can be kind of compressed into these 784 pixels. The way each of these pixels is lit up provides information about what exactly is the image. So we can train neural networks to use that information and identify the images. So let's take a look how this works. So each neuron, the value, if it is close to 1, that means it is white, whereas if it is close to 0, that means it is black. Now this is an animation of how this whole thing works. So these pixels, one of the ways of doing it is we can flatten this image and take this complete 784 pixels and feed that as input to our neural network. The neural network can consist of probably several layers. There can be a few hidden layers, and then there is an input layer and an output layer. Now the input layer takes the 784 pixels as input, the values of each of these pixels, and then you get an output which can be of 3 types or 3 classes. One can be a square, a circle, or a triangle. Now during the training process, there will be initially, obviously you feed this image and it will probably say it's a circle or it will say it's a triangle. So as a part of the training process, we then send that error back, and the weights and the biases of these neurons are adjusted till it correctly identifies that this is a square. That is the whole training mechanism that happens out here. Now let's take a look at a circle. Same way. So you feed these 784 pixels. There is a certain pattern in which the pixels are lit up, and the neural network is trained to identify that pattern. And during the training process, once again, it would probably initially identify it incorrectly, saying this is a square or a triangle, and then that error is fed back and the weights and biases are adjusted finally till it finally gets the image correct. So that is the training process. So now we will take a look at same way a triangle. So now if you feed another image which is consisting of triangles. So this is the training process. Now we have trained our neural network to classify these images into a triangle or a circle and a square. So now this neural network can identify these 3 types of objects. Now if you feed another image, and it will be able to identify whether it's a square or a triangle or a circle. Now what is important to be observed is that when you feed a new image, it is not necessary that the image or the triangle is exactly in this position, now the neural network actually identifies the patterns. So even if the triangle is, let's say, positioned here, not exactly in the middle, but maybe at the corner or in the side, it would still identify that it is a triangle. And that is the whole idea behind pattern recognition. So how does this training process work? This is a quick view of how the training process works. So we have seen that a neuron consists of inputs. It receives inputs, and then there is a weighted sum, which is nothing but this xi, wi, summation of that plus the bias. And this is then fed to the activation function, and that in turn gives us a output. Now, during the training process, initially, obviously, when you feed these images, when you send maybe a square, it will identify it as a triangle, and when you maybe feed a triangle, it will identify as a square, and so on. So that error information is fed back, and initially these weights can be random. Maybe all of them have 0 values, and then it will slowly keep changing. So as a part of the training process, the values of these weights, W1, W2 up to Wn, keep changing in such a way that towards the end of the training process, it should be able to identify these images correctly. So till then, the weights are adjusted, and that is known as the training process. So, and these weights are numeric values. It could be 0.5, 0.25, 0.35, and so on. It could be positive or it could be negative, and the value that is coming here is the pixel value. As we have seen, it can be anything between 0 to 1. You can scale it between 0 to 1 or 0 to 256, whichever way, 0 being black and 256 being white, and then all the other colors in between. So that is the input. So these are numerical values. This multiplication or the product, WIXI, is a numerical value, and the bias is also a numerical value. We need to keep in mind that the bias is fixed for a neuron. It doesn't change with the inputs, whereas the weights are 1 per input. So that is one important point to be noted. So, but the bias also keeps changing. Initially, it will again have a random value, but as a part of the training process, the weights, the values of the weights W1, W2, Wn, and the value of B will change. And ultimately, once the training process is complete, these values are fixed for this particular neuron. W1, W2 up to Wn, and plus the value of the B is also fixed for this particular neuron. And in this way, there will be multiple neurons, and there may be multiple levels of neurons here, and that's the way the training process works. So this is another example of multi-layer. So there are 2 hidden layers in between, and then you have the input layer, values coming from the input layer, then it goes through multiple layers, hidden layers, and then there is an output layer. And as you can see, there are weights and biases for each of these neurons in each layer, and all of them keeps changing during the training process. And at the end of the training process, all these weights have a certain value, and that is a trained model, and those values will be fixed once the training is completed. Alright, then there is something known as activation function. Neural networks consists of one of the components in neural networks is activation function, and every neuron has an activation function, and there are different types of activation functions that are used. It could be a ReLU, it could be sigmoid, and so on and so forth. And the activation function is what decides whether a neuron should be fired or not. So whether the output should be 0 or 1 is decided by the activation function. And the activation function in turn takes the input, which is the weighted sum. Remember, we talked about WIXI plus B. That weighted sum is fed as an input to the activation function, and then the output can be either a 0 or a 1. And there are different types of activation functions which are covered in an earlier video you might want to watch. Alright, so as a part of the training process, we feed the inputs, the labeled data or the training data, and then it gives an output, which is the predicted output by the network, which we indicate as y hat. And then there is a labeled data, because for supervised learning, we already know what should be the output. So that is the actual output. And in the initial process, before the training is complete, obviously there will be error. So that is measured by what is known as a cost function. So the difference between the predicted output and the actual output is the error. And the cost function can be defined in different ways. There are different types of cost functions. So in this case, it is like the average of the squares of the error. So, and then all the errors are added, which can sometimes be called as sum of squares, sum of square errors, or SSE. And that is then fed as a feedback in what is known as backward propagation or back propagation. And that helps in the network adjusting the weights and biases. And so the weights and biases get updated till this value, the error value or the cost function, is minimum. Now there is a optimization technique which is used here called gradient descent optimization, and this algorithm works in a way that the error, which is the cost function, needs to be minimized. So there's a lot of mathematics that goes behind this. For example, they find the local minima, the global minima using the differentiation and so on and so forth. But the idea is this. So as a training process, as the part of training, the whole idea is to bring down the error, which is like, let's say this is the function, the cost function. At certain levels it is very high, the cost value of the cost function, the output of the cost function is very high. So the weights have to be adjusted in such a way, and also the bias of course, that the cost function is minimized. So there is this optimization technique called gradient descent that is used, and this is known as the learning rate. Now gradient descent, you need to specify what should be the learning rate, and the learning rate should be optimal, because if you have a very high learning rate, then the optimization will not converge, because at some point it will cross over to the side. On the other hand, if you have very low learning rate, then it might take forever to convert. So you need to come up with the optimum value of the learning rate, and once that is done using the gradient descent optimization, the error function is reduced, and that's like the end of the training process. Alright, so this is another view of gradient descent. So this is how it looks. This is your cost function, the output of the cost function, and that has to be minimized using gradient descent algorithm. And these are like the parameters, and weight could be one of them. So initially we start with certain random values, so cost will be high, and then the weights keep changing, and in such a way that the cost function needs to come down, and at some point it may reach the minimum value, and then it may increase. So that is where the gradient descent algorithm decides that, okay, it has reached a minimum value and it will kind of try to stay here. This is known as the global minima. Now sometimes these curves may not be, just for explanation purpose, this has been drawn in a nice way, but sometimes these curves can be pretty erratic. There can be some local minima here, and then there is a peak, and so on. So the whole idea of gradient descent optimization is to identify the global minima and to find the weights and the bias at that particular point. So that's what is gradient descent. And then this is another example. So you can have these multiple local minima. So as you can see, at this point when it is coming down, it may appear like this is a minimum value, but then it is not. This is actually the global minimum value, and the gradient descent algorithm will make an effort to reach this level and not get stuck at this point. So the algorithm is already there, and it knows how to identify this global minimum, and that's what it does during the training process. Now, in order to implement deep learning, there are multiple platforms and languages that are available, but the most common platform nowadays is TensorFlow, and so that's the reason we have this tutorial. We have created this tutorial for TensorFlow. So we will take you through a quick demo of how to write a TensorFlow code using Python. And TensorFlow is an open source platform created by Google. So let's just take a look at the details of TensorFlow. And so this is a library, a Python library. So you can use Python or any other languages. It's also supported in other languages like Java and R and so on. But Python is the most common language that is used. So it is a library for developing deep learning applications, especially using neural networks. And it consists of primarily two parts, if you will. So one is the tensors, and then the other is the graphs or the flow. That's the way the name, that's the reason for this kind of a name called TensorFlow. So what are tensors? Tensors are like multi-dimensional arrays, if you will. That's one way of looking at it. So usually you have a one-dimensional array. So first of all, you can have what is known as a scalar, which means a number. And then you have a one-dimensional array, something like this, which means this is like a set of numbers. So that is a one-dimensional array. Then you can have a two-dimensional array, which is like a matrix. And beyond that, sometimes it gets difficult. So this is a three-dimensional array, but TensorFlow can handle many more dimensions. So it can have multi-dimensional arrays. That is the strength of TensorFlow, and which makes computation, deep learning computation, much faster. And that's the reason why TensorFlow is used for developing deep learning applications. So TensorFlow is a deep learning tool, and this is the way it works. So the data basically flows in the form of tensors, and the way the programming works as well is that you first create a graph of how to execute it, and then you actually execute that particular graph in the form of what is known as a session. We will see this in the TensorFlow code as we move forward. So all the data is managed or manipulated in tensors, and then the processing happens using these graphs. There are certain terms called, like for example, ranks of a tensor. The rank of a tensor is like a dimensionality in a way. So for example, if it is scalar, so there is just a number, just one number, the rank is supposed to be 0, and then it can be a one-dimensional vector, in which case the rank is supposed to be 1, and then you can have a two-dimensional vector, typically like a matrix. Then in that case we say the rank is 2, and then if it is a three-dimensional array, then rank is 3, and so on. So it can have more than 3 as well. So it is possible that you can store multi-dimensional arrays in the form of tensors. So what are some of the properties of TensorFlow? I think today it is one of the most popular platform. TensorFlow is the most popular deep learning platform or library. It is open source. It's developed by Google, developed and maintained by Google, but it is open source. One of the most important things about TensorFlow is that it can run on CPUs as well as GPUs. GPU is a graphical processing unit, just like CPU is central processing unit. Now, in earlier days, GPU was used primarily for graphics, and that's how the name has come. And one of the reasons is that it cannot perform generic activities very efficiently like CPU, but it can perform iterative actions or computations extremely fast and much faster than a CPU. So they are really good for computational activities, and in deep learning there is a lot of iterative computation that happens, so in the form of matrix multiplication and so on. So GPUs are very well suited for this kind of computation, and TensorFlow supports both GPU as well as CPU. And there's a certain way of writing code in TensorFlow. We will see as we go into the code. And of course, TensorFlow can be used for traditional machine learning as well, but then that would be an overkill. But just for understanding, it may be a good idea to start writing code for a normal machine learning use case, so that you get a hang of how TensorFlow code works, and then you can move into neural networks. So that is just a suggestion, but if you're already familiar with how TensorFlow works, then probably you can go straight into the neural networks part. So in this tutorial, we will take the use case of recognizing handwritten digits. This is like a hello world of deep learning, and this is a nice little, MNIST database is a nice little database that has images of handwritten digits, nicely formatted, because very often in deep learning and neural networks, we end up spending a lot of time in preparing the data for training. And with MNIST database, we can avoid that. You already have the data in the right format, which can be directly used for training. And MNIST also offers a bunch of built-in utility functions that we can straight away use and call those functions without worrying about writing our own functions. And that's one of the reasons why MNIST database is very popular for training purposes. Initially, when people want to learn about deep learning and TensorFlow, this is the database that is used. And it has a collection of 70,000 handwritten digits, and a large part of them are for training. Then you have test, just like in any machine learning process, and then you have validation. And all of them are labeled. So you have the images and their label. And these images, they look somewhat like this. So they are handwritten images collected from a lot of individuals. People have, these are samples written by human beings. They have handwritten these numbers going from 0 to 9. So people have written these numbers, and then the images of those have been taken and formatted in such a way that it is very easy to handle. So that is MNIST database. And the way we are going to implement this in our TensorFlow is we will feed this data, especially the training data, along with the label information. And the data is basically, these images are stored in the form of the pixel information, as we have seen in one of the previous slides. All the images are nothing but, these are pixels. So an image is nothing but an arrangement of pixels, and the value of the pixel, either it is lit up or it is not, or in somewhere in between. That's how the images are stored, and that is how they are fed into the neural network and for training. Once the network is trained, when you provide a new image, it will be able to identify within a certain error, of course. And for this, we will use one of the simpler neural network configurations called softmax. And for simplicity, what we will do is we will flatten these pixels. So instead of taking them in a two-dimensional arrangement, we just flatten them out. So for example, it starts from here. It is a 28 by 28, so there are 784 pixels. So pixel number 1 starts here, it goes all the way up to 28, then 29 starts here and it goes up to 56 and so on. And the pixel number 784 is here. So we take all these pixels, flatten them out, and feed them like one single line into our neural network. And this is what is known as a softmax layer. What it does is, once it is trained, it will be able to identify what digit this is. So there are, in this output layer, there are 10 neurons, each signifying a digit. And at any given point of time, when you feed an image, only one of these 10 neurons gets activated. So for example, if this is trained properly, and if you feed a number 9 like this, then this particular neuron gets activated. So you get an output from this neuron. Let me just use a pen or a laser to show you here. Okay, so you're feeding a number 9. Let's say this has been trained, and now if you're feeding a number 9, this will get activated. Now let's say you feed 1 to the trained network, then this neuron will get activated. If you feed 2, this neuron will get activated, and so on. I hope you get the idea. So this is one type of a neural network or an activation function known as softmax layer. So that's what we will be using here. This is one of the simpler ones for quick and easy understanding. So this is how the code would look. We will go into our lab environment in the cloud, and we will show you there directly. But very quickly, this is how the code looks. And let me run you through briefly here, and then we will go into the Jupyter notebook where the actual code is, and we will run that as well. So as a first step, first of all, we are using Python here, and that's why the syntax of the language is Python. And the first step is to import the TensorFlow library. So, and we do this by using this line of code saying import TensorFlow as TF. TF is just for convenience, so you can give any name. And once you do this, TensorFlow is available as an object in the name of TF, and then you can run its methods and access its attributes and so on and so forth. And MNIST database is actually an integral part of TensorFlow, and that's again another reason why we, as a first step, we always use this example MNIST database example. So you just simply import MNIST database as well using this line of code, and you slightly modify this so that the labels are in this format, what is known as one hot true, which means that the label information is stored like an array. And let me just use a pen to show what exactly it is. So when you do this one hot true, what happens is each label is stored in the form of an array of 10 digits, and let's say the number is 8. Okay, so in this case, all the remaining values, there will be a bunch of zeros. So this is like array at position 0, this is at position 1, position 2, and so on and so forth. Let's say this is position 7, then this is position 8, that will be 1 because our input is 8, and again position 9 will be 0. Okay, so one hot encoding, this one hot encoding true will kind of load the data in such a way that the labels are in such a way that only one of the digits has a value of 1, and that indicates, so based on which digit is 1, we know what is the label. So in this case, the 8th position is 1, therefore we know this sample data, the value is 8. Similarly, if you have a 2 here, let's say, then the labeled information will be somewhat like this. So you have your labels. So you have this as 0, the 0th position. The first position is also 0. The second position is 1 because this indicates number 2. And then you have third as 0 and so on. Okay, so that is the significance of this one hot true. All right, and then we can check how the data is looking by displaying the data. And as I mentioned earlier, this is pretty much in the form of digital form, like numbers. So all these are like pixel values, so you will not really see an image in this format, but there is a way to visualize that image. I will show you in a bit. And this tells you how many images are there in each set. So the training, there are 55,000 images in training, and in the test set there are 10,000, and then validation there are 5,000. So altogether there are 70,000 images. All right, so let's move on, and we can view the actual image by using the matplotlib library, and this is how you can view. This is the code for viewing the images, and you can view them in color or you can view them in grayscale. So the CMap is what tells in what way we want to view it, and what are the maximum values and the minimum values of the pixel values. So these are the max and minimum values, so of the pixel values. So maximum is 1 because this is a scaled value. So 1 means it is white, and 0 means it is black, and in between is, it can be anywhere in between black and white. And the way to train the model, there is a certain way in which you write your TensorFlow code. And the first step is to create some placeholders, and then you create a model. In this case, we will use the softmax model, one of the simplest ones. And placeholders are primarily to get the data from outside into the neural network. So this is a very common mechanism that is used. And then, of course, you will have variables, which are your, remember, these are your weights and biases. So for, in our case, there are 10 neurons, and each neuron actually has 784 because each neuron takes all the inputs. If we go back to our slide here, actually every neuron takes all the 784 inputs. Right? This is the first neuron. It receives all the 784. This is the second neuron. This also receives all the 780. So each of these inputs needs to be multiplied with a weight, and that's what we are talking about here. So this is a matrix of 784 values for each of the neurons, and so it is like a 10 by 784 matrix because there are 10 neurons. And similarly, there are biases. Now remember, I mentioned bias is only 1 per neuron, so it is not 1 per input, unlike the weights. So therefore there are only 10 biases because there are only 10 neurons in this case. So that is what we are creating a variable for biases. So this is something little new in TensorFlow. You will see, unlike our regular programming languages where everything is a variable, here the variables can be of three different types. You have placeholders, which are primarily used for feeding data. You have variables, which can change during the course of computation. And then a third type, which is not shown here, are constants. So these are like fixed numbers. All right. So in a regular programming language, you may have everything as variables or at the most variables and constants. But in TensorFlow, you have three different types: placeholders, variables, and constants. And then you create what is known as a graph. So TensorFlow programming consists of graphs and tensors, as I mentioned earlier. So this can be considered ultimately as a tensor. And then the graph tells how to execute the whole implementation, so that the execution is stored in the form of a graph. And in this case, what we are doing is we are doing a multiplication. TF, you remember this TF was created as a TensorFlow object here. One more level, one more. So TF is available here. Now TensorFlow has what is known as a matrix multiplication or matmul function. So that is what is being used here in this case. So we are using the matrix multiplication of TensorFlow so that you multiply your input values x with w, right? This is what we were doing, xw plus b. You're just adding b, and this is in very similar to one of the earlier slides where we saw sigma xi wi. So that's what we are doing here. Matrix multiplication is multiplying all the input values with the corresponding weights and then adding the bias. So that is the graph we created. And then we need to define what is our loss function and what is our optimizer. So in this case, we again use the TensorFlow's APIs. So tf.nn softmax cross entropy with logits is the API that we will use. And reduce mean is what is like the mechanism whereby which says that you reduce the error. And optimizer for doing reduction of the error, what optimizer are we using? So we are using gradient descent optimizer. We discussed about this in a couple of slides earlier. And for that, you need to specify the learning rate. You remember we saw that there was a slide somewhat like this, and then you define what should be the learning rate, how fast you need to come down. That is the learning rate. And this again needs to be tested and tried, and to find out the optimum level of this learning rate. It shouldn't be very high, in which case it will not converge, or shouldn't be very low, because it will, in that case, it will take very long. So you define the optimizer and then you call the method minimize for that optimizer, and that will kickstart the training process. And so far we've been creating the graph, and in order to actually execute that graph, we create what is known as a session, and then we run that session. And once the training is completed, we specify how many times, how many iterations we want it to run. So for example, in this case, we are saying 1000 steps. So that is a exit strategy in a way. So you specify the exit condition. So a training will run for 1000 iterations. And once that is done, we can then evaluate the model using some of the techniques shown here. So let us get into the code quickly and see how it works. So this is our cloud environment. Now you can install TensorFlow on your local machine as well. I'm showing this demo on our existing cloud, but you can also install TensorFlow on your local machine, and there is a separate video on how to set up your TensorFlow environment. You can watch that if you want to install your local environment. Or you can go for any cloud service, like for example Google Cloud, Amazon, or Cloud Labs. Any of these you can use and run and try the code. Okay, so it has got started. We will log in. Alright, so this is our deep learning tutorial code, and this is our TensorFlow environment. And so let's get started. The first, we have seen a little bit of a code walkthrough in the slides as well. Now you will see the actual code in action. So the first thing we need to do is import TensorFlow, and then we will import the data. and we need to adjust the data in such a way that the one hot encoding is set to true, one hot encoding, right? As I explained earlier. So in this case, the label values will be shown appropriately. And if we just check what is the type of the data, so you can see that this is a data sets, Python data sets. And if we check the number of images, the way it looks, so this is how it looks. It is an array of type float 32. Similarly, the number, if you want to see what is the number of training images, there are 55,000, then there are test images 10,000, and then validation images 5,000. Now let's take a quick look at the data itself, visualization. So we will use matplotlib for this. And if we take a look at the shape, now shape gives us like the dimension of the tensors or the arrays, if you will. So in this case, the training data set, if we see the size of the training data set using the method shape, it says there are 55,000 and 55,000 by 784. So remember, the 784 is nothing but the 28 by 28, 28 into 28. So that is equal to 784. So that's what it is showing. Now we can take just one image and just see what is the first image and see what is the shape. So again, size, obviously it is only 784. Similarly, you can look at the image itself, the data of the first image itself. So this is how it shows. So large part of it will probably be zeros, because as you can imagine, in the image only certain areas are written, rest is blank. So that's why you will mostly see zeros, either it is black or white. But then there are these values are, so the values are actually, they are scaled, so their values are between 0 and 1. Okay, so this is what you're seeing. So certain locations there are some values, and then other locations there are zeros. So that is how the data is stored and loaded. If we want to actually see what is the value of the handwritten image, if you want to view it, this is how you view it. So you create, like, do this reshape, and matplotlib has this feature to show you these images. So we will actually use the function called ImShow, and then if you pass this parameters appropriately, you will be able to see the different images. Now I can change the values in this position, so which image we are looking at, right? So we can say, if I want to see what is there in maybe 5,000, right? So 5,000 has 3. Similarly, you can just say 5. What is in 5? 5 has 8. What is in 50? Again 8. So basically, by the way, if you're wondering how I'm executing this code, Shift Enter, in case you're not familiar with Jupyter Notebooks, Shift Enter is how you execute each cell, individual cell. And if you want to execute the entire program, you can go here and say run all. So that is how this code gets executed. And here again, we can check what is the maximum value and what is the minimum value of this pixel values. As I mentioned, it is scaled, so therefore it is between, the values lie between 1 and 0. Now this is where we create our model. The first thing is to create the required placeholders and variables, and that's what we are doing here, as we have seen in the slides. So we create one placeholder and we create 2 variables, which is for the weights and biases. These 2 variables are actually matrices, so each variable has 784 by 10 actual values. Okay, so one for this 10 is for each neuron, there are 10 neurons, and 784 is for the pixel values inputs that are given, which is 28 into 28. And the biases, as I mentioned, one for each neuron, so there will be 10 biases. They are stored in a variable by the name B. And this is the graph, which is basically the multiplication of these matrix multiplication of X into W, and then the bias is added for each of the neurons. And the whole idea is to minimize the error. So let me just execute. I think this code is executed. Then we define what is our The y value is basically the label value. So this is another placeholder. We had x as one placeholder and y underscore true as a second placeholder, and this will have values in the form of 10 digit arrays. And since we said one hot encoded, the position which has a one value indicates what is the label for that particular number. All right. Then we have cross entropy, which is nothing but the loss function. And we have the optimizer. We have chosen gradient descent as our optimizer. Then the training process itself. So the training process is nothing but to minimize the cross entropy, which is again nothing but the loss function. So we define all of this in the form of a graph. So up to here, remember what we have done is we have not exactly executed any TensorFlow code till now. We are just preparing the graph, the execution plan. That's how the TensorFlow code works. So the whole structure and format of this code will be completely different from how we normally do programming. So even with people with programming experience may find this a little difficult to understand it, and it needs quite a bit of practice. So you may want to view this video also maybe a couple of times to understand this flow, because the way TensorFlow programming is done is slightly different from the normal programming. Some of you who, let's say, have done maybe Spark programming to some extent will be able to easily understand this. But even in Spark, the programming, the code itself is pretty straightforward. Behind the scenes, the execution happens slightly differently. But in TensorFlow, even the code has to be written in a completely different way. So the code doesn't get executed in the same way as you have written. So that's something you need to understand, and a little bit of practice is needed for this. So far what we have done up to here is creating the variables and feeding the variables, and or rather not feeding but setting up the variables and the graph. That's all. Defining maybe the what kind of a network you want to use. For example, we want to use softmax and so on. So you have created the variables, how to load the data, loaded the data, viewed the data, and prepared everything, but you have not yet executed anything in TensorFlow. Now the next step is the execution in TensorFlow. So the first step for doing any execution in TensorFlow is to initialize the variables. So anytime you have any variables defined in your code, you have to run this piece of code always. So you need to basically create what is known as a node for initializing. So this is a node. You still are not yet executing anything here. You just created a node for the initialization. So let us go ahead and create that. And here onwards is where you will actually execute your code in TensorFlow. And in order to execute the code, what you will need is a session, TensorFlow session. So tf.session will give you a session, and there are a couple of different ways in which you can do this, but one of the most common methods of doing this is with what is known as a with loop. So you have a with tf.session as ses and with a colon here, and this is like a block, starting of the block, and these indentations tell how far this block goes, and this session is valid till this block gets executed. So that is the purpose of creating this with block. This is known as a with block. So with tf.session as ses, you say ses.run init. Now ses.run will execute a node that is specified here. So for example, here we are saying ses.run. Ses is basically an instance of the session, right? So here we are saying tf.session. So an instance of the session gets created and we are calling that ses. And then we run a node within that, one of the nodes in the graph. So one of the nodes here is init. So we say run that particular node, and that is when the initialization of the variables happens. Now what this does is, if you have any variables in your code, in our case we have w is a variable and B is a variable. So any variables that we created, you have to run this code. You have to run the initialization of these variables, otherwise you will get an error. Okay, so that's what this is doing. Then we, within this with block, we specify a for loop, and we are saying we want the system to iterate for 1000 steps and perform the training. That's what this for loop does. Run training for 1000 iterations. And what it is doing basically is it is fetching the data or these images. Remember, there are about 50,000 images, but it cannot get all the images in one shot because it will take up a lot of memory and performance issues will be there. So this is a very common way of performing deep learning training. You always do in batches. So we have maybe 50,000 images, but you always do it in batches of 100 or maybe 500 depending on the size of your system and so on and so forth. So in this case, we are saying, okay, get me 100 images at a time and get me only the training images. Remember, we use only the training data for training purpose, and then we use test data for test purpose. You must be familiar with machine learning, so you must be aware of this. But in case you are not, in machine learning also, this is not specific to deep learning, but in machine learning in general, you have what is known as training data set and test data set. Your available data, typically you will be splitting into two parts and using the training data set for training purpose. And then to see how well the model has been trained, you use the test data set to check or test the validity or the accuracy of the model. So that's what we are doing here. And you observe here that we are actually calling an mnest function here. So we are saying mnest train.next batch. Right? So this is the advantage of using MNIST database, because they have provided some very nice helper functions which are readily available. Otherwise, this activity itself, we would have had to write a piece of code to fetch this data in batches. That itself is a lengthy exercise. So we can avoid all that if we are using MNIST database, and that's why we use this for the initial learning phase. Okay, so when we say fetch, what it will do is it will fetch the images into X and the labels into Y, and then you use this batch of 100 images and you run the training. So ses.run, basically what we are doing here is we are running the training mechanism, which is nothing but it passes this through the neural network, passes the images through the neural network, finds out what is the output, and if the output, obviously initially it will be wrong, so all that feedback is given back to the neural network, and thereby all the W's and B's get updated till it reaches 1000 iterations. In this case, the exit criteria is 1000, but you can also specify probably accuracy rate or something like that for as an exit criteria. So here it just says that, okay, this particular image was wrongly predicted, so you need to update your weights and biases. That's the feedback given to each neuron, and that is run for 1000 iterations. And typically by the end of this 1000 iterations, the model would have learned to recognize these handwritten images. Obviously it will not be 100% accurate. Okay, so once that is done, so this happens for 1000 iterations. Once that is done, you then test the accuracy of these models by using the test data set. Right? So this is what we are trying to do here. The code may appear a little complicated because if you're seeing this for the first time, you need to understand the various methods of TensorFlow and so on. But it is basically comparing the output with what is actually there. That's all it is doing. So you have your test data, and you're trying to find out what is the actual value and what is the predicted value, and seeing whether they are equal or not, tf.equal, right? And how many of them are correct, and so on and so forth. And based on that, the accuracy is calculated as well. So this is the accuracy, and that is what we are trying to see, how accurate the model is in predicting these numbers or these digits. Okay, so let us run this. This entire thing is in one cell, so we will have to just run it in one shot. It may take a little while. Let us see. And Not bad. So it has finished the 1000 iterations. And what we see here as an output is the accuracy. So we see that the accuracy of this model is around 91%. Okay. Now, which is pretty good for such a short exercise. Within such a short time, we got 90% accuracy. However, in real life, this is probably not sufficient. So there are other ways to increase the accuracy. We will see probably in some of the later tutorials how to improve this accuracy, how to change maybe the hyperparameters like number of neurons or number of layers and so on and so forth, and so that this accuracy can be increased beyond 90%.
So we will be discussing about what exactly is LangChain, Langgraph, Langflow, and Langsmith, and where can we use them, and what makes them different from others. So this is the major agenda for today's session. Let's begin with LangChain. So what exactly is LangChain? LangChain is an open source framework designed to help developers build applications powered by large language models by providing tools and abstractions to simplify the process of integrating LLMs with external data sources and workflows. Now, imagine you're building an AI application where an LLM model like GPT-4 is needed to generate an initial response to your query. Llama 3 or other versions to refine that response. A custom-built AI agent to decide whether it can answer the query without a hiccup or if it has to fetch external sources to generate a response. Most importantly, a solid memory to store all previous user interactions. Without LangChain, managing all these components manually would require extensive coding. You need to write a custom code snippet to handle API calls to your LLM like GPT, Llama, create and maintain a dedicated memory space, and most importantly, a fully customized decision-making capable AI agent. Yet in scenarios where you can see an opportunity to scale it up, the possibilities are questionable. This approach leads to a lot of boilerplate code and makes the system complex. LangChain simplifies this by providing an open source framework that helps developers build applications powered by large language models. It enables training prompts, interacting with external data, and adding memory for contextual understanding. Now, let's discuss some of the key features of LangChain. Firstly, LLM support. It works with both closed source GPT-4 and open source models like Llama 3 with simple API integrations. Prompt templates. It allows dynamic prompt customization instead of hard-coding queries. Third one is chains. It helps connect multiple tasks like querying an LLM, retrieving data, and processing responses in a seamless workflow. Fourth one is indexes. Supports document loaders and vector databases to pull in external data. Fifth one is memory. It enables applications to retain past interactions, improving contextual awareness. And lastly, the agents. It uses LLMs as reasoning engines to dynamically decide the next step in the workflow. With LangChain, developers can efficiently build AI-powered applications without reinventing the wheel. You can have a detailed briefing on LangChain on the official website. Also, should you wish to try it out, take a quick look at Quick Start page to steps to follow to set up the environment and run LangChain in your local system. Now, let's proceed with the next one in this tutorial, which is Langgraph. So what exactly is Langgraph? By definition, Langgraph is a library within the LangChain's ecosystem. It is a framework for building and managing complex stateful multi-agent LLM applications by modeling workflows as graphs, where nodes represent tasks or states and edges represent a transition between them. Now, let us imagine this. You are in a situation where you need to work with not one, but multiple agents in parallel. But LangChain can just assist you with one. You need much more enhanced platform for this. That's where Langgraph comes into the picture. Langgraph is built upon the existing LangChain and designed for managing agents and multi-agent workflows. While LangChain is excellent for chaining prompts, Langgraph excels at handling structured interactions between multiple agents. If you are building a system where multiple agents collaborate, such as a research assistant or an automation workflow, Langgraph is a great choice. So let's discuss these core components of LangGraph. First one, state. A state is a shared data structure that stores user inputs, agent outcomes, and workflows history. Now, the next one is nodes. You can have one node or also multiple nodes. These nodes are individual components or actions that execute LLM calls, run functions, or interact with external tools. Now, let's go to the third part, which is edges. Edges are nothing but connections between nodes that define execution flow. Unlike traditional directed graphs, nodes in LangGraph can dynamically decide which node to call next. That means the control flow can go in both ways. LangGraph is ideal when you need agents to interact in cyclical workflows or collaborate on complex tasks. You can have a detailed briefing on LangGraph on the official website. Also, should you wish to try it out, take a quick look at the quick start. Using LangGraph is straightforward. You just need to install the package, import it onto your project, and then using the provided classes, you can straightly access LangGraph. Now, let's proceed to the next one, which is Langflow. Now, what is Langflow? Langflow is a visual, low-code framework built upon top of LangChain, enabling developers to easily design and test AI applications, especially those involving multi-agent systems and retrieval augmented generation or RAG. Now, imagine building AI-powered applications like chatbots or data processing tools without writing any code. Langflow makes this possible with the drag-and-drop interface. Langflow is built upon top of LangChain and provides a visual interface for designing LangChain workflows. It is perfect for prototyping LLM applications, allowing users to quickly design workflows, chains, and agents and test them. However, it is not intended for production use, but it is excellent for MVPs, which is minimum viable products. Langflow is designed to simplify AI-powered app development by providing a drag-and-drop interface. It enables developers to visually design, experiment with, and test LangChain-based workflows. Now, what makes Langflow different from LangChain and LangGraph? Why use Langflow? So, there are three major reasons. Firstly, no coding required. Perfect for prototyping AI applications without having to write any code. Second one, visual workflow builder. You can easily design chains, agents, and integrations. Thirdly, quick prototyping. Best suited for MVPs, experimentation, and non-production use cases. So there are two main ways to use Langflow. First one, via DataStax, a paid cloud-hosted option. Second one, self-hosted. Install locally or on your own cloud server. So once deployed, Langflow provides a UI where you can drag and connect various components, enabling you to build and test AI workflows seamlessly. You can have a detailed briefing on Langflow on the official website. Also, should you wish to try it out, take a quick look at Quick Start to work on setting up Langflow in your local environment. You just need to install the package, import it onto your project, and start using the provided classes. Now, let's move on to the last one, which is Langsmith. So what exactly is Langsmith? So Langsmith is a platform developed by LangChain, designed to streamline the development, testing, debugging, and monitoring of LLM applications, offering tools for observability, evaluation, and prompt engineering. The LLM, genai, AI agents, all the hype was a huge hit. Everybody is interested in developing a custom AI agent to automate and optimize all the redundant CRM tasks and much more. But building an LLM-based application or AI agent is just the beginning. Monitoring, testing, and optimizing are equally crucial. Langsmith is designed to help developers at every stage of an AI application's lifecycle, from prototyping to production. Now, why use Langsmith? So there are three important reasons. Firstly, performance monitoring. It tracks API calls, token usage, errors, and latency. Second one, debugging and evaluation. It ensures models return expected results and avoid unnecessary API costs. Lastly, independent framework. It works with any LLM framework, not just the LangChain based ones. If your application requires extensive monitoring, debugging, or optimization, Langsmith is a great tool. However, for simple applications without complex tracking needs, it might not be necessary. To integrate LangChain, install the package, set up the environment variables, and use traceable annotations in your code. The Langsmith dashboard provides insights into performance metrics, including token usage, call trends, and error rates. For more details on Langsmith, visit the official page of Langsmith. Also, should you wish to try it out, take a look at the quick start to work on setting up Langsmith in your local environment. You just need to install the package, import it into your project, and start using the provided classes.
Something big is happening in the world of AI, and it's shaking up the industry. No, it's not another ChatGPT update or a new release from OpenAI. This time, it's a brand new player on the scene. DeepSeek R1, an AI model that's already outperforming the best known models in ways that have experts seriously been talking. But why is this causing such a stir? Well, it's because DeepSeek R1 doesn't just answer questions like other AIs. It thinks. And I mean really thinks. It breaks down complex problems step by step, showing you exactly how it arrives at the solution. You just don't get an answer, you get the entire process from start to finish. That too in real time. This is the kind of AI that doesn't just solve problems, it solves the way we do. Now, here's the twist. DeepSeek R1 isn't from one of the usual AI giants like OpenAI or Anthropic. It was developed by High Flyer Capital Management, a hedge fund that's quietly been making waves in the AI world. In fact, their new DeepSeek R1 Lite preview is already making headlines for its stunning performance on tasks like mathematical reasoning, logical inference, and real-time decision making. Areas where even the best of the OpenAI's models often fall short. But why is this model such a game changer? It's because in 2024, the world is demanding AIs that can think logically and reason through problems. DeepSeek's ability to show its work is what sets it apart. While other AIs give you answers, DeepSeek lets you watch its thought process unfold. Think of it as the AI that doesn't just solve problems, but teaches you how to think like it does. And if you think that's all just a hype, let me tell you, Forbes isn't the only one buzzing about it. Even experts across the industry are pointing out that DeepSeek is outperforming model from heavyweights like OpenAI and Anthropic on tests that measures complex reasoning. It's already winning in some major AI benchmarks, and it's only going to get better. So why is DeepSeek R1 such a big deal right now? And what does it mean for the future of AI in 2024 and beyond? Well, in this video, we will explore DeepSeek R1 starting with its unique capabilities and how it stands out from the other AI model. We'll also test its math reasoning and problem-solving skills, comparing it with models like OpenAI. Then we will examine the real-world application in fields like finance and tech. So let's dive in and see how it's shaping the future of AI.
So at first, let us understand what is exactly DeepSeek R1 Lite Preview. As you can see this tweet post, so DeepSeek R1 Lite Preview is an AI tool which is similar to ChatGPT and is created by a Chinese company which is known as DeepSeek. The company announced this new model on X on November 20 and shared a few details. So I'll show you the documentation page over here. So this is a documentation page of DeepSeek API. And DeepSeek R1 Lite Preview is meant to be really good at solving problem reasoning in maths, coding, and logic. It shows you how to think step by step so that you can understand how it comes up with answers and which help people to build trust more. So you can try out me on their website, and the website name I'm going to show you. So you just have to simply go to Google and type over here chat.deepseek.com. As soon as you enter this, you'll be redirected to DeepSeek's page. So simply I'll just log in with the Google account, and here you can see this is the interface of our DeepSeek R1 Lite model, and here we will enable this DeepThink preview, which is a new feature over here. And now let's start with our test and start testing whether DeepSeek, this model, is really that effective or worth the hype or not. So first we'll be doing the strawberry test, okay? So let's see what exactly is the strawberry test. So let's start with a very simple question, which is how many times does the letter R occur in the word strawberry? So this is our question over here, and let us just check what would be the answer. So I didn't expect such a long reasoning process to what seems like a straightforward task. I thought that after counting the letter R and identifying the position of the word, it would have stopped there. But what's interesting to me is that it didn't stop. It double-checked the counting a couple of times and even considered things like how people might pronounce or spell the word differently, which I think is a bit of redundant, especially the pronunciation part. But then that's how it does show how careful and thoughtful it is. So it just explained us every step by step and what process we can go through it. So let's move on to our second question, which would be a mathematical reasoning question. So a next question would be if a triangle has sides of 3, 4, 5, what would be its area? So let's just check. So as you can see here, the DeepSeek R1 model is getting our answers, and it performs the checks I predicted, although in a different order. But then it's using all the steps and all the formulas and what would be the best to go with this question. So both the explanation and the output are particularly clear and easy to follow, which makes me think that this would be a fantastic model to embed in math students' assistant. For example, this is a particular use case. Maybe the thought process could be shown first and the student could interact with acknowledging whether they understood it or not. So that's a pretty fast answer. Let's move on to our third question. So now let's ask a DeepSeek model a geometrical type of question, which is a bit tough, and let's see what answer would it generate for us and how it is taking the logic building and the process. So as you can see, it is taking all the formulas and also it is considering the other probabilities as well. So we'll just wait a few seconds. So as you can see, it has written weight and messed up in a denominator. So it is even checking what mistakes has it generated, which is really good. It is just like as if somebody is solving this mathematical problem, but then in the form of AI. So that's really interesting. So now as you can see, it has given us the final answer and also step-by-step approach, which is well-known geometric formulas and applied them directly, which makes the reasoning very easy to follow. So the output is very clear and easy to follow, and across all these examples, it's been impressive to see how it consistently double-checked calculations using different methods. The thought process is always detailed, logical, and very easy to understand. So for somebody who wants to actually learn or go through these mathematical problems, this model will give a very detailed explanation. So I would highly suggest using this. So let's now move on to our next question, which would be a coding test. So the first question would be implement a function in Python that finds the longest palindromic substring in a given particular string. The function should have a time complexity better than O n raised to the power 3. Big O of n to the power 3. So let us just see what is the time complexity. Will it generate the answer for us? The code. Let's just check it out. So as you can see, it has given us the solution code here and also the explanation part, and whatever the function it is using, it has briefly mentioned the explanation about it. And I think that the model did a very great job solving the problem and finding the longest palindromic substring. The approach was smart, efficient, and clearly explained. So instead of just brute force method, every possible substring which would be slow, it used a very clever expand around centers technique. And this method handled both odd length palindromes and even length palindromes as well, which was really clear and effective. So that was for the coding part. So now let's move on to a logical reasoning type of question, and let's see what answer does it generate. And we will also compare it with the OpenAI model here as well. So let's quickly check it out. A question here is: a man has to cross a river with a wolf, a goat, and a cabbage. His boat can only carry himself and one other thing. If left alone, the wolf would eat the goat and the goat would eat the cabbage. How can he get everything across safely? So let's quickly check out the answer. So as you can see, it's thinking of the end of reading the answer for us. Also, for the deep think messages, you can use 50 messages free per day. So we have already used 5 texts and we have 45 messages left for today. So as you can see, it has given a clear, detailed explanation, and it solved the problem really very well. I think it carefully went through the rules and checked different possibilities. It understands that some pairs like the wolf and the goat, or the goat, the cabbage, can't be left alone. It also reviewed the constraints at the starting. It also reviews the constraints at the start. Starting from this, it looks at what would happen if the man takes each item across the river first and works out if it creates any problem. What I find really nice is about how the model adjusts its plan when something doesn't work. For example, when it tries taking the wolf first, it realizes talking to the wolf first, but realizes at the same time that it causes trouble and then rethinks the step. This trial and error method feels very similar to how we as humans might solve the puzzle ourselves. So in the end, the model comes up with a very right solution and explains it in a very clear and step-by-step way. So as you can see, I've given ChatGPT this question and this is the answer it has generated, but then it wasn't that detailed as compared to DeepSeek model. So here I would rate DeepSeek model more because it gave me a very clear explanation with all the details set. You can clearly see the difference out here. So for anyone who wants to understand from depth, this DeepSeek model would be a great help. So let's quickly have a look on the DeepSeek R1 live preview benchmarks. So we have tested the model in real world conditions, but how does it stack up against other AIs on benchmarks like AIME, math, and competitive programming languages? So you have this on the screen. We have compared it with AIME, math, GPQA Diamond, Codeforces, Live Code Bench, and also Zebra Logic. So according to the benchmarks, DeepSeek R1 Live Preview blows the competition out of the water when it comes to math and logic problems, with a pass rate of 52.5% on the AIME 2024 challenge. It is really ahead of OpenAI's O1 preview and far surpasses models like GPT-4 on complex math tasks. So with this, we have come to the last part of the section, and here we will be comparing that who really wins. At first, you have seen that we have compared with the OpenAI model. So let's just quickly test some questions and just check it out that with OpenAI, which one performs much more better. So now we will compare DeepSeek versus OpenAI O1 model with some command prompts to see who really wins in different categories. So here I have this DeepSeek model. So my first command for this test is a math problem, and it says solve for x the quadratic equation 3x to the power 2 plus 5x minus 2. So let's quickly see this, what answer is it giving, and we will be comparing it with the OpenAI O1 model as well. So as you can see, it is giving us all the available solutions using different methods as well. And see the first method, the second method, quadratic formula. It's basically giving you the full overview of all the methods which you find easier, and you can use that. And here is our final answer. So let's compare it with the OpenAI O1 model as well. So here I have this question and I'll just check for the answer. It's taking a bit of time, but let's wait for a minute. So as you can see, it has only used one formula, which is the quadratic formula, and here we have the answer for this thing. But what I found is it provided a correct solution, but then it lacked, whereas our DeepSeek model, it provided much more detailed explanation. So I think DeepSeek wins for this maths question as well. For the second comparison, I have a coding problem. So let's check for both. First, we will be checking for DeepSeek model. And the coding problem is write a Python function to check if a given string is palindrome or not. And I'm waiting for the answer here. So as you can see, DeepSeek R1 live preview model has provided us a correct solution along with a detailed breakdown of why each part of the code works as it does. So let's check for the O1 model as well. So now as you can see, for the coding task, the O1 model has given us the solution, but then it provides a working solution with clear code, but it doesn't explain the logic behind it. Whereas the DeepSeek model had provided the logic and also the solution with each detailed breakdown. And I think for this also the winner would be DeepSeek R1 Preview because it provides better and clearer explanation. Now let's move on to the third test, which would be the logical reasoning. So here is my question. The logical reasoning, which is if a man has 5 apples and gives 3 away, how many apples does he left with? So let's check for the DeepSeek model. So now you can see it has given us the answer and also the correct answer, but it has explained each and every logic to go through this question and why have we used this particular logic as well. So that's a pretty breakdown, detailed step-by-step explanation. Let's check for the OpenAI O1 model as well. So here I have my question. Let's wait for the answer. See, it has given us a straightforward answer, which is approx 2 apples. But then it hasn't mentioned the logic behind it. Same as it was same for the coding task. I think since both of these models have provided the accurate, correct answer, but here also the winner would be DeepSeek because it has provided with a lot of explanation and transparency as well. So this is the wrap up of the video today. And if you're looking for an AI that excels in reasoning, problem solving, and transparency, it's definitely a contender. While OpenAI and other models are fantastic, DeepSeek brings something unique to the table. Step-by-step logic, clear explanation with an edge when it comes to math and coding challenges.
In this session, we will learn how to run DeepSeek locally in Windows command prompt. But before that, let's take a look at the DeepSeek and all the hype about it. DeepSeek, the latest in generative AI, is making waves with its advanced reasoning and problem-solving capabilities. With global AI adoption accelerating, DeepSeek emerges as a powerful contender, seemingly outpacing its rivals in efficiency and depth. Built on cutting-edge architecture, it excels in complex reasoning, coding, and multilingual understanding. AI is the new genius, and DeepSeek is pushing its boundaries further with unmatched performance. Its ability to handle intricate prompts with precision makes it a game changer. Unlike traditional models, DeepSeek leverages superior contextual awareness for human-like responses. Its efficiency in real-world applications refines productivity and automation. Businesses and developers are rapidly integrating it for high-level decision making. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icons to get notified. Also, just that you know, if you want to upskill yourself, master generative AI and artificial intelligence skills, and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various generative AI courses and certifications. Simplilearn offers various certification programs in collaboration with some of the world's leading universities like Purdue, IIT Kanpur, IIT Guwahati, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, machine learning, generative AI, and over a dozen others. That's not all, you also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also academics from top universities. After completing these courses, thousands of learners have transitioned into an AI and machine learning role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a generative AI program that fits your experience and areas of interest. Now, without further delay, let's get started. Now, before we get started, we need to check the space first. Let me explore the file explorer once. So you can see the downloads is almost full. Now we have another volume D which has a little bit of space. Let's use that. Now let's change the location of downloads to drive D. For that, go to downloads, open properties, and here go to location. Maybe if you want to create a new file, that's also okay. Let's try that. So here, let's create a file and I'll name this as temporary downloads. Maybe you can also use underscore to avoid confusion. And this might ask for some permissions, like let's say you already downloaded an application or something like that, and you set environment for that, right? So let's see, that's the one. So automatically the computer will change all the environment variables for you, just in case if you have any other applications running from downloads directly. Meanwhile, while this particular files are copying, let's wait for a moment. Let's minimize everything and open a new tab on Google. So to run DeepSeek locally, we might want to use a few things. Firstly, Llama. So let's download Llama. Go to the Llama thing in the third link. That's the one we need. Now we need to download Llama into our local system. For that, let's explore the models. So this is the first one, the first link. This is the one we are looking for. So before downloading that, let's enable Llama. For that, we need to download and install Llama. Download for Windows. So the downloading and installation might take a little bit of time. Don't worry about it. And we have started the download. Now we will explore the DeepSeek before all this download thing settles down. Let's explore a little bit about the DeepSeek models. So here you can see we have 7B, 1.5B, 8B, 14B, and let's also view all. So the B stands for billion parameters. So DeepSeek has a lot of modules based on the learning parameters, right? A couple of them have 8 billion. 671 is the highest, I guess, 400 GB. And because of space constraints, we will go with the first one, which is 1.5 billion parameters one. You can choose the model based on your space in your computer. So I'll go with the 1.5B1. So just click there and you'll get all the drop down options. Go with the one you want. And for that, just copy that code there. Llama run DeepSeek -R1 1.5B, right? That's the one. And let's open the command prompt. Okay, before that, we need to install Llama first. So the file has been downloaded successfully. Navigate to the downloads location. Start the setup. It might take a couple of time. Once the setup is completely done, then we will open the command prompt and then copy paste that particular code. Then everything will be automatically downloaded and loaded for you. So DeepSeek will be ready to run locally on your CMD. So what's the benefit of running DeepSeek locally? Basically, when you want to communicate with your generative AI, you might want the internet connection with you. If you are able to download and set the generative AI, in our case, DeepSeek, in your computer, then it is beneficial for you so that it can run without the internet connection. It might take a little time, don't worry. Once the setup is done, look at the bottom right corner. You'll get a slight notification, a smaller notification which says Llama is set up and running. Similar to that, you can just get Llama is running now, something like that. Just a couple of moments while the final settings are done. There you go, the setup is done. Close it. Now check the tray there. Should be having an Llama logo present right there. There you go. That's the notification we were looking for. Llama is running. Now to check, you can also check the logs of Llama which are presently in your computer just for cross verification. Also, make sure that to copy that Llama run DeepSeek R1 code there to run it on your command prompt. Just press Windows icon with R to have the run command. And you can type CMD to execute the command prompt. There you go. Now make sure to copy that code. Once the Windows command prompt is active, you just have to paste it and hit enter. Command prompt is loading. It might take a little glitch. Let's wait until it shows up. Let's try again. CMD, hit OK. Let's wait for a moment while the command prompt pops in. Let's check if there are any other activities. There you go. We have multiple prompts. Let's close all the other ones which we don't need. I think it's still loading. Let's close this as well. Let's give it a retry. CMD, OK. And let's wait. So here is the log file which we were looking at earlier. Let's close the log file which we don't need it. Yeah, the command prompt is active. Paste, enter. Now you should be getting something called manifesting. So that means the package is getting downloading, pulling manifest. There you go. So based on the model that we chose, which is 1.5 billion parameters, it's typically a smaller version of the DeepSeek that we were looking at. The biggest one was 675 billion parameters, which is close to 400 GB. If you have enough space in your PC, then you can go with the highest version. So due to space constraints, I'm going with the smaller one. The procedure is same. You just have to paste the code and run. So at the last where you have 1.5B, right? In place of that, you'll be having 675B. That's the only difference. It might take a little bit of time to download based on the package you're using. If you're going with the higher package, a bigger package, then the download time might even end up more than 24 hours. And if you don't have enough space, it might collapse in between. So I'd recommend select the one which suits with your memory space. Now the files are downloading. It might take a little time. Let's wait for that. The first one is downloaded, second, third. So I think it's downloading in terms of packages. So we have the fifth package, verifying. There you go, successfully downloaded. Now we can type in a message. Let's say, let's type hi DeepSeek or hello DeepSeek to verify. So hi DeepSeek. So you can see when you open the prompt, you'll have that thinking mode, right? You can see it is also thinking. Now let me type my request here. So it also said as hello, how can I assist you? So my request is I wish to learn neural networks. So you can see that when you open DeepSeek on Windows browser or Google browser, Firefox, any of the browsers, it will show you the thinking process, right? Here also you can see that thinking process, start of think and end of think. The only thing is unable to display the thought process over here, but fine. Now let's continue with the command prompt, which is I wish to learn neural networks, and hit enter. Now let's say it will help you to learn neural networks in a stage-by-stage process in the learning order. What exactly is neural networks? What are the key components of neural networks? Neurons, activation, weights and biases and everything, right? Similar to ChatGPT or even other competitors in terms of generative AI. And it is also giving you procedures and sample codes here, right? If you wanted to execute these codes on Jupyter Notebook, then you can just import NumPy as NP from TensorFlow, etc. And also you have some sample codes for generating a model, how to execute that, everything. So I guess that's the end of the line for the prompt. Now, this was the trial run on how to run DeepSeek locally on your Windows command prompt. Now, you can also develop a completely new user interface and experience for your DeepSeek to run on locally. So far, so good. For the sample purpose, this is good. Now, let's type in buy and see how it responds to the text. There you go. It might be confused, but it might give you an alternate approach. Yeah. So it looks like your message got cut off. Okay, could you clarify?
Today we are exploring Hugging Face, an amazing tool that makes working with language and AI super easy. If you are curious about using advanced technology to understand or create text, this video is perfect for you. Hugging Face is a company that helps people use AI models for language tasks like translation, text analysis, or even generating new text. They have created a library called Transformer, which comes with pre-trained models, so you don't have to build everything from scratch. It's simple, powerful, and perfect for developers, researchers, or even beginners. So in this video, I will show you 3 cool things you can do with Hugging Face. Speech to text, turn spoken words into written text easily, great for captions or voice apps. Second one is sentiment analysis. Find out if a text is positive, negative, or neutral, helpful for understanding reviews or comments. The third one is text generation. Create human-like text that sounds natural, perfect for chatbots or creative writing. I will also explain some important basics like how pipelines make using Hugging Face models super easy and how tokenization helps AI understand text. By end of this video, you will know how to use Hugging Face to start building your own projects. It's simple, fun, and really powerful. Before we move forward, unlock the future of AI with comprehensive program in collaboration with ENICT Academy, IIT Guwahati. In just a few months, you will master cutting-edge skills in generative AI, large language models, and machine learning from learning tools like ChatGPT and DALL-E 2 to gaining hands-on experience with Python and TensorFlow. This course will equip you to lead AI projects and qualify for top roles like machine learning engineer or data scientist. Plus, with an IIT certificate on your resume, you will stand out to the best employers in tech. So don't forget to check out the course link from the description box below and the pinned comment. So without any further ado, let's get started. So welcome to this demo part of this video. So here, as you know, we will be doing 3 things. First thing, speech to text recognition. The second thing, text generation from a particular sentence or a word. And the third thing, we will do sentiment analysis. Okay, so we will perform this one by one. So let's start with something called speech to text recognition. Okay, using Hugging Face. So first I will rename this. I will write here Hugging Face speech to text. Okay, yeah. So first I will install transformers library. It is already installed on my system, but again, just for you guys, I'm doing this. Okay, pip install transformer. So now let's see what is transformers. So transformers is a powerful Python library created by Hugging Face. So that allows you to download, manipulate, and run thousands of pre-trained open source AI model. Fine. So as you can see, requirement already satisfied. It means like already installed. So these transformer models cover multiple tasks across modalities like NLP, natural language processing, computer vision, audio, and multimodal learning, like many things. Fine. So now I will do from transformers import pipeline. Okay, so now let's run it. So now what is pipeline? Okay, so a transformer pipeline describes the flow of data from origin system to destination system. Fine, because you already know transformer means you can run or manipulate thousands of pre-trained open source AI model. So pipeline describes the flow of data from origin system to destination system and defines how to transform the data along the way. Okay, so let's check the versions transformers version. Okay, that long tab. Okay, why it is coming? Import transformers. Yeah, so we have currently 4.4 2.4 version of the transformer. Okay, so I am using Google Colab. Okay, so you can use either Jupyter Notebook, Visual Code Studio, or Colab. Okay, so now let's import libraries. Import Librosa. Okay, so what is Librosa? So Librosa is a Python package for audio and music analysis, right? Because we are doing speech to text, so we need this. So it provides various functions to quickly extract key audio features and matrices from the audio files. Okay, and this Librosa can also be used to analyze and manipulate audio files in a variety of formats such as WAV wave, MP3, M4A, and like that. Okay, so next we will import Torch. I hope everyone know Torch. So Torch is nothing PyTorch. It is a machine learning library based on the Torch library used for applications such as computer vision and NLP. And originally it was developed by the Meta AI and now the part of Linux Foundation, umbrella. Let's import one more thing. Import. So now let's import IPython. Okay, capital IPython dot display as display. So now you will be wondering what is this IPython display. Okay, so it is an interactive command line for the terminal for Python, and it can provide a IPython terminal and the web-based notebook platform for Python computing. And this IPython have more advanced features than the Python standard interpreter, and we quickly execute a single line of Python code. Nothing. Okay, for that I'm using this. And the next is from transformers import
WAV to vectorizer for CTC and WAV to vectorizer to tokenizer. Okay, so now what is this? So WAV2 vectorizer for CTC is supported by the notebook on how to fine-tune a speech recognition model. Okay, and this tokenizer. So tokenizer is nothing. Tokenization is a conversion of a text into meaningful lexical tokens belonging to categories defined Alexa program. In case of NLP, so those categories include nouns, verbs, adjective, punctuation, etc. Okay, now, and the last library, let's import NumPy as NP. I hope everyone know NumPy. What is NumPy? Again, NumPy is a Python library used for working with arrays. It also has a function, for working in domain like linear algebra, Fourier transform, and matrices, and many others. Fine. I hope everyone know about these library which we have imported. Okay, so let's move forward. Right, tokenizer equals to 2 tokenizer dot from pre-trained. This is why I love this Google Colab. You will just write just some words and it will show the suggestions. Facebook. So this is again one pre-trained model. Okay, so we are just importing it. Base 960th. This is nothing, the name. Okay, then model equals to WAV2 for CTC dot from pre-trained, then Facebook WAV2 vectorizer 2, then base 960th. Fine. Now let's run it. So now you can see. So we are loading this. Okay, they are downloading. Okay, so you can ignore these warning. So now let's load the audio file. So here I will write audio sampling rate equals to librosa dot load. Okay, so you know about librosa, right? Then I have v dot m4a. So I have already one speech or one audio, you can say. So I will play it, don't worry. Before the final output, I will show you 16,000. Okay, so now I will write okay, I've already loaded, I guess. Okay, no issues. I will load again. Okay, the file is loaded. I will rename it to V. Yeah, fine. So now it won't, the error won't come again. We have v.mp4a. Okay, so now we have to do. Okay, let me try it. We have v.mp4a, but I don't know why it is not coming. Okay, let me copy the path. Now it will run, I guess. It's running. Yeah. So now I will write here audio, comma, sampling rate. Okay, now listen carefully. Then I will write display dot audio, then path, comma, autoplay equals to true. Okay.
Hello and welcome. This is an AI voice message.
I guess you heard, but again, let me play it again.
Hello and welcome. This is an AI voice message.
Okay, so it is saying ki, hello and welcome. This is an AI voice message. Fine. So now what I will do, I will input some values. Input values equals to tokenizer, then audio, comma, return tensors equals to pt. Fine. Dot input values. Okay, then here input values. Okay, input values. Okay, yeah. So now logits will come here. So we have to now store the logits, which means non-normalized predictions. Okay, so logits equals to model input values dot logits. Okay, then here I will write logits. Okay, it's running. Done. So now what we will do, we will store predicted IDs, then we will pass the logits to values to softmax to get the predictive value. Okay, so here I will write predicted IDs equals to torch dot arg max. Okay, then logits comma dimension equals to -1. Okay, then I will pass the prediction to the tokenizer decode to the transcription. Okay, so here I will write transcriptions equals to tokenizer dot decode predicted IDs to 0. Running fine. So now let's see our output transcriptions. So now you can see hello and welcome. This is an AI voice message. So now let's play it again.
Hello and welcome. This is an AI voice message.
Amazing, right? So this is how you can use Hugging Face for the speech to text recognition. It's a very small code, line of code, as you can see. Okay, so now let's move forward and do the sentiment analysis, okay, or text generation. So let me open new drive. So yeah, so now I will write here, I will write sentiment slash text generation Hugging Face. Okay, So first of all, let's import the files. So first I will write import warnings, then warnings dot filter warnings. Okay, I will write here ignore, then we'll import numpy. You already know what is numpy, and import panda. So these are some basic Python library, and I hope everyone knows. And import matplotlib for the plots, matplotlib dot pyplot as plt. Then I will import cbon for the graphs, the statistics graph. Okay, sns, then sns dot set. So now we'll import sklearn model train test split. So sklearn is nothing. Scikit-learn is probably the most useful library for machine learning Python. So this library contains a lot of efficient tools for machine learning and statistical modeling, including classification you can do, regression you can do, clustering you can do from this sklearn. Okay, from sklearn dot model selection, import train test split from sklearn dot matrix, import f1 score, comma, confusion matrix, comma, ROC AUC curve or score. So again we'll import teams from transformers, import pipeline. Everyone know what is this. Then import torch. Okay, now let's run it. You have too many active session, 10 minutes existing to continue if you are interested in using one more session. Okay, wait. Yeah, fine. Now which one is open, bro? 10 minutes this, 10 minutes this, 10 minutes this. No. Okay, fine. So now let's do sentiment analysis. So we will explore sentiment analysis using a pre-trained transform model. Okay, the Hugging Face library provides convenient pipeline, as you already know, function that allows us to easily perform sentiment on the text. So now let's first import the necessary dependencies and create a sentiments pipeline using this line. So I will write here classifier equals to pipeline sentiment analysis, then type classifier. Okay, so it will download the pre-trained sentiment analysis pipeline. Pipeline is not defined. How? Okay, error is there. I hope it will run now. Yeah. So now we can pass a single sentence or a list of sentence to the classifier and get the predictive sentiment labels and associate confidence score. Fine. So now just for the testing classifier, so let's write this is a great movie. Okay, now let me run it. So now you can see here label positive. So label positive typically refers to the outcome or a class of interest that the model is designed to predict. So here we are just checking the sentiment analysis model. Okay, so this is why I wrote this. Okay, so let's check one more. This was a great course. Then I did not understood any of it. Now let's check this. Yeah, perfect. And the score, you can see the accuracy score 99%, which is almost close to 100%, and which is amazing. So now you have access to a GPU, so you can also utilize it for the faster processing by specifying the device using the parameter. Okay, so now what I will do, first I will, okay, wait, yeah, fine. So now I will import dataset airline tweets equals to pd dot read. PD means pandas library, here we are using. Okay, now first import, I will import here itself. So I have tweets.csv. Okay, tweets.csv. Let it upload. Yeah, done. So now let me airline tweets dot head. Why dot head? Means it will show me the top 5 rows. Okay, 0 1 2 3 4 5. Okay, you can see tweet ID, airline sentiment, neutral, positive, neutral, negative, then this is this. Okay, so now let's do something. Okay, so what I will do, df means data frame airline tweets, then I will write airline sentiment. We have airline sentiment, this column. Okay, comma text. I need these 2 columns. Okay, df dot head 5. So yeah, so airline sentiment is neutral, and this is what this text is all about. Okay, because these 2 are the main things, text and the sentiment. So now let's make plot, count plot. Then I will write df comma x equals to airline sentiment, then palette equals to with this. Then here I will write plt dot x label airline sentiment. Okay, then plt dot y label count plt dot show. So it will draw one graph. Okay, spelling is wrong. Yeah, so it will show neutral, positive sentiment and the negative. So as you can see, the negative sentences or the sentiments are the more. Okay, so we have now 3 classes which do not match the 2 class available in the Hugging Face pipeline. So therefore we will filter out all the rows which have been labeled as neutral. Okay, so df equals to df, and again df airline sentiment, fine, was not equals to neutral. Okay, then df target equals to df airline sentiment dot map. Then I will write here positive 1 and the negative 0. Fine, negative will be 0. Okay, then print number of rows comma df dot shape. Okay, so now you can see number of rows are 11,541. Okay, so now I will write predictions 5. It will, okay, predictions is not defined. Okay, so now what I will do, so here I will write text equals to df text and to list dot to list. Then here I will write predictions equals to classifier text. Okay, so here write probabilities equals to prediction, then score if predictions label dot starts with P means positive. Okay, else 1 minus prediction score. Okay, then I will write for prediction and prediction. Why it is not running? This is taking time, too much time. I don't know why. So as you can see, finally we have the output of predictions values. So this depends on system to system. My system took almost 17 minutes 47 seconds to complete. Okay, so now let's run it. Okay, predictions is not defined, bro. Now predictions. Yeah, so now I will write here predictions equals to np dot array. Np means numpy dot array. Then I will write 1 if prediction label is positive dot starts with P. Okay, else 0 for prediction and prediction values. Yep. Okay, fine. So now let's check the accuracy of our model. Print accuracy. Okay, then I will do round up the values. So here I will write np dot mean, then df, then the target, right? Yeah, then I will write equals to predictions, then I will write into 100 comma 2, then I will write percentage. Okay, fine, looks good. Yes, so as you can see, our accuracy is 88.99%, which is very good again. So now let's do some confusion matrix. Confusion matrix, then df target comma predictions comma normalize equals to true. Okay, then I will plot confusion matrix. Okay, df then target comma predictions comma normalize equals to true. Okay, my bad. That here confusion matrix comma labels. Okay, so here I will plot a confusion matrix using Seaborn. Okay, so here I will use ARGS, which is confusion matrix np.array, so which is labels list. So I will write plt dot figure, then figure size equals to 8,6. That's sns dot set font scale equals to 1.4. Okay, then let's create the heat map. Confusion matrix comma and not will be true. Okay, then I will write fmt equals to g, then confusion map equals to blues, then x6 labels equals to labels, then y x labels equals to labels. Okay, yes, so now I will write plt dot title will be confusion matrix, then plt dot x label will be predicted values, then plt dot y label will be actual values, then plt dot show. Okay, why the chart is not coming? Okay, so I have to write plot confusion matrix, then I write cm, then negative comma positive. Okay, now the chart will come. Okay, Yeah. So now you can see here, this is actual, and this is a confusion matrix, and the negative and the positive ratio is there. Okay. So now let's print the, now let's check the ROC AUC score. So I will write here print ROC AUC score. Then here I will write ROC AUC score, then TF target, comma, props. Okay. So 94. Okay. So first let me tell you what is this ROC AUC score. So this is the area under the ROC curve. So what it does, it sum up how well a model can produce relative scores to discriminate between positive and the negative instance across all the classification threshold. So with this ROC score of 94, 0.94, which is 94%, we can conclude that a pre-trained sentiment analysis model has achieved a high level of accuracy and effectiveness so in predicting the sentiment labels. So this indicates that the model is capable of accurately classifying text into positive or the negative sentiment categories. Okay, so now we'll do text generation. Okay, so text generation involves generating creative and coherent text based thing. So I will write here text. Okay, so text generation involves generating creative and coherent text based on a given prompt or starting point. So what we will do first, we will import the necessary dependencies and load the data set of the poem. Okay, so here I am write poems. Let me write poems equals to pd.read.csv. Don't worry, I will give you these files. Okay, description box below I will add. So here I will write robot frost. Okay, .csv. Fine. And then I will write poems dot head 5, or head, just have to write head. Module pandas has, okay, not dot underscore csv. Yeah, okay, it will show the top 5. Stopping by woods on a snowy evening, fire and ice, the aim was song, collection, content, year of publication. Okay, so now what we will do, we will write content equals to poems content dot drop na to list. Okay, so to generate text, we extract individual lines from the poems and use the pipeline text generation function to create a text generation pipeline. Fine. So here I will write lines equals to, then I will write for poem in content. Okay, for line in poem dot split into next line. Okay, then lines dot append, then I will add line dot right strip. To the right it will add. Okay, fine. So now lines equals to line for line in lines if length of line 0, then show me the lines. 5. Okay, so now you have seen here whose woods these are, I think I know. Then the next line, his house is in the village though. That's the next line, he will not sing. Okay, like this. So now let's import that pipeline text generation module. Okay, gen equals to pipeline. So these are the some pre-trained model. You already know generation. Okay, so now I will write here lines. Let's run it. Yeah, done. So in line 0 we have whose votes these are, I think I know. Okay, so now we can now generate tags by providing a prompt and specifying the parameters such as max length and num return sequence. Okay, why? Because we have imported this tag generation module. Okay, for example, see lines 0 dot max length equals to 20. So now it will generate this to the maximum 20. Okay, till 20 word maximum length. Okay, check. Okay, okay, expression cannot contain perhaps double equals to where? Okay, wait, now it will run. So see, the line was this much only. Whose words these are, I think I know. Whose words these are, think I know. But here, the generated text, I wish to go to church because I feel like. Okay, this is how you can do, text generation. Now let's check for the more. Gen lines 1. Okay, then max length equals to 30, comma, num return sequences equals to 2. Okay, so our first line was this, his house is in the village though. Okay, 0 1 2 3 4 5. Okay, so here you can see his house in the village though. However, you might say that the place was the same with the place this. So these are the generated text. Okay, and this is another return sequence second. So there are two, one and the second. Okay, so now let me import text tab. Okay, then creating function wrap x. I don't need this. Then return text wrap dot fill x comma replace white space equals to false comma fix sentence endings equals to true. Okay, so now out equals to generated lines 0 to maximum length equals to 30. Then print wrap out to 0. Then generated text Okay, so now we are setting the pad tokens to EOS tokens. Okay, so who's these are, I think I know, and this is the maximum 30 till 30. Okay, so now I will write here, okay, preview equals to, okay, so now what you can do, you can generate a prompt to generate text on a specific topic like this. Prompt equals to transformers have a wide variety of application in NLP. Okay, so this is my prompt. Okay, this I'm not importing from the data set. Okay, so I will write out equals to gen prompt comma max length equals to 100, print zap out. Okay, here I will write, anyways, here I will write generated text prompt. Okay, so it is running. Let's wait. Yeah, so okay, some error is there. Okay, so here the issue is with 100 words. Will go till 50. Yeah, so let me do it again. 100. Yeah, so now you can see we can generate text using by giving a prompt. So we have covered 3 topics in this. First thing is speech to text using Hugging Face. Second thing is sentiment analysis using Hugging Face, and the third is text generation using Hugging Face. Okay, and in this text generation we did with 2 methods, one with the data set and second thing with the by giving prompt like in ChatGPT, you can say.
On July 25th, OpenAI introduced Search GPT, a new search tool changing how we find information online. Unlike traditional search engines, which require you to type in specific keywords, Search GPT lets you ask questions in natural, everyday language, just like having a conversation. So this is a big shift from how we were used to searching the web. Instead of thinking in keywords and hoping to find the right result, you can ask now Search GPT exactly what you want to know, and it will understand the context and give you direct answers. It's designed to make searching easier and more intuitive without going through links and pages. But with this new way of searching, so there are some important questions to consider. Can Search GPT compete with Google, the search giant we all know? What makes Search GPT different from AI overviews, another recent search tool? And how does it compare to ChatGPT, OpenAI, popular conversational AI? So in this video, we are going to explore these questions and more. We will look at what makes Search GPT special, how it compares to other tools, and why it might change the way we search for information. Whether you are new into tech or just curious, this video will break it down in simple words. Stick around to learn more about Search GPT.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
But before we start, if you want to learn AI and ML from the industry expert, try Simplilearn's postgraduate program in AI and machine learning from Purdue University in collaboration with IBM. This course teaches in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, ChatGPT, and many more. So don't forget to check out the course link from the description box below and the pinned comment. So without any further ado, let's get started. So what is Search GPT? Search GPT is a new search engine prototype developed by OpenAI, designed to enhance the way we search for information using AI. Unlike a typical chatbot like ChatGPT, Search GPT isn't just about having a conversation. It's focused on improving the search experience with some key features. The first one is direct answer. Instead of simply showing you a list of links, Search GPT delivers direct answer to your question. For example, if you ask, what is the best wireless noise cancellation headphone in 2024? Search GPT will summarize the top choices, highlighting their pros and cons based on expert reviews and user opinions. So this approach is different from the traditional search engines that typically provide a list of links leading to various articles or videos. The second one is relevant sources. Search GPT responses come with clear citations and links to the original sources, ensuring transparency and accuracy. So this way you can easily verify the information and delve deeper into the topic if you want. The third one, conversational search. Search GPT allows you to have a back and forth dialogue with the search engine. You can ask follow-up questions or refine your original query based on the responses you receive, making your search experience more interactive and personalized. Now let's jump into the next topic, which is Search GPT versus Google. So Search GPT is being talked about a major competitor to Google in the future. So let's break down how they differ in their approach to search. The first one is conversational versus keyword-based search. Search GPT uses a conversational interface, allowing users to ask questions in natural language and refine their queries through follow-up questions. So this creates a more interactive search experience. On the other hand, Google relies on keyword-based search, where users enter specific terms to find relevant web pages. The second thing is direct answer versus list of links. So one of the Search GPT's standout features is its ability to provide direct answers to the question. It summarizes information from the various sources and clearly cites them, so you don't have to click through multiple links. Google typically presents a list of links, leaving users to sift through the results to find the information they need. The third one, AI-powered understanding versus keyword matching. Search GPT uses AI to understand the intent behind your question, offering more relevant results even if your query isn't perfectly worded. Google's primary method is keyword matching, which can sometimes lead to less accurate results, especially for complex queries. The fourth one, dynamic context versus isolated searches. So Search GPT maintains content across multiple interactions, allowing for more personalized responses, whereas Google treats each search as a separate query without remembering previous interaction. And the last one, real-time information versus indexed web pages. Search GPT's aim to provide the latest information using real-time data from the web, whereas Google Vast Index is comprehensive but may include outdated or less relevant information. So now let's jump into the next topic, which is Search GPT versus AI overviews. So Search GPT and AI overviews both use AI, but they approach search and information delivery differently. It's also worth noting that both tools are still being developed, so their features and capabilities may evolve and even overlap as they grow. So here are the differences. The first one is source attribution. Search GPT provides clear and direct citation linked to the original sources, making it easy for users to verify the information. Whereas AI overviews include links. The citation may not always be clear or directly associated with specific claims. The second one is transparency control. Search GPT promises greater transparency by offering publishers control over how their content is used, including the option to opt out of AI training. AI overviews offer less transparency regarding the selection of content and the summarization process used. The next one is scope and depth. Search GPT strives to deliver detailed and comprehensive answers pulling from a broad range of sources, including potential multimedia content. And in AI overviews offers a concise summary of key points, often with links for further exploration, but with a more limited scope. Now let's jump into the next part. Search GPT versus ChatGPT. Search GPT and ChatGPT, both developed by OpenAI, share some core features but serve different purposes. So here are some differences. The first one is primary purpose. Search GPT is designed for search, providing direct answer and sources from the web, whereas ChatGPT focuses on conversational AI generating text responses. The second one is information sources. Search GPT relies on real-time information from the web, whereas ChatGPT knowledge based on this training data, which might not be current. The third one is response format. Search GPT prioritizes concise answers with citation and source links. So whereas ChatGPT is more flexible, generating longer text, summarizes creative content, code, and etc. The next feature is use cases. Search GPT idle for fact-finding, research, and tasks requiring up-to-date information, whereas ChatGPT is suitable for creative writing, brainstorming, drafting emails, and other open-ended tasks. So now question arises, when will Search GPT be released? Search GPT is currently in a limited prototype phase, meaning it's not yet widely available. OpenAI is testing with a select group to gather feedback and improve the tool. So if you are interested in trying Search GPT, so you can join the waitlist on its webpage, but you will need a ChatGPT account. A full public release by the end of 2024 is unlikely, as OpenAI hasn't set a timeline. It's more probable that Search GPT features will gradually added to the ChatGPT in 2024 or in 2025, with a potential standalone release later based on testing and the feedback. So with this, we have come to the end of this video. If you have any question or doubt, please feel free to ask in the comment section below. Our team of experts will help you as soon as possible.
Did you know that within just a few lines of code, you can transform an AI model into something far more powerful? Something that responds to questions, connects to live data, pull insights from databases, and even interacts with other apps in real time. That's what LangChain allows you to do. And it's quickly becoming the go-to framework for AI developers. Think about this, you're about to create something amazing, an AI that can think, learn, and grow in ways we once only dreamed of. And here's the best part. You don't need to be an AI expert to make that happen. LangChain is like a toolkit that connects the most advanced large language models like OpenAI's GPT to real-time data, allowing you to build AI applications that are smart, flexible, and highly interactive. LangChain is more than just a way to make AI development easier. It's a framework that allows different language models to work together seamlessly. So whether you want to understand user questions with one LLM, create human-like responses with another, or pull in data from an API or a database, LangChain makes all possible. The framework takes care of heavy lifting, connecting models, managing data flows, and even customizing how your AI interacts with external sources. Now the question is, why is LangChain so popular? It has become one of the most fastest growing open source projects because it's solving a huge problem for developers. The challenge of integrating generative AI and LLMs with external data and complex workflows. As AI becomes more central to our lives in 2024, LangChain is helping developers create smarter, more powerful applications. So whether it's just for chatbots, content creation, or advanced data analysis. In this tutorial, I'll show you exactly how to get started with LangChain, from setting up your environment to building the first AI-powered app. I'll walk you through it. So LangChain makes it possible to train models on our own custom data, opening up more possibilities for building specialized intelligent applications. By the end of this video, you will be ready to start building with LangChain, and trust me, once you see how easy it is, you'll wonder why you didn't start using it sooner. Let's start with a simple question, why should we use LangChain? Imagine you're working with large language models like GPT-4 or Hugging Face models, and you want to take their capabilities further, like integrating them with your own data sources or allowing them to take action based on information they retrieve. This is where LangChain comes in. LangChain is like an open source framework that allows you to build intelligent applications by connecting large language models with external data sources. It can turn static AI interactions into dynamic, data-aware workflows. One of the best parts is you don't have to manually code everything from scratch. LangChain abstracts away much more complexity of working with LLMs, allowing developers to focus on building functional applications instead of wrangling API calls and managing data pipelines. So LangChain is set to play even bigger role in AI development because it enables you to harness true power of generative AI by connecting it with real-time data and external tools. So now we have understood what LangChain is. Let us now understand how to install LangChain. So let's start with the installation of LangChain. We'll just simply go to the website docs part, and we'll just read through this documentation. So here it has explained what LangChain is and what are the framework consisting of. So we also have these tutorials on how do we install LangChain. Okay, so for installing, you can just simply click on this quick start and see here it has written how do we set up on Jupyter Notebook. So this is the command. If you want to install LangChain, we will use the pip command. So just simply you can copy this command pip install LangChain, and you have to open your command prompt or the terminal in your computer, and here you have to simply copy paste the command. So as you can see, it will load all the packages which is required for installing LangChain. So you can see your requirement already satisfied. This is because I had already installed my LangChain before. So we have understood how to install this LangChain by using this command, and you can also install the LLM chain. We'll understand it later. So let me just show you what else you need to install. First, we have understood this LangChain. Then we have the Pinecone client. So we'll just simply search here Pinecone client, and it will redirect us to this page. So Pinecone client is actually a vector store for storing and retrieving embeddings, which we will use in the later steps. So Pinecone is also used to actually, create secret API keys. So here you can also create the API keys. You can also read the documentation part. So we'll understand how to create API keys using OpenAI. But first, let us install Pinecone client in our system. So we'll again go to command prompt this terminal, and we'll just copy paste pip install Pinecone client. So you can see here it will download and install all the packages required. So it has been installed. Now the third thing we're talking about is OpenAI client. So we'll use OpenAI models for a large language task. So we'll just simply search here OpenAI. Okay, and so it has redirected us to this page, OpenAI platform. And okay, before starting this, so this is the platform here where you can create, export an API key in OpenAI. Okay, so you can see here overview, quick start, concept, everything is there. And to create an API key, we'll just simply click here, and here you have to select this option, create a new secret key. Suppose I give my secret key name, anything you can give. Suppose I give test 1, 2, 3. Okay, and permissions is all, and we create the secret key. Now you need to actually save your key. We'll just copy this key because it will be required later while debugging the code. So we will just copy paste this secret key. We will require it later, and then done. So these are the keys I have created. So actually ChatGPT and other LLM models like OpenAI and Hugging Face uses LangChain to integrate with other APIs to create your own custom LLM models or chatbots. So suppose here we have logged in our ChatGPT here, and if I search here who won the WTC World Cup in 2023. So here it has shown the answer, but for example, if I search who won the cricket match World Cup So here, as you can see, the ChatGPT has given answer as my last knowledge update, the 2024 Men's World Cup has not taken place yet. This is happening because this ChatGPT older version has not been trained on the latest upcoming news or whatever the new technology is. So by using LangChain, you can integrate with other APIs and you can create your own customized LLM models or chatbots, which help you to train your own custom data using various tools and APIs. So before we move on, I've already showed you how to create the secret API key and how you have to store the API key address. So first we have already understood how do we install LangChain here. So by using the pip command, we do it. And So you also need to install Python 3.8 or later installed in your system. So I already have Python installed. And to check that, you can just simply, I already have it installed in my system. So to check that, I'll simply just type here Python -- version and click enter. So as you can see, it has shown me the Python version which is installed in my computer. So the second step is already we have discussed, which is OpenAI API key here. So second step, we have already discussed how do we create our OpenAI API key. So we have to sign up in our OpenAI, then go to the API key section and then create a new secret key. And these are the keys I have created, and you can just keep it later. Later you'll use that. So now we'll come to the third step, which is create a project directory and setup. So what we do is we have Jupyter installed in our system. So we'll just go to command prompt here and type JUPY, Jupyter Notebook. So it will redirect us to the Jupyter Notebook installed in our system. So if not, we can just simply go from here. It is loading right now. We have to wait. Now you just need to click on this new and Python 3 IPy kernel, because Python has been installed in my system. So we will use Python as our kernel here. And here you can just give the prompts, the command. Before that, you have to create a Python file, which we can also create this Python file in Visual Studio Code. Just simply go to Visual Studio Code here and just simply click on File, New File, and I'll just type here python.py. And you can you have to first store the API key. For this, we use the command OpenAI _ API _ key equal to, and just give your secret key. Okay, you can just simply copy paste your secret key and just store this. So this ensures that your API key is stored securely and it can be used whenever needed. Now the step 4 is to initialize a project and install the required libraries. So you need to add some additional libraries like Streamlit to make a user interface. So let's add that too in our project folder. You can either create a text file named requirements.txt and then install all these. We have already installed the OpenAI LangChain. We just need to install Streamlit. So here you can just give the command pip install Streamlit. So as you can see, this I have already installed Streamlit before. Same wise, you can also install OpenAI if it is not installed in your system using the command terminal, the Windows PowerShell. So we have understood this, what all packages and what all we need to install. Now the next step is to build your first LangChain app. To create a simple app which uses a input query, and the app will generate a response using OpenAI's GPT model. So you have to create a Python file named main.py here. So as you can see, I've already imported this main.py, and this is my code here. Import Streamlit as st from LangChain and the constants I have created, and then I have initialized the OpenAI with our API key. So you have to just type this prompt here. I'm using VS Code here. You can also do it in your Jupyter Notebook. And then to create the Streamlit app, you have to give a title, LangChain demo with OpenAI. So this is the title I have provided. And then the text input for prompt. The prompt is st.text input and enter a prompt. You can just type enter a prompt or whatever you wish to. And then display the response. So if prompt response is LLM.predict prompt, so you can use the predict method for LLM. So here what the app will, so after creating and debugging this in the terminal, so your app will initialize OpenAI using your API key, and the user inputs a prompt through the Streamlit interface. LangChain processes the input and sends it to the OpenAI's GPT model, and the AI generates a response which is then displayed in the app. So now you can use all these prompts to run on your app. So to do this, you can just, to see your app in action, you can just go to the terminal and run the following command, which is streamlit run main.py. So you can just simply go to the terminal here and just simply type the command, which is streamlit Streamlit run main.py. So by giving this prompt, a new tab in your browser will open displaying the app, and you can also type any question into the input box. So now we have understood all these steps. So this was a quite basic tutorial on how to install LangChain and then integrate it with the app. You can also customize and expand. So LangChain's flexibility allows you to integrate other APIs also, external data sources, or even add memory to your AI application. So whether you're building a simple chatbot or more complex AI system, the possibilities are endless. So by following all these steps, you will have a fully functioning app running in your system in no time.
What if I've told you I've tested over 1,000 AI tools? Yep, after all that exploring, experimenting, and a few late nights, I've finally narrowed them down to absolutely the best. In this video, I'm going to share my top picks of 10 tools from each of the 5 biggest AI categories that are actually worth your time. Whether you're into image creation, writing, voice tools, video generation, or AI coding assistance, I've got something lined up for you. These aren't random tools that kind of work. These are the ones that stood out, the ones that genuinely get the job done. So if you have ever felt overwhelmed by the flood of AI tools out there, this video is gonna be your cheat sheet to the top performers in every category. Let's start with the category of image creation. In the first place, we have Midjourney. If you're after breathtaking, artistic visuals, this one is for you. It's especially great for concept art, fantasy scenes, or anything with surreal polished look. Next is DALL-E 3, integrated right inside the ChatGPT. What makes this tool stand out is how well it understands prompts. It nails small details, and you can even edit parts of your image directly. Super useful for content creators or marketers who need fast, accurate visuals. Third is Stable Diffusion, and it's go-to for anyone who wants full control. It's open source, so you can run it locally, train your own models, and even build your own styles. If you're technically or just love to tinker, this one is for you. Coming to number 4 is Leonardo AI. It's made with game developers and storytellers in mind. It has pre-trained models for characters, environments, and even items. So if you are building a world, this tool makes it faster and easy to bring it to life. At number 5, we have Adobe Firefly. This one's perfect for professionals. It fits right into the Adobe ecosystem if you're already using the Photoshop or Illustrator. It's a smooth experience. The image quality is high, and text effects are great for branding or designing work. Number 6 is Playground AI. This is probably the most flexible tool on this list. It's web-based, fast, and great for trying out multiple styles without any complexity. If you want something lightweight but powerful, definitely check this out. Artbreeder comes in at number 7, and it's a bit different from others. Instead of generating images from prompts, you mix and evolve existing images, great for character design, especially faces. It's super collaborative and creative, though a bit limited in image resolution. Number 8 is Night Cafe. This one's great if you want variety. It supports multiple generation styles like Vikugan and Stable Diffusion. There is also a strong community aspect, so you can share your work and get inspired by others. At number 9, we have Photo. It's clean, simple, and ideal for creating social media graphics, posters, or marketing visuals. You don't need any design skills. It's perfect for your quick results. And finally, number 10 is Deep Dream Generator. This one's all about the weird and abstract. It creates psychedelic dreamlike visuals that are super unique. It won't fit every project, but experimental or surreal work, it's awesome. Next category is voice generation. These AI tools can narrate, speak, or even clone your voice with shockingly realism. Whether you're creating YouTube videos, podcasts, audiobooks, or building characters for games, these are the voice tools that actually deliver. In the first place, we have 11 Labs. It's the most natural sounding AI voice out there. You get emotion, depth, and even voice cloning that sounds incredibly real. Coming to the second is Murph AI. This one is great for polished voiceover, perfect for videos, presentation, and training content. It even includes background music and timing control. At number 3, we have got Lovo AI, also known as Genai. With a huge voice library and support for 100 plus languages, it's ideal for creators who want expensive multilingual voiceovers. In the fourth place, we have Play.ht. It's fast, reliable, and offers detailed control over the tone, pitch, and speed. Great for podcast, articles, or any voice-first content. Number 5 goes to Resemble AI. This one's all about real-time voice cloning and emotionally delivering. Perfect for interactive content like games and virtual assistants. At number 6, we have Descript Overdub, audio by editing text. It's a lifesaver for podcasters and video creators fixing mistakes or adding new lines. 7th on this list is Typecast. It combines realistic voice AI with animated characters, making it perfect for explainer videos, YouTubers, and storytelling content. At number 8, we have Speechify. Originally made for reading, but now you can use it to turn any text into clean, human-like speech. Great for audiobooks and productivity. Number 9 is Synthesis. A solid choice for business voiceover, whether it's ads, explainers, or training videos. This one gets it done with professional sounds. And finally, in the 10th place, we have Podcastle. It's an all-in-one podcasting platform with built-in voice generation, recording, and editing. Perfect for creators on the go. Now let's talk about writing. Whether you're crafting blog posts, emails, scripts, or social media caption, AI writing tools can save you hours and spark ideas you wouldn't have a thought of. I have tested dozens and these are 10 that stood out how well they actually help you write smarter and faster. In the first place, we have ChatGPT by OpenAI. It's a gold standard. From brainstorming to full-on article drafts, it handles everything with context and style. Especially with GPT-4, it's like having a writing assistant that just gets it. Second is Jasper AI, built specially for marketers and content creators. Jasper comes with tons of pre-built templates for product description, ad copy, blog intros, you name it. It's fast, efficient, and optimized for high converting content. At number 3, we have Sonnet. This one's amazing for versatility. It does blogs, landing pages, Google Ads, and even long form content. It also has a chatbot, so it feels more interactive while creating. Fourth is Copy.ai. If you need social media post, product description, or email subject lines in seconds, this tool nails it. It's super intuitive and beginner friendly, perfect for quick content sprints. In the 5th place, we have Notion AI. Built right into Notion, this tool helps you expand, summarize, and brainstorm inside your notes and docs. Great for people who want writing help in their daily workflow without switching tools. Number 6 is Pseudo-Write. This one's made for creative writers such as novelists and storytellers. It helps with characters, development, plot twist, and rewriting the scenes. If you write friction, this is a secret weapon. 7th is Ink Editor. It combines AI writing with SEO optimization. So if you want your content to rank while sounding human, this tool does both. Great for bloggers, content marketers. Coming to number 8 is HypeWrite. It is like a smart autocomplete that works across your browser. It helps you draft emails, social posts, and even essays. At number 9, we have got Writer. Clean, fast, and super affordable. Writer is a solid tool for small businesses and freelancers who want quick content without any complexity. And finally, number 10 is WordTune. It is not a full-blown writing platform, but it's amazing at rewriting, rephrasing, and polishing your text. Great for improving tone, clarity, and shortening long sentences. Alright, now let's move on into the most powerful category, which is AI video creation. Whether you are a content creator, marketer, educator, or just someone who wants to make videos without cameras, editing headaches, these tools can seriously level up your workflow. In the first place, we have got Pictory. This tool turns scripts or blog posts into professional looking videos in minutes. It picks stock footage and adds music and even guarantees subtitles all automatically. Next up at number 2 is Synthesia. It's famous for its AI avatars that looks and sounds like real people. Just type in your script, pick an avatar, and boom, you have got your studio style video with zero filming. In the third place is Runway. This one's creative powerhouse. You can remove the video backgrounds, edit scenes and text commands, and even generate a new video content using Gen 2. It's especially great for short form content or experimental visuals. Coming at number 4 is InVideo. It's built for marketers, content creators who want to make polished promo videos, reels, or even YouTube content. Tons of templates, stock assets, and AI script assistance makes it fast and easy. Fifth is Lumen 5, ideal for turning blog posts or article into animated videos. You just paste in your text and it automatically adds visuals, animations, and transition to match your message. Great for social media and explained content. At number 6, we have Descript. While it is more known for podcasting and editing audio, its video editor is crazy useful. You can edit videos by editing the transcript. It's great for talking head content, interviews, and repurposing long-form recordings. Number 7 is Wheat.io, a browser-based editor that is surprisingly powerful. You get subtitles, transition, audio cleanup, and more, all with a super clean UI. It's great for social media content and quick edits on the fly. 8th is Rephrase.ai. This one lets you create personalized video messages using AI avatars. Perfect for sales, onboarding, or sending custom messages at scale without having to record anything manually. In the 9th place, we have Steve.ai. Super beginner friendly. It turns simple text into videos using animations and voiceover. Great for explained videos, internal training, or educational content. And finally, number 10 is Eli.io. It creates AI avatar videos from just a prompt or script. Similar to Synthesia, but with a focus on e-learning and corporate training content. Scalable, clean, and no need a production crew. Now let's get into the most game-changing areas of AI, coding assistance. Whether you're a beginner or a pro developer, these tools can help you write better code, debug faster, and even learn new languages or frameworks without getting overwhelmed. In the first place, we have GitHub Copilot, powered by OpenAI. This tool is an autocomplete on steroids. It suggests whole functions, helps you write boilerplate, and even explains code, all from inside your editor. If you're coding on a daily basis, this is a must-have. Second is Codium. It's a free, fast, and supports a wide range of languages. It works like a copilot but adds some extra customization. And a lot of devs love it for its speed and clean interface. At number 3 is Replit Ghostwriter. Especially great for beginners and educator, Replit's AI can help you code right inside the browser. No setup needed. It also helps you explain errors and teach you as you build. Fourth is Tabline, one of the easiest code compilation tool. Tabline runs locally for privacy and works across multiple IDEs. It's great for developers who want predictive coding without sending data to the cloud. In the 5th place, we have Amazon Code Whisper. designers to integrate smoothly with AWS tools and workflows. It's perfect if you're building cloud-native application or working on AWS ecosystem. Coming at number 6 is Codex by OpenAI. It's an underlying model behind Copilot, and if you're working in an experimental or custom environment, it offers a deep integration potential for AI-driven apps. Number 7 is Mutable AI, a newer player focused on speeding up your workflow with smart suggestions, automatic doc generation, and code refraction. It's great for clean, productive level code. 8th is Kite. It is one of the OG AI assistants for Python and still holds up if you want lightweight, fast suggestions without overwhelming features. At number 9, we have SourceGraph Cody. It's made for enterprises terms that work on massive code bases. It gives powerful contextual help and scales well across big projects. And finally, number 10 is Ask Cody. It's super handy for generating snippets, SQL queries, and even API docs. A nice tool for quick tasks when you don't want to dive too deep. Just an information, if you're interested in mastering the future of technology, the professional certificate course in Gen AI, which is Generative AI and Machine Learning, is perfect opportunity for you. Offered in collaboration with the E&ICT Academy, IIT Kanpur, this 11-month live and interactive program provides hands-on experience in cutting-edge areas like generative AI, machine learning, and tools such as ChatGPT, DALL-E 2, and Hugging Face. You'll gain practical experience through 15 plus projects, integrated labs, and live masterclass delivered by esteemed IIT Kanpur faculty. Alongside earning a prestigious certificate from IIT Kanpur, you'll receive official Microsoft badges for Azure AI courses and career support through Simplilearn's Job Assistant program. Hurry and enroll now. Find the course link in the description box and pin comments. And that wraps up the top AI tools across image creation, voice generation, writing, video production, and coding. These tools aren't just cool. They actually help you get things done faster, better, and with a less effort. If you found this helpful, drop a like, subscribe, and let me know in the comments which tool you're excited to try or if there is anything that you love that I missed.
So now what is RNN? RNN are a type of neural network that are designed to process sequential data. They can analyze data with temporal dimensions such as time series, speech, and text. RNN can do this by using a hidden state passed from one timestamp to the next. The next hidden state is updated at each other time step based on the input and the previous hidden state. RNN are able to capture short-term dependencies in sequential data, but they struggle with capturing long-term dependencies. Why the LSTMs are made. So moving forward, let's discuss types of LSTM gates. So LSTM models have three types of gates: the input gate, the forget gate, and the output gate. So let's first discuss the input gate. The input gate controls the flow of information into the memory cell, deciding what to store. The input gate determines which values from the input should be updated in the memory cell. It uses a sigmoid activation function to scale the values between 0 and 1, and then applies pointwise multiplication to decide what information to store. Next is forget gate. Controls the flow of information out of the memory cell, deciding what to discard. The forget gate decides what information should be discarded from the memory cell. It also uses a sigmoid activation function to scale the values between 0 and 1, followed by pointwise multiplication to determine what information to forget. The last one is output gate. Controls the flow of information out of the LSTMs, deciding what to use for the output. The output gate determines the output of the LSTMs unit. It uses a sigmoid activation function to scale the values from 0 to 1, then applies pointwise multiplication to produce the output of the LSTM unit. So these gates implemented using sigmoid function are trained using backpropagation. They open and close based on the input and the previous hidden state, allowing the LSTM to selectively retain or discard information, effectively capturing long-term dependencies. So now let's discuss application of LSTM. LSTM models are highly effective and used in various applications, including video analysis, analyzing video frames to identify action, object, and scenes. The second is language simulation, tasks like language modeling, machine translation, and text summarization. The third one is time series prediction, so predicting future values in a time series. The fourth is voice recognition, tasks such as speech to text transcription and command recognition. The last one is sentiment analysis, classifying text sentiment as positive, negative, or neutral. So there are many more examples of LSTM. So now let's move forward and understand LSTM model and how it works with example. Let's consider the task of predicting the next word in a sentence. This is a common application of LSTM networks in natural language processing. So I will break it down step by step using the analogy of remembering a story and deciding what comes next based on the context. So imagine you are reading a story. As you read, you need to remember what has happened so far to predict what might happen next. So let's illustrate with a simple example sentence. The cat sat on the dash. So you want to predict the next word, which could be mat or roof or something else. An LSTM network helps this make prediction by remembering important parts of the story and forgetting irrelevant details. So now let's dive into step-by-step process. So step-by-step explanation using LSTM. The first one is reading the story, input sequence. As you read each word in the word sentence, you process it and store relevant information. For example, you understand it's a determiner. Cat, you know it's a noun and the subject of the sentence. Sat indicates the action performed by the subject. On, preposition indicating the relationship between the cat and the next noun. So this sequence diagram showing the words being read and processed. So second comes forget gate. As you move through the sentence, you might decide that some details are no longer important. For instance, you might decide that knowing the is less important now that you have cat and said. So the word forget gate helps discard this less important information. So this sequence diagram you can see on the screen showing how relevant information is discarded. So the third one, input gate. When you read on, you need to decide how relevant this information is. So this sequence diagram in the screen is showing how new information is integrated with the last one. Okay, the fourth one is the cell state, memory part. So this is like your memory of the story so far. It carries information about the subject cat and the action sat on. So it updates the new information as you read each word. Okay, the cat sat on the, retaining the important context. So this sequence diagram showing how the memory is updated with the new information. So the last one is output gate. When you need to predict the next word, the output gate helps you decide based on the current memory, cell state. So it uses the context, the cat sat on the. So the predict the next word might be mat because cat and mat are often associated with the context. So it can predict anything. The cat sat on the table or on the sofa, anything. But mat, why I'm saying mat? Because cat and mat are often associated in the same context. So this diagram is showing the prediction of the next word based on the current memory. So there are many applications where you can use LSTM in predicting time series or next word in the sentence. So by the using of LSTM gates, input gate, forget gate, and output gate, and updating the cell state, the network can predict the next word in a sequence by maintaining relevant context and discarding unnecessary information. This step-by-step process allows LSTM network to effectively handle sequence and make accurate prediction based on the context.
So here's the OpenAI documentation, and you could see the new features introduced with the ChatGPT 4.0. So these are the improvements. One is the updated and interactive bar graphs or pie charts that you can create, and these are the features that you could see here. You could change the color, you could download it, and what we have is you could upload the latest file versions directly from Google Drive and Microsoft OneDrive. And we have the interaction with tables and charts in a new expandable view that I showed you here. That is here, you can expand it in the new window. And you can customize and download charts for presentations and documents. Moreover, you can create the presentation also. That we'll see in further. And here we have how data analysis works in ChatGPT. You could directly upload the files from Google Drive and Microsoft OneDrive. I will show you guys how we can do that and where this option is. And we can work on tables in real time. And there we have customized presentation ready charts. That is, you can create a presentation with all the charts based on a data provided by you. And moreover, a comprehensive security and privacy feature. So with that, guys, we'll move to ChatGPT. And here we have the ChatGPT 4.0 version. So before commencing, guys, there's a quick info for you. If you're one of the aspiring data analysts looking for online training and graduating from the best universities, or a professional who elicits to switch careers with data analytics by learning from the experts, then try giving a shot to Simplilearn's Purdue postgraduate program in data analytics in collaboration with IBM. You can find the link in the description box and pinned comment. So let's get started with data analysis part. So this is the pin section or the insert section, where you can have the options to connect to Google Drive, connect to Microsoft OneDrive, and you can upload it from the computer. This option was already there, that is upload from computer, and you can upload at least or at max the 10 files. That could be around Excel files or documents. So the max limit is 10. And if you have connected to Google Drive, I'll show you guys. I'm not connecting you, but you guys can connect it too, and you could upload it from there also. And there's another cool update, that is ability to quote directly in your chat. So while chatting with ChatGPT, I'll show you guys how we can do that. And you could find some new changes, that is in the layout. So this is the profile section. It used to be at the left bottom, but now it's moved to the top right and making it more accessible than ever. So let's start with the data analysis part, and the first thing we need is data. So you can find it on Kaggle, or you could ask ChatGPT 4.0 to provide the data. I will show you guys. So this is the Kaggle website. You can sign in here and click on datasets. You can find all the datasets here. That would be around computer science, education, classification, computer vision. Or else you could move back to ChatGPT and you could ask the ChatGPT 4.0 model to generate a data and provide it in Excel format. So we'll ask him, we'll not ask him can you, we'll just ask him provide a data set that I can use for data analysis and provide in CSV format. So you could see that it has responded that I can provide a sample data set, and he has started generating the data set here. So you could see that he has provided only 10 rows, and he is saying that I will now generate this data set in CSV format. First he has provided the visual presentation on the screen, and now he is generating the CSV format. So if you want more data, like if you want 100 rows or 1000 rows, you could specify in the prompt and ChatGPT will generate that for you. So we already have the data. I will import that data. You could import it from here, or else you can import it from your Google Drive. So we have a sales data here. We will open it. So we have the sales data here. So the first step we need to do is data cleaning. So this is the crucial step to ensure that the accuracy of our analysis is at its best. So we can do that by handling missing values. That is, missing values can distort our analysis. And here ChatGPT 4 can suggest methods to impute these values, such as using the mean, median, or a sophisticated approach based on data patterns. And after handling the missing values, we will remove duplicates and outlier detection. So we'll ask ChatGPT, clean the data if needed. So we can just write a simple prompt that would be clean the data if needed. And this is also a new feature. You can see the visual presentation of the data here, that we have 100 rows here and the columns provided, that is sales ID, date, product, category, quantity, and price per unit and total sales. So this is also a new feature that, okay, we just headed back. We'll move back to our ChatGPT chat here. Okay, so here we are. So you could see that ChatGPT has cleaned the data, and he has provided that it has checked for missing values, checked for duplicates, and ensured consistent formatting. And he's saying, okay, so now we will ask him that execute these steps and provide the clean data. As ChatGPT has provided that these would be the steps to clean the data, and let's see. So he has provided a new CSV file with the clean sales data. We will download it and ask him to use the same file only. Use this new cleaned sales data CSV file for further analysis. So you could see that he is providing what analysis we can do further. But once our data is clean, the next step is visualization. So visualizations help us understand the data better by providing a graphical representation. So the first thing we will do is we will create a prompt for generating the histograms, and we'll do that for the age distribution part. So we'll write a prompt that generate a histogram to visualize the distribution of customer ages. To visualize the distribution of customer ages. And what I was telling you guys is this code button. If you just select the text and you would find this reply section, just click on that and you could see that it has selected the text or what you want to get, or the prompts started with ChatGPT. So we'll make it cross, and you could see that it has provided the histogram here, and these are the new features here. And we could see that he is providing a notification that interactive charts of this type are not yet supported. That is, histogram don't have the color change option. I will show you the color change option in the bar chart section. So these features are also new. You can download the chart from here only, and this is the expand chart. If we click on that, you could see that you could expand the chart here and continue your chat with ChatGPT here. So this is the interactive section. So you could see that he has provided the histogram that is showing the distribution of customer ages, and the age range are from 18 to 70 years with the distribution visualized in 15 bins, that he has created 15 bins here. And now moving to another visualization that we'll do by sales by region. So before that, I will open the CSV file that is provided by the ChatGPT. So you guys can also see what data he has provided. So this is the clean sales data, and you could see that we have columns: sales ID, date, product, category, quantity, price per item, total sales, region, and salesperson. So now moving back to ChatGPT. So now we will create a bar chart showing total sales by region. So we'll enter this prompt that create a bar chart showing total sales by region. So what we are doing here is we are creating bar charts or histogram charts, but we can do that for only 2 columns. If we want to create these data visualization charts, we need 2 columns to do so. So you could see that he has provided the response and created the bar chart here. And this is the interactive section. You could see that here's an option to switch to static chart. If we click on that, we can't, we are not getting any information if we scroll on that. And if I enable this option, you could see that I can visually see how many numbers this bar is indicating. And after that, we have the change color section. You can change the color of the data set provided. So we can change it to any color that is provided here, or you could just write the color code here. And similarly, we have other 2 options, that is download, and another is the expand chart section. And if you need what code it has done to figure out this bar graph, So this is the code. You could use any ID to do so. If you don't want the presentations or the visualizations of the bar charts here, you could use your ID and use the Python language, and he will provide the code for you. Just take your data set and read it through pandas and generate the bar charts. So moving to next section, that is category wise sales section. So here we will generate a pie chart showing the proportion of sales for each product category. So for that we will write a prompt, generate a pie chart showing the proportion of sales for each product category. So you could see that it has started generating the pie chart, and this is also an interactive section. If you click on that, you would be seeing a static pie chart, and if you want to change the color, you can change for any section. That could be clothing, electronics, furniture, or kitchen. And similarly, we have the download section and the expand chart section. So this is how this new ChatGPT 4 model is better than ChatGPT 4, that you could use a more interactive pie charts. You could change the colors for that, and you can just hover over these bar charts and found all the information according to them. So after this data visualization, now we'll move to statistical analysis. So this will help us uncover patterns and relationships in the data. So the first thing we'll do is correlation analysis, and for that we'll write the prompt, analyze the correlation between age and purchase amount. So this correlation analysis help us understand the relationship between two variables. So this can indicate if older customers tend to spend more or less. So we'll find out that by analyzing the data, and we'll provide a prompt to ChatGPT that analyze the correlation between age and purchase amount. So let's see what it provides. So here's the response by ChatGPT. You could see a scatter plot that shows the relationship between customer age and total sales. That is with a calculated correlation coefficient of approximately 0.16. So this indicates a weak positive correlation between age and purchase amount, suggesting that as customer age increases, there's a slight tendency for total sales to increase as well. So you could just see the scatter plot here, that if the age increases, so it is not correlated to sales, as you could see an empty graph here. So till 40 to 50 years of age or the 70 years of age, you could find what amount they have spent here. That is the total sales accumulated by these ages. So now moving to sales trend. So here we will perform a time series analysis of purchase amount over the given dates. So what does this do is, time series analysis allows us to examine how sales amount changes over time, helping us identify trends and seasonal patterns. So for that we'll write a prompt, perform a time series analysis of purchase amount over given dates. So you could see that ChatGPT has provided us the response, and here is the time series plot showing total sales over the given dates, and each point on the plot represents the total sales for a particular day. So through this you can find out, and the businesses find out, which is the seasonal part of the year and where to stock up their stocks for these kind of dates. And after that you could also do customer segmentation. So what does this do is, so we can use clustering here to segment customers based on age, income, and purchase amount. So clustering groups customers into segments based on similarities. This is useful for targeted marketing and personalized services. And after that, we have the advanced usage for data analysis. Here we can draw a predictive modeling table and do the market basket analysis and perform a customer lifetime value analysis. So we will see one of those, and what we'll do is we'll perform a market basket analysis and perform an association rule mining to find frequently bought together products. So the theory behind this is the association rule mining helps identify patterns of products that are often purchased together, aiding in inventory management and cross-selling strategies. So for that, we'll write a prompt that perform an association rule mining to find frequently bought together products. So for that, we'll write a prompt here, perform an association rule mining to find frequently bought products together. So let's see for this prompt, what does ChatGPT 4 respond to us? So you could see that he is providing a code here, but we don't need a code here. We need the analysis. Don't provide code. Do the market basket analysis and provide visualizations. So you could see that ChatGPT has provided the response that given the limitations in this environment, so he is not able to do the market basket analysis here. So but he can help us how we can perform this in an IDE. So he's providing, you can install the required libraries, then prepare the data, and here he is providing the example code. So you could see there are some limitations to ChatGPT 4 also, that he can't do advanced data analysis. So you could use the code in your IDE and do the market basket analysis there. So there are some limitations to ChatGPT 4 also. And now we will ask ChatGPT, can you create a presentation based on the data set? And we'll provide a data set to it also. So we'll provide sample sales data. And we'll ask him, can you create a presentation or PowerPoint presentation based on this data set and only provide data visualization graphs. So you can see that ChatGPT 4 has started analyzing the data, and he is stating that, and he will start by creating a data visualization from the provided data set and compile them into a PowerPoint presentation. So you could see that ChatGPT 4 has provided us the response, and these are all the presentations or the bar graphs that he has created. And now we have downloaded the presentation here. We will open that, and here's the presentation that is created by ChatGPT 4.
Sora is here. OpenAI has introduced Sora, an advanced AI tool for creating videos, now available at Sora.com. Earlier this year, Sora was launched to turn text into realistic videos, showcasing exciting progress in AI technology. Now, OpenAI has released Sora Turbo, a faster and more powerful version available to ChatGPT Plus and Pro users. Sora lets users create videos in 1080p quality up to 20 seconds long and in different formats like widescreen, vertical, or square. It includes tools like a storyboard for precise control and options to remix or create videos from scratch. There is also a community section with featured and recent videos to spark ideas. ChatGPT Plus users can make up to 50 videos per month at 480p resolution, while pro user get access to more features like higher resolution and longer video duration. While Sora Turbo is much faster. OpenAI is still working to improve areas like handling complex action and making the technology more affordable. To ensure safe and ethical use, Sora includes features like visible watermarks, content moderation, and metadata to identify videos created with Sora. Sora makes it easier for people to create and share stories through video. OpenAI is excited to see how users will explore new creative possibilities with the powerful tool. Before we move forward, unlock the future of AI with comprehensive program in collaboration with ENICT Academy, IIT Guwahati. In just few months, you will master cutting-edge skills in generative AI, large language models, and machine learning. From learning tools like ChatGPT and DALL-E 2 to gaining hands-on experience with Python and TensorFlow. This course will equip you to lead an AI project and quality for top roles like machine learning engineer or data scientist. Plus, with an IIT certificate on your resume, you will stand out to the best employers in tech. So don't forget to check out the course link from the description box below and the pinned comment. So without any further ado, let's get started. So welcome to the demo part of the Sora. So this is the landing page when you will log in Sora. So let me tell you, I have the ChatGPT Plus version, not the Pro version. So I have some 721 credits left. Okay, later on I will tell you what are the credits. Okay, so let's explore something here. So these are some recent videos which I have created or tested, you can say, and this featured version is all the users of Sora which are creating videos. So it's coming under featured, so we can learn or we can generate some new ideas like this. Okay, like this parrot and all. Like this is very cool for learning, and these are some of the saved version, and these are all videos and uploads like this. So let's come into the credit parts. Okay, so you can see I have 721 credit left. So if you will go this help openai.com page, and this page you can see what are the credits. So credits are used to generate videos with Sora. Okay, so if you will create 480p square 5-second video, it will take only 20 credits. Okay, for 10 it will take 40, then this. Okay, for 480p this much credit, 25 credit, 50 credit, like this. 720 is different, 1080p different. Okay, so here it is written, please note that requesting multiple variation at once will be charged at the same rate as running two separate generation requests. Okay, so here this plus icon you can see. So here you can upload the image or video. Okay, so you can also do like this, you can upload the image and you can create that video from that image. Okay, and this is choose from library, your personal library, this library, right? And this option is for the variation. Okay, like these are basically presets like balloon world, stop motion, archival, film noir, or cardboard art, and the paper. Okay, so this is the resolution. Okay, 480p, this is the fastest in video generation. Okay, 720p will take like 4x slower, and 1080p 8x slower. I guess 1080p is only available in ChatGPT's Pro version. Got it? Okay, so we are just doing. I'm just showing you demo, so I will choose this fastest version only. Okay, so this is the time duration, how long you want, like 5 seconds, 10 seconds, 15 and 20 seconds is available in Pro version. Okay, of ChatGPT, and this is how much versions you want to take. I will select only 2. Okay, because it will again charge more credits to you. Okay, and these credits are monthly basis, I guess. Okay, these credits are monthly basis. Okay, see again, recut, remix, blend, loop to create content. This will take again more credits. Okay, see here, ChatGPT Plus, up to 50 priority videos, 1000 credits. Okay, per month, I guess. Yeah, per month. Up to 720p resolution and the 5-second duration. And ChatGPT Pro, up to 500 priority videos, 10,000 credits. Unlimited relax videos, up to 1080p resolution, 20-second duration. Download without watermark. Here you can download with watermark, I guess. I don't know. Yeah, we'll see. About everything, okay, ChatGPT. But ChatGPT Pro is $200 per month. So, yeah, it's expensive, right?
So yes, let's do something creative. So okay, I will write here. Okay, polar bear enjoying on the Sahara desert. Okay, Sahara desert. Yeah. Okay, you can do storyboard as well, or you can create directly videos. Okay, so let me show you the storyboard first. Yeah, so frame by frame you can give, you know, different what to say, prompt. Okay, here you can give different prompt. Okay, polar bear with family. Okay, playing with sand, like this. Okay, and later on it will create a whole the video. Okay, third you can describe again, you can add image, like this. Okay, this is a story created by the ChatGPT. Okay, let's create. Okay, add it to the queue. Okay, it's very fast actually, almost done. Yeah, see, with family, you can see playing with the sand. Okay, so these are the two variation. Okay, you can choose either this or either that one or either that one. Okay, I'm feeling this much as, yeah. So here you can again edit your story, recut, you can trim or extend this video in a new storyboard. Okay, so basically record features allow you to creators to, you know, pinpoint and isolate the most impactful frame in a video, extending them in either direction to build out of like complete scene. Okay, if we'll choose record. Okay, this thing, fine. Then remix. What remix do is like the remix features allows user to reimagine existing videos by altering their components without losing, you know, that essence of the originality, you can say. Okay, you want to, you know, add or remove certain things. Okay, what if I want to remove, you know, that this polar bear or like this. Okay, or you can say we can, you know, change colors or we can some tweak visual elements and this blend. So this blend feature allows you to combine with different video. If I want to upload some videos, it will blend both the video, this video particular with that video which I will upload. Okay, right. And the last loop, you know, by the name, loop features, you know, feature make it easy to create seamless repetition of the video. Okay, this will like, this is one option is ideal for background visuals, music videos, like this. Okay, so this is how you can create video in 2 minutes, I can say, just by giving prompt. Okay, this one is favorite, you can save it for the favorite, and this you can sharing options are there, copy link or this unpublished, and you can download. See, I told you without watermark is available in only pro version. So I have this with watermark, you can download. See, download a video in just a click, or you can download as a GIF as well, right? And add to a folder. Okay, fine, this is the notification activity on, right? So let's create one. Okay, monkey with family driving car on the space. Yeah, so okay, I will choose this time 16:9. Like, it takes more credit of mine, it's okay. Yeah, add it to the queue. If you'll go to favorites, it will come this one because I chose it. Okay, and if you will ask how this Sora is working, so it's like text to image generative AI models such as like DALE 3, Stable Diffusion, and Midjourney. So Sora is a diffusion models. That means that it starts with each frame of the video consisting of the static noise. See, oh, it's cartoonish, but yeah. See, if you want Lamborghini, you can add that I want Lamborghini or Tesla, whatever. So this is how you can generate videos with Sora in quick 2 minutes. Okay. Hello everyone, I am Mank and welcome to today's video where we will be talking about LLM benchmarks, tools used to test and measure how well large language models like GPT and Google Gemini performs. If you have ever wondered how AI models are evaluated, this video will explain it in simple terms. LLM benchmarks are used to check how good these models are at tasks like coding, answering questions, and translating languages or summarizing text. These tests use sample data and specific measurement to see how well the model performs. For example, the model might be tested with a few examples, like few short learning, or none at all, like zero short learning, to see how it handles new tasks. So now the question arises, why are these benchmarks important? They help developers understand where a model is strong and where it needs improvement. They also make it easier to compare different models, helping people choose the best one for their needs. However, LLM benchmarks do have some limits. They don't always predict how well a model will work in real-world situations, and sometimes model can overfit, meaning they perform well on test data but struggle in practical use. We will also cover how LLM leaderboards rank different models based on their benchmark scores, giving us a clear picture of which models are performing the best. So stay tuned as we dive into how LLM benchmarks work and why they are so important for advancing AI.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
But before we start, here is a quick info for you. Dive into the future of AI with our Generative AI and Machine Learning course in collaboration with ENICT Academy, IIT Guwahati. Learn tools like ChatGPT, OpenAI, Hugging Face, Python, and more. Join masterclass led by IIT Guwahati faculty, engage in hands-on projects, and earn executive alumni status. This Generative AI and Machine Learning course enriches your career journey with comprehensive coverage of machine learning, deep learning, NLP, generative AI, reinforcement learning, computer vision, and many more. So don't forget to find the course link from the description box below and the pinned comment. So without any further ado, let's get started. So what are LLM benchmarks? LLM benchmarks are standardized tools used to evaluate the performance of large language models. They provide a structured way to test LLMs on a specific task or question, using sample data and predefined metrics to measure their capabilities. These benchmarks assess various skills such as coding, common sense reasoning, and NLP tasks like machine translation, question answering, and text summarization. The importance of LLM benchmark lies in their role in advancing model development. They track the progress of an LLM, offering quantitative insights into where the model performs well and where improvement is needed. This feedback is crucial for guiding the fine-tuning process, allowing researchers and developers to enhance model performance. Additionally, benchmarks offers an objective comparison between different LLMs, helping developers and organizations choose the best model for their needs. So how LLM benchmarks work? LLM benchmarks follow a clear and systematic process. They present a task for LLM to complete, evaluate its performance using specific metrics, and assign a score based on how well the model performs. So here is a breakdown of how this process works. The first one is setup. LLM benchmarks come with pre-prepared sample data, including coding challenges, long documents, math problems, and real-world conversation. The task spans various areas like common sense reasoning, problem solving, question answering, summary generation, and translation, all present to the model at the start of testing. The second step is testing. The model is tested on one of the three ways. Few shot, the LLM is provided with a few examples before being prompted to complete a task, demonstrating its ability to learn from limited data. The second one is zero shot. The model is asked to perform a task without any prior examples, testing its ability to understand new concepts and adapt to unfamiliar scenarios. The third one is fine-tune. The model is trained on a dataset similar to the one used in the benchmark, aiming to enhance its performance on the specific task involved. The third step is scoring. So after completing the task, the benchmark compares the model's output with the expected answer and generates a score, typically ranging from 0 to 100, reflecting how accurately the LLM performs. So now moving forward, let's see key metrics for benchmarking LLMs. So LLMs benchmark uses various metrics to assess the performance of large language model. So here are some commonly used metrics. The first one is accuracy or precision. Measure the percentage of correct prediction made by the model. The second one is recall, also known as sensitivity. Measure the number of true positive reflecting the correct prediction made by the model. The third one is F1 score.
combines both accuracy and recall into a single metric, weighing them equally to address any false positive or negatives. F1 score ranging from 0 to 1, where 1 indicates perfect precision and recall. The fourth one is exact match. Tracks the percentage of predictions that exactly match the correct answer, which is especially used for the tasks like translation and question answering. The fifth one is perplexity gauges. Here it will tell you how well a model predicts the next word or token. A lower perplexity score indicates better task comprehension by the model. The sixth one is BLUE, bilingual evaluation understudy. Is used for evaluating machine translation by comparing n-grams, sequence of adjacent text element, between the model's output and the human-produced translation. So these quantitative metrics are often combined for more through evaluation. So in addition, human evaluation introduces qualitatively factors like coherence, relevance, and semantic meaning, provide a nuanced assessment. However, human evaluation can be time-consuming and subjective, making a balance between quantitative and qualitative measures important for comprehensive evaluation. So now let's moving forward see some limitation of LLM benchmarking. While LLM benchmarking are valuable for assessing model performance, they have several limitations that prevents them from the fully predicting real-world effectiveness. So here are some few. The first one is bounded scoring. Once a model achieves the highest possible scores on the benchmark, that benchmark loses its utility and must be updated with more challenging tasks to remain a meaningful assessment tool. The second one is broad dataset. LLM benchmark often rely on sample data from diverse subjects and tasks. So this wide scope may not effectively evaluate a model's performance in edge cases, specialized fields, or specific use cases where more tailored data would be needed. The third one is finite assessment. Benchmark only tests a model's current skills, and as LLMs evolve and new capabilities emerge, new benchmarks must be created to measure these advancements. The fourth one is overfitting. So if an LLM is trained on the same data used for benchmarking, it can be lead to overfitting, where the model performs well on the test data but struggles with the real task. So this result is scores that don't truly represent the model's broader capabilities. So now what are LLM leaderboards? So LLM leaderboards publish a ranking of LLMs based on the variety of benchmarks. Leaderboards provide a way to keep track to the myriad LLMs and compare their performance. LLM leaderboards are especially beneficial in making decisions on which models to use. So here are some. So in this you can see here OpenAI is leading and GPT-4o second and the Llama third with 405 parameter B and 3.5 Sonnet is there. So this is best in multitask reasoning. What about the best in coding? So here OpenAI O1 is leading. I guess this is the Orion one, and the second one is 3.5 Sonnet, and after that in the third position there is GPT-4o. So this is in best in coding. So next comes fastest and most affordable models. So fastest models are Llama 8B parameter, and the second one is LLM Llama 70B. And the third one is 1.5 Flash. This is Gemini 1. And lowest latency. Here it is leading Llama again. In cheapest models, again Llama 8B is leading. And in the second number, we have Gemini Flash 1.5. And in third, we have GPT-4o Mini. Moving forward, let's see standard benchmarks between Claude 3 Opus and GPT-4. So in general, they are equal. In reasoning, Claude 3 Opus is leading. And in coding, GPT-4 is leading. In math, again GPT-4o is leading. In tool use, Claude 3 Opus is leading. And in multilingual, Claude 3 Opus is leading.
Hey there, tech adventurers! Have you ever wished for an AI assistant that's super smart, lightning fast, and can help you code like a pro? Well, buckle up, because today we are diving into the world of Claude 3.7 Sonnet, or as some may like to call it, Claude Code. This AI model just launched, and let me tell you, it's making waves. But what makes it so special? And how does it compare to OpenAI's ChatGPT, Google Gemini, and even Grok from xAI? Well, stick around because we are going to break it down all for you. So what exactly is Claude 3.7 Sonnet? It's the newest brainchild of Anthropic, and it's designed to be one of the smartest AI assistant out there. Think of it as the next level upgrade to its predecessor, Claude 3.0. But wait, there's something extra special about this version. It's not just a general AI assistant, it has a superpower, which is coding. That's why people call it Claude Code.
So whether you're writing Python, JavaScript or C++, Claude Code can be your ultimate coding sidekick. Now let's talk about why Claude 3.7 is such a big deal. Imagine a super cool AI competition where we bring in the best of the best. Claude 3.7 Sonnet, ChatGPT 4, Gemini 2 and Grok 1.5. Now let's find out who is the smartest, who's the fastest and who's the best at coding. First, let's talk about speed and efficiency. Claude 3.7 Sonnet is fast. If ChatGPT 4 were a high-speed train, then Claude 3.7 would be a rocket. It processes responses quickly, making conversation feel super smooth. And talking about Grok, well, it's got speed, but it's not that sharp when it comes to deep reasoning. Now let's compare between intelligence and understanding. Let's talk about brains. ChatGPT 4 is really smart, but Claude 3.7 has a special trick. It's better at understanding long and complex prompts. Imagine explaining a super tricky math problem to an AI. ChatGPT 4 does a good job, but Claude 3.7 really gets it and responds with a clear, accurate answer. Gemini is great for general knowledge, but sometimes it gets things mixed up. Now let's talk about coding superpowers. This is where Claude 3.7 really shines. It's designed to be a coding genius. Need to write a Python script? Claude's code got your back. Stuck on debugging? It finds errors fast and even suggests fixes. Want to optimize your code? It offers solutions that make your program run better and faster. While ChatGPT 4 is also an awesome coding assistant, Claude 3.7 often gives more structured, step-by-step explanations, making it easier for beginners and pros alike. Gemini can code too, but it sometimes struggles with more complex programming logic. And Grok, well, it's all catching up in coding department. Let's now talk about memory and context. One of the coolest things about Claude 3.7 is that it remembers context really well. If you give it a long conversation with multiple steps, it doesn't lose track. ChatGPT 4 is also great at this, but sometimes it forgets little details. Gemini, it's improving, but it can get confused in long discussions. Let's talk about safety and reliability. Let's be real for a second. AI safety is super important. Nobody wants weird or harmful responses. Claude 3.7 is built with strong guardrails, making sure it's helpful, respectful, and accurate. It's one of the safest AI models out there. ChatGPT 4 is also really good in this area, while Grok and Gemini are still fine-tuning their safety measures. Alright, so if you're into coding or even just thinking about learning to code, you need to check out Claude Code. Here's why. First of all, it's great for beginners. It explains things step by step, so even if you're new to coding, you won't feel lost. Second of all, advanced debugging. It finds and fixes errors in your code, sometimes before you even realize there's a problem. Third is code optimization. It suggests better, faster, and more efficient ways to write your programs. Multi-language support. So whether you're working in Python, Java, C++, or even web languages like HTML and JavaScript, Claude Code can help too. Clear explanations. It doesn't just give you answers, it teaches you how to solve problems. If ChatGPT 4 is a really good coding tutor, then Claude Code is like a super coach that makes you better programmer. So, is Claude 3.7 Sonnet the best AI assistant? Well, if you need a coding partner, absolutely. It's fast, smart, accurate, and safe. Compared to ChatGPT 4, it holds its own and even outperforms in some areas like speed and long context understanding. Against Gemini, it's more reliable and less likely to make mistakes. And versus Grok, well, Grok is still learning the ropes. And at the end of the day, the best AI depends on what you need. But if you're a coder or want to become one, Claude 3.7 Sonnet, that is Claude Code, is the ultimate AI assistant for you. Alright, tech explorers, now it's your turn. If you want to see Claude Code in action, go try it out. Whether you're writing your first Hello World program or building a complex AI project, Claude 3.7 Sonnet is here to help. Who knows, with an AI assistant this smart, you might just become the next coding superstar.
OpenAI is one of the main leaders in the field of generative AI, with its ChatGPT being one of the most popular and widely used examples. ChatGPT is powered by OpenAI's GPT family of large language models. LLMs. In August and September 2024, there were rumors about a new model from OpenAI, codenamed Strawberry. At first, it was unclear if it was the next version of GPT-4o or something different. On September 12, OpenAI officially introduced the O1 model. Hi, I am Mayank. In this video, we will discuss about OpenAI model O1 and its types. After this, we will perform some basic prompts using OpenAI Preview and OpenAI Mini. And at the end, we will see comparison between the OpenAI O1 models and GPT-4o. So without any further ado, let's get started. What is OpenAI O1? The OpenAI O1 family is a group of LLMs that have been improved to handle more complex reasoning. These models are designed to offer a different experience from GPT-4o, focusing on thinking through problems more thoroughly before responding. Unlike older models, O1 is built to solve challenging problems that require multiple steps and deep reasoning. OpenAI O1 models also use a technique called chain of thought prompting, which allows the model to think through problem step by step. OpenAI O1 consists of two models, O1 Preview and O1 Mini. The O1 Preview model is meant for more complex tasks, while the O1 Mini is a smaller, more affordable version. So what can OpenAI O1 do? OpenAI O1 can handle many tasks, just like other GPT models from OpenAI, such as answering questions, summarizing content, and creating new material. However, O1 is especially good at more complex tasks, including the first one is enhanced reasoning. The O1 models are designed for advanced problem solving, particularly in subjects like science, technology, engineering, and math. The second one is brainstorming and ideation. With its improved reasoning, O1 is great at coming up with creative ideas and solutions in various fields. The number third is scientific research. O1 is perfect for tasks like annotating cell sequencing data or solving complex math needed in areas like quantum optics. The number fourth is coding. The O1 models can write and fix code, performing well on coding tests like human eval and code forces, and helping developers build multi-step workflows. The fifth one, mathematics. O1 is much better at math than previous model, scoring 83% in the International Mathematics Olympiad test compared to GPT-4o's 13%. It also did well in other math competitions like AIME, making it useful for generating complex formulas for physics. And the last one is self-fact checking. O1 can check the accuracy of its own responses, helping to improve the reliability of its answer. You can use OpenAI O1 models in several ways. ChatGPT Plus and team users have access to O1 Preview and O1 Mini models and can manually choose them in the model picker. Although free users don't have access to the O1 models yet, OpenAI planning to offer O1 Mini to them in the future. Developers can also use these models, OpenAI's API, and they are available on third-party platforms like Microsoft Azure AI Studio and GitHub models. So before jumping to the demo part, here is a quick info for you. Dive into the future of AI with the Generative AI and Machine Learning course in collaboration with ENICT Academy IIT Guwahati. Learn tools like ChatGPT, OpenAI, Hugging Face, Python, and more. Join masterclass led by IITG faculty, engage in hands-on project, and earn executive alumni status. So this Generative AI and Machine Learning course enriches your career journey with comprehensive coverage of machine learning, deep learning, NLP, generative AI, reinforcement learning, computer vision, and many more. So find the course link from the description box below and the pinned comment. So yes guys, I have opened this ChatGPT 4o model here and ChatGPT O1 Preview, as you can see. So I have this plus model, okay, the paid version of ChatGPT. So I can access this O1 Preview and O1 Mini model. Okay, we will go with O1 Preview model and we will put same prompts in both the model of the ChatGPT 4o and the O1 Preview and see what are the differences are coming. Okay, so we will do some math questions and we will do some coding. We will do some advanced reasoning and quantum physics as well. Okay, so let's start with, so I have some prompt already written with me. So first one is number theory. Okay, so what I will do, I will copy it from here and paste it in this and both. Okay, so let me run in 4o and O1 Preview. So here you can see it's thinking. Okay, so this is what I was saying, chain of thoughts. Okay, so these are the chain of thoughts. First is breaking down the primes, this is, and then is identifying the GCD. And now see the difference between the output.
See, output is 561 is not a prime number, and the GCD, greatest common receiver, of 48 and 180 is 12. Okay, here, see, ChatGPT O1 preview is giving the output in step by step. First, see, determine if 561 is a prime number or not. The number 561 is not a prime number. It's a composite number because it has this. Okay, then second step, then the greatest common divisor. Then they found 12. And answer is no, 561 is not composite number because of this, and the greatest common divisor of 48 and 180 is 12. See, just see the difference between the two models. This is why ChatGPT O1 models are crazy for math, coding, and advanced reasoning, quantum physics, for these things. Okay, so let's go with our second step. So here, if you will see, you can see the attach file option in ChatGPT 4.0. Okay, you can come upload from your computer, but here you will see in O1 there is no attach file option. This is one drawback. Okay, so here upload from computer. So this is one small. Okay, and let me open this, and this is the question I have. Okay, yeah, so I will copy this, I will run this and this. Okay, see, it's start giving the answer, and O1 is still thinking, solving the equation, then analyzing the relationship. Okay, so ChatGPT O1 will take time, but it will give you more accurate, more step by step as you want. Okay, so here you can see solve for actions question, this, and here the steps you can see. Okay, this is more structured way, you can say, in a good structured way. Okay, ChatGPT O1 preview gave you in good structured way as O1 mini as well. Okay, so yeah, so here they wrote just 1 and 2, this, and here if you'll see question 1, solve for x in this, and step 1 is this, step 2 is this, and step 3 is this, then the answer of x is equal to 3. But here simply they wrote we know this, and x equals to 3. For the second question, see, expanding the left hand side, this, but here step 1, square both sides of the given equation. Start by squaring both sides. Okay, it's written but not in good way. Okay, so this is why O1 is better for math. Okay, so now let's check it for the coding part. Okay, so I have one question. Okay, let me see what output it will give to. First I will write I need. Okay, leave it. I will copy it, and I will copy it as well here, run it and run it. See, it start giving answer. Okay, and still this will adjust the parameters, ensuring the code generation, because ChatGPT O1 will think first, then it will analyze, then after that it will give you answers. Okay, here the code is done. See, here the code is done and it's still thinking. Step 1, and first here you can't see anything. See, step setup development environment, pip install numpy matplotlib, then this, and here nothing. And but I will ask it, okay, give me code in one tab. Okay, here also I will write give me code in single tab. Okay, so I can just copy and paste. So what I will do, I will open one online compiler and I will directly copy it and paste. Okay, so let's finish this. I hope it will work. So let me open W3 Schools compiler. Okay, yeah, Same I will open for this W3 school. Okay, so let me copy the code and my bad and paste it here. Same works for this. Okay. Okay. I will copy the code and I will paste it here. Okay. I hope it gives something. Yeah, cool. So yes, now you can see the difference between the output. So this is the output of 4.0 and this is the output of O1 preview. See, O1 preview output is this and this is the output of 4.0. So this is the difference. This is why O1 takes time, but it will give you more accurate result in a good way. Okay. So now let's check something else. So moving on, let's see some advanced reasoning question. Okay, so this is the logical puzzle one, the first one. Okay, so I will copy it and I will paste it here. Okay, this is for O1, this is for preview. Because why I'm not comparing O1 with mini? Because they both are same, but slightly differences there. Okay, so here we can see more difference between 4.0 old model versus new model, you can say. Okay, so now see the answer is end in this much only, but it will explain you in a better way. See, thoughts for 7 seconds, explanation, that case 1, then case 2. Okay, with conclusion in both scenarios, summary, and this here, this one, small explanation, and that's it, right? So they created O1 preview for more, it will describe you more in a better way, right? Now let's see some scientific reasoning as well. Okay, so let me copy it here. So still thinking, but start giving answer. Says thought for 16 seconds. So again, I will say that ChatGPT O1 is much better than ChatGPT 4.0. ChatGPT 4.0 is great for content writing and all, but ChatGPT O1 preview and mini are very good for reasoning, math, coding, or quantum physics, these type of things. Okay, advanced reasoning. Okay, ChatGPT 4.0 is great for generative text. Okay, like for marketing, writing copies, emails, and all of those. So now let's see some comparison between O1 models and GPT-4o model. When new models are released, their capabilities are revealed through benchmark data in the technical reports. The new OpenAI model excels in complex reasoning tasks. It surpasses human PhD level accuracy in physics, chemistry, biology on the GPQA benchmark. Coding becomes easier with O1 as it ranks in the 89th percentile of the competitive programming questions Codeforce. The model is also outstanding in math. On a qualifying exam for International Mathematics Olympiad IMO, GPT-4o solved only 13% of problems, while O1 achieved 83%. This is truly next level. On the standard ML benchmarks, it has huge improvement across the board. MMLU means multitask accuracy and GPQA is reasoning capabilities. Human evaluation. OpenAI asks people to compare O1 Mini with GPT-4o on difficult open-ended tasks across different topics using the same method as the O1 preview versus GPT-4o comparison. Like O1 preview, O1 Mini was preferred over GPT-4o for tasks that require strong reasoning skills, but GPT-4o was still favored for language-based tasks. Model speed. As a concrete example, we compared responses from GPT-4o, O1 Mini, and O1 preview on the word reasoning question. While GPT-4o did not answer correctly, both O1 Mini and O1 preview did, and O1 Mini reached the answer around 3 to 5x faster. Limitation and what's next. Due to its specialization on STEM, science, technology, engineering, and math, reasoning capabilities, O1 Mini's factual knowledge on non-STEM topics such as dates, biographics,
and trivia is comparable to small LLMs such as GPT-4o Mini. OpenAI will improve these limitations in future versions, as well as experiment the extending the model to other modalities and specialties outside of STEM.
Today, we are diving into the fascinating world of Google Quantum AI. We'll break it down step by step. What Google Quantum AI is, how it's different from classical computers, and why it's a game changer, and the real problem it's solving. We'll also explore the latest developments, their innovative hardware, the challenges they face, and why, despite the hurdles, it's still an incredibly exciting field with a bright future. Stick with me because by the end, you'll be amazed at how this technology is shaping tomorrow. So let's get started. The universe operates on quantum mechanics, constantly adapting and evolving to overcome the hurdles it encounters. Quantum computing mirrors the dynamic nature. It doesn't just work within its environment, it responds to it. This unique trait opens the door to groundbreaking solutions for tomorrow's toughest challenges. The question arises, what is Google Quantum AI? Quantum AI is Google's leap into the future of computing. It's a cutting-edge project where they are building powerful quantum computers and exploring how these machines can solve problems that traditional computers struggle with or can't solve at all. If not aware, classical computers use bits like 0 or 1 and solve tasks step by step, great for everyday use. Now, quantum computers use qubits, which can be 0, 1, or both simultaneously, allowing them to solve complex problems much faster. So think of Google Quantum AI like you're trying to design a new medicine to fight a disease. A regular computer would analyze molecules step by step, which could take years. But Google Quantum AI, on the other hand, can simulate how molecules interact at the quantum level almost instantly. This speeds up drug discovery, potentially saving millions of lives by finding treatments faster. Now, you must be wondering, why is it so necessary? Google Quantum AI is necessary because some problems are just too big and complex for regular computers to solve efficiently. These are challenges like developing life-saving medicines, creating unbreakable cybersecurity, optimizing traffic systems, or even understanding how the universe works. Regular computers can take years or even centuries to crack these problems, while quantum computers could solve them in minutes or hours. So the question is actually what problems they are solving. It is basically solving so many problems. I will list some of them. Number 1, drug discovery, simulating molecules to find new treatments faster. Then comes cybersecurity, developing ultra-secure encryption systems to keep your data safe. AI advancements, training AI models much quicker and with more accuracy. Climate modeling, understanding climate changes to create better solutions for global warming. So in simple terms, Google Quantum AI is here to tackle the impossible problems and bring futuristic solutions to today's challenges. It's like upgrading the world's brain to think smarter and faster. So, Google Quantum AI has been at the forefront of quantum computing advancements, pushing boundaries from the groundbreaking Sycamore process to the latest innovation, Willow. In 2019, Google introduced Sycamore, a 53-qubit processor that achieves something called quantum supremacy. So, qubits or quantum bits are the core of quantum computers. Unlike regular bits, which are either 0 or 1, qubits can be 0, 1, or both at once. This is called superposition, allowing quantum computers to process vast data simultaneously. They are powerful but fragile, needing precise control and hold the key to solving complex problems. Sycamore solved a problem in just 200 seconds that would take the world's fastest supercomputer over 10,000 years. This was a big moment. It showed quantum computers could do things that classical computers couldn't. After Sycamore, scientists realized a key issue. Quantum computers are very sensitive to errors. Even small disturbances can mess up calculations. To fix this, Google started working on error correction, making their systems more accurate and reliable for real-world use. In 2024, Google launched Willow, a 105-qubit processor. This chip is smarter and more powerful, and it can correct errors as they happen. So Willow shows how much closer we are to building quantum computers that can solve practical problems. Google's logical qubits have reached a huge breakthrough. They now operate below the critical quantum error correction threshold. Sounds exciting, right? But what does this mean? Let's break it down. So quantum computers use qubits, which are very powerful but also very fragile. They can easily be disrupted by noise or interference, causing errors. So to make quantum computers practical, they need to correct these errors while running complex calculations. This is where logical qubits comes in. They group multiple physical qubits to create a more stable and reliable unit for computing. The error correction threshold is like a magic line. If errors can be corrected faster than they appear, the system becomes scalable and much more reliable. By getting their logical qubits to operate below this threshold, Google has shown that their quantum computers can handle errors effectively, paving the way for larger and more powerful quantum systems. So let's discuss what is a great hardware approach in Google Quantum AI that made it possible. Google Quantum AI's hardware approach focuses on making quantum computers stable and reliable for practical use. They group qubits, which are the building blocks of quantum computers, to work together, allowing the system to fix errors as they happen. So by keeping the chips at extremely cold temperatures, they reduce interference, which keeps the calculations accurate. This setup helps the system handle bigger and more complex tasks like simulating molecules for drug discovery, improving AI models, and creating stronger encryption for data security. It's a big step in making quantum computing a tool for solving real-world problems. So while Google Quantum AI has achieved incredible milestones, it still faces some key limitations, which are fragile qubits. Qubits are extremely sensitive to noise and interference, which can cause errors. Keeping them stable requires ultra-cold temperatures and precise control. Error correction challenges. Although Google has made progress in fixing errors, quantum error correction still isn't perfect and needs more work before quantum computers can scale to solve real-world problems reliably. Limited applications. Right now, quantum computers are great for specialized problems like optimization and simulation. For everyday computing tasks, classical computers are still better. Hardware complexity. Building and maintaining a quantum computer is incredibly expensive and complicated. The advanced cooling systems and infrastructure make it hard to expand these systems widely. Still in early stages, quantum computers, including Google's, are still in the experimental phase. They are not yet ready for large-scale practical use in industries. But despite its challenges, Google Quantum AI is paving the way for a future where quantum computing tackles problems that regular computers can't handle, like finding new medicines, predicting climate changes, and building smarter AI. It's an exciting start to a whole new era of technology, full of possibilities we are just beginning to explore. The future of Google Quantum AI is incredibly exciting with the potential to solve real-world problems that traditional computers can't handle. It's set to revolutionize industries like healthcare by speeding up drug discovery, finance through advanced optimization, and energy with better material modeling. So quantum AI could also lead to breakthroughs in AI by training smarter models faster and creating unbreakable encryption for stronger data security. As Google improves its hardware and error correction, its quantum systems will become more powerful and reliable, paving the way for large-scale practical applications. The possibilities are endless, and Google Quantum AI is the forefront of shaping a transformative future.
Imagine a world where computers can solve problems in seconds. Problems that would take today's fastest supercomputers thousands of years to crack. Sounds like a science fiction, right? Well, thanks to quantum computing, we are getting closer to that reality. And at the heart of this revolution is Microsoft's Majorana chip. But what exactly is Majorana? Why is it so important, and how does it change the future of computing? Let's break it down. Microsoft's Majorana chip is groundbreaking development in quantum computing, designed to create more stable, reliable, and scalable quantum computers. But to fully understand its importance, we need to break it down into three key aspects. The science behind Majorana particles, how Majorana particles improve quantum computing, Microsoft's unique approach with Majorana qubits. Let's dive into each of these. At first, let's understand the science behind Majorana particles. The name Majorana comes from an Italian physicist, Ettore Majorana, who predicted the existence of Majorana fermions back in 1937. These are unique subatomic particles that are their own antiparticles. This means that if two Majorana particles meet, they cancel each other out. But why does this actually matter? In classical physics, every particle has an opposite, that is an antiparticle. For example, the electron has a positron. So when they collide, they annihilate each other. But Majorana fermions are special. They are both the particle and the antiparticle at the same time, making them behave differently from anything else we have discovered in nature. For decades, Majorana fermions were just a theory. However, in 2012, scientists of Delft University of Technology in the Netherlands, along with Microsoft, provided the first experimental evidence of their existence in certain quantum materials. Microsoft then spent over a decade refining this research, leading to the creation of the Majorana-based quantum chip. Now let's talk about how Majorana particles improve quantum computing. Quantum computers operate using qubits, the quantum version of classical bits. Traditional qubits like superconducting qubits used by Google and IBM are highly sensitive to their environment. Even the smallest disturbance like a tiny temperature fluctuation can cause them to lose information, and this is called quantum decoherence. Majorana qubits, however, solve this issue by using a principle called topological protection. Here's how they did it. Majorana particles naturally resist external noise and interference. Information stored in Majorana-based qubits is spread out across multiple locations, making it much harder to corrupt. This results in lower error rates and more stable quantum system, which is crucial for scaling up quantum computers. Think of it like this. Imagine writing an important message to a single piece of paper. If that paper gets destroyed, the message is lost forever. But if you spread the message across multiple papers, losing one doesn't erase the whole thing. And this is how Majorana qubits protect quantum information. Now let's talk about Microsoft's unique approach with Majorana qubits. While other companies like Google, IBM, and Intel are building quantum computers using superconducting qubits, Microsoft took a different path. Their research team developed topological qubits based on Majorana fermions. And this approach is groundbreaking for several reasons. First of all, it gives more stability. Unlike superconducting qubits, which need complex error correction, Majorana qubits naturally protect themselves from errors. It provides better scalability. Traditional qubits require more enormous amounts of hardware to correct errors, but Majorana qubits reduce this need, making it easier to scale up quantum computers. It also provides higher efficiency. Microsoft believes that using Majorana qubits will allow them to build a quantum computer with far fewer qubits than other methods. What came before Majorana? Before Majorana, the quantum computing world was mostly focused on superconducting qubits. Companies like IBM, Google, and Intel have been developing these for years. Google's Sky Mode processor made headlines in 2019 when it claimed quantum supremacy, solving a problem that would take a supercomputer thousands of years in just 200 seconds. IBM has also made significant progress building quantum computers with over 1,000 qubits. But despite these achievements, quantum computers remained unstable and error-prone. And Microsoft's Majorana qubits aim to fix this, making quantum computing more practical for real-world application. Microsoft Majorana is a game changer. It's not just another quantum chip, it's a very new way of thinking about quantum computing. By using topological qubits, Microsoft is paving the way for more stable, reliable, and scalable quantum future. So what do you think? Will quantum computers change the world as we know it? Let us know in the comment section below. And if you really like this video, don't forget to like, share, and subscribe to Simplilearn for more tech insights. So let's talk about the very first top AI tool, which is Skillora.ai. This AI tool aims to provide the best AI-driven mock interview experience. You can take mock interviews for any job roles and subject, receiving instant constructive feedback. Skillora's AI interviewer listens to your responses and asks dynamic flow-up questions to test your depth of knowledge. With the Essential plan, you gain access to 6 AI mock interviews per month. You'll receive instant feedback, ideal answers, and performance reports, helping you upgrade your skills for just $8 per month. The premium plan allows you to enjoy 15 AI mock interviews per month. You'll get the same instant feedback, ideal answers, and performance reports along with priority support, maximizing your learning for only $15 per month. Next up, we have Visco's. Visco's advanced AI coach is designed to elevate your job interview skills, harnessing insights from over 10,000 companies. It offers tailored sessions that simulate real interviews, providing personalized feedback and performance analytics. It transcribes your performance and delivers a conversational experience akin to an actual interview. It also offers customized feedback and performance analytics, helping you refine both your answers and communication skills.
During practice session, you can craft questions specific to your desired role and industry, ensuring relevance and depth in your preparation. Supporting various interview styles. The price for AVA services are available for free. Next up, we have interviewing.io. Interviewing.io is an AI-powered platform that provides candidates with simulated technical interviews. The platform uses machine learning algorithms to assess your coding skills, problem-solving abilities, and communication style. You can get 4 simulated technical interviews for $225. Next up, we have MockMate. MockMate is an AI-powered tool that allows you to practice answering common interview questions. This tool provides feedback on your answers and gives tips on how to improve your performance. The service is available for $29 per month. Moving on to ChatGPT. ChatGPT is an AI chatbot that can be used to practice answering interview questions in a conversational setting. The chatbot can be customized to simulate the style of an actual interview, and it provides feedback on your answers. The free plan allows you to get started with writing assistant, problem solving, and many more. You will have limited access to ChatGPT 4o mini, including data analysis, file uploads, vision, web browsing, and custom GPTs. All of this is available at no cost. Then we have the Plus plan, which is for $20 per month. The Plus plan amplifies your productivity by offering early access to new features, access to ChatGPT 4, 4o, and GPT-4o's mini, up to 5x more messages for ChatGPT 4o. You can access to data analysis, upload files, vision web browsing, and DALL-E image generation. You can also create and use custom GPTs. Then we have My Interview Practice. My Interview Practice is an AI tool that allows you to practice interviews in a simulated environment. The platform uses AI to generate interview questions based on your chosen field and provides instant feedback on your responses. This tool is particularly useful for those who want to practice their interview skills in low-pressure environment. The Plus plan is for $49 per month. You get 1 month of access. And the Premium plan is for $57 per month, and you will get access to additional features and many more benefits. Next up, we have Udly. Udly offers real-time interview coaching using AI. It analyzes your speech and body language, providing feedback on how to improve your performance. Udly services are available for free. Now you might be wondering how AI tools can help you ace your job interviews. AI tools can assist in several ways. At first, we have research companies. AI tool provides information about companies' website, news articles, and social media, helping you tailor your answers to the interview's question. Practice questions. AI tool help you practice answering common interview questions, boosting your confidence and preparation. Feedback. AI tool offers feedback on your answers, highlighting areas for improvement and refining your responses. Personalized advice. AI tools provide tips and advice on improving your interview skills, giving you an edge to your next job interview. Choose the right AI tool and select an AI tool that fits your needs and preferences. Use the tool consistently, starting a few weeks before your interview to maximize its benefits. After practicing with the AI tool, get feedback from others to identify areas for further improvement. Dress professionally and be punctual for your interview to make a positive first impression. Show enthusiasm and confidence during the interview to leave a lasting impression on the interviewer. AI tools can significantly aid in interviewing preparation. By using them effectively, you can enhance your chances of success in your next job interview.
That's a wrap on a full course, guys. If you have any doubts or questions, you can ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.